So if I click on this, I can come here, I can select the two tokens, pop the two different tokens we have. Let's select the fee. This is the fee, and I want to assign, let's say, 1000 equal amount of liquidity. Set the price to minimum price 1 and maximum is going to be 1 also, because I want to keep into the range. So fix 1. Click on this, and here you can see the MetaMask got open. Here we got the details, and here you can see we are initializing or create an initialized pool. So here we are giving the permission to Uniswap smart contract to take our token. So click on confirm, and here you can see this is the second one. We have two tokens. So this will, again, we have to give the confirmation of this Ryan token. So click on confirm, and it will have another contract. This will create the you can see we got the data, and here we are calling this mint function, so it will make the liquidity. Click on this confirm, and we'll have one more pop-up, and this pop-up will store the data of the liquidity we have created. You can see we got the transaction log, transaction went successful, and here we are interacting with the contract to store the data into our smart contract about this liquidity. Click on this confirm, and boom, the transaction went successful. If you click on this MetaMask, you can see, just wait, you can see the transaction went successful. We have called this all method: initialize, approve, mint, and creations. Now if you want to see that whether the data is gone, so we can find that very easily. Go back here. Here you can see we have the data. We have the name of the tokens, we have the two token owner, and the fee right now is 3000, means 0.3%, and here we have the price range. If we want, I can simply type 1 and I'll get the output. Just wait, it's loading. And here we get the output. The output we get, this is the addresses we got it from fetch pricing of the two contract, and this is the output we get. Now we can click on the swap, and here we have the MetaMask. Let's do the transaction. Let's confirm it. Let's click on confirm, and we have the MetaMask. Simply click on confirm, and the transaction went successful. You can see here we got the transaction log, the balance of the DAI token, and this is the transaction, the successful transaction. You can easily able to test on a, if you're doing on a test network, you can easily able to find this on a Etherscan. So this is pretty fine. If you reload the browser, you can able to find the DAI token here. Let's make on full screen. You can see this data is also getting updated. Okay, this will take a little bit of time. You can see this is the data we updated. We have that. So it looks fine. You can see all the data we have here, and it's already responsive. So on the left hand side you will have your logo, then you will have the three menus: swap, token, and pool. From here anybody can search for any token, and from here you can easily able to find that which network you are connected to in your MetaMask. Once you connect, you will have your account address. You can click here and you can easily able to find all the token which you have in your MetaMask. Okay, so all the list of tokens, that what's the balance, the name of the token, and the symbol. You can simply close and you can see all the thing, and from here you can easily able to swap the token from one another. You can click here and you can do some advanced settings. So you can set the tolerance, you can set the timing, you can set the deadline timing, turn on advanced mode. Okay, and from here you can easily able to pick the token which you want to swap. So right now we have Ether. If you click on this, from here you can easily able to select whatever token you have. Okay, so I go for this dog token. I can click here and I have this dog, and here the balance of the token will display. If I click on this, I can come here and I can go for the token which I want. I want to go with the Uniswap. Click on this, and here I have it, and I can click on this swap, so it will happen. So everything is dynamic. We'll take one step at a time, try to understand every fundamental that what's going on. So that's the overview of the template which we are about to build in the very first sections. And after the first section, we'll move to the second section where we're going to build the entire smart contract and write some code for the blockchain. So let me take you to my Visual Code Studio, and let's start installing some packages and do some setup before we start creating this beautiful UI for our Uniswap Clone. I hope you guys are excited. If you are, then hit that like button. Do subscribe to my channel. Do let me know that are you excited. Type yes, and then we can start coding straight away. Hello beautiful people, here we are back in our Visual Code Studio, and now we're going to install a couple of powerful things which allow us to build our beautiful Uniswap clone. Okay, so I have created a folder And right now you can see I have nothing in this folder. I have given the name to this folder is Uniswap clone because that's what we're going to do. So what we have to do is open up your terminal, and now we have to simply clear the terminal first. And now we're going to initialize our next app. You can create with a TypeScript, you can create with React, but I will go with my next app because that's my favorite. So I'll tap next, create, and hit enter. And this will create all the folder and file structure for my application. So this will take a little bit of time, but I'm using the power of editing, so it will happen very fast. So just wait, it's happening. And here you can see that we got our folder and file structure. Let's clear the terminal, and now let's come on this section in the pages, and now we have to clear this stuff. As you all know that before I start coding, I need to have a clean environment. Okay, so I don't need to have those packages, those folder and file structure which I don't like, which I'm not going to use it. Okay, so first thing, I will delete this API folder because I'm not going to use this one, and come back to the index. We're going to remove this entire code, and we'll type RAFCE, and I'm going to simply change the text to home, and in between we're going to type home. So this is our home page. Simply come here and go to this app.js, and here we have to convert this normal function into a arrow function. Okay, simply copy this one, remove this, and take this block, take a div, inside that paste the code. So that's the setup for the app.js, and we're going to do a lot of setups. Okay, so just follow along with me. Now come here in the style file, and we don't need this style file, simply delete this one, and that looks good. Now come back to the packages and file, and here you will find all the dependency and dev dependency which you are using in this project. Let's remove this packages. Simply copy, open up your terminal, and type npx uninstall and paste the name of the package. Hit enter, and this will happen fast. Do the same thing for the other package as well. Simply copy the entire package and simply press arrow up, so that will take you to the previous command, and simply paste the name and hit enter. Now we have clean environment. So here we are using only those packages which we are, and that looks pretty fine to me. Now let's come here, and now we have to create the folder and file structure for our Uniswap clone. So let's create the first component folder, and that we're going to have all the components of our entire application. So let's come here, create another folder, this time called hero section. In that we're going to create a JSX file. Simply type modules, and come here and type RAFCE, React's functional base component. That looks pretty good to me. So we have one component. Now let's create another component in the same component folder, and this one is called model. Now create a file, model JSX, and now we have to create the CSS file, model.css. So these are the two components we have. Let's create one more. This will say NavBar, so NavBar JSX, RAFCE, and now we have to create the CSS file for this, module.css. Three component. Now let's create the fourth one, search token. We have to create the JSX, RAFCE, and now we have to create the CSS file, module.css. So right now we have 4 folders. We need a couple of more. So I'll come here, and we have to create this toggle JSX, and we have to create the CSS file for that as well. So module.css. So let's come here, let's create one more, which is a token list. So the token list which we are showing that how many token user has, that's what we're going to build in this component. So let's create the JSX for this, and we have to create the CSS file for this as well, module.css. So for the time being, these are the folder and file structure we have all. And now we have to create the index file in which we're going to import the entire component. That's the logic we are following out in the entire previous project. So let's type index.js and simply press Ctrl W to close all the open files. And now we have to import all these files in the index. So things are looking good to me. Now let's quickly import. So we have to import the hero section, and that's coming from the hero section. Import the model, coming from the same directory. Import the NavBar. Now we have to import the search token. We have to import the toggle button, and now the final one is the token list, and coming from the same directory. And now we're going to export the entire component which we have imported one by one. Looks good. Let's come down, type export, and we'll go say hero section, model, NavBar, search token, toggle, and token list. This is how we are exporting all the component from this single file, and we can use it wherever we want in our entire application. So simply close this one and come here, and things looking good to me. Now let's come back to the pages and here, and come back to the styles. Delete this one because we are not using ESLint in our project, so it's better to remove this full file. Let's come back to the config file. Right now we don't need to do anything here. We definitely going to add something here when we'll deal with the blockchain. Okay, so no changes we have to do. Come back here. So far things are looking good to me. Come back to the global CSS, and here we have to define the font family and the colors which we are using in this project. So for that, what I want, come back here in the Google Fonts, and I'm using this project, and I have already selected couple of fonts which I am using in this, and this all you will get in a starter file. Don't need to worry. And here I have pre-selected the entire font file, so I'm using 100, 200, 400, 500, 700 till the way to 900. Now click on this Roboto. Here you will find what I'm using, and you can simply scroll and you can see I'm using all these fonts sizes. And simply come here, go to this media query, simply grab this code, media query, copy, and come back to the code editor. Come back and simply paste on top. Come and paste on top. So these are the font which we are using in this project, and it's look good to me. Now we can simply remove this font family, and we can simply copy from here because we are using Roboto. So we have our font family, and now we have to import the colors which we are using in this project. So in the last video yesterday, I have uploaded a video on the free resources on the Figma community. Okay, so from there I'm going to pick the design concept, the color palette, and that's what I'm going to use in this project. So I have opened the Figma community, the project which I'm using, and here they have the colors, and these are the colors I'm going to use in this project. So, and if you want to know that how you have to do the editing, how you have to extract the files, then you can must watch the last video. In that I have explained everything when I was talking about the free resources. So this looks good. Click on this, and here from here left hand side you can easily able to navigate on the text, the colors which you want, and that's what I'm going to use it. Simply come here. So I have already completed this project, and this is the original project. So I'm simply going to copy the entire background color and the font family from here. Don't need to worry, you guys will get this entire thing in the starter file. So simply copy this one, and I'll come back to the project here, and I'm going to simply paste here. Remove this and paste here. So we are done with the color and the font family. So that's the only setup we have to do here. It's looked pretty good to me, no problem. We have simply closed this one, and now we can start building. So let's come up and let's try to start the application and see how it looks on the browser, because we have done the folder and file structure. We have set our colors and the text color. So npm run dev, click on this, open up in your browser, and in my case I have 3001. In your case it might be 3000 because I have other project running in the same port. So it's look good to me, and here finally it's looking fine. We have our background color, we have our white text. So far things are looking good to us, and we are ready to start. Bring the terminal down. Now come back to the Figma community, and we need this icon. Remember that this is the icon, this is the logo we are using in our application. So we're going to take that icon, actually our logo. So let me zoom out and let me show you how you can extract. Simply click on this, and you can easily able to navigate to that icon. Okay, so I can click on this. Inside that I have this icon. You can see I can easily able to select, and this is the complete icon, and from here I can easily able to export the icon. So I can have a preview. So this is how the icon would look like, and from here I can easily able to export. But I have already exported all the icons and the images which I'm using in this project. So I'm going to simply import the folder. So this is the original project which we have already completed, and I can simply come here and I'm going to simply drag and drop the folder. So let's bring that file. From here I can simply able to drag and drop this asset folder, and that we have all the images. Simply copy the folder, and if I open that, you will find all the images which we have in this. So arrow up we have, arrow we have, and you can see that's tiny arrow, and we have the cross, we have the ether logo, home icon, and lock icon, we have search and swap. So this is our logo, and I have imported all the images in this index.js. Don't need to worry, I will provide this folder in the starter file, so you will have the images and all the setup. So here in this index file I have imported all the images one by one, and I'm making a default export. So that's the only thing I'm doing here, and this is the default export. So simply close down. So we have our images, we have our folder and file structure, we have our coloring, so everything is done. Now we can start working on the application, because we should always start with setting the entire environment, and after that we can start building. So now what we can want, let's come here and we can go to this index, and here we are. Here in the app.js I'm going to import the navigation bar, because navigation bar is going to be in every single page. So let's import the navigation bar. I'll say internal import, and this navbar is coming from our component dot slash component slash index. So this is our navbar. Simply come here and paste here. So our navbar is set. If we save and come back to the application, you can see we have our navbar and the home. Things are looking good to me. Come back to our code editor. So we are done with the setups. So this looks pretty fine. Close this one, and now we can go back to the component and we can start with navigation first. Click on this navbar, go to this navbar.jsx, and let's start writing some JSX. So first thing, we have to import couple of things from React. So it's gonna be use state, use effect, and use context. Although we're not going to use this use context right now, but it's better to import it, because this use context will need when we'll use the React context for sharing the data, okay, for our state management. So just follow along with me. We have this three thing from React. Let's import the image that's coming from Next and import the link. So these are the three external import, and let's do a couple of internal import. So import internal, and we need to import the style file for the navigation bar, and we have to import the images. So that's how I'm importing the image. I'm importing the entire image folder, and that's the image I have. And now I have to import the component which I'm going to use. So I need to use model, and I'm going to use the TokenList component, and that's coming from the index. Actually we are in the component folder, so it's coming from the index file as well. So these are the two components we are using in the navigation bar. Looks good to me. So we have our internal and external import. Let's come down, and here let me take the menu. All together we are displaying three menu. So let's take menu item. It's gonna be an array of object. So the first one is going to be name, so I'll say swap. The second is link, and let's come down, simply replicate this 3 times, because we'll have 3 pages, and this will say tokens, and this will say pools. So we have to add a lot of functionality. We want to make it 100% decentralized, like a Uniswap. No centralized authority going to provide any transactions. Everything would be done or through the smart contract and the blockchain. So I'm very excited, because it took me a lot of time to design the entire architecture of this application, to explain you in an easier way, and to teach you more concept and how you can build your own. So that's the entire menu we have for our navigation. Let me give this command use state, and here I'm going to take a use state, and this will call, let's say, open model. Initially it would be false. So that's the model. We have taken another use state, and this will call open token box false. So that's the external, that's the internal, and these are the use state we have. So we are done with the setup, and now we can start working on the JSX part. So we come here, remove this one, take a div. It will have a class called style.navbar, and that's how we're going to assign the style, because we are using Next.js, and in Next.js this is how you have to denote your style classes. You have to use the style keyword, and you can call the class name, so NavBar. I believe that this is nothing new to all of you. The same structure we have followed in our NFT marketplace, in our chat application, in our ICO. So let's take another div. It will have a class called style.navbar-box. In that, we're going to take another div. It will have a class called style.navbar-box left. Inside that, we're going to take another div. It will have a class called -navbar-box right. Actually, I remember that I have put inside the left. So simply do one thing, select this cut and bring it up and paste here. So here we're going to say left, this one is right. So let's save it and let's have a look in the browser. You can see everything is working fine. We have left and right and home. So things are looking good. Let's come back here and we're going to remove this and we're going to write some code in our left section first. So first we're going to take a div. It will have a class called style.navbar-box image, left image, and we'll have the image source image Uniswap, and we'll have this alt logo. We'll have this width 550 and height 50. So that's how the image would look like. So that's the image we have. Let me give this comment because it's very important that you should always provide comment in your JSX part, that what the JSX stand for. So we have the logo. Let's bring this down. We'll take the menu items, and here I'm going to take a div. It will have a class called NavBar box left menu. In that we're going to have the menu. We have our menu items. We're going to use this map element I, and we want to instantly return this one. We'll take a link tag, and so we have imported this link tag. That's look good. Let's bring this down and we'll take the key I+1. We'll take the href and we'll say path $, template literal, and we have to provide the name. So element.name. So we have the name and we have to send the query as well. So in the query we're going to send this element.link, which we have. So that's our link. Look fine so far. Now in this we're going to take this p tag and it will have a class. It will have a class called NavBar box left menu item, and in that we're going to display the menu itself. So link.name, and in that we have the name of the item. Looks good to me. Everything's looking fine. If we come here in the application, you can see we have our swap token and pool. If you click on this, our router is also working fine. We can easily able to redirect to the token page, which we don't have. That's why you can see 404. Click on this token, we don't have this one. Click on pool, we don't have that one. So simply come here, remove this one, reload the browser, remove this and hit enter, and we are back. So our router is also working absolutely perfect. Things are looking good so far. We have all these menus. Let's come here and now we can start working in the middle section in the search bar. So let's come here. Let me try this right section. And actually we need to have a middle section. So what I can do, I can simply type middle and I can replicate this one and this will become middle. I have to change the name of the class middle, and let's start working in the middle section. It's actually going to be the search bar. So right now we are just building the layout, but we're going to add the functionality so the user can search the tokens. We'll take a div. It will have a class, and the class name we want to provide NavBar box middle dash search. Inside that we're going to have a div. It will have a class called NavBar box middle search dash image. In that we will take the image tag Next.js, and we have to provide the source, and this image is coming from the images which we have imported. Inside that images we have the search images. Okay, we made a default export, that's why we can easily able to use in this way. We have to provide the alt name, search width is going to be, let's say 20, and height is going to be 20. So looks pretty good so far. Let's come here. We have to provide the input section, and here we're going to take a input, normal input. It will have type, and type is going to be text. We have to provide the placeholder, and it will say search token. So we have our input, or we have our images. Things are looking good to me. Let's come down. Let's start working on the right section. So this section is going to be pretty huge. So let's start working straight away. Remove, and we'll take a div. It will have the class. We'll say NavBar box right box. Inside that, we're going to take a div. It will have a class called style NavBar box right box, and it will say, let's say, image. In that, we're going to have an image. We have to provide the source. It's ether, all tags, network, and we have to provide the height. So height is going to 30 and width is going to be 30 as well. We'll come down, we'll take a p tag, and in that we're going to type the name. So we're going to do this hard code for the time being, network name, but we're going to make this dynamic. So that's the right section, and right section is also divided into section. We'll take a button, and it will have a on click function. And so right now we don't have the function, so let's make an empty function, and we want to give the name to this button. Let's call it address for the time being. So that's the button we have. So everything's looking good. So we have the search icon, we have the input, we have the ether logo, network, address, and home. Things are looking good so far. Now what we can do is, let's come here, and we're going to take the dynamic block, because we have to show the logging option. So we have to show the MetaMask connect wallet, so user can click and connect. So let's take a open model. So this is the use state we have already taken, and we have to say that if open model is true, then we have to display this component. If it's false, then we have to hide this component. So we'll use this model, and in that we have to send couple of props. So set open models, because in the model section we will have a button which will hide this model. So that's why we are using this set open model. We'll say set open model, and we have to set the connect wallet function as well, but right now we don't have. So for the time being, I just simply send this text message string. So that's the model for connecting from the wallet. That's one model we have, which we have to build. Let's come here, and now we have to work on the token list component, in which we're going to list all the token which user have in his wallet. So let's come here, and we're going to take this open token box. If it's true, then only we want to display this component. So here we're going to call the component, and in this we're going to pass couple of data, couple of props. So the first prop, we have to pass the token data, exactly that, how many tokens we want to render. So the token data itself. So right now we don't have the token data, so let's pass a string hey. Now we have to send the props, because we want to close this model as well. So let's send the props for that as well. That looks good to me. So these are the complete JSX part for writing this entire navigation. So this is the external, this is the internal we have, this is the navigation menus we have, this is the use state we have, and this is the entire JSX part we have written. So this is the logo section, this is the entire menu section, this is the middle sections, right sections, and the model component and the token list component. So hope everything is clear so far to all of you. So I believe that you guys have understood whatever we have done so far in our NavBar. And now what we can do, we can start styling the navigation bar straight away. So let's come here, go to this NavBar module.css. Let's make it side by side so you guys can see what we are working and what we are exactly styling. So whatever JSX we have written so far, that's how it's looking on the browser. And now we're going to turn it something beautiful. So we have our NavBar, and we're going to assign the width is 90%. We have to assign the margin to RAM and auto, so we'll have some space from top and bottom, and we have to target the NavBar box, and we have to assign the display grid template column repeat 3 1FR, because we're going to divide the entire navigation in 3 parts. First, the left hand side, the second one is the middle section, and the third one is the right hand side. We have to assign the align item is going to be center, so that will keep everything in the center. Justify content is going to be, let's say, space between, so all the 3 section will have space from each other. We have to assign a gap, so 1 RAM. So that's how it will look. I know that's looking quite weird, but we're going to make it something beautiful. Come down, we have to target the navbar box left, and let's make it display flex. We have to provide a gap 4 RAM, and we have to provide the align item center. That's how it will look. Come down, left menu. Let's say display is going to be flex, align item center, gap is going to be 2 RAM. So that's how it will look. Looking pretty good. Now let's come here. We have to target the left menu item, and font size is going to be 1.2 RAM, little big, and we have to assign the color to our. So this is the color code which I got from the design, CFF80B. So that's the color for the text, looking fine to me. And from here I got the color. If I open it, and this is the color which I'm using. Okay, looking fine. Come back to the code. Let's come down, and we have to target the, let's say, navbar middle sections. We have to say background is going to be our primary color, so 1E 1E 1E. So this is the primary color we are using. We have to assign the width is 80%. Padding is going to be 1 RAM and 0.5 RAM. Border radius is going to be 0.5 RAM. Let's provide margin 0 auto. Everything will be, that will hold everything in middle. Let's come down. Now we have to target the navbar middle search. It will have a display is going to be a flex, justify content center, and align item center. Gap is going to be 2 RAM, and cursor pointer. So things will be in the middle. Come down. We have to target the middle. We have to target the input. First thing we have to say background is going to be transparent. Remove the outline, none. Remove the border, none. And we have to set the font size to 1 RAM. Color is going to be our second primary color. We have to target the navbar box right. And that's how it will look. We have our left side looking good. We have our menus, and we have our search bar in the middle. And now we have to work on the right hand sides, this part. So let's make it on 335 pixels, 320 pixels. First thing we have to target display is going to be a flex, align item center, justify content, end, and gap is going to be 1 RAM. Navbar box right box, display is going to be flex, align item center, gap 1 RAM. Background color, our primary color, padding 1.5 RAM and 1.5 RAM. We have border radius 0.5 RAM and cursor pointer. Text transformation capitalize. That looks stunning. Let's come down. We have to target the navbar box right P. Font size 1.2 RAM. Line height 0. Color is going to be our second primary. And that's how it will look. Come down. Navbar box right button. Background color is going to be primary 1, border none, outline none, and color our second primary, and border radius 0.5 RAM. Padding 1 RAM, 1.2 RAM, and 1.5 RAM. Font size 1.2 RAM, cursor pointer. Display is going to be flex, align item center, gap 1 RAM. That's how it will look. Everything's looking pretty beautiful. Let's make on a full screen, and that's how it will look on a desktop. So we have our left, middle, and the right side. All these data are static type, but we're going to make it dynamic. So that looks pretty good to me. Let's make it inspect element, and let's start working on the responsive. Add media query only, and we'll say max width 35 EM. We'll target the navbar. Width is going to be 90%. We'll target the navbar box. Grid template column 0.5 RAM and 1 FR. That looks pretty good. We have to target the navbar box middle, display none. And we have to tab bar the menu and display none. So that's how it will look. And actually I don't want to display the network, that which network user is connected. So let's hide that part as well. So let's come here. We have to target the NavBar right box, and we have to still display none. So that's how it will look. On a mobile device, we want to display only the icon and the addresses. So things are looking good to me, pretty good. And let's check on the breakpoints. So it's pretty good. We're going to do a lot of things in this. So for the time being, that looks pretty good. For the time being, I'm not displaying the menus because the menu is not ready. Okay, so when we build the menus and the pages, on that time we're going to worry about the menu. For the time being, let's go like this. So we are done with the CSS part. Simply come here and close this one. Now we have to start working on the model section, because on the model section we'll have the options for the user, so user can connect to the MetaMask or any other wallet. So altogether we are displaying 3 options, and that's what we're going to design inside this model. So come here inside the model, and here you can see we are done with this part, and that's how it will look on a browser. So in this model we are sending couple of props. So we are sending set open model, and we are sending the connect wallet function. So simply click on this, and this is the setup. Now we have to import couple of things from React: use state, use effect. We have to import the image, and we have to do the internal imports. We have to import the CSS file, and that's coming from the same directory. Now we have to import this assets, all the images, and that's coming from the assets folder. So this is nothing new. We are following the same old school. That looks pretty good. And here, let's come here. We have to give this import couple of states. Let's take couple of variables. So we'll say const wallet name. So altogether we are displaying 4 types of wallet. So let's take it as an array. So first one is going to be MetaMask. Second one is going to be Coinbase. Third one is going to be wallet, and the last one we have is wallet connect. User will have to connect to. So that's the menu we have. Now these are the props we are sending into our model component. So simply copy and paste here. You should always, whenever you receive props in the model, make sure to use this bracket. If you don't provide this bracket, it will throw an error. Okay, so make sure to provide the bracket, and in that you have to import all the props which you want to receive. So let's come here. We have to receive this prop as well. So these are the true props we are sending for the time being. Don't need to worry about the functionality. Once the functionality is ready, we're going to simply plug the functionality and everything would be working fine. So let's go like this. Now we have to start working on the JSX. So we'll take a div. It will have a class called style model. Inside that we'll have another div. It will have a class called style model dash box. Inside that we'll have another div. It will have a class called style model box heading, and in that we're going to display text. So connect a wallet, and down below we'll have a div. It will have a class called style and model box heading image, and it will have the image of the, so I'll take the image source image, and I have the image close, and this will say alt. So generally this one is the close one. It will have an on-click function, so whenever we click on this model will close. And we have received this prop, and we have to set false. If it's true, then the model will open. If the model is true, then if we click on that cross button, it will turn to false. So that's the prop we are utilizing here. Let's come here, and that's the one we are using in the model. And here you can see initially we have assigned the value to false. So if someone will open, it will turn to true. And when it will turn to true, that means that the model is open, and when someone will click on the cross button, it will close. So that's the entire logic we have here, and that's what we have learned. So things are looking pretty good to me, and we're going to take another div. It will have a class called style dot model box wallet. Inside that we're going to take the menu variable, the array, and we're going to simply loop over it element I, and we want to have instant return in the P. So it will have a key, and it will have an on-click functionality, and in that we're going to call the function which we have received, connect wallet. So right now we don't have the function, just call it like it. It will not create any problem unless or until you will not click on that. So that's working fine, and here in that we're going to display the name of the wallet element. So that's how it will look. Things are looking pretty good to me. No more problem we have here. Let's come here. We have to take a p tag. It will have a class called style model para, and in that I'm going to simply paste the text. Paste. So this is what I have copied from the original Uniswap website. The text, you can get it from there as well, or you can pause the video and you can simply write. So that's the entire JSX. Let's add the break so it will look nice. So that looks pretty good to me. So far we are doing pretty well. Come here and let's come back, and now we have to simply to see that how the model is looking on the browser. We have to turn it to, currently it's false, so we have to provide this exclamation mark. This will turn to true, and now we can easily able to see that model. You can see this is how it look, token list, but this is not what I want to display. Simply remove this one and do this spawn. Okay, we have to simply call this, and here we have that. We have the connect wallet, we have the button, we have the providers and the paragraph. Things are looking good so far, and now we have to style this component. Now come back here and we have to simply select this model component and come back and go to this model, open the CSS file and make it side by side, and we can start working on the CSS part as well. Things are looking pretty good to me. We have to model and we can say positions absolute, insert 0%, 0%, 0%. Background is going to be our primary color. But we have to provide the opacity 5A. Display is going to be grid, align item center, justify content center. Height is going to be 100 VH. Width is going to be 100 VW. And we have to Z index, so it will be on top of everything. Model box, background color is going to be our primary color. Padding 2 RAM, border radius 0.5 RAM. That's how it will look. Model box heading, display flex, align item center, justify content space between. Model heading P, font size 1.2 RAM. Model box wallet P, background color our second primary color. We have to assign the padding 1 RAM, border radius 0.5 RAM, color our primary, and font width is going to be 700 and cursor pointer. So that's how it will look. You can see it's looking pretty beautiful. Come down, we have to target the model box para. Padding is 1 RAM, line height 1.2, border 1 pixel solid, and it will have our second primary color. Border radius 0.5 RAM, so that's how it will look, pretty good. Now you can't close it because to close it you have to make it true. So that's how it will look. This click is not working because we have hard coded the value. So to make things work, we can come back here, go to this navigation, and here you can see that we have used this exclamation. So all we have to do is to simply remove this one and save it. Come here and click on this. Okay, this one is not working. Okay, my bad. Actually, I'm not calling the function. So you can see the address is blank. So here we have to call the function. Actually, the state, simply copy this one. And the same thing we have to call it here. So when someone will click on this address, we have to make our state true. Initially it's false, so we have to turn it to true. So this will open the component. Click on, you can see it's working fine. And if you click on this, you can close it. Open, close, open, close. It's already looking beautiful. Let's do the inspect element and see the responsiveness. So that's how it will look on a mobile device, 100% responsive. And that's how it will look on a desktop. Looks pretty awesome to me. Simple, sweet, but powerful. You can close it, you can open it. Now let's come back to the code, and I guess we are done with this model. This looks pretty good to me. If we find that we need to add anything else, and obviously we have to add the functionality. Right now it's not doing anything, but we're going to add it. So simply close this one, and come back to the navigation. And here we have to create this component as well, TokenList. So let's quickly start working on it. Simply come here, and here we have to receive the props, so the data, and we have to receive this one as well. So these are the two props we are receiving, and now we have to receive a couple of things from React. So let's come here. So let's import the image, and let's do the internal import. We have to import the CSS file that's coming from the same directory. We have to import the entire images, and that's coming from the assets folder. So those are the external and internal imports we have. Now let's create a couple of variables. So data, and this will say 1 2 3 4 and 7. So right now we have no data which we can use to render the token list, that how many token a user have in his account and how many types of token he has. So for the time being, just for the designing purpose, we are going with this demo array, but everything we're going to make it dynamic. So let's come here, let's start writing the JSX. We'll take a div, it will have a class called style, and it will call token list. Inside that we'll have this p, it will have a class called style dot token list dash close, and in that we're going to have an on click function, and we're going to call this set open token to false, because when someone will open this model means our open token is true, and we have to turn is false to close it. So that's the logic, and here we are missing the arrow. Let's provide it. So that looks pretty good. Now in that we're going to simply provide the image. So we have to provide the close images, all tag, we'll say close width, and we have to provide the height as well, 550. That looks pretty good to me. Now come here, we have to take a div, it will have a class called style dash token list dash title. In that we're going to take this h2, we'll say your token list. Looks pretty good. We have this h2, and down below we're going to render the entire token. So right now we have taken the demo data and we're going to use it for time being. So we have that array, we're going to loop over it element I, and it's a string return, and we're going to take a div, it will have a class style dot token list dash box. It will have another div, it will take dot token list box info. Inside that we'll have this p, and we're going to provide this class style dot token list box info symbol, and inside that we're going to provide the text hey. Right now we don't have any data for the symbol, so right now we are going with this hardcode value hey. We'll come down, and here we're going to provide this span, and inside this span we're going to provide that how many token a user have. So let's do hardcode, and we can provide the coin name, the token name itself. So that's the entire demo dynamic data, and you can see right now nothing is happening. So to see things are looking good, we have to come here and we have to turn this to true, because right now it's false. So make it true and save it, come back, and here you can see we have the list of all the arrays. So altogether we have taken the 7 array, and it's rendering 7 times. We have the name, we have the icons, and we have the name, and everything's looking pretty good to me. So pretty good. Come back to the code and simply do side by side, and we can start working on the CSS. Let's bring this side and come here, and we have to grab the class, and let's come back to the token list and the CSS file, and now we have to target that. So we'll say token list position is going to be absolute, because we want it to be on the right hand side, not on the left hand side. So position absolute, width is going to be 20 RAM, border radius 0.5 RAM, background our primary color, margin top is going to be 2 RAM, margin left is going to be 66.4 RAM, and padding is going to be 1 RAM. So that's how it will look. It's far on the right hand side, but we're going to make it responsive for the time being. So make it on a full screen. So that's how it will look on our desktop. And you might be wondering that from where I'm getting these numbers. these numbers are not magical because I have already built this project and I found that which value I have to put for placing the div and the boxes. Okay, so we have the main token list, and now we're going to work on the other one. So we'll target the token list title. Width is going to be 100%. Padding is going to be 0.2 RAM and 1 RAM. Font width is going to be 900 and line height is going to be 0. Cursor color, it's going to be our second primary color. We have to target our font size 0.8 RAM. Border radius 0.5 RAM. That looks good. Let's come down. We have to target the close button itself. And this time we're going to say position is going to be absolute. Right is going to be -1 RAM. Cursor pointer. Top is going to be -2 RAM. Z index on top of everything. So that's how it will look. Pretty good. Come here. Target the token list box. Position relative. Cursor pointer. Border bottom 1 pixel solid. And we have our this light color. It's actually a second primary color, but I have added the opacity 53. That's how it look. Let's target the box info. Display is going to be grid template column 1FR 5FR. Cap is going to be 1 RAM. Align item center. That looks pretty good. Come down. We have to target the box info p span, and font size is going to be, let's say, font width is going to be 900. Color is going to be our second primary, and I want to provide some space from the right hand side. 0.5 RAM would be enough. Okay, that looks good. Come down. We have to target the box info symbol, and background color is going to be primary color. Padding is 0.5 RAM and border radius 0.5 RAM, and we'll have our color to primary, and font width is going to be 700. So that's how it will look. It looks already beautiful. You can see everything is working fine, and don't need to worry that this data is going to be dynamic. Once you will log, and it will fetch all the data from your MetaMask and it will display. So that looks pretty good to me. And okay, so we have our symbol. Let's check the responsiveness. This is how it will look on a mobile. And now let's add the media query. So let's come here, and I can go back into the NavBar, and we have written already media query. So I'm going to simply copy this one and come back, because this is the breakpoint I'm going to use in the entire application. So that looks good. Simply come here, copy this one, and we have to first, what's the width we have provided? So we have to set this margin left to 0. That looks good. Let's say -1, 0. 0 is better. 0 is better. Now we have to take this one, token list close, and we have to adjust the placement of this. So we'll say right is going to be 1 RAM, so it will come on this side, and we can easily move to 2. That's how it will look. And here we have the width. So simply copy that one and paste, not here, we have to paste here. And the width I want is, let's say, 90%. So that's look good. 100% responsive, and that's looking pretty good. Now what we can do is close this one and come here. So that's what we have. Now turn this one, remove this and save it. Right now you can see we don't have, and that's how it will look. And right now we are not connected, there is no account, so this is the one which is displaying, because we haven't written any logic for the account on which we're going to build the logic. So when a user is connected, then on that time we're going to display this token list. But if the user is not connected, we're going to display this connect wallet option. Actually we don't have the address, so that's why we can't able to do anything like that right now, but everything will work fine. So if I provide this, so this is the button where we're going to attach the functions for closing and opening both the models. So let's change, this is the function we have here, and that's how it will look. And let's come up here, and what I'm going to do is, so if I turn this to true, if I click on this one is also opening, and Okay, let's remove this one, save it, and you can see right now it's opening. Remove this, save it, and if I turn this to false, if I click on this, this is how it will open. And right now it will not opening here. We can full the screen. So things are looking good. Everything's working fine. We have successfully designed our component. We're going to build that logic because right now we don't have the data. So right now we can't able to build the logic. Although we can do that, but we have to write a lot of custom codes, which I don't want to do it. Let's come here, and now we can start working on the other component as well. So this is the model component we have done with the NavBar, we had done with the token list. So 3 component is already done. Now we can come here and we can start working on the hero section. So click on this, and this is what I have so far. Come here and go back to the pages, and in the pages we have to import couple of things. So we have to use the use state, use effect, and use context. So these are the 3 things coming. Now we have to do the internal import, and we have to simply import the hero section, the component, and that's coming from the component index. So we have the hero component. Now what we can do is, let's come here, we can take a div. Inside the div we're going to call the component, and all the data we're going to share right up here. Okay, first we'll receive the data in the index page, and we're going to send as a prop in our hero section. So let's send a couple of props. So we have to send the account because we have to build a logic around this, and right now we don't have, so we are sending this text. We have to send the token data, that how many tokens user has, and last now we don't have the data, so just send the text. And now let's receive this prop, receive the props account, and we have to receive this token data. So that's the setup we have to do, and now we can start saying that this is how the hero section would look like. You can see everything's looking perfect, no error we have here. Now we have to import couple of things from React, use context. We have to import the image, and we have to do the internal import as well. So import style from same directory, and we have to import all the images, and that's coming from the assets folder. Now we have to import the, let's say, component. So first the component we need is the token component. We need the token search component, and that's coming from the, let's say, index. I believe everything's looking fine to all of you guys. If you have still any confusion, or if you haven't subscribed and like my video, please do that. That will help me a lot. And here we're going to take the states. So first thing, we need the open setting. Initially it will be false. We'll take the another one, open token false. We'll take the use state, and this will say open tokens 2, and this will be also false. So these are the 3 states we have taken, and now we have to take 2 more states for the token. So there's token 1, and this will be an object. So we'll say token 1, and in that it will have the name. Initially it will be empty, and we'll have the image. So when someone will select the token, we want to fetch the data and we want to display. So this is the token 1, simply copy and paste token 2, and we have to change the name to token 2. Come here. Now let's start writing the JSX. Take a div, it will have a class called style hero section. Inside that we'll have another div, style hero section box. Inside that we'll have another div, it will have a class called style dot hero section box heading, and in that we're going to take a p tag. It will say swap, and it will have a div. Inside the div we'll take the class, and the class we want to say heading image, and in that we're going to display the image. So we have the source, we have all the images in this close, and we have to provide the all tag. Let's say image width is going to be 50 and height is going to be 50. So this one is going to be our close button. So let's add an on click function, and we have the props. We'll say set open setting to true. So when someone will click on this, it will open the model in which the user will have the option to select different tokens. So let's provide this equal sign. Now things are looking good. Let's come down. We'll take a div. It will have a class called style hero section box input. Inside that, we'll take this input text, and placeholder is going to be 0. We'll take a button. It will have a on click function, and the function we want to call is this set, and that's what we're going to call it, and we're going to say true. In that, we're going to take this image, and we will have this image. If we have the image, so display the image. If we don't have the image, then we have to display this default image, which is a Ether logo. Hope this makes sense. So when we'll have the data in the token 1 or in the token 2, then we're going to display that. Otherwise, we'll display this default image. It will have a width 20, height is going to be 20, and we have to provide the alt as well, Ether. So that's the image component we have. Image. We'll take this dynamic block. We'll say to token1.name. When the user will select the token in the 1, this will get updated. So if we have the name, to display the name. If we don't have the name, then display the default name is Ether. So that's the entire logic. And here we're going to display that price, how many token the user has. So right now we're going with this hardcode value. So that looks pretty good for the token 1. And what we can do is simply come here, copy and paste, because we need to have 2 input. Then the user can swap the token. So that looks pretty fine to me. Let's come here, and here we're going to say token 2. And here we have to, let's say, here we have to do the changes, token 2 as well. That looks good to me. Now come down, account. If we have account, then we want to display this button. Okay, so let's come here, and we have to display a button. So here we're going to take a button, and in this we're going to have a class, and we'll say hero box button. We'll say connect wallet if there is no account, but if we have account, then we want to display different button. Okay, simply copy and paste here, and that looks pretty good to me. And here it will have on click functions, and the function we want to call, actually we don't have the function right now, so just set this empty functions for the time being. So once we have the function, we all going to do is simply attach the function in this button so the transaction can happen. And this looks good. And we have to change the token to swap, so the user can swap the token. And that looks pretty good to me. And that's the entire JSX part. Actually, we need a couple of more, because when someone will click on the, we have to display the like tolerance, so the user can set the deadline and the model. Okay, so let's start building that part first. We'll say open setting. If we have the open setting, then we want to display this token in which we have all the tokens. Okay, so let's send the props. So we want to send this open setting, so we can close this model. We have to take another one. We'll say open token. If it's open, then we have to call this search token. Now let's call the search token component. From the user can search the token, and in that we're going to send a couple of props. So first one is going to be the open token, and the other one is going to be the data of the token. Right now we don't have, so let's call it token. And right now we can simply come here, let's call it tokens. Let's set this, let's call it set token 1, and we have this token data. Right now we don't have the data, so we are sending this one. So that's the first token, and we have to do one more second token as well. Simply copy this one part and replicate this one, and here we have to change do the change. So we'll say set open token 2, and here we're going to set open token 2, and here we have to do the changes as well. So it's not only open token. I believe that you guys have spotted the error. So that's looking pretty fine to me. We have 2 dynamic block in which we are storing the data of 2 different token which user want to show up. So that's the entire JSX part for this hero section. Is looking pretty good. Let's reload the browser and you can see that's how it will look. We have the swap, we have the image, we have the input and the hardcode value and the button itself. So that looks pretty good. No more error we have, and now we can make it side by side so we can start working on the CSS part. Let's do the inspect element, make it side by side, and from here I can grab this search, hero search, so we can target and start styling. And let's target that width. Let's assign the width is going to be 90%, margin 2 RAM auto, display is going to flex, align item center, justify content center, position and relative, hero section box, margin top is going to be 5 RAM, background color is going to be our primary color, we'll have our padding 1 RAM, border radius 0.5 RAM, width is going to be 30 RAM. Let's come down, we have to target the box heading, display is going to be flex, align item center, justify content space between. I'm going a little faster for the CSS because we are following the same structures, same syntax, same variables. So that's why I'm going a little faster here. If you guys think that I'm too fast, then you can simply adjust the speed from the setting. Okay, so let's target that. We'll target the hero section input, and display is going to be flex, align item center, justify content space between, border 1 pixel solid, and we'll have our second primary color, border radius 0.5 RAM, padding left is going to be 2 RAM, margin top 1 RAM. That's how it will look. Come down, we have to target the hero section box input import itself. Border is going to be 0, outline 0, background color transparent, color second primary, font size 1.2 RAM, and that's how it will look. Let's adjust the width, and that looks pretty fine, but we have to make it responsive for all the devices, and that's we can do it very easily. So let's come here and we're going to target the box input button, display is going to be flex, align item center, justify content space between, gap is going to be 1 RAM, line height 0, background color our second primary, padding 1 RAM, font width 700, font size 1.2 RAM, border radius 0.5 RAM. That's how it will look, pretty beautiful. Let's come down and target the hero section dash box button, background color our second primary, border 0, outline 0, width is going to be 100%, margin top is going to be 1.5 RAM, padding 1 RAM, border radius 0.2 RAM, 2 RAM, font size 1.2 RAM. That's how it will look. Let's come here, target the media query, so only, and max width is going to be 35 EM. So hero section width is going to be 95%. Target the hero box, and this will say width is going to be 95%. Okay, that's perfect, and we have to adjust the input width as well. So let's target the input itself, and the width that we want to set is, let's say, 50%. So now it looks pretty good. You can see that looks perfect on a mobile device, and that's how it will look on a desktop. So we have the icons, we have the input, we have the balance and the ether. Here we are sending the props and receiving the props. And actually we haven't created this token component, so this one is not we have created. So let's quickly create that one. Okay, so let's come here and create another component. Create a folder called token. We have to create the JSX file, and we have to create the CSS file as well. Click on this and create the CSS file, module.css, and that looks pretty good. And if we come here back in the token sections, and here we are sending this prop open setting. So simply copy, and that's what we have to receive here as a prop. And now we have to receive couple of things from the React as well. So use state, use effect. We have to import the image. We have to do the internal import style, that's coming from the same directory. We have to import the images, that's coming from the asset folder. We have to import couple of components. So we need to import the toggle button. So when someone will click, it will go to left to right. That's the button we are creating. And say from, and let's say it's coming from the index, and that's the internal import we have. Now we can start working on the JSX. So let's take a div. It will have a class, say, let's say token. Inside that we'll have another div. It will have a class called style.token dash box. We'll have another div. It will have a style dash token box heading. We'll have a h4, and here we're going to type our text setting. We'll come down, we'll take our image, we'll say images.close button. It will have the alt tag, close width 50, height 50, and it will have an on click function. So this will allow us to close the model. So we'll say this is what we have received. Simply copy, come here, and we are calling this open setting. And actually we didn't need to, we have to call this set open setting. We have to call, simply copy this, and we have to set this, change this to open setting, not set open setting, not only open setting. Okay, so simply copy and receive the right one, and that's the one we're going to call it here. We'll say it false. So that's our close button we have, looking fine. Come here, we'll take a p. It will have a class called style dot token box para. In that we're going to take this slippage tolerance, and down below we're going to take this image, and we want to display the image of the lock. It will have the alt tag image, width is going to be 20 and height is going to be 20, pretty small. So that's the slippage tolerance. Let's take a div. It will have a style, it will have a token box input. Inside that we'll have a button, and it will say auto, and down below we're going to take the input, and this input will have a text type placeholder 0.10%, because that's what I want to set as a percentage. You can set it something high, but this I'm going with the 10%. Okay, 0.10%. So that's the input we have. Now we can come down, we can take a para, and it will have a class called style box para. Actually we are repeating. Simply do one thing, simply copy this part and replace this with, because we going to need the same thing, we can only change the text. So lock would be there, and we have to, the snippet orange is also there. Okay, so right now I'm going with this text, but we're going to check it. Simply copy this part as well and simply paste here. So this is the two input field we have, copy, cut and paste here, and change the text, because this is what we have in the design, and this is going to be 30. So that looks pretty good to me. This looks pretty decent. And now we're going to take this h3, and then that's, we'll say interface setting, and we'll take a div. It will have a class style dot, we'll say token box toggle. In that we're going to take this paragraph, and we'll say style token box, and in that we're going to simply type our text transaction deadline. So that's the one we have. And now here we're going to call the toggle component itself, and that's the entire JSX part for this token. We haven't written any code for the toggle, but we're going to create that as well. So let's come here and come to the browser, and if I click on this, you can see I am getting this error message. Refresh, and I know why I'm getting this error message, because we have created this component, token component, but we haven't imported that, and we are using straight away. So if I turn this on, I'll get an error. You can see I'm getting that error because I haven't imported the component, token component. So that looks pretty good to me. That's the only error I have. Come here and we go to into the index.js, and here we have to import the token component. and we have to export that. Simply copy and we have to simply export it. If you save it, come back, and right now you can see we have the token component and our click function is also working. Close, open, close, open. It's working fine. Now we can start styling that part. So let's do the inspect element very quickly and come here, go to this index, close this one, and here we are. Copy this hero section and we can start styling that part. Simply come here and things are looking good to me. So we have to start working on the token itself because we have done the hero section. So let's start working on the token style part. Come here, go to this where it is here, and we have to target the token, make it side by side. First thing is going to be position absolute, margin 0 auto, background color is going to be our primary color, and padding is going to be 2 RAM, border radius 0.5 RAM, and width is going to be 13 RAM, and height is going to be 25 RAM. So that's how it will look, pretty good. Let's come down. We have to take the token and box heading. Display is going to be flex, align item center, justify content space between, token box heading 2, font size going to 1.2 RAM, line height 0, token box para, display flex, align item center, gap is going to be 1 RAM. Let's come down. Token box input, display flex, gap is going to be 1 RAM, align item center, token box input button, background color is going to be our second primary, border 0, outline 0, padding 0.5 RAM and 1 RAM, border radius 0.5 RAM, font size and font size 1 RAM. That's how it will look, pretty good. Target the token box input, color transparent, border 0, outline 0, width is going to be 80%, and border is going to be 1 pixels solid, and it will have our second primary color. Padding is going to be 0.5 RAM and 1 RAM. Border radius 0.5 RAM, text align end, and cursor pointer. Actually, that looks pretty good, but I don't need the cursor. Simply remove this one, and that looks pretty good. Okay, so let's come down. We have to target the token box toggle, and display is going to flex, align item center, justify content space between. That's how it will look. Now let's add the media query only, and max width 35 EM, token width is going to be 100%. That looks pretty beautiful, and that's the token width we have. We can open, we can close. You can see it's 100% responsive. That looks pretty good on our desktop. We can easily able to type the slippage tolerance. Right now it's not doing, but it's going to work. So that's the entire CSS parts looking pretty good, and here we can provide this color. So if we type, we can have the color in the input as well. Look good to me. And we can open, close. Things are looking good. Things are looking good to me. You can close. And now we can start working on the toggle section. So what we can do, let's make it inspect element. This looks pretty good to me. Close this one, and here we are, and that's the component we have. And this is the token we have. Inside the token we have this toggle. So let's click on this, and that's what we're going to work on now. So first thing we have to do is we have to import couple of things. So we have to do the internal import. We need the style file, and let's remove this one. We'll take a div. It will have a class called style dot toggle div. It will have another div. It will have a class called toggle dash switch. It will have this input type is going to be, let's say, check box, and it will have a class called style dot check box. Name is going to be, let's say, what we can call something like no, and we can provide the id. So we can take the, let's do one thing, let's take this label and simply copy this one and replace it with this label as well, and we have to receive that label as a prop. Okay, so let's receive that as a prop, and what we can do, we can simply come here and we can send that as a prop. So in the prop I can send the text to no. Okay, so that's the prop we are sending in the toggle, and that's what we are receiving, and this looks pretty good. Now let's take here another label, and here we're going to display the label. We have to take the class style and we'll call it label, and come here and we have to take the span, and here we're going to take the class is going to be, let's say, inner, and it's going to be, let's say, let's take a toggle inner, because this is the convention we are following. Toggle, let's do that for all the classes. Let's call it toggle dash label. This looks pretty good, and this one is going to be self-closing. Okay, replicate it and change this to switch, and that looks pretty fine. And that's the only JSX part we have to write for this toggle button. If we need anything extra, we can definitely come back here. So let's come here, copy this toggle class, and let's start styling on the CSS part. Simply click on this and make the things side by side so we can see what we are working on. So let's click on this and how it will look. Click on this, you can see we have our checkbox. That means everything's working fine. Now we can target that toggle, text align center, toggle switch. It will have a position relative, width is going to be 75%, display is going to be inline block, and text aligned left. Top is going to be 8 pixels. We'll come down, we'll target the toggle check box. Display is going to be none because we want to display our custom toggle. The second one is toggle dash label. Display is going to be block, overflow hidden, cursor pointer, border 0 pixels solid, and we have this random color. You can pick anything, no matter. So I'm going with this gray one. Now let's take this border radius 20 pixels. Let's come down, we have target the toggle inner. Display is going to be block, width is going to be 200%, margin left is going to be minus 100%, and we'll have the transition is going to be margin 0.3 second, easy in 0.0 second. Let's come here, we have to target the toggle dash inner before, and we have to target the toggle dash, and this is the after. And here we have to set the float is going to be left, width is going to be 50%, height is going to be 36 pixels, padding is going to be 0, line height is going to be 36 pixels, color is going to be our white, and it will have our font width is going to be bold. Box sizing is going to be border box. That looks pretty good to me. Right now you can't see anything, but everything's happening. So let's come here, and this time we can come down and we can simply target the toggle inner before. So earlier we targeted the together because we want to apply the styling, some common styling, and now we're going to target individually. So content type is going to be yes, before one is, we'll say padding left is going to be 10 pixels, background color is going to be our second primary, and color is going to be our primary color. What you can do is simply replicate this one, and you have to change this text to no, and that looks pretty good. Okay, let's come down, we have to target the toggle switch, and display is going to be, let's say, block. Width is going to be 24 pixels, margin 5 pixels, and we have the background color is going to be our this red color. We'll have the position absolute, top is going to be 0, bottom is going to be 0. Okay, that's weird. This is not what I want. Okay, we have done something wrong. Okay, right is going to be 40 pixels, and border is going to be, let's say, 0 pixels solid, and this random color. So something's wrong. Okay, let's write the code. Transition all 0.3 second, easy in, and 0s. That looks pretty good to me. Now let's come down, and this is okay. This is also okay. Let's comment this out, no problem. And we can target this toggle checkbox. Let's say checked. If it's checked, then we have to target the toggle label. We have to target the toggles, and this is called inner, and we have to say margin left is going to be 0. Simply do one thing, replicate this one, and here we have to do the changes. So instead of toggle inner, we have to say toggle switch, and this will also be changed. So we can say right 0. So okay, some problem we have because this looks weird. Save it, and if you click on this, our animation is working fine. You can see it's sliding beautifully, but there is some problem. That's working. What we can do, come here, and I can see the problem where it's happening. You can see I have assigned the same classes in 2 places, toggle switch and toggle switch, one for the div and one for the span. So what I can do, I can simply change this to toggle switch box. If you save it, copy and come here, and if I replace this one, toggle switch, and boom, you can see now it's looking fine. You can click, but it's not 100%. This is not what I want. And if I come here, and here I can see that it's 2. So let's change this one, let's make it 1. Maybe this could fix this one. Save it, and here we have to change this, not before, it's after. Save it, and you can see now it's looking pretty good. So you can see, but this is not what I want. Still we have to do some, and this one is right. We have to make it is left. Okay, you can see the before one is left, but we have to turn it to right. So we have to turn this to right. It's good, and this one is fine to me. And here we can define that. So we can say border radius, because we have to make it a circle, and it's now a square. So that's look good. We have this circle, and okay, that looks good. We have to do adjustment. Let's come back to the code, and I know where is the problem is happening. So that looks good. There's no problem in this code, in this area. In the label section we have, so this is the problem we have. And actually, my bad, it's percentage. We have to assign in pixels. Save it, and now it's look good. You can see, okay, we have to provide a little bit space. So let's come here, and here we can add that space. So let's say text alignment is going to be right, and now it's going to be good. It looks beautiful. You can see yes, no, yes, no. And if you do the inspect element, it's already 100% responsive for mobile device as well. And that's how our toggle is looking. This is how our custom toggle, open, close, everything's looking fine to this. You can type the tolerance, you can type the slippage, everything's working fine. You can check the media query, it's 100% responsive. That looks good. And now, okay, this is the problem we have to fix this one. Still we have this problem, but this far we have came, and everything's working fine. No more issues we have. Can we close this one, close this one? And now we can come back here. Now go back to the hero section, click on this hero section, and in the hero section we have this search token. Okay, so this is the only component is left where we have to display all the token in which user can select, and it will swap the token. Okay, so this is the search token we have. Simply click on this, and we have to receive the props. Although we are making this component as a reusable component because we are using in two different places. Okay, so we have to give the similar name. So simply copy this open token, copy this tokens, the data, and this is the data itself. And now we have to import couple of things from React. So use state, we have to import the image, and we have to do the internal import. So import style, and that's coming from the directory. We have to import the entire images asset folder, and here we're going to define a couple of use states. So let's give this comment use state, and we'll say active. So whenever a user will select any particular token, we have to turn that token to active. So it will be initially one ether, and we'll take a variable, we'll say coin. So right now we don't have the data, so let's take a demo data. So coin, and it's going to be an object. It will have the image of the token. So image.ether, which in the image we have all the images, and we're displaying the image. And let's give the name. So we'll say name, it's ethers, and simply replicate couple of times. Okay, replicate couple of times. So this is the entire our demo data which we have in the coin. Okay, so that's the demo data. Let's start working on the JSX part. Div class style, and we want to call it to search token. We'll take another div, it will have a style search token dash box. Inside that we'll have another div, it will have a style search token dash box heading. Inside that we'll take this h4, and it will say select a token. Well, down below we'll take this image src image dot close, because when our model is open, the search token component is open, we have to close it as well. Okay, so we have to assign that. So we'll say close, it will have the width to 50, height to 50, and it will have on click function, so it will close it. And we have that function here, open token, and that we have to send that to false. So that's the closing button. Now let's come down, we'll take a div, it will have a class called dash search token box dash search. In that we'll take a div, it will have a class search dash box dash search image, and we'll take this image. In that we have the images dot search alt, and width is going to be, let's say 20, height is going to be 20. So we have the images. Now let's come down, we have to take the input, so the user can type the token name and they can search, or they can put the address of the token and they can search. So let's do placeholder is going to be something like search name and paste address, paste the address. So that's the input, and here we're going to simply render the demo data. So that looks good. We'll take a div, it will have a class called style token box token, and in that we're going to use the demo data. So we'll have the data in this coin, we're going to map over it, element I instant return. We'll take a let's say small tag, take a span, and in that it will have a key. So active I+1, then we have to display this class. So it will take a template literal style dot active, else we want to display nothing. So I believe you guys have understood that what we are exactly doing. So hope this makes sense. This is the simple JavaScript. So that's what we have here. Let's come down, inside that we let's have a on click function, and on the click event we have to set the active to I+1, and we want to set this as well token, and here we have the token, and we have to simply pass the data of the token. So this is how we can send as an object. So we have to send the name. So you can see this is the coin, and we have the image and we have the name. Okay, so element dot not image, we have to send, let's send the name, and we have to send the image. So element dot ing. So this is the image data we are sending in the token. Hope you guys have understood that what we are exactly doing. Now let's take the image. We'll say search element.image. If we have the image, then display the image. If we don't have the image, then we have to display this hardcode image, ether. And it will have the alt, it will have the width, it will have the height, 30. That looks pretty good to me. Now come down, and here we're going to display the actual name of the token. So things are looking good. Come back here, and if we simply turn this, save it, and here you can see we got all the token. So we have the input, we have the the hardcode demo data. So things are looking pretty good. And now we can start styling this component. Okay, so let's come here, simply copy this search token, and let's go to the style file, search token, and make it side by side, and let's start styling this. So we'll target that. First thing, we have to set the position is going to be absolute, margin 0 auto, background color is going to be our primary color, padding is going to be 2 RAM, border radius 0.5 RAM, width is going to be 13 RAM, height is going to be 25 RAM. Come down, we have to target the search token box heading. Okay, what error we are getting? Okay, no problem, compilation error, flex, and align term center, justify content space between. We'll come down, we have to take this media query only, and max width is going to be 35 EM. We'll say width is going to be 95%, so looks pretty good. And now we can start styling. So come here, we have to target the search token box, search, and display is going to flex, align item center. Background color is going to be our, let's say, second primary color. Padding is going to be 0.5 RAM and 1 RAM. Border radius 0.5 RAM. Gap is going to be 1 RAM. So that's how it will look. Come down, and we have to target the input. We'll say background color is going to be transparent, outline 0, border 0. Color, we're going to attach this primary color, and font width is going to be 500. Width is going to be 90%. And that's how it will look. Come down. We have to simply get it box token, and here what we have called, so it's actually search token dash box. It's tokens. Copy list, target the margin top 1.5 RAM, and display is going to be grid template column repeat for 1 FR. Gap is going to be 0.5 RAM. That's how it will look, pretty beautiful. Come here, and we have target the span, and display is going to be flex, align item center. Gap is going to be 0.2 RAM. Border 2 pixels solid, and it will have our second primary color. Width is going to be 5.7 RAM, and padding is going to be 0.3 RAM. Border radius 1 RAM, and we'll have a cursor pointer. So that's how it will look. Come here, just target the active class, and we'll say background color is going to be this, and color is going to be this. So that looks pretty good. And come back, and let's set the media query. So we'll target the tokens, and we'll say display is going to be flex, wrap is going to be wrapped. So that's how it will look on a mobile device. Okay, we're going to fix this one. It's looks pretty big, but we're going to fix it. So if we close, this is how it will look on our desktop. It's looking perfect. You can see 100% responsive. You can click, and you can simply select. You can simply close. Okay, we can't close it, so let's reload this. So what we can do, simply close this one and come here, and here we are doing this one. Simply remove this exclamation mark, and it will get off. And if you click on this, okay, we have some problem. It say open token is not defined. Actually, this is the error we are getting for the quite long, and I know why it's happening. Instead of calling set open token, I'm called something else. So let's make it here, and where it is. So here we are doing this one, and this is what we have. Simply copy that one, and that's what we are sending here. That's what we are receiving here, and that's what we are calling here. No more problem we have here. So actually this is not the problem. Actually it's happening here in the search token. So this problem is not happening in the search token, it's happening in the hero section. Okay, this is the problem we have, I guess. So let's have a look. Okay, here we are calling this, but we have to call this one. Simply copy this one, and that's what we have to call here, and simply copy this, and that's what we have to call here. Now this will work fine, and these are fine. You don't need to do any changes. Simply reload the page, and now let's test. You can see, you can close it. You can open the component and you can simply click, but you can't close it. So we have a problem in the close. Okay, that's what we are receiving. Simply come here, we can select, but we can't close it. And okay, that's the problem we have. I got it. So these are the good. This is looking good, but this is also looking good. And the reason why we are having this issue is because this. So here you can see we have this open token too, and this is not what we are utilizing. And instead of open token writing twice, we have to write this, replace this one and save it, close, and now you can see it's working fine. Open, close, select whichever token you want. But right now you can see the token are not changing because we have provided the same name. So let's come here, and here we have the coins, and let's quickly change the name of this coin. Okay, so this is the ether. Let's make it die, dog, fun, with 9, uni, time, lu. This become o, and this become hey. So I've changed the name of the token, and the name of the token is changed. And if you select any token, you can see this tolerance is working fine, and you can see everything is working fine. No more issues we have here. But here we have to select the token. So if I select this token, a time, and here you can see the time is changed, so the state is changed. If we click here, the fun, and this is changed. That's working fine, and this one is also working fine. No issues we have here. You can easily open and close the model. So that looks pretty good. So what we can do is, let's come here. Here we're going to take another use state, and this will say account, because right now we don't have the data on which we can do the testing. So that's why we are going with this hardcore data. Okay, so we'll say account, and it will be false initially, false, and scroll down, and here we're going to call that. So we'll say paste here, and if account is true, then do this. If account is false, then do this. Okay, so now this one is still working. Here we have to do the changes. So simply copy this one, and that's what we're going to call in the second button, and this will open the list of the tokens a user have in the MetaMask. And that looks good. It's working fine. You can see it's working fine. All the token list is displaying, and here we have to do the changes. So if you turn it this true, so the current wallet will open, and if you turn it to false, the token list will open. So that looks fine, and here we have to do the change. We'll say display the account address once the user is connected. So that's how it will look. Let's make it a little bigger. That's how it will look, the address of the token. And if we make it true, we have this one, and here we have to change this tag to connect. We'll say connect. Here we have click and connect. If user is connected, then we have to display this one. Let's turn this false, and now it looks good. This looks beautiful. You can open, close. Everything is dynamic. I hope you guys can appreciate that how everything is looking good. We have built the beautiful UI part for our Uniswap clones, and now we're going to assign the functionality in the next section. Okay, so let's have a look final time that how it's looking. And this is the problem we have. It's going behind. Let's fix this issue. So this is the problem we have in the token list, and we can come back to the CSS, and all we have to do is to simply provide this Z index. send it this something high, and it will come on top of that. Okay, that looks good. This is also looking fine, 100% responsive, and this looks little big, but we're going to make it small. Okay, for the timing, let's leave it like it. We're going to fix it later. So that looks good, and everything's looking fine, no issues we have. So the template is almost ready, and finally we have built the entire template of our Uniswap clones. Now all we have to do is to add the functionality. So we are done in the first part. We have built this beautiful UI with all the dynamic pop-ups, all the dynamic demo data. Now in the second section, we're going to build the smart contract, and we're going to test that smart contract using Mocha library in Hardhat. That's what we're going to do in the second part. In the third part, we're going to connect our smart contract with SDK of Uniswap. Don't need to worry if it sounds confusing. I'll explain you everything, that how you can use Uniswap smart contract, Uniswap SDK to do all these swaps, pools, liquidity, fetching data, everything. So hope you have enjoyed this first section. You have learned all the basic fundamentals of the React and Next.js, how to build a beautiful UI using normal CSS. So that's why I have included this part in the first section, where I want to teach you everything about the React. So if you learn whatever I have covered in this so far about the React, so you are ready. That's the only knowledge you need, and you will gain knowledge as you will build project. But this is good for the beginner. If you know this much about React, then you can start working on the blockchain part. Okay, so that's the end of this first section. Let's move to the next section. In the next video, in that we're going to learn about, in that video we're going to build the smart contract and test the smart contract in the Hardhat. So I'll see you there. Hey everyone, hope all of you are doing great. So finally today we are starting our smart contract section of our decentralized exchange. So I believe that you guys have watched the first section, in that we have built the beautiful front end using Next.js and using the React.js hooks. So if you haven't watched, I'll link out the complete playlist in the I button on the description, so you guys can follow that. From right this video, we will start working on the smart contract and the testing of the smart contract. So here I have opened the project, and all the folder and file structure you will find on the right hand side. So I will provide you the entire files. So make sure you can go to the website, or you can join the Discord server, in that I have already provided all the starter file. So here you can see we have all the folder files. If I open this asset folder, in that you will have all the images which is already given to you, and these are the components. We have Horio sections, model sections, we have NavBar, we have search token toggles and token, we have the token list, and in this index.js we have imported the entire component. So this is the same old structure we have been following. If you haven't watched the NFT marketplace, so I have followed the same structure here in this project as well. So we have all these components. Let me close this one, and here we have these two pages. So we have .app.js, and we have this index.js. These are the two pages we have. Now in the style folder, we have all done this configuration. So we are using Roboto. So this is the Google fonts, and these are the setups we have done already in the front end part. So the very first thing we have to do is we have to delete this readme file, because we're going to initialize Hardhat in our project. And when you initialize Hardhat, Hardhat will automatically generate this readme file. So we have to remove this. So let's simply remove this one, delete this. So that's the only thing you have to do. And now we have to open up the terminal, and now we're going to initialize Hardhat in our project. So if you don't know what is Hardhat, I have a complete project, I have a complete tutorial. Actually you can call it course, which I will link an I button on the description. In that I have explained everything, that how you can install Hardhat in your computer globally and how you can do the testing. So in this video I will not go into that detail explaining about the Hardhat. I will do, and I will use it straight away. When I will write the test, when I will write the contract, I will start using it straight away. So if you want to learn more about the Hardhat, make sure to check that complete Hardhat course, which already I have in my YouTube channel, which I will link in the I button in the description, so you guys can follow that. So let's clear the terminal first, and here I'm going to initialize Hardhat, npx Hardhat, hit enter, and this will take a little bit time. So here we have three options. Make sure to install with the JavaScript project, hit enter, hit enter, hit enter, and here we have to install all these packages. recommended packages, just hit enter, and this will take a little bit time. So in your case it might take 6 to 8 minutes, but I'm using the power of editing of fast forward, so it will happen very quickly. Okay, so this generally take times because these packages are really huge. So just wait. And finally we have installed Hardhat in our project, and let me clear the terminal. And on the right and left hand side you will find that you will get some folder and files. So here we have this Hardhat config file. In that you will have the Solidity version which you are using in the project. So it using 8.17 Solidity version we have, and this is the config file we have. And here you can able to find all the packages which you have installed. So we have installed Hardhat, and we have used this Nomic Foundation. If you don't know, it's a powerful tools it's provide which you can use it for testing your smart contract and writing the smart contract. Okay, so we're going to use these packages a lot. So we have Hardhat, this is the package. Simply close down, and here Hardhat will create couple of folders and file as well. So we have this contract, and inside the contract we have this lock.sol. So this is a Solidity file, a demo one which you guys already know. So these are the Solidity demo file is created. So let's delete this one because we not need this one, and I'm going to create our first contract. Okay, so let's click on this, but before we do that, let's have a look on the script file. Click on this, and here you can see this is the entire script we have. Simply remove all these comments. We should start with a fresh environment. Okay, we don't need this one, and we don't need to pass any argument in our deployment script, and we have to remove this. So all looks pretty good. Remove this part as well. So deploy to and the address. So that looks pretty good, the deployment section. And right now we don't need to do anything, so just close this one, and let's come here in the contract. And now we have to create the first smart contract. So let's create the file for that, and this time the smart contract we're going to call it swap token.sol. okay, so this is the file name I have given to my smart contract, and here we are. So we'll go in this way. First we'll write the smart contract for the single swap, then we'll write the script for testing. So when we get succeed in that, then we'll move to the multiple swap, and then we'll test, and that's how we'll take ahead. Okay, so let's do one thing at a time. So let's write the contract for the single swap first. So you know the drill, we have to provide the general configuration. So we have to provide the Solidity license identifier, and this is the recommended which I'm following from the Uniswap documentation. Okay, so this is the exact license identifier you have to provide. We have to pick the Pragma Solidity version, which is a recommended one is this. So make sure to pick the same Solidity version, otherwise you guys will have an error. Okay, so make sure to pick the Solidity version between these range. It's greater or equal to 7.0 or less than 9. And you might be wondering that what is ABI encoder? This ABI encoder V2 will allow you to use nested array in your smart contract struct, and that's why you have to use it, because internally our smart contract which I'm going to write, it uses this. And now we have to import couple of packages. So we need to import the, let's come here, open up your terminal. So before we start importing, we have to install the packages which we want to use, like Uniswap V3 we have to install, and we have to install other packages. So let's install all those packages. So let's come here, and we can type this npm I Uniswap V3 periphery. Hope I'm pronouncing this name correctly, periphery. Okay, so this is the package which you have to install. Hit enter, and this will happen very quickly. So here we have installed the first package, and now we have to install the second package. So let's remove this, and this time we have to install Open Zeppelin, and this is the package we're going to use to build our ERC20 token which we're going to use to swap. So let's install this. So here we have installed that, and now we have to install the other package. So we have to install the Ether. This will allow to interact with the contract, and now we have to install the Web3 model. So right now we have to install 4 these packages. Just wait, it's installing. So here we have all the 4 important packages we have installed, and now we can start importing those packages in our contract. So let's come here, let's go to this, and you will find, if you open this packages and file, here you will find that we have all the packages. So make sure you have to install the exact version. You can get the Open Zeppelin, the updated one, but when it's come to the Uniswap, you have to pick the exact version V3, then it will work. So this is the version you have to install. We have the Ether and we have this Web3 model. And this is the dev dependency we have. So now we can start importing those files. So we have this V3, simply remove this one and we have to import. So let's come here in the node modules, and first you have to find out. So I just want to show you that from where we are getting this file. So you guys have to know that how we are importing and what we are exactly importing. So let's come here and let's try to find out the Uniswap, where it is. Here we have this Uniswap entire folder. Inside the Uniswap we have this V3 periphery, and that's the one we are using. So we have V2, we have V3 core, but we have V3 4. So but here I'm going for the V3. So let's type Uniswap/V3 periphery and let's open this folder, and inside that you will find couple of folders. You will find the artifact, you will find the contract, node modules, license. So we have to get into the contracts. Open the contract. Now we have to go into the library, and inside the library we have this smart contract, and the contract we want to use is, let's say, this one, transfer helper. So this will allow you to do the transfer. Okay, so make sure to import the exact folder which we're going to use. So right now I'm getting this error. It says wrong file casing, and now you can see the error is gone. We don't have any error. If you have any error, make sure to provide the exact path which I have provided, although I will provide you the entire code in the file, in the starter file, so you can compare from there. Okay, so let's import the other package, and that's the other package we are using. Contract interface is swap router. This will allow us to do the swapping. So make sure these are the two packages you have to install, and we have this one, interface is swap router. So these are the two packages, and now we can start writing the contract. So let's type contract, and we're going to call this contract single swap token, and here we have to define our swap router. So we'll say swap router public constant, because this router is, the address of this router is not going to be changed, it's going to be permanent, and that's why I have defined constant, because when I will deploy the contract on any network, it will cost me less. So I believe that you guys haven't forgot this concept which we have discussed in our smart contract, in our Solidity course. So make sure to follow that Solidity course to have a better understanding of each of these keyword, each of this function which we are creating here in the contract. So here we're going to say swap router, and there are two ways to provide the swap router. You can do it in the constructor. So at the time of deployment, you can pass the swap router in the constructor and you will update that, or you have the other option, you can do it like this, provide it straight away, because you know that this is the router which is not going to be changed. So I will go in this way. I'm not going to provide through the constructor. So I have already saved it. So this is how you have to define. You have to define is swap router, and you have to simply paste the address of the contract. So this address is deployed. So this swap router contract is deployed on this address. So we are passing that. So believe that so far whatever we have covered, that makes sense to all of you. So just follow along with me and everything will make sense. So we have our swap router, and here we're going to define all the token which we want to swap. So generally what I'm planning to do is, we are using Hardhat, and Hardhat will provide you couple of accounts, and each of the account will have couple of Ether. Okay, so we're going to swap the token from WETH to DAI. So that's the first swap we'll do, because we already have some WETH, and I'm not going to do on the mainnet because I don't have any real WETH, so I can do the transaction. So we're going to use it whatever Hardhat provide to us. So let's provide the address of the token. So we'll say public constant DAI, and here we're going to define the address of the DAI. Now we have to say public constant, and this will say WETH9, and here we're going to define this USDC. So these are the addresses of the token DAI, WETH, and USD. I'll provide this in the starter file, so from there you can copy. So now we have to create a very first function which allow us to do the swap. So what we're going to do is, we're going to pass a fixed amount of WETH, and in return we'll get DAI. So let's write the function for that. We'll say function swap exact input string. That's the name of the functions. Again, I'm telling you, I'm getting all these stuffs from the documentation because that's the only resource we have about the Uniswap V3, and that's what we have to follow to do the swap using the swap router of Uniswap. So make sure to follow along with me. In that, we're going to pass an argument. So we're going to pass the amount in. So how much amount we want to provide into this function and what we want. So amount in, it's gonna be external and return, and we want to return the output. So amount out. So that's the simple function we have here, and inside the function we're going to define a couple of things. Let's try to understand that how the entire swap exactly work. So when you will call this function, whoever will call this functions, we're going to utilize this transfer helper function, and in this transfer help function we have two functions. One we have the approve, and the other one we have is save transfer. So first we have to transfer the fund to the smart contract of Uniswap. We have to approve them, so the smart contract of the Uniswap will going to spend the token on behalf of us. So that's the entire logic. Okay, so that's the only thing you have to keep in mind. So we have this import, simply copy, and that's what we're going to call it. So we'll say transfer helper, and we're going to call this method save transfer from, and in that we have to pass couple of data. So first we have to pass the token, that what token we want to provide, so with, and the other one is going to be the message.sender, the person who's calling the function, and to whom we want to provide. So address this means the smart contract, Uniswap smart contract, and then we have to provide the amount in. Okay, I believe so far everything is clear to all of you how everything's working. First we are transferring the fund to the contract and approving them. So we have transferred the fund, now let's try to approve them. So we're going to call this transfer helper save approve and with, and we have to call it address this, not address this, swap router, because that's the router we are approving, so it can expend the token on behalf of us, and we have to define the amount in. So that's the save approve, and now we're going to define the is swap router and some parameter, because we have to assign some data, and that's what method we're going to call swap input single param. So memory params and we have is swap router exact input single param. So this is the one we have, and inside this we have to pass a struct. So if you look at the documentations, you will find that exact input single param is just like a struct. We have to define the couple of parameter which we want to pass to our param, to our swap router. So in that we have to define, so first thing we have to define the token in, what token we are trying to provide and to an exchange. Okay, what token we want to provide in exchange. So token in, we have to make it token out, and here we have to define the fees pool fee. So right now I'm going with the hardcode value, but in the real world, in the production level, this should be never be hard coded. We'll have a different function which allow us to update this token fee as per the user interaction. If a user trying to swap token very frequently, so for that we're going to charge less, or maybe we can charge higher. So this should be dynamic, but right now I'm just going with the hard code because I will show you that how you can do the testing. So just for that, but later we're going to make it dynamic. So we have this full fee, we have to define the recipient, that who going to receive it, to message.sender. We have to define the deadline. So you don't want that your transaction gets stuck. You need to wait for a particular amount of time. If the transaction happened in that particular amount of time, then it's okay. If it took more than that, then you want to simply stop the transaction. So we have to define the deadline as well. And now we have to define the amount in, and we have to define the amount out. Initially we are going with the 0, but in the real world it should be never 0 for the security purpose, which we'll talk later. And here we have to define this square price limit. So that's the entire struct we have defined, and I think I'm getting some error. So it says the amount, so amount out we have here, and it says minimum. So make sure to do this change, and what else, and here we have to simply change the rewrite the spelling. Okay, there was a spelling mistake, and you guys know that I make a lot of spelling mistakes. So I believe that whatever we have done so far, that makes sense. We are using the is swap router and passing all this data, and here we're going to simply do the transfer. So amount out swap router, and we're going to say exact input single, and in that we have to pass the entire data which we have inside the param. So that's the very first function which allows us to do the single swap. Now we have to write the second function, and in this function we have to consider one problem. And the problem is, if someone wants to have a fixed amount of output, just imagine that if someone wants to have 100 DAI, if they're putting any amount and they want to have 100 DAI as an output, but in the previous function, what the output we are getting is not fixed. Whatever amount you will put, you will get a DAI, but it's not fixed that how much DAI you will get. Although you can calculate, but that's the topic of the later part. And that's the second function we're going to write, which give us the fixed amount of output. Swap exact input string, and in that we have to pass two data. We have to pass the unt amount out, so how much output we want, and the other one is going to be unt amount in maximum. It should be external return, and we want to have a return which is a amount in. And now we have to follow the same structure which we have followed above. We have to approve the contract, so we'll call this safe transfer from, and that's what we're going to pass with 9. It will go to the message.sender, then we have to pass the contract this and the value. So amount in maximum, that's the safe transfer form. Now let's have to approve one. We have to pass the token, we have to pass the address is going to be the this, and the value is going to be the amount in maximum. So that's the approving. Let's come down, and now we have to work on the struct, which actually is a param. So we're going to use our swap router, and that we have this method called the method name is output single param, memory param, and we'll say is swap router exact output. Simply copy this one because that's the one thing, same thing we have to type here, and inside this we're going to pass the struct, means all the data. So we have to pass this token, so simply copy this, the same data we have to pass, copy this and simply paste here. And again, this time what we have to do is the token in is going to be the width, token out is going to be the DAI, fees, everything would be the same. And here we have to do the changes, not here, here. So this is the amount in. Instead of this amount in, we have to type amount out. We are getting an error, and this will become the, let's simply select, remove this one and copy and paste here. So amount out minimum. So that's the only two changes you have to do, and the rest would be the same. So let's see, we are getting an error, and that's coming from where? So maybe I'm having some spelling mistake, so let's check. So it's good. Okay, we have to provide the comma, and now you can see we don't have any error, everything's looking fine. And right now we are getting this warning because we haven't used that variable, so we have to use it. So that looks fine, our struct is ready. Now let's come down, we have to do the transfer. So amount in swap router dot exact output single, and in that we have to pass the param, sorry. And here we have to do the checks when the transaction is happening. If amount in is less than amount in maximum, then we want to do this transfer helper save approve with to address this and the amount address swap router, because that's what we are transferring. I forgot all the time. And here we have to say that 0. And now we have to call this transfer helper save transfer. We have to pass this data message.sender and the amount in maximum minus amount in. So that's the only thing you have to do. If it sounds complicated, just follow along with me, everything will make sense. So we have this, and now everything's looking fine. So with this we are end with this entire smart contract, and now we can easily able to swap the token from WETH to DAI, because that's what we have defined in the smart contract. Later we're going to make it more dynamic when we're going to convert it and attach with our front end. So we have this license identifier, we are using the Solidity version, and we have this ABI coder which allow us to use struct and nested arrays. This is the swap router. We have the token addresses, the first function wait to die, and that's the second function. So let's come here and let's come to this, close this one Uniswap and close this node module folders. And now we have to create one more smart contract which allow us to do the transfer of the token. So let's come here, let's create a smart contract, and this will call IEWTH. And inside this we're going to define all the functions like deposit, getting symbols, transfer token, all the function which we have in ERC20 token. That's all we're going to define in this, because we have to use it when we do the transfer in the test. We need this. Let's come here and simply grab this startup file, and that's simply grab this one and paste here. And here we're going to define the entire interface of our in ERC20 token. So let's come here and we have to take this interface and we're going to call it IEWTH. That's the name we're going to do. And here let's define all the functions. So we have the first function is deposit. So we can easily able to deposit the token into the contract. When someone will call the function of swap token, we are depositing the token to the contract, and then the contract is sending the token to the user back. That's the entire logic is happening. So let's create the deposit function. So in external, the other function is going to be the withdrawal, UNT external. The third one is the total supply, external view, return, and it will return the UNT. So these are the three functions we have. Now let's create the fourth one, and this one is called balance of address, account, external view, return UNT. And the fifth one we have is this transfer address, recipient, UNT amount, and we have the external view, returns, and UNT. Allowance, we have this address, spender, UNT amount, external, returns, and boolean. And here we have to create one more function which is approve, because we will have to approve the Uniswap contract to send the transfer on behalf of us. So approve function will take the address, suspender, and the amount, that how much we are approving. It should be external, return, and it will return the boolean. Let's create another function. This will say transfer from. So it will take the address of the sender and address of the recipient, amount, UNT is an amount, external, and it will return the boolean. So these are all the function we have created, and these are the normal function which you find in ERC20 token, and that's the interface we have defined here. Withdrawal, total supply, balance of, transfer, allowance, transfer from. And now let's create the two event, which is very important. So event, this will call transfer. It will take the address index from address index to and the amount value. Now that's the event. Let's create the another one, approve, address index owner, address index spender, and the value itself. So these are the interface we have defined, and that's what we're going to use for transfer the fund. So hope so far things are making sense to all of you guys. These are the simple function for the ERC20 token which we have declared here. So things are looking fine to me. Everything's good. We have all the function. If we find that we are missing anything else, we can definitely come back and rewrite some functions. So here we are getting this error y. Okay, so let's remove this. Let's try this comma, and now the error is gone. Now it's looking good. So we are done with this entire interface. Hope this makes sense. Let's close, and we are done with this smart contracts, single swap. Close this one, and now we are done with the two smart contract, and now we can start writing some tests to check whatever the contract we have written, is it working or not. So that looks good. Let's come here and come back to the test, and here we're going to delete this one. So come here and delete this file, and we have to create our test file. Click on this, and we have to call, let's say, single swap JS, and in this we're going to write the test for the single swap. So let's start writing. So we have to import couple of packages, const accept, and that's coming from the child library. And if you don't know that from where we are getting these packages, make sure to watch the Hardhat course, in that I have explained everything about this library and how it's worked. So we have imported this expect, and now we have to import the ethers package, and that's coming from, let's say, ether Hardhat. So we have these two packages, and now we have to simply import the token DAI. We have to simply come here and replace this, will become with 9, and this will become USDC. And here we have to provide the token addresses. So for that, what we can do, we can come back to the contract, and inside the contract we have the addresses. So simply copy the address and come and paste here for the DAI. Come back and paste this with, paste here, come back and copy and simply paste here USD. So these are the three token addresses we have here. Now let's come down. So these are the general setups we have done, and now we're going to write the test. So we'll say describe, you can give the name whatever you want. We'll call it single swap token. It will be async function, not a normal function. And here we're going to define a couple of variables. And the reason why I'm going with this approach, because I'm going to write multiple tests, not only a single text, and there are a couple of code which we want to run every time. So I don't want to write the same code over and over again in all the tests. So what we're going to do, we're going to run a before. There is a concept in before. If you haven't watched the Hardhat, make sure to watch, in that I have explained. So we're going to define one function which will execute every time, no matter what script we run, and that's the entire logic, and that's the only thing you have to know. So let's declare a couple of variables. Let single swap token, this will contain the instead of the contract. Let's define the other one is the accounts, define the width and the DAI and the USD. So these are the variables we have, and now we're going to use this before. In that, we're going to take this async, and here we're going to run this one. So we need to have the account. So we'll say account await ether dot get signer and a one. So which Hardhat provide us. We have the account and we are updating that, and now we have to simply get the contract. So single swap token, we have to use this, copy this one, and you can see this is the contract name we have given. Simply copy that one and paste here. We'll say await ether dot get contract factory, and in that we have to provide the name of the contract. Now we have to simply, we have this single swap token, which the variable we have already taken. We're going to simply update the data. So deploy. So in this way we will have all the instant of this contract in this single swap token, and that's what we have here. Now we have to say await single swap dot deployed, and everything's working fine. Hope this makes sense to all of you. We have deploy, and once it get deployed, we have to simply update this one with. So with, we have this await ether dot get contract at, and you have noticed one thing, that the Ethers.js we have used, it's coming from the Hardhat. We are not using from the Ethers package itself, because in Ether package you won't find this function get contract at. So this one is an additional addition by Hardhat in this Ether package. If you want to know more about it, you can simply visit to the Hardhat documentation in Ethers.js, and from there you can easily able to know that what this function does. But the one thing I want to highlight here, that this get contract at coming from Hardhat, not from Ethers.js. This one is the addition to the Ether package, and this will only work when you will use Hardhat. If you use the normal Ether package, it won't work. And here we have to define. So let's come here. Here we have to define that IEWTH, the interface we have created, and that's what we're going to define. And here we'll type the name of the token with, simply remove this, and this will call ERC20 token, not ERC. We have to provide the token name. So this will become DAI, this will become USD, and this time we're going to use the inbuilt. This time we're going to use the inbuilt smart contract of Uniswap for the ERC20 token. So let's replace this one with the IERC20, and that's coming from the Uniswap. So that's the setup we have done. Simply copy this one, and now we have to simply update here DAI and USD here. So far I believe things are clear to all of you guys. And now let's do the console log. So we'll say with, this will become DAI, this will become the USD, and this will become account. And now we have to take this one and single swap token. We are done with this first block, and this piece of code, this before piece of code will run every time, no matter what section of the smart contract we are testing. This will run every time whenever we try to test the contract. And that's the best part, because in this way we can easily able to save a lot of time. We don't need to write a lot of code over and over again. That looks pretty good to me, and that's looking fine. Let's come here, and now we have to do a little bit configuration. And now the testing we want to do is on the fork network. So just do exactly the way I'm doing. So let's come here, go back to this Hardhat config file, and here we have to define the network. So we say non-network, we'll use this Hardhat, and we'll say forking, and in that we'll say URL, and here we have to provide the RPC URL of our main network, main Ethereum network. And to get that, we have to come back to the one powerful thing. So you have two options to get the URL, RPC URL. You can come to the Acmeli, and I'm going to get it from Acmeli, or you can go to Infura. So let me log into my account, and that's, you can see I'm into my dashboard. So if you log in, create your account, you will have a similar dashboard. You can see I have already created a couple of projects, and right now the contract which I'm deploy NFT marketplace, you can see a lot of you guys are already visiting that, uploading and creating NFT, and that's why we have so many activities every single day. So I have already this mainnet. I will simply open this, and I will get this HTTP. This is the code. So make sure to use your own, don't use my. Otherwise, if a lot of you guys are using the same URL, it will create problem and it might not work. So that's the URL I'm going to provide here. So that's the forking network we have taken, and on this we're going to do the swap. Later we're going to talk about that how we can optimize. So there is a lot of concept which will keep it for a side. So there is a concept of optimizing the code, optimizing the version. That's all we have, but just right now just focus on this. So that's the forking network we have. Close this one and come here, open up your terminal, and here we have to simply clear the terminal, and now we have to simply run npx hardhat. We have to type test and hit enter. So the test is running, and you can see the test is passed. And as I told you that you won't get any output, as we have done the console log, but we can't get it. But when we write the statement for the testing the smart contract, and that will get the data. So generally this is how it's work. I don't know why they have this weird behavior, but this is how it's work. Even I was not knowing this when I was doing this testing. When I tried to log the data from this before element, the data was not coming. So that's the one thing you have to keep in mind. So that's the past, and now let's write the test for the contract. So simply comment this one. This looks good to me so far, and let's write the function. So that's how you can test the contract. So we'll come here and we're going to write the it. So when you want to test any smart contract section, whether you want to test the function, whether you want to text the variable, that's how you have to do. You have to write in a it block, and you can write the statements, the logic you want to write. So I'm going to say the swap exact input single. That's what we have. It's going to be async function, and here we'll say const amount in, and here we have to provide this big number, and let's deposit the ETH. And first we have to deposit the token with to our contract, to the router. So we'll say await with dot deposit, and this is the function we have created in our interface, and from there we are getting, because this w with has all the function, all the instant of the interface. Hope you haven't forgot that. And in that we go to pass the value and the amount we want to simply approve. So it says that this variable is not defined, not find name, and why? So we have this. I know why it's happening. So let's do one thing. Simply select this entire one and simply cut this one and simply paste here, because this is the problem I have done. I came out of the block, and that's what you have to do. And now we have the access of this with variable. So first we are depositing the ETH, and now we have to simply approve, and here we have to provide the contract address which we want to approve. So we want to approve, we have the instant of this single swap token, in that we have the instant of the swap router, and we have the address, and in that we're going to pass the amount, because that's the two parameter we have to pass in the approve. If you still have any confusion, check the interface. In that we have this approve function, and these are the two data we are passing in that. So we are approving, looking fine so far, and let's comment this, and these are the console log we had. Okay, remember, now simply grab this and let's try to access those data here, paste here, and simply uncomment this, and now this time we have to run the script. So if we run the script, so Hardhat test, and just wait, you will find all the data here. So single swap token, looking fine, and here you can see we got all the instant and the test is passed. We got all these instants. So we have this DAI function, USD function, WETH functions, and the function we have created. I believe all this makes sense to all of you guys. So this is the entire interface, providers, all the accounts. Let's do one thing, let's try to comment this all and just uncomment this account sections. In this we'll have a lot of account, so still you will find a lot of logs here. So let's try to test this one more time, and here we'll have all the account. So just wait, and here we have that test is passed, and here we have all the accounts. So this is the account, this one is, and this one is. We have all these methods, providers, all the database available to every single account. Okay, so that means that our before function is working fine, and now we can start working on our main function. So that looks good. Simply let's uncomment this one, and now let's try to simply do the swap. So to do the swap, all we have to do is await. We have to call the instant of the contract, single swap token, and in that we have this function available. So this function, let's come here, go to the contract, and in the contract we have the very first function. So this is the first function we have to call. In that we have to provide the width, amount of width which we want to provide, and in return we'll get the DAI token. So this is the function we want to call. Simply copy and come back, and that's the function we're going to call. And that we have to pass the amount, because this is the amount we want to provide to this function. So, and simply console log out the token. So we'll say DAI balance, and this data we have inside this await. We'll use this DAI dot balance of. Remember from where I'm getting this balance of, because we have that interface, and in that we have this balance of function. In that we have to simply pass the address. So all the token which we have in the account number 1, the very first account, so we have to simply pass the address of that account, and this will give us the data. So first we are depositing the width, then we are approving the swap router, the address, then we are approving, and then we are doing the simple transaction. Hope this makes sense to all of you, and that's what exactly we are doing. Input is width and output we're going to DAI. That looks fine to me. Now open up your terminal, and finger crossed, hope everything's work fine. So clear the terminal, head the test. Wow, what is this? So swap exact input string is not a function. So we got a weird here. So we have some problem in our code. Maybe we have some sort of spelling mistake in our code. So let me quickly review and let me try to find out what problem we have exactly. So I was stuck for a half an hour, and I was trying to find out that what's the problem actually we are having and why our test is not working. And what I have found that I did a little bit spelling mistake in our contract. So let me show you, let me run the test, and let me show you that now everything's working fine. So here we are in the single swap.js file. These are all the before, and this is the function we have written. And now we go to test this. So let's open up your terminal, and we're going to run the command npx hardhat. We have to get into the compile. So first we have to compile it, and we got nothing to compile because we haven't done any changes in our smart contract. And now we're going to simply clear the terminal, and we're going to run the test. And here we have, and boom, here you can see that finally successfully we have done the single swap, and this is the exact value, DAI value, which we have done, which we have got. Okay, so this is the exact value, we have got it back. And if we come here, and this is from where we are console logout. And now let me show you that what are the changes you need to do to have the same working environment. So first thing we have to do is, let's get back into this smart contract, IEWTH.sol. So in that, what I have noticed that I made a spelling mistake in the deposit function, and because this function we are calling in our test to deposit the amount into our smart contract. So we had a spelling mistake in the deposit and in the other function. So I simply change the spelling, and you can see, make sure to type the exact spelling which I have done here. So this is the transfer, allowance, approve, transfer from, and these are the events. So make sure to do these changes. I will provide you this contract and the single swap contract as well. So from there you can easily able to copy. So that's the only change you have to do. Make sure to go through the entire exact thing what I have. And now let's come back to the other function, and this is the other function we have. So in this, I also made a little bit spelling mistake. I had the same function twice, and because of that I was getting the error. So I did these changes. So this is the single swap token. You can see this is the swap exact input single. We are passing the amount, and these are the transfer, save transfer, approve. This is the params, all the data we have. And this time we have to call this swap exact output single. I was calling the same single input. So we had two functions with the same name, and because of that we were getting an error. So make sure you have to type this output single, and the rest would be same. So make sure to do these two changes in both the smart contract. I will provide you the contract so you can copy and paste here. So things are looking fine. Let's come back to the taste, and this is all the general setups we have done. So this is the before element we have, and this is the first aid block. So I believe that you guys have done with all the changes in both the contract. I'll provide the code in the starter file, so from there you guys can get it. So let's start working and testing the second function. So let's create a it block, and in this we're going to test this function, swap exact output single. This function is not that popular in most of the decentralized exchange. If you look at Uniswap, SushiSwap, Pancake, in that you will find that you have to put your amount and you will get back the token. But in this function, what happened that you have to specify that what amount of token you want as an output, and on the base of that your input amount will decide. So let's test this functionality which we have in our smart contract. So I'll simply paste the name, and let's create the functions. So the same old school we have to follow. We have to get the amount, the maximum amount we want to provide. So I want to provide, let's say, 10th Ether, and I want to get back the DAI token. So I want close to this amount of DAI. Let's deposit the ETH to our contract. So we'll say deposit, and we're going to define the value. So this is the amount, the maximum amount we want to define in exchange of that token. So we have our token. Now let's call the approve, and we have to approve our single swap token address and the amount. Now we have to call the swap. So let's say await single swap, and now we have to call the function. So let's come here in the contract, and simply let's come here and grab this function, and in that we have to pass these two data. So let's come here, and we have to simply pass the DAI amount out and DAI width. And now we have to console log out this account 0 and address, and we have to simply call the DAI balance await DAI balance off, and in that we have to pass the account 0 and address, and that's the only thing you have to do. So this will give us the exact amount of output. And let's comment out this very first function because it's already working. Simply comment this one, and it's working fine. Now we have to test this one. So what we can do is, so we have this input amount, this is the output amount token we want, this is the deposit, and this is the swap. Open up your terminal, and now we have to simply run the test, and here you can see we got the DAI back. The DAI balance, it is in the big number, you can convert, you will get that. So everything is working fine. So this function is also looking fine to me. So let's come here, and this is the address. What we can do is simply replicate this, and let's say account 1, and let me show you that what balance you will get. Can you guess that what balance we'll get in this account 1, because we are not transferring any DAI token into that. So obviously it's going to be the 0 one. I hope you guys have guessed the right. So let's check this account one, and let's do one thing. Let's make this one as well. And here you can see, okay, let's rerun the test. And here you can see we got back this number. So the 0 account, the first account, we have this much DAI, and the second account we have 0 DAI. So the entire smart contract is absolutely working fine, and we can easily able to call this single swap and input and single swap output. Both the functions are working fine. So this is the contract address of each of these token. This is the variables. This is the before block we have taken. And this is the two function we have taken. So you can define in multiple way. So right now you can see that I have written a simple function to check this function. If you want to check a specific value inside the function, so you can see our single input. So you can see the function like swap exact input single. We have a lot of parameters, a lot of data. First we are transferring, then we are approving, then we are calling the swap. So if you want to access those variables, you can do the test for that as well. So it's not necessary that you have to check, but when you will work in the real world application, when you're going to deploy those contracts, at that time you have to check every variable. So it's looking fine to me. Let's simply uncomment this one. And this is what we have, the second function. So things are looking good to me. Now what we can do, simply close this one, and come here. Here we have, this is this entire smart contract for the single swap token. So we are done with this. We're going to write a lot of contract. We have to add liquidities, a lot of things. So just focus one thing at a time, and simply close this one. And let's come here and let's create another file. And this time we'll say swap MultiHop, because right now we had done with a single swap token, and now we'll start working on the multiple hop. And let's come here in the, this is the exact smart contract. We have to do a little bit changes into this. So first we need to take this one, license identifiers, and paste here. Come back to the token and simply grab this one and paste here. And here it's looking fine to me. What is the error? This is not for, okay, so let's come here. What we can do is simply grab this entire one and simply replace with this. Okay, the error is gone. So sometime it happen, sometime you have to wait, and sometime you have to close the file and restart. The error will gone. So this looks fine. And what we can do, let's come here in this contract, and we need the addresses. Simply grab this entire one and paste here. We have to create a contract, and we're going to call this one swap MultiHop, and in that we're going to simply paste that. So simply grab this one, entire one, and simply come and paste here. So that's the token addresses we have. We have our router which allow us to do the swap, and that looks fine. Now we have to come here and we're going to create the function. So swap exact input MultiHop. So in that we have to pass the amount. It's going to be external return, and it will return the UNT amount out. So the amount out we want from this token. Now we have to call this transfer save. In that we want to transfer from with to message.sender. Then we have to add the contract and the value itself. So the amount in. Once we have done with that, now we have to transfer call this save approve. So our contract can call and send the token on behalf of us. So let's approve that. So we have to approve the token. So with9. Now we have to call this address swap router, and we have to say amount in. Things are making sense because we are following the same old school here. And here we're going to call this swap router, and in that we're going to call this method swap exact input params memory and params. And here we're going to define this. Simply grab this one, and that's what we're going to send. And in that we're going to define all the data of the token. So first thing we have to define the path ABI encoded packed, and in that we have to define the token. So we want to convert it from with 9 to, and in that we have to define the pool fee, because that's what we have to pay. So the fee is something like this, UNT 224, and we have to pay 3000. So if you visit the Uniswap pool fee section, in that you will find the list of the entire token when you do the trade. So if you have any confusion right now, don't need to worry, because when we'll start working on the liquidity section, and that time we're going to understand every single fundamentals that why these things are important. These are the same repetitive things, so that's why I'm not explaining in that way. And this we're going to cover in details when we start working on the liquidity section, because that one is the most important concepts, and that's Uniswap is all about. So let's just follow along with me. So we have this WETH9. Now we have to define the USDC. We have to define the USDC is 100, and then we have this DAI. So this is how the transaction will hop, and this is why it's called multi-hop. So we want to put this with, first it will get converted into USDC, and then we'll convert it into DAI. And these are the different fees range of each of these tokens. So everything is explained in the documentation, but again I'm telling you over and over again, if it's so, again just follow along with me. We're going to get into more details when we start working on the liquidity sections. Right now I can assume that you guys are a little confused that from where I'm getting this functions and what these functions are doing. I just try to keep the explanation part for the later video in the liquidity section, because we're going to refer the documentation and we're going to focus each of these models which Uniswap provide us. So just build the contract so we can test. So let's come here. So it's looking fine. Why we are getting an error? And so now here we have to simply come here. We have to define the recipient. So message.sender. Let's call this deadline, because we don't want that our transaction go forever. So we have to define a specific time in which the transaction get completed. So we have to define the amount in. We have to define the amount out, minimum, and 0. So that looks fine to me. Why we are getting an error? So provide this, and now I think it will fine. So everything's looking good. You can see no more error we have. Now simply grab this one and let's work around it. Let's make the transaction. So amount out, swap router, exact input params, and that's the amazing things. Okay, that looks good. We have the token transferring, converting, and that's happening. So with this we are done with this first function, which will do the input multiple hop. So you will put an amount and you will get an output. So this function is done. Now let's start writing the output one. So we'll say simply copy this and paste here, because we have to do minor changes here. First we have to change the name of the function. So we'll say swap exact output MultiHop, and in this we need to pass the data output. We have to pass the input maximum, because the output token is fixed but the input is not fixed, because the price will fluctuate and the price will be calculated internally, and on the basis of that you will have to pay the price for getting a fixed amount of output. Hope things are making sense. If it's not making sense, just work along with me. We are trying to return the amount in. So this is the transfer function here. This is the message.sender address, and here we have to paste this one. Simply copy and replace this, and that's also looking fine. Save, approve with address. Simply grab this and replace with this. So it's also looking fine, and we have to delete the rest of the code, because now we're going to write the contract functions. So let's come here and we have to define our swap router, and that we have this functions called output params, memory params, and we're going to simply copy and paste here, and then that we're going to send an object. So first we have to define the paths, ABI encoded back, and that we have to define that we need to have output as a DAI. We want to have a DAI as an output, so that's what we are defining at the top. Now we have to define the fee, so it's 100, and here we have to define the USDC. So it's a USDC, because when you convert the token from DAI to USDC, the full fee you have to pay is 0.100, and that's what we have done here. We're going to discuss this even more. Okay, just follow along with me. Now define the third one is 3000, and now we're going to take this width, and we have to call this recipient. So message.sender is going to be the recipient who's calling function, and define the deadline. We have to define the mount out and mount maximum, and this one is the same. So that looks pretty good. So everything's working fine. Now let's come here and let's make the transaction swap we'll have this output params, and here we have to check for a condition. So if amount is less than the maximum amount, then we have to call this save transfer. We have to say with9 address is going to be swap router, and we have to define the 0. Then we have to call this save transfer from. We have to define, let's say, with9 address this message.sender and the amount in maximum minus minus amount in. So that's the simple check we are doing. Hope things are making sense to all of you. So things are looking good. This is what we have. This is the very first function. That's the entire check. This is the second functions, in that we are checking for this if statement, the amount, and then we are calling this function. So with this, we are done with this entire function of this multiple hop. So we are done with this. Let's simply close this one and come here and go to this. Now we should start writing the test. So open up your terminal and simply clear your terminal. And now what we can do is, first thing we have to do is to compile the contract. So clean the artifact, and now we can simply compile it. And now, so that's what we are done. So if we come in the test, and here what I'm going to do is, so this one is for single swap. I'm going to simply come here, and we need a lot of things. Simply select this entire code, and we're going to create a new file for the multiple hops. I don't want to mix all things together, because that will save a lot of mess when we'll start working in other functionality. Okay, so let's create a new file. We'll call it, let's something like what is the name we have given? Swap MultiHop, and that's the name I'm going to give to my test. So come here, and we're going to call swap MultiHop JS, and simply come here, grab this one and paste here. So we got our entire test file, and here we're going to do a couple of modifications. So here, this is going to be the fine, no changes we have to do here. We need the instead of the contract. So here we're going to change the name of the contract. So let's come here, and so let's get into the contract. So this is the multi-hop we have. Simply come here and grab this contract, come back, and first thing we have to do is to change this one, the name. We have to change the name, and we have to change here as well, and we have to change here, and here we have to do the changes, because we need the instances of the contract globally, so we can use in different tests. So paste here, and simply replace all. So click Control F, paste, and paste the replace one. So this is the one which I want to replace, and this time what I want to do is I want to make it as small as. Hit enter, and boom, here you can see we have successfully replaced that. So that's the changes you have to do. If I scroll down, and that looks good to me, no problem we have here. And this is the two function we have written, and simply comment this out, open up your terminal, and let's run the test to see that things are looking fine or not. So let's run the test, and this time we have two files in our test folder. So when you have one file, you can simply type npm hardhat test. It will execute the very first file, but right now we have two files, so we have to define the file specifically, that which file we want to run. So we are running npx hardhat test. We are in the test folder / and the folder we want, the file we want to execute is this swap multihop.js. Hit enter, and boom, here you can see it's compiled successfully. No more error we have, and these warnings we're getting, that's for different reason, don't need to worry about it. So that's looking fine. We have passed this one, and now we can start testing. So let me bring the terminal down, and where is that? So that's the first function. We have simply uncomment this one, and we have to change the name of this function. So let's come here. This is the very first function, input multi-hop, and paste here. And this time we have the amount in. This is the deposit. Then we have the approve. We are approving the amount in, and here we have to change the name of the function. Simply replace with this. So simply come here and grab the function name, and come here and simply paste here. So that's the function we want to call, and that's the first check. So open up your terminal and let's test this out. So if we run the test and just wait, okay, this, just wait, it's taking a little bit time. That means everything's working fine. So just wait, and boom, here you can see we have got the token successfully back. So that's how MultiHop is working fine. We got our token back. So we are taking the amount, then we are depositing to the contract, and then we are doing the swap. So that's working fine. And now let's test the second function. So let's simply uncomment this one, come here and grab the function. In this we have to pass two amounts, simply paste here, and we already have this width and die, and that's what we are passing. Simply change the function name, and that looks good to me. No more error we have here. Things are looking, comment this one, that looks good. Uncomment this and simply comment this one. So that's looking fine. Let's run the test, and boom, here you can see it's working fine. So our MultiHop is also working. We got these amount of tie, and this is very important because you have to know that whatever function you have written, it's working or not. Because when we'll add the liquidity, when we'll do the swap, these things are going to help you a lot. Right now still you have any confusion, don't need to worry. We're going to get into more details when we'll start working in the liquidity section, because the liquidity is a very huge concept. You have to build the logic about the price curve, that you have to find out price curve. You have to understand that how the price of the token increase or decrease, what is the curve, all the thing. So we're going to have a detailed discussion on that. Just for the time being, just focus what we have done, the way I have tested the contract, do in the exact way. If it's working, that means everything good and you are on the right path. So that looks fine to me. And let's uncomment this one. So the test is ready, the contract is ready. So we are getting closer to our project. So we have the three contracts. One, we have the interface. The other one, we have the single swap and the multiple swap. So things are looking good to me. Now what we can do is, let's come here into the contract, and I'm going to create another file. This will call ERC20 token live, and in this we're going to create the token, because we need to have our own token which we're going to deploy into the test network, and we'll create the liquidity pool and we'll do the swap. So let's create the first token. Altogether I'm going to create two tokens, and let's create another file. This will call the ERC20 token and we'll call boo. Okay, so these are the two contract I have created, and now in that we're going to come here and simply grab a couple of codes. So this is the license identifier, the convention we have to simply copy, and that's what we're going to paste here. Simply paste here and paste here, and now we have to create our tokens. So we'll say we'll have to import the OpenZeppelin. So OpenZeppelin, we have to get into the contract, we have to get into the token ERC20 so we are using the ERC20 interface to build our token. You can write your own custom code, but I don't want to go through that, otherwise it will take a lot of time. And OpenZeppelin is really trustable package which you can trust to create your token. So we have that one, and I'm getting some sort of error. So this error is coming fine, so I remove that extra E which I have added in OpenZeppelin. And now let's create the contract. Let's call the contract name to live token, and we want to inherit the ERC20 interface. In that we're going to define our constructor ERC20, and that we have to define the, let's say, token symbol, and we have to define the token name. So I'll call it live, and inside that I want to call this mint function. So message.sender is going to be the owner of the entire token, and how much token I want to assign is this, close to 1 million. I want to multiply with this 10, and I'm going to use this decimal function. So we'll have this 18 decimal. So that looks good, and we have our 1 million token. So it's 2 6 1 2 3 4 5. So we have our token, and if I come here, you can see the entire, so here we are in the ERC20 token, and you can see that how things are happening. Most of the work is taken away by this OpenZeppelin, so you don't need to worry. All you can do is to use the function, so it will have the function symbols and all those things. If you click on the mint, you can see this is the mint function, and that you have to pass the address, you have to pass the amount, and this is the check it do internally. Then we have this required before and these all things. So these are the not pretty hard, self-explanatory. So if you want to know each and every function which we are using, just simply click on this, press control and click on that. It will take you to that interface and you can have a look at what is happening inside that. Okay, so that's the entire contract which we have written for our live token. Simply copy this one and come here and paste that exact code here, and here we're going to do the changes in the contract name. We'll call this, let's say, we'll say boo, and so that's the name of the token we have given. So our two token is ready, live and boo token is ready. So let's close this one, and this looks fine to me. So let's come here and we have to simply compile, clear the artifacts first, and then we have to simply compile it. So you can see successfully compile, and we have got our here we have all the 5 contract which we have written. First we have 2 token, then we have our interface for the ERC20 tokens, then we have the multi swap, and we have single swap. All the contract is ready. So we are done with the 5 contract, and we have tested those contract locally, and our front end is also ready. So what we can do is now we can start connecting this contract to the front end and do those trades and to check everything's working fine or not. So once we're done with that, once we build all the logic for connecting and all the swap functionality, after that we're going to add the liquidity contract. We're going to work on the liquidity contract and do the testing. So whatever we have covered so far, that's what we're going to connect to the front end in the next video. So let's move to that. So the very first thing we have to do is to create a folder. We'll call it context, and inside the context folder we have to create the constants, the same old school we are following here, and this will call swap context.js, and that we're going to build all the functionality. So this is the context folder we have. Now what we can do is, let's come here into the deploy script, and here we're going to build the environment for deploying all the contract. So we have close to 5 contract, and we have to deploy all the contract, so we have to write the script for that. So if we open the contract, here we have all these 5 contract, and we have to build the script. So what we can do, let me give this comment. So this one is this ERC20 token, boo token, and we are deploying that. Simply copy this, paste here, and this will call, simply select all this one and say remove boo, and this will become small b. So this is the boo token deploy script. Simply copy this one and do the same thing for other token. So this will become the live token, and we have to change the name. Here we're going to simply say boo, this one is become live, and what is the name we have given? So it's a live token. So simply replace this live, and this is a live one with small l. So this is the live deploy script. Now simply grab this one, and we have to deploy the, let's say, so this is swap, single swap. Simply grab that one, and we have to deploy that. So paste here, and simply replace this one and change this one and simply say small, and that's the deploy script. Swap, single swap. Simply grab, and we have to do the same thing for the multiple. So change the name, placed here, and this is called MultiHop, and this one, save it, change it, MultiHop, and here we have to make it small, so this will become small s, and small s. So we have this MultiHop. So we have all these 4 deploy script, and we have this one as well. This is the interface we have created. What we can do is, let's create a folder, and we're going to call it interface, and inside that we're going to place this one. And this is the right structure which you have to follow when you are building the smart contract. So if you have created an interface, you have to put inside the interface folder and make it separate between the contract and the interface. Looks good to me, no more problem we have here. So this is all the deploy script, and close this one, and now close this, open up your terminal, and here we go to simply, first thing we have to do is split the terminal, and we have to run the local blockchain. So for that you can type npx hardhat node. This will initialize the local blockchain, so let's just wait. And here we have all these accounts, everything is working fine. Now we have to come here npx hardhat, and we have to clean the old artifact. So not that, so we have to type npx hardhat clean. This will delete the old artifact. So you can see we don't have the artifact. Now we have to compile the code. So if you do that, so let me go up. So this is the script which you have to run. So we are deploying this contract to our local host, and I believe that this is not new to all of you. So this is a script we have to run, and here we have compile, and here we have got all the addresses, So we have the boo address, we have the live, we have the single swap and the multiple swap. So that looks fine to me, no more error we have. Let's come here in the context. But before go into the context, let's come here in the artifact. Inside the artifact we have this contract, and here we have this boo token ABI. Simply drag and drop in the context. Do the same thing for the other token, do multi-hop, and do for the single hop. And we have also created this ABI for the interface as well. So let's get that one as well. Simply copy and drop here. So we have all the ABIs and we have all the addresses. Simply copy this one and paste here, comment this. Do the same thing for the live token, and we have to grab it till here, paste here. We have to grab this single and paste here, and we have to grab this one multi-hop. So these are the addresses we have, and now we have to do the setup. So you know what we have to do. First we have to import the ABI. So that's coming from the same directory. We have to import the ABI for the what is the name of that file? So it's a live token, and that's come from the same directory. We have to import the ABI for the swap what is the name, single swap token, and that's come from the same directory. And the last one we have is swap multi-hop, and that's also come from the same directory. So these are the ABIs we have imported in the context, and this is the right structure you have to build. All the imports, all the private key imports you can do in this way in one single file. Now we have to build the logic. So first we have to do is we have to export this const, and this will say boo address, the token address. Simply grab the token address, do the same thing for the live token address, and we have to do the same for the single swap token address, and this will become the multi-hop swap multi-hop address. And we have this addresses. Simply copy and paste, copy and paste, copy, paste, and copy and paste. So these are the addresses we have. Now we have to import the ABI. So this will call boo token. We have to import the ABI, boo token ABI, and that's coming from boo token ABI. Do the same thing for the other token. So we'll say live token, and export cons live token ABI, live token.abi. Let's make this single swap token, and export cons single swap ABI, and this will become swap multi-hop, and we have the ABI for this as well, multi-hop ABI. These are the contracts addresses and the ABI. Everything we are exporting from one single file. Now what we can do, come here and go into this, create a new folder in the main directory by the name utils, and inside that we have to create one file. In this we're going to keep all the normal functions, like interaction with the contract, connecting wallet, all those functions we're going to write in this utils. And I'm going to call this file name is going to be, let's say, app feature JS, and that we're going to build all the functionality. So what we're going to do is first we have to import couple of things. First, Ethers, and that's coming from, let's say, Ethers, not from Hardhat. And here you can see we have installed this. Okay, I have installed the wrong one. If we have to install with S, so it's only Ether, so simply grab this one and we have to uninstall this package first. Uninstall Ether, and here we have uninstall that. Okay, it's uninstall that, and now we have to import this one. So npm I ethers with S. This is the package we need. It's working fine. So we have this package now working, and that's what we have imported. Now we have to import Web3 model, and that's coming from Web3 model. We have to import this is all the export we have doing from this context, and that's what we have to import in the API feature. So Boo token address, Boo token API, all these we have to import. Simply grab this, copy and paste, and this is coming from the context. Let's import that. Import this one. So here we have all the API and the addresses of the contract. Now things looking good so far. Here we have to import one more thing. So let's come here, import, and we need to import the with API, and that's coming from the same directory. Simply copy that, and here we have to build a logic. So what we have to do is we have to export the const with address, and in that we're going to simply pass this. So if we come back to the single swap token, here we have the token addresses. So we need this one with 9, and this is the address we need. Simply grab this one, and that's what we're going to pass it here. And we already have the API, so we're going to simply call the API, which is coming from here. So that's the with 9 token. Close this one, and that's what we're going to import here. So that looks pretty good. So we are done with all these general setups. Now let's start writing the function for connecting wallet. So let's check if wallet is connected. Export const check wallet connected. It's going to be async function. Try and catch console log out the install wallet. If window.ethereum is not there, then we have to simply return this error message. Console log out this install MetaMask, and in this I want to return the entire error object, so error. So that's the simple thing, the same thing we are doing here. So I'm going a little faster here. Now the second thing we have to do is const accounts, and we have to get all the accounts which is coming from window Ethereum request method, and we have to call this accounts, ETH accounts. Once we get the account, we have to simply call it, store it as a variable, and we want to call it first account. And here we have the account 1, because all the accounts will come in the form of array, and we have to get the first account. And from here we want to return the account, and that's the only thing we have to do here in check if wallet is connected. Simply close this one, and now we have to write the other function. So let's call this connect wallet, and connect wallet async. We'll have this try and catch. We have to console log out the entire error, and here we have to do the same thing. So simply open this one, and we have to get the entire code, copy and paste here. And here the only change we have to do in the method. So let's change this method to request accounts, and that's the only thing we have to do. Looking fine to me. So we are done with this two functions. First, check if wallet is connected, and this function I want to call every time. So whenever someone will visit our application, this function will call, but this connect wallet function will going to attach on the button. So that looks fine. We have this two function ready. Now let's come here. Now we have to start communicating with the contract, and let's connect the contract. So we'll say connecting with Boo token, because we have multiple contract, we don't have only one contract. So this is the one we have. We have to build export const connecting with Boo token async, it will have a try and catch. We have to console log of the entire error object, and in that, first thing we have to do is to get the contract. And this is how we can do const web3 model, new web3 model. We have to build the connection, and then we have to build the provider. That's new ether.provider. In that we have to pass the connection. Now once we have the connection, we have to get the signer, provider.get signer, and then finally we have to simply get the contract. So contract, and here we're going to create another function. So let's call this function fetch boo contract. In that we have to pass the signer, and this is the function we have to create, fetch boo contract. So let's come here and let's create here fetching contract, and we'll say boo token fetching. Create the function, so export const, and it will take this signer or provider. It will take this normal arrow function new ether.contract, and that we have to pass this boo AB addresses. So make sure this is the order you have to follow. First you have to provide the token address, then you have to provide the ABI, and then you have to provide the signature or validator. If you don't provide in this order, you will get an error. So that's the function is ready for interacting with the first token, and that looks good to me. Now simply what we can do, simply, because we have to write multiple function and all the function is going to have the similar structure, so it's better to, what we can do, simply grab this one and paste here. And the only changes we have to do is the name. So this will call live, this will become live, and this will become live. And here we have to pass the right ABI. So this is the address and this is the ABI, and that's it. That's the only thing we have to do. This function is ready. And here we have to return the contract from this function, so we can use wherever we want, whether we want in the navigation bar, footer, or in the context. Return the contract, and simply grab this one and do the same thing here. So this is the two function is ready for both the tokens. Simply copy this and paste here, and here we have to simply change the name again. So this time we're going to call this one swap, single swap, not multiple swap, and that's what we're going to paste here. And this is going to be called single swap, and here we have to change the address and the ABI. So that's the single swap. Simply grab this one and paste here, change the name. So this is the third single swap is ready. Now let's work on the multiple hop. So you know the drill, simply grab the entire code, grab this one and paste here, and this will become IEWTH, the interface, and we'll say width, and we have to change this one as well. We have to change this one, and that's how we are interacting with our interface. So we have our interface ready, looking good so far. Simply come here, and here we're going to pass the width address and pass this ABI. So that looks good. Simply grab and paste one more time, and this will going to call, and we have the another token, because we have two token, we have die and width. So we need to get both the contract instances and both the contract addresses. So we already have the die token, and what I can do, I can simply change the name and change this one as well, and change the name this one as well, is become die. So that's ready, but in this we have to pass the address, the die address, and we already have the ABI. We can use the same ABI, the same interface we have created, but we need to provide the die address. So what we can do, come here, we'll say const, and we'll say die address. We're going to take it the variable. So let's come back to the contract, and we have the address of the die token. Simply grab this entire one, and that's what we're going to simply paste here. So that looks fine to me, no more error we have, and here we're going to simply replace this one. So that looks pretty good. We can use the same interface because all the two ERC20 tokens have the same interface. So it looks fine to me. So that's working absolutely great. We have successfully interacted with the contracts. Close this one, and close this one, close this one, close this one, close this one, and close this one. So make sure to check once more time, check all the function we have created, it's working or not. So right now I'm not creating this multi-hop contract interaction function, we're going to create later. So that looks fine to me. All things are looking good. We have all these imports, all these functions, and here we have all the interaction with the contract. Tokens, we have this, all this looking fine to me. So this is our API features. Now simply close this one, and this is the contract we have. Simply close this one, and now things are looking good. So let's have a look. Let's come back to the context, and now we can go to this actual context. You can easily able to search for the token. So if I want to search for the Ether, you can easily able to search, and you can check the price and the trade volume. You can display the network. So this was absolutely working fine, and we have also done with the pool sections. You can see you can add different pools. So if you add I just want to have your opinions. As you all know that we are working on our decentralized finance DeFi project where we are building Uniswap Clone. And I was wondering that should I include the analytical part or not. So let me show you what I mean by that. So if I come to the pool section and if I click on this top pools, I'll land up here. And I'm talking about this section. So you guys want me to add this analytical section where we can display the entire trade volume of every single token. So right now you can see we have the Ethereum price. We have this different graphs, so you can be able to map the TVLs, volumes, you can able to see the price, and you can able to find all the top tokens. So right now we have this USDC, Ether, all these coins. Then we have the top pools, and you can able to find the pools. So this is the different conversion rate, and that's what we are working on in our liquidity sections, where I have explained you that how you can define this pools. So that video will come very soon in that. So do you guys want me to add this analytical section where we can display this entire data of every single token and every single things? So that's the one part we have. And if I come to the pool section, you can able to see that here we have this separate page for the pools. So if you want to go with a specific pool, you can select that and you can check the pricing. If you come to the token section, if I click on the token section, here you will find the entire data of the tokens with the symbols, and this is how the slider will go. And if you want to know more about it, you want to see the trend, that how the graph is going up, how the trade volume is getting down, how many peoples are buying, what is the trade volume, what is the price. And if you want to check that, we can add that functionality as well. So if I click on this Uniswap, we'll land up here, and here we can able to find the entire data of that particular token, that what is the trade volume, how the price is fluctuating. You can easily able to add the graph, and if I scroll down, you can able to find the top pools. If you come here, you can able to find the transactions which is happening in this particular token. So just tell me that should I include this section or not, because this section is going to be the additional one, because the core function of our decentralized finance is the providing liquidity and providing swap. If you really want me to add this data where we can display the data of all the tokens, all the history, we have two options to do this analytical part. One with the help of the API, and the other one is running the entire Ethereum node in our local computer. So do let me know if you guys really want me to add this in our decentralized exchange, in our Uniswap clones. So if you want that, I can simply build all these 3 pages and we can display all this data. So do leave in the comment section. And if you look at the current project, so we are almost done with this project. So you can see this is our home page. Here you can easily able to select the token, and you can select the different tokens which you want to swap. You can set the tolerance, you can set the slippage. That's everything is working fine. If you come to this token section, here we have built this page, and here we can easily able to search for the token. So if I want to search for the Ether, you can easily able to search, and you can check the price and the trade volume. You can display the network. So this was absolutely working fine. And we have also done with the pool sections. You can see you can add different pools. So if you add a particular fees trade, this is all is dynamic, everything's happening with a smart contract. This price will get updated. From here you can easily able to adjust the tolerance. That looks pretty fine. From here you can easily provide the maximum and minimum price, and you can select the tokens. So all the functionality is done. I'm just making this video to ask you that should I include the analytical part? You want me to display the history of the entire transaction of every single token. So do leave me in the comment section with yes, Daulat, include that. If you don't want me to do that, then say no, don't include that, we don't need that, so I will not include. So the additional analytical part is going to be up to you, all of you guys. If you really want me, do let me know in the comment section that we want that. So I'm going to definitely add all this data which you guys can find here. All these trading blocks, overview, everything I would include here, so you can make a full-fledged decentralized exchange where you can provide everything. So do leave in the comment section and do let me know that you guys want it. If you want, then I can definitely add, otherwise I'm going to skip that. So that's the only thing I want to cover. Hope you guys have liked this video. If you have still any confusion, do leave in the comment section and do let me know. And if you haven't followed the decentralized finance exchange project, then make sure to follow that, because as a blockchain developer you have to know how to work with a DeFi, because blockchain is all about crypto token exchange, and you have to know how the protocol works and how can provide different things. Okay, it's a huge concept, but I'm taking one step at a time to explain you in a better way. So do let me know that you guys really want or not, and after that I'm going to decide that whether I have to include or not. So with that, I'm ending this video. Hope you guys have found this video valuable. If you have still any confusion, any doubt, do leave in the comment section, and I would love to hear from you guys. Have a wonderful day. So this part I'm recording one more time because somehow I deleted my old recording, and what I have found that I don't have this part, so again I'm recording this. Okay, so here we are in swap context. So let's start the code. So we'll type RAFC, and we have to import a couple of things from React, UseState, UseEffect. We have to import our Ether and big number that's coming from Ethers package, and we have to import the, let's say, Web3 model, which we have already installed, and that's coming from Web3 model. Come here, remove this part, and let's do the internal import. So we're going to import a couple of things. So first thing, we have to import as you remember that we have created all those functions in our API feature, and from there we're going to import. So these are the utils API feature, and here we have that we are inside the API feature, and here you can see we have all these function: connect wallet, connect on the buttons, and we have connecting with each of these contracts. So we have to simply copy each of this function, and that's what we have to call in our context. So let's come here. What I have done, I have simply copy and paste the entire function which we are exporting from our API features. That's what I have here, and you can see it's looking absolutely fine. And let's come here, and now we have to import. So we want to import our interface, so IEWTH ABI, and we have to import the ERC20 API, and that's coming from the context. So hope this makes sense. You guys can understand from where we are getting these all functions and all the files. So that's the only setup we have to do, and now we have to create our context. So export const, we have to create our context, swap token context, and that's coming from create context, React create context. This is the context we have, and now we have to create our provider. So const export const swap context provider, and inside that we're going to pass the children, and here we have to pass the data. So we want to return, and what we want to return, can you guess? Because this is the same thing which we are following in other project. So we have to pass this swap context dot provider, and inside that we have to pass the children. So children, and here we have to pass the value. So whatever data we'll pass here, that would be available to us in the entire application. So that's looking fine to me. So what we can do here, we're going to take a variable. So just for example, I'll go and I will pass a variable which I'm not going to use right now, but this is how you can do. You can define any variable and you can pass in the value, and that value is available in your context in the entire applications. So that's the setups which we have done for our swap context, and that's a very simple thing which we have done. That looks pretty fine to me. That's all the setup we have here. And now let's come here, go to this pages, and inside the pages we have this API, and you can see as I already recorded this part, but somehow I deleted that. So that's few codes are already there. So this is the context which we have already set. So here we are importing our context, and that's coming from our swap context. So this is the provider we have, and that's what we are wrapping our entire application. So we have already done this setup, and that's the only thing you have to do in this part. Make sure to follow the exact thing, because from the next video you will have the normal flow, because this is the part was deleted and I have to re-record this video to fix this one. So that's the only configuration you have to do right now in your context, so you can continue working. So with that, I'm ending this video because that's the only thing I want to re-record, and I want to show you guys that these are the contexts you have to do the settings before we start actually writing the functionality for fetching the data. With that said, see you in the next video. Have a wonderful day. So this is where we left in the last video. So let's start working once again. So what I can do, let's give this comment use state, and let's define a couple of states. So we'll take this account, we'll take another one, this will become ether. We'll have to take another one, this will become, let's say, network. So which network we are connected, a user is connected, so we have to get the name of the network. It's going to be a string. And let's get the width balance, and we have to get the die balance as well. So that's the use state we have taken. Let's come down, and now we have to create another use state for getting the token data, and it's going to be an array, because you have noticed in your MetaMask you will have multiple tokens. So we want to get all the tokens, and we can store it into this array, and all the information that how much token a user have in his wallet, what is the name of the token, what is the balance. That's all we're going to store into this token data. So it's array now. So right now we don't have any input from which we can take the address of the token which user want to store in our application. So what I'm going to do is, for the time being, we're going to do hard code. Let me show you what I mean. Just follow along with me. So we'll say add token, and in this we're going to keep all the token addresses which we want to display as a portfolio, that what is the balance of that particular token a particular user has. So we're going to make it dynamic, but for the time being we are just doing hard code. So in that I'm going to paste the address of the token. So I have this token, so let's come here. This is the two token we have created. So let's quickly import that. Get this width token. First one is this width, and the second one we have is this, and this is the boot token. We have simply copy and paste here the boot token in a string, and the third one we have this our live token. So these are the three tokens. For the time being we are just doing hard code, and this looks fine. Now let's come down. Now we have to get the fetch data. So now we have to fetch couple of data. So when a user will come to our application, we have to display the information about him, that what is the portfolio, what is the balance, all those things. So we have to build a functionality for that. So let's call it fetch data, and let's create the function. I'll say fetching data async function, and we'll have this sim try and catch, and we have to console log out the entire error. Look fine. The first thing we have to do is to get the account, and we have the account here. So we have our user account, and we have to set the account. So this is the account of a user who will connect to our application. We have the account. Now let's say get user account. This will become the create provider. So we need to create a provider so he can interact. So let's say web3 model away new web3. We have to build our connections. Inside the connection we have to pass the connect. Now we have to build the provider. It's new ether dot provider and web3 provider. In that we have to pass the connection. So we have our provider. Now we have to check the balance of that user. So const will say balance await provider dot get balance. In that we have to pass the user account so I can get his balance. So once I have his balance, it will come in the form of big number. So I have to convert that. So let's come here. We have to do the console log first to let me show you that what we get exactly. So let's come here. Let's start the application and open up your terminal and split your terminal. And in the first terminal, you have to run your local blockchain. So npx hardhat node. And on the other hand, we have to start the dev environment. So npx run dev and hit enter, open in the browser. And so here everything is working fine. Let's open the logs, and you can see I have to connect with my MetaMask. Let me log in my credential. Let me log in, unlock, and this is my first account. Open it, go back to the second account, and that's what I have. So simply reload the browser and inspect element, go to the console logs, and right now I don't have anything. Reload the browser. Okay, why nothing is happening? So simply come here. Okay, my bad, I have to call this function. Simply copy, and we have to call this function use effect, and in that we're going to call this function. If you come here, reload the browser, and here you can see we got this big number. So it's working fine. We have this big number and it's working fine. So now we have to simply convert this into a readable format. So what we can do is get rid of this, and we can say convert balance. We're going to use this big number from, and then we have to pass the balance, and we have to call this toString method. Once we get done with that, we have to simply console log out the balance to show you. So this is the huge number we have, it's in the string, and now we have to simply convert this into a readable format. So you can see we have a lot of zeros, so we have to define that how many ether it has. So let's come here and let's convert that. So we'll say ether value ether.utils, in that we have a function ethers.utils, in that we have this function format ether, and in that we're going to simply pass the convert balance and simply log it, and you can see we have this 10,000 ether. We have successfully converted that. That's the exact amount we have. So we got our ether. That looks good to me. Simply copy, and that's what we have set as a ether value. Now we have to get the data of all the accounts, all the tokens, all token balance, the token we have designed. So let's write the function for that. So we have the add token, the array, we're going to loop over it, map element I, and that we're going to take a variable. So first give the comment getting contract. So let's get the contract first, contract, and we have this ether.contract, and in that we're going to use this. So we have our, let's say, element, the address, and we're going to provide the ABI. So if you come here, and this is the two ABI we have, but the reason why I'm using the second ABI ERC21, because in that we have the two function, getting the name and the supply name or symbol. So I'm using this ERC20, and we have to pass the provider. This will give us the contract. So let me simply console log out the contract. So if we save it, if we come back to the browser, you can see here we got the contract, 3 contract. If you open this, in that you will have this first token, the address, which is a WETH. But if you close it, this one is the token we have created, our 2 token. So it's working fine. So let's come here. Let me give the comment. We have to fetch the balance of this token. So we can say something like const user balance. We have to get the balance, so we'll have the contract, and that we call balance of, and we have to pass the user account, the person who's interacting. It's going to be async function, and again we have to simply convert this. So here we are getting an error. What? Okay, this is the problem we are having. So what I can do is, let's come here and simply come here, and we have to take a vary value token lift. We'll say big number from, and we have to convert this balance string. Once we convert that, we have to simply do one thing. We have to say convert token balance. We have to convert into ether token left. So that looks good. Simply copy and paste here, and let's try to log out. Still we are getting the same error, but we are getting the balance is 0, and I know why it's happening, because right now we don't have anything. So we are getting the balance. If I open this one, and here you can see this is the token which I have already imported, and we don't have anything in that. So what we can do is, let's come here. So simply copy, and let's try to import it. Click here, import this one, and it says that token has already been added. Okay, it's already added. What we can do, refresh the browser, and still we are getting the same error. What I want to do is, let's come here and let's open up your terminal, stop the application from running, and let's try to deploy the contract one more time. and I guess we get the same addresses. You can see the addresses are same for the tokens and the swap. So all these addresses are same. Let's try to compare it one more time. So this is 70 and this is 6F. This is the single swap token. So this one is same. So this is the life 6565. Okay, it's good. Now we have this one. Simply copy this one is, and it's same. Simply copy this one as well, MultiHop, and this is also same. Okay, no changes we have in our addresses. Now you can close this one and let's start the development. So npm run dev, hit on this, open in the new browser and just wait. We have no error. Go to the inspect element and click on this console, and boom, you can see everything's working fine. We got our token balance. If I open MetaMask, okay, this one is taking a little bit time. If you can see, this is, we are in the account 2 and we have paid a little bit gas amount for deploying the contract. That's why the ether is not 10,000, it's less. So it's working fine. It's working fine. And if I scroll down here, you can see we have these 2 tokens and the name is different. And the reason the name is different is because I was already created in other project and I got the same address in that project as well. That's why the name is there. Okay, no problem. What we can do is, if the name is different, we can simply click on this, and simply we can hide this token. Hide. We do the same thing for this token as well and hide it. So the 2 tokens are gone. If you refresh the browser, you can have the balance. And if you really want to import the token we have created, simply grab the addresses and import it. This time you will get the right name. Hit enter. You can see the name is displaying Boo and add token. So right now we have this Boo token. Do the same thing for the other one. Copy, paste here, and here we have that live token. And the reason why it was not working in the first place, because I was not deployed. Actually, I would deploy the contract, but I got an error and I stopped the application from running. And when I restarted the application, I did not deploy the contract. That's why we were not getting the token. So if you still have any error, make sure to delete the artifacts, redeploy the contract. It will work fine. So things are looking good. So right now, if I copy and try to import it, and this address is for the mainnet. So we are working on the forknet, and this is the real address, so which we can't use in the local host. So that's why you are getting this error. So simply remove this. What we can do, simply comment this, because we don't have any ether in that, and that's why we are getting that error. So simply comment this, and you can see the 2 token, we have the balance is working fine. So bring this one down and simply remove this. And here we have that. Let's try to get the data. So get name and symbol. So we have the balance. Now we have to get the name and the symbol. So let's say custom symbol, contract symbol, and let's get the name. So contract name await. So this is the name and symbol it will provide. Once we have the name and symbols, we're going to take our data array, token data array, and in that we're going to push all this. So we have to push this. So we want to push the name, we want to push the symbol, and we want to push the token balance. And we have called token balance, but we have called converted token balance. Paste here. Okay, so that looks fine. We have the data. Once we have the data, simply console log out the data that we are getting that or not. So let's console log out the data, and here you can see we are getting those data. Refresh the browser, and here you can see we have the array. If you open that, it's rendering twice, but we're going to fix this one. You can see this is the first token we have. The name is LF, the symbol is Boo, and the total supply is balance is given. If I open the second one, is also LF. Maybe I have not changed the name of the token, so it's working fine. You can see we have the Boo symbol and life. So this is the name, this is the symbol, and this is the token balance. If you look at the second one, this is also have the same name. So maybe I have done something wrong in the contract. So if I come here and if I go into the contract in the boo token, and that's my bad, actually I haven't provided the name, I haven't changed the name, it's LF. So just keep it like this for the time being. We're going to do the changes at the end when we'll actually deploy to the Gorilla test network. So let's leave it like it. It's working fine. We can easily able to fetch the data and we can store as an array, so we can display in our front end application. So that looks fine to me, and that's the data we have. Now let's come here. No, we need more data. So if I come here, and this is, you can see we have this width and die. So we have to fetch this token data as well for the time being, because when we go to do the single swap or multiple hop, we're going to do between these two tokens. So let's get the balance of these two tokens as well. So what we can do, let's scroll down and we can get the data here. So we'll say die balance, and we have to interact with the contract. So we have the contracts. So this is the width, WITH. We have to call, say, die, and in that we're going to simply pass the die to see the contract. So let's come here, and this is the contract. It's working fine. You can see this is the contract we got, die. It's actually width, so let's replace it with width. So, and here we're going to say width balance, width dot balance of, and that we have to pass the user account and simply grab this part, because we have to convert this balance into a readable number. So this is width, that's the balance we're going to provide here, and we're going to change the name. We'll say width token, and that's what we're going to pass it here, converted. So we're going to say width. So we have to have our width token, simply call this set die, and then that we're going to simply pass this, simply pass this one, set die, replace this one. So it's look good, we don't have any error, everything's working fine. Replicate it, and this will become width, and let's see what's the name I have given. So sometime it happens. Okay, so this is die, copy that one, and that's what we're going to paste it here. And here we have to make the changes. Instead of width, we have to call it die, DAI die, and we have to simply change the name. So this is set die, and what happened? So set width 9. So that's what I'm going to call it here, set width 9, and here we're going to simply call this console.log, and I want to log out the die and the width. So this is the data we want to take. So it's a width 9 and die 9. So okay, so simply come here, paste here width 9, and this become die contract, and this become also contract. So it's become very easy to read, contract, and this become contract. And this is the spelling mistake I have done. It's a DAI, and here I have called DIA. So simply change this one, change this DAI, and this will become DAI, and here we have to do the changes. So this has become DAI, and this is also a DAI. So make sure to do these changes. And if I refresh the browser, and here you can see an empty balance. The reason why we are getting this empty, because we don't have any balance in our die and the width. Everything's working fine. So let's redo the browser. Still we are getting the same thing. So the things are working fine. So just we keep it like this for the time being, and let's paste here, and you can see the balance we are getting is 0. Fine, it's fine. Here we are getting the balance. So simply come here and remove that. Things are looking fine to me in this fetch data function. So let's clear it, and I know it's a huge function. So simply grab this account and we have to pass it here so we can receive in other places. So simply remove this one, we don't need it, and we have to simply simply close this function, and we have to get this width 9, we have to get this die, we have to get this connect network, and we have to get this as well, ether. That looks fine, and I think I'm missing something, so remove this one. So these are the things we have. Open this one, and now I forgot to write one more function. We have to get the name of the network. So what we can do, let's come here and let's get the name of the network. So we can come here, let me give the command get network name, const will say network, wait, we have the provider, and that we can call this simple function get network. It will give you the network name, and we have to set that network name, network.name. If you console log out the network.name, you can see we are connected with this unknown network because we are using our localhost, and this is a chain ID. So sometime you have to do this configuration in our Hardhat config file or in your MetaMask if you encounter any type of error. But whatever we are covering right now, you have to follow the exact step whatever I'm following. You have to install exact packages whatever we have installed. So things are looking fine. If you reload the browser, you can see we got the chain ID and the network name. Looking fine to me. Oh, that looks pretty good. So that's the network name we have, and so far things are looking good to me. So that's the only thing I want to cover about this fetch data. With that said, let's move to the next video. So this is where we left in the last video. So first thing we have to do, come here and close this one, and here come into the navigation bar, and we have the data, like we have the name of the network, we have the account address. So let's test with those data we have already. What we can do here, we have this context, and that we're going to import the data. We're going to import the ether, we're going to import the account, we're going to import the, and here we have two accounts. So right now we don't need this one, so you can do one thing. Let's see where we are using. So simply comment this, and we have the network. Here we have it, the network, and here we are displaying the demo network data account, and here we have to display the account address. So type account, and looks good to me. If you save it, refresh the browser, okay, we are connected, but still we are getting that connect wallet. So okay, my bad. If we have an account, then we have to display connect wallet, and I know what is the problem. Simply grab this entire one, and we have to copy this one here, and this one is down below. So if we have an account, then we want to display this first button, but if we don't have the account, then we want to display this button, connect wallet button. And you can see we got our address, but it's pretty huge. So what we can do, we can slice it down. So we can use the slice function, and that I want to take this 0 and I want to take 20 characters. So that looks good. It looks good. What we can do, let's pass dot 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 dot, so the user can understand that there is more address. Or you can do one thing, you can add a click button, like when someone will click on that, the address will get copied. You can add that as well, but we're going to add it at the end. So we have the address, looking fine, and you can see this is the demo data, the demo token list we are displaying here. But here we're going to display all the list of the token which a user has in that particular account address. This looks fine to me. Now we have this network, and we have to display the network name. So where we are displaying the name of the network, and here we have the network name, the data, and this is where we are importing, and here we are calling that. Simply replace with this actual network name, save it. You can see right now we have unknown, and that's what it is displaying. So no matter user is connected with the test or the mainnet, this will get updated. So network name is also working fine. Now let's come here and Scroll all the way up, simply open this one, and what else we can display. Here we have this connect wallet function which we are passing in this open model. So right now we are sending this text, but we need to send the function. So let's come here, and if we come here we have the function in our context, swap context. Simply copy, and that's what we can pass here. So we can receive this function. So here in the navigation bar, let's receive it. Let's receive the import the function, and that's the function we're going to pass it here. Pass the function connect wallet. So that looks fine to me, and this is the data. So remember that the data we have got, token data, that's the data we're going to pass here. So right now we are passing hey. So let's come back here, and in this array we have the data of all the tokens. So simply get the token data and simply receive it here in the context, and that's what we're going to simply pass it. Simply copy that one, and that's the data we're going to pass it here. Instead of this text, we want to pass the entire data, and we are receiving here. So here we have receiving this token data. Simply grab this one, and that's what we have to paste here. And here you can see we are using this demo data. So what I can do, simply paste this token data, and let's comment this one. If I save, if I click on this, okay, we are getting this error message, undefined. Why so? Cannot read properties of undefined. So to see the data, what I can do, let's bring it back. That's mean somehow the data is not coming. So it's looking fine, and that looks good to me. No problem. We have to check in the function that why we are getting this undefined. So if I come here we have this token. If I try to simply console log out the data, console.log the entire token data, and if I do the inspect element, you can see here we got the array. So this we have two tokens, but it's repeating 3 times. We're going to fix this behavior, but right now just focus on the token. So we are getting the data, but why it's saying the undefined? If you reload, we are getting this data, name, symbols, and the balance of each token. It's working, but why it's showing me this weird behavior? And simply come here, let's try to log the data here. So token data, and let's try to refresh the browser, and nothing we got here. We got nothing here. Let's come here, and what I can do is I can simply console the data here in this NavBar. So here we are receiving, simply paste it, and no response we are getting. Let's come here, and here we are importing from the context. Simply grab this one, and let's try to console log of the data here. So console.log token data, it's a token data, and simply copy this one and paste here. Okay, that looks good. Okay, I'm getting undefined. So the data is undefined. So maybe we have some problem in the context itself. So let's try to check what's the problem. Everything's look good here. Here we have the data, and I found the problem that here we actually not passing the data in our children. So here we have to send the data, and because of this we were getting undefined. So make sure to do this. And if we come here, and if we go to this component NavBar, and here we are in the NavBar section, and here we are receiving that data. So what we can do, simply come here, and we're going to pass the data here into this token list. That's the data we are passing, get into this component, and here we are receiving that console.log, and just open up the browser, do the inspect element, and let's test this out that do we exactly getting the data or not. So console, and here you can see that still we are getting undefined. Make sure to reload the browser to make the things happen, and nothing happened. That's weird. So what we can do, simply cut this one and simply copy this and simply paste here. So right now we are not using our demo data, we are using the 2 tokens we have, and that data we have inside this token data. So let's try to save it, and let's try to reload the browser, okay, and here you can see it's working. Here we got this 4 token. Actually we have 2 token, but our data is getting repeated, so that's why you can see there are 4 element, but we actually have 2 element. So let's reload the browser and click on this, and here you can see we have the data. Don't need to worry about this repetition. We're going to write a small little fun script which can solve this problem. So that looks pretty good to me. It's working, but why the data is not displaying here? So what I can do, let me console log this out here, and let's try to find out that why the data is not displaying here. So I'm going to simply pass the data. So here we have the data. Now let's do the inspect element and let's try to have a look one more time. Still this is empty. That's weird. Okay, so we can't get this data. Simply cut this one and come back to this NavBar, because here we are sending that prop. So let's come up here, and here you can see that we are getting this data from this context, and here I'm going to simply console log out the data. So simply console log out the data, and let's see that do we have the data or not. So let's console log out this, and here you can see that here we got that token data. So you can see we have 4 array because 1 token is getting repeated. We're gonna fix this. So inside this 0 element first array, we have the name, we have the symbol, and we have the token balance. Simply come here and let's get into this token list, and here we are hard coding the value. Now we're going to display the actual data. So here we have the hey, so which I'm going to remove with the name. So we have the element, inside that we have the name. Now we have to take the symbols. Simply grab the symbol, come back. Here we're going to display the symbol. So element.symbol. And here you can notice one thing, the symbol has a big name. Okay, I made a mistake. So instead of symbol, I have to add name. And at the place of name, I have to add the symbols. But just go like this. You can see that the data is working fine. So let's take this token balance, and that's what we're going to display here. Element.token balance. It's looking fine to me. Now what we can do, come here, reload the browser, and let's try to check this out. If you click on this, and here you can see that we have the symbol LF, and we have the name of the token, which is a boo token, and the live token, and we have the total supply. So each of these token has 10,000 tokens, and that's all we can easily able to display right here in this component. So that's working fine. The logic is also working fine. We can easily able to retrieve the data and display the data. Everything's working fine. Now let's reload the browser and click on this. So this looks pretty good. Let's come back to the code, and what we can do, come here, and now we have to filter the data. So right now you can see the data is repeating twice. Now what I want to do is, I'm not going to do the changes in the entire data model, so I'm going to write a small fun script which can do that for me. So if you want to do it in your main data model, you can do that, but I will go in this approach. So let me take a variable. I'll call it let token list. It's gonna be an empty array. Inside that, I'm going to run a for loop. So I'll say let I is equal to 0. If I is less than the token data dot length, then we want to increment that. So I plus plus, that's the script we have. Now we have to check for a condition. So we'll say if I, and if I get the remainder 1. So what I want to do is take that element, and I want to push that element into this array. Very simple logic. I hope this makes sense to all of you guys. So right now we have the data into that token list, and that's the data we're going to render here. So instead of this token data, we're going to simply paste this token list data. So if you save, and here you can see, boom, it's working fine. So we have our 2 tokens, life. The bow is not displaying. Okay, so we're gonna fix that. But it's working fine. You can see that we have reduced, instead of 4, we can reduce the 2. So that looks pretty fine to me. So let's come back to the code, and that looks pretty awesome. So don't need to worry that currently the boo token is not displaying. I know why it's not displaying, because we have lost tokens. So it will work fine when we'll add more token, which I will going to definitely fix that problem. So just go in that way. So that's the entire code. That looks pretty fine to me. Now let's close this one, and this is the entire swap token, and this is the entire fetch data function we have written. We are calling that function, and let's come here. What I want to do is, this is the entire state we have. Now we're going to write the actual function which allow us to swap the token in our front end. So you have seen that we have tested the smart contract in our Hardhat test file, but now we're going to connect the smart contract with the front end, and we're going to swap the token. So now the fun part is getting begin. So let me give this comment. So I'll say single swap token, and we get here functions. We'll say single swap token. It's going to be an async function again because we are dealing with the promises. It will have this try and catch, and inside this we're going to log the entire error. So that's the error we have, and now we have to simply get this, create a couple of variables, because we have to store the instant of the smart contract. We have to store the ABI of the smart contract, the tokens we want to interact as a global, so we can use in other functions. So just code along with me. Let's say single swap token. We'll take another one with, and this is going to be a DAI. And because we generally going to perform this swap between with token and the DAI token, because we are connected with the Fort network. So actually we are using the mainnet as a copy, and we are doing the transaction. So take this one, and now we're going to simply deploy the contract. So we'll say come here, and here we have the contract connecting with single swap token. Simply grab that one, and that's the function we're going to call it here. So here we'll get the entire instance of the contract. Once we have the instance of the contract, now what I want to do is, let me call this function. So I'll say use effect, and inside that I'm going to call this function, not this one. Come here and grab this one, single swap token, and it's going to be an empty array. So hope things are making sense. Pretty simple. Now we're going to simply console log out the entire instant of the contract. So let's come here, and not this one, and here we are on the application. Open up inspect element and do the console log, and boom, here you can see right now we have those arrays. Come back to the console, and here you can see right down below we have our contract. Click on this, and inside that you will have the instant of the entire smart contract. So we have the DAI, we have the width, we have the address, and we have all the function we have included into our smart contract. You can open and you can check everything, so we can easily able to get the instant of the contract. So let's come back to the code. Everything's working fine. Now let's start working. Now we're going to get the contract of the with token and the DAI token, and we have already done that. So simply grab this one, with token contract, and that's what we're going to call it, and we're going to call this one. So in this way we can easily able to have the instant of the contract. So let's paste here. We have the instant globally, and now we're going to take a variable amount in, how much amount we want to do the swap. So let's define that, and now let's come here. So once we have that, we'll say await dot with deposit. So we have to deposit the contract to, we have to deposit the amount to the contract, then the contract going to swap it and send it back to us. So let me console log out this with, this is the contract, and that's what I have. Simply come here and refresh the browser. So here you can see we got two contracts. So this is the data, entire data we have. So let's come here, from where we getting those data logs. So if I open this, no, in this I'm not logging any data. So this probably is coming from the NavBar. So it's coming from the NavBar. So come here, go to this NavBar component, and we are just remove this one and save it. Reload the browser, and now we have our console pretty clean. So these are the two contracts we have, and this is the second contract, the with. We will have the address of the token, then other function method we have available, and this is the first one. Okay, that looks pretty good to me. Now let's come back here. Now what I can do is, we have the with instance, and now this is the one we have. Now we're going to call this function. So where is the function we have? Deposit, because we have to allow. So we're going to call this, simply remove this one, and here we're going to simply uncomment this one. Uncomment this, we'll call it value. So this is the amount we want to send, and remove this comma. Now we're going to call this approve. So we have to approve the smart contract address and the amount, and let's do the swap. So await single swap, and that we have this function. So let's come back to the contract, and inside the contract we have the very first function, the where it is. So this is the function swap exact input single. So we have to pass the amount, and this function will do the swap. So let's copy and come here and simply paste here. So in that we have to pass the amount, and we have to pass the gas, that how much gas we want to estimate, otherwise it will throw an error. Okay, so let's come here. We're going to say that close to 3, that's the gas estimation we have, gas limit. Let's come here. Now we have to get the balance, await, and we have the DAI balance, and we'll pass the account, because we're going to transfer the fund to this account. and we have to check the balance of the account as well. So let's come here. We have the balance. Now what we're going to do, we're going to convert that. So we'll use this big number from, and that we're going to pass the balance, and we're going to convert it into a string, into a readable format. Once we have the data, simply provide this comma. Let's come here. Now we're going to simply set the value. So ETH utils, and we have to convert into a ether. We'll say transform, and once we have the data, the balance of DAI. So let's come here. Here we have already taken the state, use state. So here we have this set DAI. Simply copy that one, and we're going to say store the data into that. So let's come here, and where it is, here we are. ETH value. That looks pretty good. Now let me console log out to show you. So console.DAI balance, and we're going to say ETH. Provide this comma, and that's the entire function we have to write for the swap. So simply copy that one. And come here. First thing, we have to remove this because we don't want to call this function whenever someone rolload the application. Okay, we want to attach this function on a button. So copy this one, and that's what we're going to pass it here, so we can receive wherever we want. And simply grab this, come back here, go to this where we can go. We go to this hero section. Inside the hero section, we have to simply call the function here. So let's come up here, and here we can see that we don't have our context. So first thing we have to do is to get the context. So let's get back to the navigation bar and simply grab this entire one, copy, and come back and paste here. So that's the context we have, and we have already imported the context. So let's come here, and we're going to import the data. So we'll say const. We have to use the use context, and in that we have to pass our context, the same old schools we are following. Swap token context. So we have the context, grab the functions, and that's what we're going to receive here. So paste here. So that's the function we have, copy, and that's what we're going to call it here. So let's scroll down, and here we're going to call the function. So swap, paste the function, and later we're going to define and pass the data, the amount into this, but right now we are doing hard code. Okay, so just call the function like this. Later we're going to make it more dynamic. So that's the function we have, and what we can do now, here we have connect wallet function, grab that one, and that's what we're going to attach right up here, connect wallet. Let's take a on click and wallet, and that's the function we have. So it's looking absolutely fine to me. Now let's come here and reload the browser. And here you can see that we have called the function straight away, and it's automatically triggered the MetaMask. So we simply cut this one and reload the browser because we want to do it, everything's manually. So click on this. We have the tokens. Things are looking pretty fine to me. And let's come here, reload the browser once again, and let's do the inspect element. Click on inspect element, and now go to the console, and let's make the transactions. So let's come here. Now reload the browser, click on this connect wallet. Okay, so we are getting this error, connect wallet is not defined. What is this? It's not defined. So let's come back to the code, and here we are calling the functions. Simply grab the function, and here we have the account. Let's come here, and actually we are not receiving the function here. So we have this account, and that's what we are calling here. So I know what's the problem we have. So let's come here. We have to take a console.log. Simply cut this, remove this one, because we can take the account and the connect wallet from direct context. So we have our connect wallet, save it, and still we are getting the error that account is not defined. Obviously we have removed that, so it's not there. So what we can do is, now we have to import the account as well. So let's come here, and we'll say account, only account, not accounts. So if we copy and come and paste here, because I'm really bad with the spelling, and let's scroll down here, and here we have the account. Simply paste here. So make sure you should do these changes, save it, and come here in the browser, and you can see that here we have this function. The button is saying that connect wallet, but instead of connect we want swap token. So we have some issues in that, so not a big deal. Let's come back to the, let's reload the browser and come back to the code, and we have to grab this function and we have to paste here. and this function, this button, we have to paste down below. I believe that you guys have understood that why we have done that. If we are connected, if account is there, then we want to display this button, swap button. But if the account is not there, then we have to display this connect wallet button. So that's why we have done this. So it looks pretty fine to me. It's pretty fine to me. And let's come here. It looks pretty good to me. So let's reload the browser and let's try to have a transaction. So let's click on this swap. Here we have the MetaMask, and here you can see we are trying to send that 1 Ether and we are calling the deposit function. That's the function we are calling. So here you can see complete confirm and boom, and sorry. And here we got an error, and I know why this error has happened. So let's click on the MetaMask and we have to clear all the histories. So here the transaction got failed. Click on the setting and we have to remove the reset account and reload the browser, and this will fix the issue. If it's still not fix the issue, make sure to stop the application, restart the application, clear your MetaMask, and that will fix the problem, because this problem is not related with the code, but it's has the problem in the MetaMask. So that looks pretty good to me. Now click on swap, and here we are again interactive with the MetaMask. Here we are depositing 1 Ether. Here we have another MetaMask pop-up, and here we are confirming. We are giving the permission to our smart contract, Uniswap smart contract, to transfer the fund on behalf of us, because we're going to receive that fund back. So here we are providing the permission, access your ETH. Click on confirm, and one more pop-up will get open, and here you are making the transaction, calling this function swap exact input single, and you can able to find all the data. Click on confirm, and boom, the transaction went. Just wait, because it will take a little bit time, and here you can see that we got this much DAI back. So we have sent 1 Ether and we got back 11.17.8 Ether back in return. So 1 Ether valued that much DAI, and you know that DAI is a stable coin. So 1 DAI is equal to $1. And currently the Ether price is above 11,000, close to the exact amount. If you calculate into a dollar, you will get the exact amount which is for Ether. So we got our DAI balance. It looks pretty fine to me. This is a huge number. Now what we can do, come back to the code and click here, and let's come here. Here we have the entire smart contract which we have written. Here we have this V3 and we have the Ether, we have the DAI, everything we have. So simply grab one thing, and here we're going to display the balance itself. So right now we are displaying this hardcode value. So what we can do, first thing we have to receive the data with, and we have to receive the DAI. Simply grab that one and paste here, copy that one, and simply come and paste here. So we have to paste this V3 and we have to paste the DAI as well. So scroll down, and where it is, here we are. Simply place the DAI and save it. Come back to the browser, and here you can see that the V3 is not displaying, but our DAI balance is displaying. So it's working fine. So we have to go through this. Okay, I know the problem why it's happening, because we are calling the wrong variable. So instead of ETH, we can have to call Ether. So let's come here, and we have to grab this Ether, and that's what we have to call, because we have done the swap in exchange of Ether. So let's come here and paste that Ether. So we'll save it, and here we have this Ether. So we have right now 9998 point this much Ether in our MetaMask. Obviously it's a fake Ether, we are using Hardhat. So this much Ether I have. So it's looking fine to me. Now if we have to make it short, because this balance is really big, we have to slice it down. So we'll say something like we'll start from 0 and we'll go all the way to, let's say 5. Let's save it. Okay, let's make it 7, 2 digit. So this looks perfect. Now the same thing we have to do with the other currency. Simply grab that one and simply go to paste it and save it. You can see right now it's looking perfect. We have 7 digit. Looks fine to me. Now reload the browser and let's try one more time. Let's swap that. So right now you can see the balance I have in Ether is 9998.92, but the amount I have in the DAI, I have 1178.92. So again I'm going to do the swap, and you will see that this number will go up. the DAI balance will go up. Click on this swap. Here we have the MetaMask. Again, we are giving 1 Ether. Click confirm, and here we have the another MetaMask, another pop-up, and now we have to give the permission to spend that, confirm it, and here we have the final one to make the transaction. So confirm. So generally this process will take a little bit time, so just wait, and we're going to reload the browser, and boom, here you can see that right now the Ether we have is 9997. Earlier we had 98, and the DAI balance is also gone up, so 2357 now we have. So it's looking pretty fine, and our single swap is absolutely working perfectly in our front end. You can see that's absolutely perfect, looking fine. We're going to add a lot of things. So right now you can see that we are going with the hardcode value, but in the production level we're going to allow the user to provide the slippage, to provide the tolerance, to provide the option to send as many Ether or DAI they can swap in exchange of that. So we are doing this just for testing purpose. Once everything's working fine, we're going to make it dynamic. So you can see everything's working fine to me. This function is really look good. This looks pretty good to me. Let's close this one, and close this one. So just close this one, all of these. So right now we have this clean environment, no more jargons we have, and that's the only thing I want to cover in this video. Hope you guys have found and everything makes sense. Still, if you have any confusion, any doubt, do leave in the comment section, and do let me know that what problem you are facing. With that said, let's move to the next video, and that we're going to do some magic. In the last video, we have tested our smart contract, single swap smart contract, and connected with the front end, and we did the swap. In this video, we're going to write the smart contract for liquidity, and that's the contract is one of the most important contract when it's come to decentralized exchange, because you have to know how to provide liquidity so anybody can add their token as a liquidity, so anybody can come and purchase and do the swap. And that's the contract we're going to build right now. So here we are back into the project. Let me open the contract, and inside that I'm going to create a file. I'm going to call it liquidity, because that's the contract we're going to write. So that's the contract we have. Let's come here, and now let's start writing the smart contract. So we're going to follow the same old school. We have to provide the license identifier, SPDX license identifier, GPL2, and this. Then we have to define the Solidity version. We're going to take this one. We have to provide the Pragma ABI encoder, so we can do the struct. We can use struct and arrays, nested array. Now we have to import couple of packages. So we need to UB core contract interface Uniswap V3 pool. Now we have to install the Uniswap V3 core contract library, take math soul. We have to import this OpenZeppelin contract token ERC21 ERC receiver dot soul, and we have a Uniswap V3 periphery contract library transfer helper dot soul. We have Uniswap V3 periphery contract interface if in non-fungible position manager dot soul, Uniswap V3 periphery contract balance liquidity manager management import hardcode console. So these are the important packages which we're going to use in this liquidity smart contract. So you can see that we are using OpenZeppelin, we are using Uniswap V3 core, we are using Uniswap V3 periphery. All these tools are really powerful, and without these you can't able to create your liquidity smart contract. So we are using OpenZeppelin, and this package is really very important, and that's what we're going to use it to create the instances of our liquidity. So everything will make sense. So make sure you have to type the exact one. You have to use this variable. Okay, so let's continue. So let's come here. We're going to define the contract. We'll call it liquidity example is, and we are going to inherit the property. So we're going to inherit this IERC 721 receiver. That's the contract we have. And I'm getting this error message because currently I'm testing an extension which we have developed. So that's why you can see that I haven't done any configuration. So that's why I'm getting this error message. But let's complete the smart contract. After that, I'm going to fix it. So let's take a variable, say address public constant DAI. So this is the DAI token contract address which I have got from the mainnet, which you will find in the descriptions. Sorry, starter file. Now we'll take another one constant, and this is going to be USDC. We'll have to provide the address of the contract. Now we're going to come here. We're going to define that fee we want to charge whenever someone will do the swap. So we're going to take 0.01% fee. You can take it 0.03% or you can take it 1%. But in most of the exchange, you will find that this is the range. Generally, the liquidity providers takes 1 to 3. Now let's come here. We have to define that UNT public constant pool fee is going to be this 100. And the reason why I have defined constant, because I'm not going to change this pool fee, although you can. But when you have to change this pool fee, on that time you don't need to define this word constant. So we have our pool fee, sorry. Now we have to take this non-fungible position manager, and this will allow us to create the liquidity. So we need to have it. So we'll say public non-fungible position manager, and in that we have to define the address. So we'll say non-fungible position manager, and in that we're going to type the contract address. So right now I'm going with this hardcode value, or if you want you can pass this same thing in the constructor at the time of deployment and you can update this variable, but I have the address, so I don't want to use the constructor to paste. So this is the address you have to pass. Now let's come here. We have to, let me give this comment, say notice represent the deposit of an NFT. So we're going to follow some of the structure for the ERC71, and that's what we are inheriting from OpenZeppelin in our contract, because every liquidity will have a unique identity in our exchange, so we can easily able to identify, and that can be only possible when you are using the inherent properties of ERC20 tokens of like NFTs. So just follow along with me. That's what I have mentioned here. So let's define the struct. So we'll have a deposit, and in that we have to define that address honor. Then we have to define the UNT is the liquidity, the amount of liquidity we have provided. Then we have the address token 1, and this is going to be the token 1. So token 0 and token 1, because in that we're going to provide the liquidity. So that's, we have our struct. Let's close that one. Now let me give this command dev deposit token ID deposit. So we have to create a mapping. Let's create a mapping. UNT we can say deposit public deposit, because all the liquidity is going to be stored into this mapping. That's what we have here. Now let's come here. Let me give this command store token ID used in this example. So UNT public token ID, and that's because every time someone will provide the liquidity, this token ID will get increased. So when someone will provide the liquidity for the very first time, that person will assign ID1, ID2 or something like that. Okay, so we have the IDT. Let's define that implementing on ERC receiver, so that this contract can receive custody of ERC70 token, and that's the package we are getting from the OpenZeppelin, and that's what we are utilizing. So let's come here. We'll create a function on ERC70 receiver. We're going to add the address operator. We're going to add the address of, and we're going to add the address of the token ID, and we have to add this byte data, the data we want to provide. So call data external override returns, it's byte 4. Now let's come here. We have to create deposit, and in that we're going to pass this two data, operator and token ID, and this function we're going to create. So it's going to be an internal function. Let's define the variable. So we have to return this dot receiver dot selector. Once we have that one, now let's come here and we have to create a function dot create deposit. It will have a owner, it will have the token ID internal, and we have to define couple of variables. So let's provide this comma, and this is the structure we have got in the documentation of ERC20 token, and that's what you have to follow here. So we have to provide the address token 0, we have to provide the address token 1, we have to, the other one we have is this dot, then this we'll say UNT 128 liquidity, and this one is going to be comma, and this one will be have this one. Non-fungible position manager positions, and in that we have to pass the token ID. Let's give me this command, set the owner and data for position. So for that, what we can do is, let's operator is a message.sender. So whoever will call this function will call this deposit. In that we're going to pass this one token ID, and we have this struct, and now we have to update that. So we have this owner, and we have our liquidity is liquidity. We have to provide the token one, first token, and this is going to be the second token. That looks pretty fine. Let's come here. So that's the come here, and we have to simply console log out the token ID so we can check that it's working or not. And now we have to simply pass out the liquidity so we can see what's the liquidity exactly we have got. So that's working fine. Now we have to simply take this token ID to token ID, and now we have to write the other function. So with that, we are done with this function. So we have created the function which can create the liquidity, and now we have to write the function which can mint. So let's create that. So we'll say function mint new positions, and in that is going to be external. This will say return UNT token ID, UNT 128 liquidity, UNT amount, and this will become UNT amount 1. For this example, we will provide equal amounts of liquidity in the both assets. And that's generally what happened in decentralized exchange. So when you will create the liquidity, you define a 50-50 ratio. So don't need to worry, we're going to talk about the concept that how you have to define the right liquidity so it can create good impact on your liquidity, so you can earn more money from your liquidity which you provide on decentralized exchange. So we're going to talk about that concept. Just write the smart contract and everything will make sense when we'll connect this contract and do the swap in the real applications. Everything you will make sense. Just code along with me. If you have any confusion, any doubt, do just keep that for a time being. Just code along with me. So that's the asset we have. Let's give this comment. Providing liquidity in both assets means liquidity will be earning fee and is. So UNT amount to mint itna, that's the token, and that's the second one is going to be this much because we are doing with the with to die. That's the amount we have. Let's approve the position manager. So we have this transfer helper, save, approve, and in that we have to simply pass the data. So we have to provide the die, and we want to assign this non-fungible position manager, and we have this amount. So we are transferring now. We have to simply use the transfer helper, save, approve, and in that we have to simply assign the data. So we have this USDC. Then we have to define the address, so non-fungible position manager, and now we have to define the simply the amount, so 1. So that's the safe transfer, approve. Let's come here, use the non-fungible position manager mint params, and in that we have to use this memory params, and we have to define this non-fungible position manager mint params, and in that we have to define the entire object. So the thing we have to provide is token is going to be the die, and token second is going to be our USDC, and we have to define the fee. So we're going to take the exact fee of the pool fee we have defined. So that's the pool fee we have, and let's give this command by using this tick math mint and tick math max tick. So we are providing liquidity across the whole range of the pool. Again, it sounds complicated, but just follow along with me. Not recommended in production. Tick low is going to be tick math min tick. We have this tick upper tick max tick. So that's what we have here. Now we have to define the amount desirable, and this is the amount we have to pass. Amount 1 desired, and this one. Amount min is going to be 0. Amount 1 min is going to be 0. We have to provide the recipient, so it's going to be the address this. Deadline is going to block timestamp. Now let's do that. Note that the pool defined by die used. The reason why I have provided this comment, that if you really want to know that what is the pool fee exactly happening in Uniswap, so if you visit the Uniswap pool section, in that you will find the range of the entire fee which you have to pay if you really want to do the swap from any token. So the current fee in the Uniswap exchange is from between DAI and USDT is 0.01%, and that's the exact fee we are defining here. Already be created and initialized in order to mint. So let's take this token ID, liquidity, amount 0, amount 1, and we call this non-position manager, non-fungible position manager, and we have to call this mint, and in that we have to pass the entire data which we have defined in the param. So that looks fine. Let me give this command, create a deposit. So we have to call this create deposit function. In that we have to pass the sender and the ID as well. So let's come here. Let me give this command, remove allowance and refund in both assets. So if amount is less than amount 0 to mint, so if amount 0 is less than amount 0 to mint, in that condition we want to simply call this transfer helper.save approve, and we have to define this data. So the data we want to define is DAI, and the second one is going to be, let's say, address non-fungible position manager 0, and let's call the unt refund 0, and we have to provide the amount minus this transfer save transfer DAI message.sender and refund. If amount is 1 is less than, now we have to do the same thing whatever we have done with the first one, amount 1. Let's do that very quickly. Transfer helper.save approve, and we have to simply approve it. So this time we're going to approve the USDC. Now we have to simply approve the address. So address, this will become non-fungible position manager, and now we have to define the amount. So the amount is going to be the 0. Let's close this one, and now we have to call this function. Let's take a variable unt refund 1, because that's what we have done in the previous one, and we have to subtract it. Once we get that, we have to simply approve that. So save transfer, and then we're going to pass this data. So that looks pretty good to me. So let's come here, close this one, and so that looks pretty fine. With this we are end with this mint position function, which allow us to mint the liquidity into our decentralized exchange. Now let's write the function which allow us to get the liquidity fee, increase liquidity fee, or we can decrease the liquidity, we can remove the liquidity, all those functions. So let's write the first function is, let's call function, and we have to create this collect all fee. So whenever someone will do the transaction in our exchange, we have to get the fee. So all the fee is going to be stored in the contract, and we have to have a function which allow us to get the fee so we can take it out. So let's create the functions. We'll say external return, and we have to return this unt amount 0 and unt amount 1. That's what we have. Now we have to simply call set a max, and this call to 1 to unit collect all fee. So no matter what token they are swapping, so right now we are going with this 2 token hardcode value, but we're going to make it dynamic. So no matter what token, no matter what token they're going to swap, we're going to take the fee from all of them, and we're going to take it out with the help of this function collect all fee. And now let me give this current alternative can set receipt to message.sender and avoid another transaction. Let's come here, let's call this non-fungible position manager collect params, memory params, and we're going to simply pass the same non-fungible position manager collect, and in that we have to send the entire object. So the object we want to define is this 2 token ID. That's the first one, and the second one we want to assign is this recipient is going to be the address, this the contract itself, and the third data we want to provide is this amount max is going to be this max value, and the second, third, fourth data we have to provide this 1, which is for the second token max. That looks pretty good. Now we have to assign, close this one, and come here. Now we have to make the transaction. So we'll say amount 1, and this is going to be the non-fungible position manager collect, and in that we're going to pass the params. So that's how we are making the transaction. Now let's console log out the fee. So amount 0. Let's do the same thing for the second one, console. And so with that we are done with this function which allows us to collect the fee. Now let's write the second function. We'll say increase liquidity current. So this function will allow us to increase the liquidity. So what happened that in most of the exchange, suppose you have created your token and at the initial time you have provided 50% liquidity, but later you found that the tokens are performing better and you want to provide more liquidity. So this is how you can do it with the help of this function. And again, I'm telling you these functions, these all methods I'm getting from the Uniswap documentations. So let's write the function from here. So I'll say range, and in that we have to set the couple of variables. So unt amount add, the number of token added, and we have to define the token other one. So let's make it external, and this will become return, and we want to return is the unt 180 and liquidity unt 256 token amount 0 and the amount 1. Transfer, save transfer, and that we have to provide the token message.sender and the address and the amount add. Let's call the other save transfer from USDC message.sender address and the one add one. Once we're done with that, now here we're going to write the transfer dot save approve, so we can approve the contract. So die address non-fungible token position manager and the amount, and we have to call the same thing for the second function, second token. So position manager and the amount add one. Once we're done with that, let's come here. We're going to call this non-fungible position manager increase liquidity params memory, and in that we're going to call this non-fungible position manager increase liquidity params, and in that we have to send the entire object, which we have done already on top before. So we have to pass the token ID, and we have to simply pass this amount increased, and we have to pass the second token amount 1. Let's define the min and do the same thing for the second token as well, amount 1 min 0. Let's provide the deadline block.timestamp, close this one, and here we're going to call that. So we'll say liquidity amount 0 amount 1, and we're going to call this non-fungible position manager, and that we're going to call this increase liquidity and provide the params. That looks fine to me. Let's come here, let's console log out this liquidity, and we have to simply console log out this amount 0, and the third one is going to be this dot amount 01 and amount 1. So that looks pretty fine. Close this one. And so with that, we are done with this function, which help us to increase the liquidity in existing liquidity. There is so many liquidity. I do understand that you guys are confused right this moment, but don't need to worry. Just be patient, work along with me, everything will make sense. The reason why I have decided to write the smart contract first, and later we're going to examine the entire contract, entire functions, that from where we are going and what exactly happening in the params and what this increased liquidity function are doing. We're going to examine each and everything in detail, and that's very important, because when you will go in a decentralized exchange and create bots which can do the trade, so you have to know that what are the things goes into that to create a bot and automated tools which can do all the things for you. So with that, we are done with this function. Now let's write the other function. So let's come here, we'll call it function, and this function is going to be get liquidity. So if you want to know that how much liquidity you have provided in exchange, so for that we need to have functions, and that function we're going to create. So in that, we're going to pass this token ID external view, and it's going to return this unt, the amount of liquidity we have provided. So we have that one. Now what we can do is come here. So we have to define a couple of variables. So this is the general convention which you have to follow. So comma unt 128 liquidity, non-fungible position manager, positions, in that we have to pass the token ID, and now we have to simply return this liquidity. With this, we are done with this function get liquidity. All it does, it's provide you that how much liquidity you have provided in exchange. Now let's write the another functions, which is called function, and we're going to call it decrease liquidity. So we have already written a function which allow us to increase the liquidity in the existing liquidity. Now what if you want to decrease the liquidity in the existing liquidity? And that's the function we're going to write. So in that, we have to provide the liquidity external return, and it's going to return the amount 1 and amount 2, amount 0 and amount 1. So By the name, you can easily understand that what is this amount 1 and amount 1. It's going to represent your token. And let's come here. We're going to use this non-fungible position manager, decrease liquidity, memory, params, and we're going to use this non-fungible position manager, decrease liquidity, params, and we have to send the entire object. The same thing what we have done above. So in that, we're going to provide this token ID, because that's how we can easily able to identify that what liquidity we are talking about, because exchange will have a lot of users, lot of liquidity providers who will create the liquidity, but every liquidity is going to be unique to a particular user. So that's token ID is the unique identification of every single liquidity. So we have that liquidity ID. Now we have to take the liquidity to liquidity, and we have to simply grab the amount 0 is going to be a 0, and amount 1 min is going to be the same 0. Let's come down here. We're going to define the deadline time, which is inside the block.timestamp. Let's close this one, and let's simply make the transaction. So amount 0, amount 1, and we're going to call this non-fungible position manager, decrease liquidity, and we're going to pass the entire params. Once we've done that, we can simply console log out the data. So we want to have a look on 0, amount 0, and we want to have a look on the amount 1. So that's the things we want to have a look. Close this one, and with that, we have done with all the functions and functionality for the smart contract. Now you can easily able to create liquidity, you can decrease liquidity, you can increase liquidity, you can get liquidity. We have written so many functions, and I believe that 80% of the code you guys haven't understood. You have coded along with me that you guys haven't understood. Don't need to worry. I was in the same state. I was confused when I had this contract and I looked at it, because DeFi is really very complicated thing. A lot of things goes into that, but I'm going to explain everything. Just code along with me and try to understand whatever I'm doing. So with this, we are done with this entire smart contract. Let's come up here, and if I come here, this is the function. So we have this license identifier, general convention. We are using all these packages, and we're going to have a detailed discussion on each of these packages. We're going to explore that what the codes are doing exactly, and why you should use this one, or why you should use this one. And if you want to come up with your own, you can simply do the modification and create your own as per the requirement. We're going to talk about that as well. So that's what here we have the contract name. We are inheriting the property of this 721. We have the 2 tokens which we want to swap, and this is the non-fungible position manager. This is the mapping we have. This is the first function. Simply close this one. This is the create deposit function which will run internally, and this is the mint position. This will create the liquidity, and this is the collect all fee. This will collect the fee, and this is going to be the increase liquidity. Close this one, pretty huge function. And now we have this get liquidity, which is a very simple function. Now we have this decrease liquidity. So we have written so many functions. This is the one, liquidity, increase current range, and that looks pretty good to me. So hope things are making sense again. And if you guys have encountered any error, I'll provide you the code in the starter file or in the complete code. From there you can get it. So that looks pretty fine to me. Now what we can do is, let's come here. With that, we are done with this entire smart contract for the liquidity, and that's the only thing I want to cover, because we have already written so many code, and I don't want to make this video so huge, because most of you guys are complaining that the videos are getting huge, and that's why I try to make it shorter video so you guys can get maximum in a small span of time. Okay, so let's move to the next video, and that we're going to do the testing of the contract which we have written. So let's move to that. So this is where we left in the last video. We have done with the entire liquidity smart contract, and I believe that most of the things make sense to all of you guys. In this video, we're going to test the liquidity code, liquidity smart contract which we have written. So here we are. Now what we can do is come here, close this one and close this one as well, and let's go to the test. Inside that, we're going to create a new file we'll call liquidity. And I try to keep all these test files separately. All I can do the testing in the same file, but I don't want to mix the thing together, because when I'm going to provide you the code, it becomes very easy for you to navigate and understand that what's going on, which one is for liquidity, which one is for single, which one is for multiple. That will make more sense. And now we have to import a couple of packages so we can utilize it. So the first package we want to import, which is coming from Chai accept. And now we have to import the Ethers package that's coming from Hardhat. And now we have to define a couple of token addresses, contract addresses. The first one is going to be a DAI, and this is the DAI token contract address, and we need USDC, and this is the contract address. Here you have to notice one thing, that we need to have DAI and USDC if we want to use this Liquidity smart contract. But the account which we get from Hardhat, account 1, it doesn't contain any one of these tokens. So how we can test the contract? And we are doing this testing on the mainnet. So we need a real account which actually have some DAI and USDC. So we can utilize that account to test the contract. And that's what I'm going to do. So what I have done, I have found an account address on the mainnet which actually contain DAI and USDC, and we're going to unlock that account. So we are working on the forknet, which actually a copy of the mainnet. So we have to find an account wallet address on the mainnet which actually contain DAI and USDC. So we're going to take that account, import it here, and we're going to unlock that account so we can do the test. And how we can unlock that account, I'm going to show you how you can do it, but there is a lot of things goes into that. So I will make a separate video, and that I will go into more detail that how you can unlock different accounts from the mainnet to use it in the forknet. Okay, so I have found an address, wallet address, which actually contain these two tokens. So let me write that. So I'm going to say that DAI well, and I'm going to paste the wallet address. So this is the wallet address, actually has some DAI token. Do the same thing for the USDC. Let's come here. Once we have that, now we have to write our describe block, and that we have to define the contract address, async, and in that we have to define couple of variables. So we're going to create global instances so we can use in multiple tests. So first is going to be the smart contract instance. Now we have to define the account. Then third one is going to be DAI, and now we're going to have USDC. So these are the variables we have. Now let's come here. We have to write the before element. So async, and that we have to simply write the account. So this is coming from ether.getSigner1. We have the account. Here we're going to simply write the liquidity await get contract factory, and that we have to provide the name of the contract. So liquidity example. Now we have to simply deploy that. So liquidity await liquidity.deploy. So in that way we can easily able to have the instance globally. And now we have to simply call liquidity.deployed. So the contract is getting deployed. Now we have to call this DAI, and we have to update that. So we'll call it ether get contract at, and this function get contract at is coming from Hardhat. So if you install normal Ethers.js, and that you will not find this function, because this is the addition by Hardhat, not by Ethers.js. And in that we have to pass this ERC20 interface, which is already there in the package. So just simply write, and in that we have to define the token. So DAI. Do the same thing for the USDC. So get contract at, and we have USDC. So we have the instances, in that we have all the interface, all the functions for ERC20 token, like getting number, getting balance, transfer, approve, all the function we have available in this IERC20. Once we have that, let's come here. We have to, let me give this command, unlock DAI and USD whale. So now we have to unlock the account. We have the wallet address which actually contain the DAI and USDC. So to use that, to test the smart contract, we have to unlock the account. So that's pretty easy. We can do it. So here we're going to say await network.provider.request. In that we have to pass this method, and this method is hardhat.impersonate account. And if you want to read about this, you can simply visit the documentation, or I will make a dedicated video on this. So this is the method we have to call. In that we have to call this param. So we have to pass the account wallet. So DAI whale. And that's it. Do the same thing for the other tokens. So request, we have to find the network, personate account, and we have to send the params. So the second, the USD whale. So this is how you can unlock the account to test the contract locally. So that looks pretty fine to me. Now let's come here. We have to take a variable DAI whale and await ether get signer, and in that we have to pass that die whale, so we can see. So this is going to be our signer. We have to do the same thing for the USDC, and that we find USDC whale. So the same wallet address is getting. Look fine so far. Let's give this command send die and USDC to account 0, because we're going to use Hardhat and Hardhat account 1, which is a 0, and in that we're going to transfer the die, because that doesn't contain, because account 1 doesn't contain any die, so we're going to transfer from this account to that account. So that looks pretty fine. Now let's come here, const die amount, and this is the amount we want to transfer. Die const USDC amount is gonna be this. Once we have the amount, we're going to say console die balance await die balance die whale that address. So the wallet address. Do the same thing for the USDC. So die whale dot balance is gonna be USDC whale address. Come here, console.log die whale USDC whale die amount and USDC amounts. So we can easily able to see the data. Now do the check await die balance dot balance of die whale address to this die amount. So the amount we have in this die whale is equal to the die amount. That's the check we are doing. Pretty simple. Now we have to do the same thing for the other USDC balance and whale address, and we have to simply compare that. Pretty simple. Let's come here, await die dot connect, and we have to connect the real wallet address, and we have to transfer the fund to the MetaMask account, Hardhat account first, and we have to pass the amount. So that's how we can do the transfer. Do the same thing for the USDC. Transfer the fund from the USDC whale to the first account, and that's the entire code block we have for the before statement. So no matter what test we do, every time we'll do the test, this before code is going to execute first, and then the other code will execute. Now let's write the test the function like mint function. So let's do that. So we're going to call it mint new positions async, and then we have to define the const die amount. This is the amount we want to simply pass it liquidity, and do the same thing for the USDC, because after running that block, the first if block, our account 1 will have the liquidity, the die token and the USD token. So we're going to use that account 1, not the die whale, to do the test. We're going to say await die is connected account 0, so we have to connect with the 0 account, which is our MetaMask and Hardhat. Now we have to simply call the transfer and transfer this token to the liquidity, our smart contract, and we have to pass the amount. Do the same thing for the USDC. The same thing we are following here, account 0, we have to call the transfer functions, and we have to pass the liquidity smart contract address and the amount, so it can receive. Once we have the data, now we have to do this liquidity.example, and we have to call this function mint new positions. That's the function we have to call. And once we call the function, now let's me call console log out the data. So the data we want to log out is die balance after add liquidity. So let's console log out the data, die balance of, we have to pass the account 0 and address, and do the same thing for the USDC balance after add liquidity, and we're gonna use the same USDC balance of account address 0 address. So that looks pretty fine. In that way we can easily able to see the logs, the token, the liquidity we have provided. Let's close this one, and that looks pretty fine to me. So with this we are done with this entire test file which we have written, and now we can test our smart contract. So you can see this is the addresses, this is the describe block we have, the entire function, this is the entire network, this is the die whale, this is the amount, everything is looking fine, this is the mint new positions, and that looks pretty good. So let's close this one and comment this function. Let's test the end block first. So let's comment this one. No more error we have here. We are back in our terminal. Let's clear your terminal, and let's simply, first we have to simply test this one. Okay, npx Hardhat test liquidity.js. So this is the file we want to execute. Simply hit enter, and Okay, this is an error we are getting. Open Zeppelin contract token, this immutable. Okay, I do understand what is the problem we are having. So this problem is coming in this Uniswap V3 periphery contract, and this is happening because the Uniswap used the old version of Open Zeppelin contract, and we are using the latest one, and this is the problem we are having. So we have to install the old version of Open Zeppelin contract. So not a big deal. So what we can do, let's come here. Here we are in package.json file, and this is the latest version we are using of Open Zeppelin, but this is not what we want to use. If you want to use this version, we have to do a lot of configuration in the Uniswap smart contract, which I don't want to do it. So what I can do is I'm going to simply uninstall this, and I'm going to install the recommended package Open Zeppelin. So first thing we have to do is we have to simply uninstall this one, Open Zeppelin contract, uninstall this one, the latest version, npm uninstall, and simply paste here. So here we have installed that, and now we have to install this version. Simply clear your terminal and npm I, and this is the version we have to install. So open Zeppelin, this the version name is, provide this @ Open Zeppelin contract @ 3.4.2. This is the exact version you have to use, otherwise your contract will not work. So once you're done with that, simply hit enter and install this package. Just wait, it's installing. And here you can see this is the version we are using, not 4, we have to use 3. If you want to know more about this packages Open Zeppelin, you can simply check the code on the GitHub, or you can visit the website to read everything about the contract. But I'm going to use this straight away. If you want me to make a dedicated video on this Open Zeppelin, then do leave in the comment section. I'll definitely include that. That looks pretty fine. Now let's come here, let's close this one, come back to the contract, and here you can see, and the problem was happening from here. This is the function, because this is the function in the old one, not in the new one. In the new one they have changed the name, they have added some modification in that, and the error was coming from here. So because we need to use the old one, so let's go in that way. So everything's working fine, no more problem. We have closed this one, and now we can test the contract. Let's come here, clear your console, and simply come back to the test and hit enter. Okay, so this time finally we are getting a different error message, and this error message is coming from our configuration file. So dependency cannot be compiled with your config, so we have to do the configuration, because the contract, the Uniswap contract and the Open Zeppelin contract need to use specific Solidity version, and this error is coming from there. So let's configure that as well. So we can bring this terminal down, and we can go back to the, come here in the Hardhat config file, and here we have to do the configuration. So right now you can see this is the configuration we have done in the start. So we are using Solidity version 0.8.17, and this is how we have connected with the forking net. You can call it forknet or forking net, whatever you want. And we have used Acmely mainnet, and here we're going to configure our Solidity. So this is how you can do it. I will simply come here, and I'm going to simply paste my code. So simply remove, and I'm going to paste my code. So this is the compiler code you have to write. So you have to provide the Solidity name, compiler, then the version, then the setting. This is the exact thing you have to write: version, setting, event version, optimizer, and this run. So this is the thing you have to do, and this will fix the issue. Close this one, open up your terminal, clear your terminal, and let's rerun the test. So rerun the test, and this looks pretty good. This will take a little bit time, means our code is working, and here you can see the test is passed. Just ignore all this warning, that's not important. So that looks pretty fine. Now what we can do, now we can actually test this. We have already tested all this one. Now we have to call this function. So let's simply uncomment this one, because we want to test this one, mint new position. Looks pretty fine. Let's bring this one up, clear the terminal, and hit the test. It's taking time, means everything's looking fine. Liquidity example, we got it. And here you can see this is the first log we have got, the balance, the DAI and USDC balance we have got. And just wait, we have to get the amount address, and boom, here you can see we got all the data. So this is the token ID we got the liquidity, that how much liquidity we have provided in our exchange, and this is the DAI balance, and this is the USDC balance. You can see it's looking absolutely fine. So our smart contract is absolutely working fine. We have created the liquidity, we have checked in the balance, and things looks pretty good to me. This looks pretty good. Let's bring this terminal down. This is working 100% fine, and now we can start working the fun part and start connecting this into our front end. So this looks pretty fine. All the function we have written, all these balance are logging out. This is the transfer, everything's working fine. Close this one and close this one, close this. So that's the only thing I want to cover in this video. Hope you guys have understood everything about the testing of the contract of our liquidity. Okay, with that, let's move to the next video. In the last video, we have tested our liquidity smart contract, and we have seen that everything's working fine. So we have written so many smart contracts, and now it's the time that we should start focusing on the front end, and we start connecting the front end with the contract. So this is how the front end is looking right this moment. So let me show you that what we have done so far. So from here you can easily able to search, you can click and you can open, everything's looking fine. And right now we don't have any token because we have not passing any data, so don't worry about that. Everything's working fine. If you come here, click here, and this is what we're going to build now. So this is the finished product. You can see that you can able to find all the tokens which you have provided as a liquidity, or we're going to provide all the token exist on a Ethereum blockchain. So we're going to use one powerful API, although we can run our own node in our computer and we get the data right from the blockchains, but I don't want to create my own node, otherwise my computer will get down. A lot of pressure will come on my computer. So I'm going to use a third-party package like CoinMarketCap, which provide the same data, and that's the data we're going to display here. So right now you can see that we have created a couple of liquidity, couple of tokens, and all the data I can easily able to find here. So this is what we're going to build. So you can see this is the Ether, USDC, Wrap Ether, and Uniswap, and from here you can easily able to filter. So if you type Ether, you can easily able to filter the token. You can see the price and range and volume. If you can remove, and if you want to find about any other tokens, Uniswap, that's working fine. And we are working on the Ethereum blockchain, so we are displaying Ethereum. If you want to work on a specific blockchain, so that's going to be dynamic. So that looks pretty fine to me. This looks pretty beautiful. So this is where we left in the last video. You can see our entire project is looking so clean. Come back to page, and we have to create another page. So that data we're going to display on a token page. So let's create a token page first. So we'll call it token.js, and we have to create a component. So we'll create a component called all tokens, and inside that we have to create the JSX, and we have to create the CSS file for all tokens, module.css. So that's the component. We are here now. Let's come back here, close this one, and come back to the style file, and we have to create the CSS file for this token page as well. So click on that, and we have to create a file. We'll call it token.module.css. So that's the setup we have to do. Now let's come back to the token page, and here we're going to write the code, the JSX for our token page. So let's quickly write that. We have to import a couple of things from React. So use state and use effect. We have to import the image, and that's coming from the Next.js. Let's do a couple of internal imports. So we want to import the style, the CSS file, and that's coming from the style directory. And now we have to import the images, all the images which we have inside the asset folder. We have to import a component. So this is the component we want to import, all token, the one we have created, and that's coming from component index. And now we have to define our function. So we'll say tokens is going to be asyncs, and here we're going to define the data. So right now we'll go with the demo data. So right now on the images you can see that this is the data. So we're going to display some demo data. Once we build the entire architecture, then we're going to push the real data. So this is the data we have: Ether, USDC, this one. So let's write that first. All token lists, we'll call it set token list, and it's gonna be an array. Inside that we have to define the array object. So this one is going to be number 1, and you can see that this is how it's looking when I'm typing. The below code is not displaying because I'm using an extension which I can see the code, but you guys cannot see. So currently I'm testing this extension in my code editor, and that's why it's coming like this. So just code along with me, everything will make sense. So this one is going to be the image.ether logo. We have to define the name ether, we have to define the symbol ETH, and we have to define the price this, and we define the change, and the last one is going to be the TLV, and this one is going to be the volume. So this is going to be the last one. So these are the data every single token will have. We're going to add more data. I'm thinking to add graph. So a graph will say up and down that what is the price range is going up and down. So that's also I'm going to include, but right now just go like this. So this is the first one, and let's write the second data object. So this one become number 2. Let me quickly write this one. So we have created all the 4 arrays. So right now I'm going with the 4 array. We can create more. So let's close this one, and we can come here. We're going to create another copy all token list. The reason why we am creating this one, because we have to add a filter. So when someone will search for anything, we're going to filter the entire array, and we're going to display only those data which will match the query. So use state, and it's going to be all token. That's what we're going to pass it, and on that we're going to filter the entire data. So let's take another variable. We'll say search, set search is going to be empty, and we have to take this search item, set search item is going to be this search. So let's create a function which allows us to search the token. So on handle search, we're going to pass the value, and inside that we're going to take this const filter token. We're going to take the entire token list, and we're going to call this filter method, and we want to add the filter on the base of the name. You can add it on the base of the address, but I'm going with the name. So we have the name, and once we have the name, we'll call this to, we have to convert into a small, and then we have to check this for this method, include value. That's how we can compare. So that's the on handle search function, and in that we have to check for the if statement. So if filter token dot length is equal to 0, in that scenario we have to display this set all token, and we're going to pass this all copy all token list. Else we call this set all token list, and then we're going to pass this filter token. So if someone type any text and that text matches the query, then we want to display the text query. Otherwise we have to display this entire filter token. That looks fine to me. Let's close this function. Let's create another function which is called on clear. So when someone will clear the input not typing anything, on that time what we have to do? So on that time we're going to simply come here, and we'll say if all token list length, copy this one length, all token list dot length, and copy all token list dot length. If that, then we have to set this copy all length token list, sorry. And that's the simple thing we have to do. What we are doing, we are checking that all token list dot length and copy all token list. If both the statements are true, then we have to simply display the copy all token list. That's the clear search function. Now let's come here, let's take this use effect, and in that we're going to simply call this. So we'll say const timer, because we want to check that is there anything in our input or not. So for that we're going to use this set timer function. So we'll say set timer out set search, and we're going to search this. It's going to be 100 millisecond, and we have to simply return this clear timeout. Once everything searched, we have to clear that, and that's our use effect. In that we're going to pass this search item. Simple JavaScript. Hope this makes sense to all of you guys. So that's the function we have. Let's take this use effect, and in that we're going to simply call this one if search, then we're going to call this handle search, and that we're going to pass the search. Else we have to call this function on clear search, and we have to simply close this one, and it's going to be a search. So that's the second use state. So if we have a search data, then we have to call this on handle search function. If we don't have anything, then we have to call this and we have to pass the search in. So that looks pretty fine to me. Let's come here and now we can start writing the JSX. So we have done with the entire functionality with the search, and now we are writing the entire JSX for our page. So we're gonna take this, we're gonna take a div, it will have a class style token. So we are working on this, we are working on this entire div. In that div we have this top token on Uniswap, we have this header, and we have the entire body. So first we are working on this, so let's work. So we'll take another div, it will have a class called style.tokenBox. We'll have another h2, in that we're going to have the title, so top token on Uniswap. We'll come down, we're going to take a div, it will have a class called style token box header. In that we have to build two components, we have to build this ether and we have to build this search input. So let's code that. So what we're going to do is we're going to take a div, it will have a class style token box Ethereum, sorry, and in that we're going to have this p. So we will have the image, so we're going to provide the property. So we have to provide the source ether logo, we have to provide the width is going to be 200, and we have to provide the height is going to be the 200. So that looks pretty fine to me. We have to close the image and we want to provide the text as well. So we're going to take another p tag, and in that we're going to type Ethereum. Let's close this one div, that's the close one we have. And now let's create another one, and that we're going to create the input filter. So it will have a style, we'll say token box search, and it will have a p, and that we're going to display the search icon. So this is the icon we want to display, this is the icon. You can do in the div, but I'm going with the p tag and I want to treat as a text. So we'll have to do the same thing, we have to provide the images source, we have to provide the alt, and we have to width is going to be 20 and height is going to be 20, and we have to close the p tag. Once we have closed the p tag, then we have to take this input, we have to provide the type is going to be the text, and the placeholder we have to assign. So the placeholder would say something like filter token, and we have to add the functions. So the function we have to add is on change, and we have to update the data. So we're going to call this set search item. So this is the state we have created, and in that we're going to pass the data e.target.value. So whenever someone will type anything, our state search item will get updated, and in that we can easily able to filter the data, the logic we have built. So on change we have, let's come here, we're going to call this value is going to be search item. So this is the initial value we're going to pass. We can close this div. Now we have to close this div, main div. So we have closed the div. Now let's come here, we have to create another. So this is the component we have created, all token, and that we have to send the props. So all token list, we're going to send the data, and we're going to close it, close this div, and now we have to simply export default, and then we're going to pass this token. So what we can do, let's have a look. We are done with this, looking fine to me. This is the entire token, this is the component we have created, and I have noticed one thing, that we haven't imported that component into our component index. So that's the one change we have to do. The rest is looking fine. This is the entire data we have, this is the entire use state we have, this is the on handle search filter on clean, and we have this use state, looks pretty fine. This entire JSX we have here, and this is the component we have. Let's come here, go back to the component. Inside the component we have this index.js, and in that we have to import this component, the component we have created. So let's call it import all tokens, and that's coming from the same directory, component all token. So that looks pretty fine, and pass it here. So now it will work absolutely great. Let's come here, come to this portion and go back to the, open up your terminal, and let's restart the application to see that things are working fine or not. Now what we can do is simply clear the terminal, and we have to run the dev environment. Click on this, and Here it's working fine, and here you can see the MetaMask is getting open because we have this fetch data function which is getting triggered every time someone will visit our application. So it's looking fine. And what I want, let me log in first, unlock my account. So things looks pretty good. I've logged into my account. Now what I want to stop this. So let's come here into the context, and for the time being I just want to hide this. I want to comment this because I don't want to deal with the data right now. Let's focus on the front end first. So let's comment this one, and you can see this is how it will look. We have our top token on Uniswap, we have the icon, we have the Ethereum, we have search, and we have input. So it's looking absolutely fine. Come here, and that looks pretty good to me. Come to the global CSS, and here we have to do the CSS. Before we uncomment that, let's do the CSS first. So let's come back to the token, and we have to style this entire. So we'll target the token, and we're going to provide margin block 5 RAM. We're going to target the token box, and it will say width is going to be 60%. It will have the margin 0 auto, so everything will be in the middle. Let's target the token box h2, and we're going to say font size is going to be 2 RAM. Font width is going to be 400. Token box header going to be display flex. Gap is going to be 1 RAM. Align item center. Token box Ethereum. Display is going to be flex. Align item center. Gap 0.5 RAM. Font size 1.2 RAM. Font width is going to be 700. Background color is going to be our primary color. Padding 0 RAM and 2 RAM. Line height is going to be 0. Border radius 0.5 RAM. Color our second primary. Border 1 pixel solid. Color is going to be our second primary with opacity. Target our token box search. Display flex. Align item center. Gap 1 RAM. Background color primary color. Padding 0.2 RAM, 2 RAM. Line height 0. Border radius 0.5 RAM. Width is going to be 50%. Border 1 pixel solid, our second primary color. Token box search input. Background color transparent. Outline none. Border 0. Color our second primary. Width is going to be 90%. Let's add the media query. Only screen and maximum width 35 EM. Token box width is going to be 90%. Margin 0 auto. Token box header. Display going to be grid. Token box search. Padding 0.5 RAM and 2 RAM. Width is going to be 100%. Token box h2. We want to make the font size is going to be 1.5 RAM. Font width is going to be 400. Close this one, and that looks pretty good to me. So we are done with this entire CSS part of this token page. It looks pretty good. You can see this is the entire media query we have written. Let's come back to the application. You can see it looks pretty good, just like the design we have. So we have this top Uniswap token on Uniswap. We have this Ether, we have the search. Things are looking beautiful to me. Let's do the inspect element. You can see it's 100% responsive for mobile device as well. Do the console and see we have no more error. Looks pretty fine. So that looks pretty good. Now we can simply come here, and now we can simply uncomment this. We can uncomment, we can click on this, And now we can start working on our all token JSX. So let's import couple of things from React, and we need to have the image that's coming from Next.js. We have to do the internal imports, so we have to import the style file, and that's coming from the same directory. We have to import the images that's coming from the assets. Now let's create the function all token, and in that we have to receive the props. So this is the props we are sending all token list. It's gonna be an async. We have to return the entire JSX. So let's take a div. It will have a class style.allToken, and inside that we're gonna have another div. It will have a style all token dash box. Inside that we're going to have another div. It will have a class called all token dash box header. Inside that we're going to take a p tag, and it will have a class called hide, because certain headers we want to display only on desktop, but sometimes we want to hide on the mobile device. So this will have a hash. Now we'll take another p tag, and in that we're going to have this token name. We'll take another one. It will have the token price. We'll have another one. This will have the change, and it will have a class called this change, because this one we're going to hide on a mobile device. And we'll want to take another one. We'll say this class is going to be hide. Let's come here. We have to take and we have to take the image. So this is the image we're going to provide inside this small tag. So let's take an image. We have the image inside this image folder question, which is going to be 50%, and height is going to be 50%. Let's close this one image. Let's close this our p tag. We're going to take another p tag, and inside that we're going to have this class hide, and we're going to take this small box, and in that we're going to display the image. So we'll have this image. We'll have to add the source, arrow, price, alt, width is going to be 15, and height is going to be 15. Inside that we have to display the text. So we're going to close this one small tag, and we're going to add our text, and this will call volume. And that's normal, guys. If you guys can see the sounds in the background, just ignore. And here we're going to display the another small tag, and in that we're going to take the image. So let's take the image. We have to provide the source. We have to provide the alt tag, width, and we have to provide the height. Let's close this one. So that looks pretty fine. Now let's close this p tag. So this is the entire header. Let's close this one, header component, header div, and that looks fine. So that's the entire header component we have written. And now we're going to write the actual data. So we have all the data into this all token list, and we're going to loop over it, and we're going to render the entire data on the table. So all token list, we're going to say map element I, and it's going to be an instant return, and that we're going to have a div. It will have a class called style.allToken box list. Inside that we gonna have a p tag, and this will have the data. So we're going to attach this hide element.number, because if you look at the data, and that we have defined a lot of things, number, we have the price, we have the change, volume, everything. So element.number, we can easily able to access that. Let's define the other variable. So we have the number. Now we have to define the name. So we'll have this style all token box list para, and inside that we're going to take this small tag, and it will have the image, the icon of the token. Width is going to be 25, and height is going to be 25, little bigger, and we're going to close this small tag. And inside this small tag, inside the p, and now we have to take the text. So we're going to take this small tag, and then we're going to pass the name, and here we're going to pass the logo itself. Let's close this p tag. Now let's take another p tag, and in that we're going to display the price. We have to take another p tag, and that we're going to display the simply change, and it will have the hide class. We'll take another p tag. It will have the class hide, and in that we're going to display this TLV. Now we're going to simply add another p class. In that we're going to display this volume, and we're going to simply close the div, and we're going to close the entire loop. close the div as well. Let's come here, close this one and close the entire one, and now we're going to simply export. So we'll say export default, and we have to export the entire token, and with that we are done. So it's looking absolutely fine. This is the entire import, this is the data we have, and this is the entire JSX we have written. So hope things are making sense to all of you guys. Let's come here, and here you can see this is how the data is look right now. So we have all the data which is rendering absolutely perfect. The only thing we have to do is to add the CSS. You can see this is the entire data, and somehow the images are not displaying, but we're gonna fix that. Not a big deal. So this looks pretty fine to me. Let's come back to the code and simply close this one, and let's start working on the CSS. So first thing, we are targeting on our header. So you can see this is the header we have. This is the portion we're going to target because we have already designed this in our token CSS. We have to target this, then we'll move to this row. So let's target that. So first thing, we're going to do all token box, and we're going to target margin block is going to be 1 RAM. We'll have the background is going to be color, our main color. We'll have the border 1 pixel solid. This will have our second primary with opacity. Let's add a border radius 0.5 RAM, and we'll have all token box header. In that, we're going to add display is going to be grid template column 0.5 FR, 4 FR, 2 FR, and 2 FR, because we want to build all together 1 2 3 4 5 6 column, and that's what we have defined: 0.5 FR, 4 FR, 2 FR, 2 FR, 2 FR, 2 FR. Let's define align temp center, padding 0.5 RAM and 1 RAM. We have to take the border bottom is going to be 1 pixel solid, and it will have our second primary color with opacity. All token box header P, and is going to be a display flex. It will have the align item center. It will also have the gap 0.5 RAM. And let's come here, and here we're going to target the entire data. So all token box list, we're going to target the display is going to be grid, and here we have to define the entire column. So it will have a grid template column. Width is going to 0.5, 4 FR, 2 FR, 2 FR, 2 FR, and 2 FR. It's the same column we have to provide, and it will have a padding 0.5 RAM and 1 RAM. It will have the align item center, and it will also have the margin top minus 0.5 RAM. All token box list para. This will have the font size is going to be 1.3 RAM, little bigger. Display is going to be flex, and a gap is going to be 0.5 RAM, and it will have the align height is going to be 0. It will have the align item is going to be a center. Let's come down. We have to add the media query, so we'll say only screen, and max width is going to 35 RAM, and we have to target the all token box list, and in that we have to say that grid template column 3.5 FR and 1 FR, because I don't want to display the entire data table. I want to display only the name and the price. So let's close that one, and we have to get that height class, and we have to say display none. So all the component will have this height class will be height. And let's come down here. We're going to target the all token box header, and in that we have to pass this grid template column. It's going to be 3.5 FR and 1 FR, and that looks pretty fine to me. Now let's call this hide class, so all token box header, and we have to hide that as well. We'll say display is going to be none. That looks pretty good. And now we have to target the all token box list para, and here we have to change the text. So font size is going to be 1.1 RM, and that looks pretty fine. So with that we are done with this entire CSS. Let's come here and let's have a look. So things are looking fine. You can see this is the all the styling part for this entire component, and with this we are done. You can see, let's come here in the browser, and you can see this is how it looks. It's beautiful. Don't you think that? If you really think it's beautiful, do hit like and subscribe, and do let me know that it's beautiful. Let's see how many beautiful words I get in my comments, so I can see that you guys are really enjoying the project. So this is the entire data table looking absolutely phenomenal to me. We're going to add more coloring to this. So we're going to add the pricing, the color. If the pricing goes up, we want to add the green color. If the pricing goes down, we're going to add the red color. So we're going to add those things as well. But these images are somehow not working, and I know why it's not working, because I don't have those images. So let's quickly import the images. So let's come here, and I'm going to simply import very quickly. So these are the images which I have in the image folder. So I'm simply importing questions, arrow 1, wallet, left arrow, and tick. And now simply come here and export that, and if you save, it will work fine. So save it, and again, this images, this folder and file structure you will find in the starter file, and I will provide you all the entire source code in the complete project, okay, very soon. Let's come here, and here you can see we have our images back. We have the questions, arrow, and that. Reload the browser, and things looks absolutely awesome to me. And here you can see this is the problem we have here. You can see the token, then we have the question marks, and because the reason why it's question mark, and somehow by mistake I have sent the query, and that's why we have that question mark. So let's fix that. Let's come back to the code, and let's close all these tabs. Close this one, and close this one. Come back here in the navbar. Inside the navbar we are rendering this menu. So here we have the menu, and here we are sending the link, the query, but actually we don't need to send the query. So simply remove the entire query, and this will fix the problem. So let's come here, reload the browser, and if you click on this token, you can see right now we don't have that problem. If you click on the poll, we'll get this 404 error because we don't have that page, but you can see our router is working fine. If you click, you can come back and you can check everything's working fine. You can simply able to filter. So if you want to filter the data, you can filter that. If you want to filter the Uniswap, let's remove that. Let's search that. Okay, let's search that USDC. Okay, it's working fine. You can see we can easily able to filter the entire token, and that looks fine to me. So hope these things are making sense to all of you guys. You can simply navigate to the different pages, and that's the only thing I want to cover in this video about the token page. In the next video we're going to start working on the pool page, and that's going to be a lot of fun. So in the last video we have finally completed our entire token search page. In this video we're going to focus on the pool section. So here I have opened the project. Make sure to do that. Come here and go back to this. Close all these open files. Come here in the page, and here we have to create a page. So we're going to call pool.js, and we have to create a CSS file, and that we're going to do in the style. So let's create the CSS file, pool module.css. That's the CSS file we have, and that looks fine to me. What we can do, let's come back here, and you can see this is the component we have designed in the last video, the search component, the entire component. Looks fine to me. Let's come here in the pool section, and this is the finished product. So this is I already have designed. So let me show you what we're going to design in this video. So this is our first liquidity component. Actually we have two components. One, we have the liquidity component, and in the other component, which is a pool component, in that we are checking that whether the user is connected or not. So let me show you what are the we have here. Let's click on this token. Click on this. So here we're going to display all the token which a user has, and from here you can select and provide the liquidity. So it's also working fine. We have this pop-up module, and it's looking fine. It looks fine, and from here you can easily able to select the tier fee. So 0.5, 0.3, and 1 you can select right from here. You can come here. From here you can provide the minimum and maximum price to your token, and from here you can easily able to do the changes. And this is the second component. Somehow I have attached both the component together, but I'm going to make it separate because we have to check if the user is connected with the application, then we want to display the add liquidity. But if the user is not connected, then we're going to display this pool component with connect wallet. So both the components are displaying, but we're going to fix this. So that's the component we're going to design in this video. So let's come back to the component section, and here we have to create a component. So we're going to call pool add, and we have to create the CSS file and the JSX. So let's create the JSX, and we have to create the CSS file for this module.css. So we have this two files. Close this one, and now we have to create another component which is a pool connect, and we're going to create the JSX file for this pool connect.jsx, and we have to create the CSS file for this as well. So pool connect.module.css. So these are the two files we have. So we are done with this two component. And now let's come back to the index, and here we have to import. So we have to import the component. So pool add, and that's coming from the same directory, pool add. And now we have to import the other component which is a pool connect, and that's coming from the same directory, and we have to export both the components so we can receive in our entire applications. And you can see that this color of these components are red because we haven't written anything in our component. That's why you can see it's red, but when we write it, this color will become blue. So it looks pretty fine, no more problem we have. Let's come here, and now we can start working on our pool page first. So let's come back to the page and we can start working on the pool page. So first thing we have to do, we have to import a couple of things from React, and we have to import the image. We have to do the internal imports. So we need to import the first image, all the images. Now we have to import the CSS file, and that's coming from the style pool.module.css. And now we have to define the component. So we need these two components, pool add and pool connect, and that's coming from the context index. And now we're going to define the pool. So const pool, and we'll return this. We'll have a div. Inside the div we'll have this two component, so pool add and pool connect, and we have to simply close that one, and we're going to close it, and we have to make it export default pool. And that's the only thing we have to write in this pool page, because all the designing, all the data will flow inside each of these component. We have pool connected and pool add. So things are looking fine to me. That looks pretty good. Now that looks good. What we can do is simply comment this one because we haven't written anything. So let's focus one component at a time so we don't get any error. So let's come here and we can go into the style folder, and here we have to do the styling. So we're going to provide the styling. So pool, we have to make it width is going to be 50%, and we want margin 5 RAM and auto, so it will be in the middle. We have to make it position relative, and that's the only thing we have to do about the pool. So that's the CSS we have written. Close this one and click on this pool add, and let's write the JSX for the pool add. So we have to import React, use state, use effect, and that's coming from React. Now we have to import the image, next image. Now we have to do the internal import. We have to first import the images, that's coming from the asset folder. Now we have to import the style folder, style, and we have to import the component. So we need the token and token search. These are the two components we're going to use, which we have already built, and that's the component we're going to use, and that's coming from the context index. That looks fine. So far everything's looking good, and these are the external and internal import we have. Now let's start writing on the function. So we'll have this pool add, and let's come here. We have to define a couple of variables. So we'll say open model, set open model, and initially it's going to be this false. We have to define another variable, open token model, and this is also going to be false because we have to display the token model and the search token model. So for that I'm taking this use state so we can display and hide. So these are the two use state we have. Now we have to take another variable. This will say active, and it will be 1, and this active will use for the pricing. So you see that we are charging fee 3%, 1%. So whichever the user will select, we have to make that one active. So that's why we are taking this one. Now take another variable. We'll say open fee to set open fee. Initial is going to be false. Now we have to take the min price. So here we're going to take a couple of object. So let's take that. It will have the fee, and this will say info. So this is the general information which I have got from the Uniswap, actually Uniswap. So best pair, stable pair, and close this one, and we have to take a number. So it will be 0% sale. Close this one, and we have to take altogether 3. So let's take the other two very quickly, and this will have the fee 3%. We'll have the same information message, best for stable pairs, and we have to take the number. It will be 0 stable. Close this one, and we have to take the last one, and this fee is going to be 1%. You can define, it's totally up to you that what fee you want to charge as a liquidity. So that's the fee we have. Let's define the information, and the last one we have to define number. So 0 select. Close this one. So that looks pretty fine. These are the 3 different type of fee we are providing in our clone, in our Uniswap. Let's close this one and come here, and here we have to define the min price range, because we want that when someone will click on, so when the user will click on the plus, we want to increase the price. When the user will click on the minus, we have to decrease the price. So let's write the function for that, because once we have the function, all we have to do is to attach that function and everything would be ready. So let's write the function. It's gonna be this, and it will say if text is equal to plus. So if the text will get is it plus, then we want to simply do this. What we want to do is we have this set min price, we have to simply add 1 to that. So whatever the price would be, we're going to add 1 whenever someone will click on the plus button. And the same thing we have to do for the minus, so we have to subtract 1. So we'll say min price minus 1. Simple function, simple JavaScript. Close this one. And now we have to write one more function, because this one is going to be for the max price. And that's the exact thing we have to do here. If it's plus, then we want to add 1, and if it's minus, then we want to subtract 1. Minus, then we want to say set max price minus 1. So these are the two functions which is ready. With that, we can easily able to increase and decrease the price. And now we can start working on the JSX part. So we'll take this return. Inside that, we'll have a div. It will have a class called style.poolAdd. Inside that, we'll have another div. It will say .poolAdd dash box. Inside that, we'll have another div. It will have this pool dash box header. Inside that, we're going to have a div. It will have a class called pool box header dash left. And inside that, we're going to take image. It will have the source arrow left image. Width is going to be 30% and height is going to be 30%. Now we have to come down, and here we're going to close the div. Take another div. It will have a class. We'll say pool add box header middle, and inside that, we're going to take a p tag. It will say add liquidity, and we'll come down, and here we're going to take a closing div. And now we have to take a div. It will have a class called style pool add box header right, and in the right hand side, we're going to take the p tag. It will say clear all, and we'll take the image, and it will have the source. So in that, we have to provide the image close, and we have to define the alt, and in the alt, we're going to call image. We have to define the, let's say, width is going to be 50 and the height is also going to be 50. So height 50. And now let's attach a on click function, and we already have this state set open model true. So when someone will click on this, we have to display the pop-up model. From there, the user can select the slippage. So that's what we have. And now once we have that one, we can simply close this one. So it's working fine. Now let's come here, and we're going to close this div. We're going to have this div also, and let's come here. We're going to take a blocks. We'll say select price range. So we are done with the header section. Now we are working on the price range section. So let's come here. We're gonna take a div. It will have a class called style pool add box price. Inside that, we'll have this left section, because we'll have two sections, one left and other one is right. And on the right hand side, we'll display the like wallet and the price range selection min max. But on the right hand side, on the left hand side, we're going to display the like full pool fee, the token balance, all those things. So let's take a div. It will have a class. We'll say pool add box price left, and inside that, we're going to have a h4. We'll say select pair. Then this is the title we have. Then we'll have a div. It will have a class called style pool add box price left token, and in here, we're going to take this div. It will have a class name style pool box price left token input, and here we can call this p, and we have to define the image. It will have the image, select image, will have the ether logo, and we have to provide the alt tags, which is the image. And now we have to provide the width and height. So the width is going to be something 20, and the height is going to be also 20, because we want to make a 1:1 ratio. And this will have no click function, so we have to close this one, and now close the p tag. So that looks fine to me. Let's take another p tag. Here we can display the token. The token user will select the symbol, so just go with the hardcode value, we'll make it dynamic. So that's the p tag. Let's come here, we take another p tag, it will display this icon, and close the div, and we'll take a div. Inside that we'll have a class, we'll say po add box price left token info, and we'll take a, it will have a on click function, and in that we're going to call this function token model true. Let's come here, we're going to simply take a p tag, and here what we're going to do is we're going to provide this image because we want to display the image, and this will have the image. We'll have to provide the source. This is again Ether logo, and here we have that one. Once we have that, we have to display the alt tag because that's the general convention you have to follow, otherwise Next.js will give you an error. We have to provide the width is going to be 20 and height is going to be 20 as well. So that looks fine to me, and at the end we have to simply close the image tag, and we have to close the p tag. So we are done with this first one, and now let's take another p tag. It will have the logo, so for the second token, and now we have to simply take another p tag. It will have the symbol, and we have to close this div, close this one. So it looks fine to me, and we'll take the fee section. So we are done with this token section. Now we are working on the different fee section. So let's take here, let's take a div. It will have a class name. It will say pool add box price left fee. Inside that we're going to take a div. It will have a class called pool box price left fee left, and inside that we're going to take h4. We'll say p tier, and here we're going to render the p tag. Percentage will be earned in fee. So that's the message we want to display, and here we're going to simply close the div, and now that's the first section. Now we have to simply render the data. So we are hiding the fee and showing the fee on the click event. So that's the check we are doing. So we'll say open fee. If that's true, then we want to render this component. So we'll say button on click, and we'll say set fee false, and we'll display this hide. We'll close that one. Else we want to display this one. So on will click function, and here we have to call this set open fee to true, and we say show. So this is our dynamic button. That looks fine. That looks fine to me. Close this one. So it's working fine. Let's come here. Here we're going to take this fee list because we are displaying 3 different type of fee. So let's write that JSX for that. So we'll have this dynamic block. We'll say open fee. If that's true, then we want to display this component. So we'll say div. It will have a class. We'll say pool add box price left list, and it will have this if fee pair. We have to map over it, and we have to instantly return that. So in that we're going to take a, let's say div, and it will have a class because we want to looping it. So it will have a class called, let's say pool add box price left list item, and we have to simply provide a key because every item would be unique. So I+1. Once we have the item, we have to add on click functions, and in that we have to set the active I+1. So whichever the box fee pair will click, that become the active one, I+1. So that's the active we have. Now we have to simply close this. So inside the div we're going to take another div. We'll have another div, and here we're going to provide the class name. It will have the add pool box price left list item, and that looks good to me. Close that one. We'll come here. We'll take the left fee because we have the fee already there, and we have to take the, let's say we want to display the active. If active is equal to I+1, then we want to display the active tick button, tick image, sorry. So in that, say we have to take the image and we have to provide the tick image. So the image is already provided to you guys, and that we have this image dot tick. We have to assign the, let's say we have to assign the alt tag image, and we have the image here. We have to provide the width 220 and we have to provide the height, and that's also going to be 20. Else if it's not active, then we can display nothing, so empty. And that's our dynamic block, which will show that which one is active and which one is not active. So that looks fine to me. So far things are looking good. Let's close the p tag and let's come here. We're going to take a close this pd. We'll take a small tag here. We'll display the info, and here we're going to display the p. It will have a class called pool add box price left list pair, and here we're going to display the number because we want to add a custom class to this. So let's close this p tag, and that looks fine to me, and close the div, and we can close this dynamic block. So this is going to be our dynamic block. Let's close it. So this is the entire feature we have. That looks fine. Hope whatever we have done, that's making sense to all of you guys. If you still have any confusion, do leave in the comment section and do let me know. So that looks fine to me. Let's come here. We have to display the deposit amount. So we are done with the feature. Now we have to display the two component, that how much amount they are depositing for the liquidity. So let's build that component. So that looks fine. Let's come here. We'll take this class. It will have pool add box deposit, and in that we're going to take this h4. We'll say deposit amount. Here we're going to display the div, class name, style, pool add box deposit box, and that's the box we have. We'll have this input type text. Placeholder will have this 0 because currently we are not displaying anything. Well, we will make it dynamic. It will have a div. It will have a class called style pool box deposit box input, and inside that we're going to take a, let's say we'll take a p, and we can display this un, the coin, and here we can simply close that. And down below we're going to take another p tag. It will have a class called style pool add box deposit box input and item, and in that we're going to display this balance, that what the balance user have exactly. And now we can simply close this p tag. So that's the component we have. Now close this div. So this is the div we have to close, and now we have to close the another div. So that's the input component we have for the one token, and that's the same thing we have to do for the other token. So let's do it very quickly what we have done for the other one. So let me do it very quickly. Let's close this one, and we have to close this one as well. So this is the second component we have. Let's come here, close this one, and come here, we have to close this one. Now we can start working on the right hand section. So whatever we have done so far, whatever JSX we have written, that's for the left hand side. Now we are start working on the right hand side. Let's come here. Let's take a div. It will have a class called box price right, and inside that we're going to take this h4. We'll say set price range. Here we're going to display the div. It will have a class called pool add box price right box, pretty huge name, and we'll provide this p class. It will have this pool add box price right box dash para, and in that we're going to display our short message. So currently price this and pair with. So right now we are doing this hard code, but we'll make it dynamic. So that looks fine to us. Let's simply close this one. So that's the first one. Let's come here. We have to take an image, so we have to display the wallet type, wallet image. Where the height is going to be 80 and width is going to be 80 as well. So we have the wallet, and we can simply take H3 and we'll say your position will appear here. So that looks fine, and we have to close this div. That looks good. And here we can take this price range. We'll take a div. It will have a class called pool at box price range, and in that, what we're gonna do, we're gonna take a div. It will have a class called pool at box price range box, and in that we're going to take a p tag. It will say min price, and inside the p tag we'll come out of that and we'll take on another p tag, and here we're going to display this. So we'll take a class. It will have the style pool at box price range box. That's what we have here. Now what we can do is, let's come here. It will have on click function, and in that we're going to display this price range. We have to target that. We have to grab that text, and we're going to display this small minus. We'll say min price, and this will become plus. We'll come here. We'll say close this one. So this p will have a on click function. So whenever we click on that, if we click on the -1, we'll get the minus. If we click on the plus, we'll get the plus, and with the help of that we can easily able to display, increase the price or decrease the price. So that looks fine to me. So that's the one we have here. We'll say per width, and we close this div. Let's take another one, max range. We'll have a pool box price range box, and the same thing we have to do what we have done above. So let me do it very quickly. Let's have an on click function on this, and the same thing we have to do exactly what we have done. Here we're going to pass this e.target.innerText, and we have to get the minus and plus sign. So let me quickly provide that. Minus, we have to provide the max price, and this is going to be plus. That looks fine. Close this one. We have to close this div, sorry, p, and here we're going to display the text, the price. Close this div, and we have to close this div as well. Let's come here. Here we're going to display the button, and it will say that div class pool at box price right button, and that's the button we want to display. So here we're going to display the button component. So we'll say full range button. So this is the one button with the small one, and now we have to display the bigger button. So we'll take this div. It will have a class pool at box price right button amount, right amount, and inside that we're going to have this bigger button, enter an amount, and we have to close it. And that's it. That's the entire JSX we have written. Now simply close the div. We have to close the div, and now we have to simply close the div. So close this one. Now we have to add the dynamic block. So let me add that very quickly. We'll say open model. If that's true, then we want to display this component. We'll display this div. It will have a class token, and inside that we're going to display the component. So we'll have this token component, and then we have to set this prop so we can close that open model from the component section, and that's what we are following exactly, and close this one. So that's the first component we have, and now we have to simply close this. This is the one dynamic component. Now we have to add the other one, open token model. If that's true, then we want to display this component. So we'll say this token, and it will have this component search token, and it will have the data. Right now we are sending hey, but we'll pass the real data, and let's set this open token model so we can close it. Close this one, and we have to simply close this as well, and that's it. And now we have to simply make it default export, and that's the entire JSX we have written for this pool ad. If you have missed anything, make sure to rewatch that and try to find out and understand what's going on exactly. So these are the external and internal boards we have all this import. These are the use state we have taken. These are the price pair range. This is the function for min price and max price, and this is the entire JSX part we have written. It's pretty huge. You can see this is the left hand section. So what I can do is, let's close this one. So this is the header section we have, and this is the select price range. Let's close this one, left section. And no, we have closed the entire one. Simply open that one. We have to get into this left one. This is the left one, so simply close this one, and this is the right one we have. So if you want, you can click on this, and these are the dynamic blocks we have. So things are looking good. We have no more error. If we find that we have any error, we can definitely come. So this is how it will look. You can see everything is looking fine. If you click on this, you can see our model is open, so the function is also working. If you click on this, you can close. If you click on this, you can open, and if you click on this, you can close. So that looks fine to me. These are looking good. If you click on this show, you can see our dynamic component is also working, so we can easily able to have the price. You can click and you can select whichever you want, 1%, 3%, 0.5%. So you can hide and you can show. That looks good. So all the functionality is working. So we have done all the hard work, and now we can simply start styling this component. So it looks good. No more error we have. Nothing's wrong. Everything is working fine. So this is the width, and here we can simply open and select. So right now we don't have any function to get this data. That's why we are getting an error. So we'll fix that. So just focus on the designing for the time being. So reload the browser, and things looking good to me. Now what we can do is, let's come back to the code, and now we can start styling this one. So let's come here, and we have to get this, copy the class, and now we can start styling this. So come here, we have to target the pool add box, and we have to assign the background, and we have to assign the border radius, we have to assign the padding 1 rem, and let's target the box header, and we have to assign the display is going to flex, align item center, and we have to assign justify content space between, target the box header right, we have to display flex, align item center, and we'll have the gap 1 rem, color this, we'll target the box price, it will have the display is gonna be grid, and we have to display grid template column, repeat to 1FR, background is going to be our primary color, and we have to display the padding is 1 rem, gap is going to 2 rem. Let's come down, pool box price left to token, display is going to be grid template column, will have this repeat 1FR, 2FR, 1FR, gap is going to 1 rem, and we'll have to close this one. Let's come down, we'll target the pool box price left token info, display is going to be flex, align item center, gap is going to be 1 rem, background color will have the second primary, will have the border radius 0.5 rem, will have the color is going to be primary color, and will have the padding 0 and 2 rem. We'll have the font width is going to be 700. Let's come down, we have to target the pool box price left fee, and this will have a display flex, will have align item center, align height is going to be 0, padding 0.5 rem and 1 rem, justify content space between, border 1 pixel solid, our second primary, and margin top is going to be 1 rem, border radius 0.5 rem, close that one, pool add box price left fee p, and we have target the font size going to be 0.8 rem, pool add box price left fee button, and this will become background color is going to be our second color, border 0, padding 0.5 rem and 1 rem, border radius 0.5 rem, we'll have the cursor pointer, we'll have the font width is 100. Let's come here, we'll target the pool add box price left list, and this will say display grid, it will have the grid template column, will have repeat 3 1FR, and will gap 1 rem, we'll target the margin top is going to be 1 rem. Let's come down, add pool box price left list item, border is going to be 1 pixel solid, will have the second primary color, and we'll assign this padding 0.5 rem, line height is going to be 8, border radius 0.85 rem, and we'll have a cursor pointer, close this one, come here, we'll take this pool add box price left list item info, and that we're going to display flex, we'll say align item center, and justify content space between, we'll have the pool box price left list item info item para, and we'll say background going to be this, color, border radius 0.5 ram, we'll have the padding 0.3 ram, and let's target the box deposit box. Display flex, we'll have the align item center, justify content space between, we'll have the line height is going to be 0, and we'll have the border 1 pixel solid, we'll have a second primary color, border radius 0.5 ram, margin top 1 ram. Let's come down, target the pool box add deposit box input. This will become width is going to be 50%, background color is going to be transparent, outline none, border none, color will have the second primary color, and font size is going to be 1.5 ram. We'll have margin left 2 ram. We'll tag close, then we'll target the add pool add box deposit box input. We'll take this background color is going to be our second primary color. We'll have the padding 0.1 ram. We'll have border radius 0.5 ram. We'll have a cursor first primary color, font size is going to be 1.2 ram. We'll close that one, and we'll say pool add box deposit box input pay, and we have to take display is going to be flex, align item center, gap is going to be 0.5 ram, and we'll take this pool add box deposit box input p small. We'll take the background color is going to be our primary color. We'll take the color is going to be second primary color, and we have to take this padding 1 ram. We have to take the border radius 0.5 ram. We have to take the font size going to be 0.5 ram. We'll close that and add box deposit box input balance, and we have to add the font size going to be 0.8 ram. Margin top is going to be minus 0.5 ram. The padding is going to be left 1.4 ram, and box price right box, and we have to target that. We'll take the text align center. We'll say line height is going to be 1 ram. Margin top is going to be 1 ram. We'll add the put box price right box para, and that we'll say font size is going to be 0.8 ram. We'll say margin top margin bottom 0.5 ram. We'll say pool add box price right range, and this will say display is going to be grid template column repeat to 1fr. We'll say gap is going to be 1 ram, and we'll say pool box price right range box. This will become border radius 0.5 ram, border 1 pixel solid, will have a second color, text align center, line height 1, pool add box price right range box para small, margin inline is going to be 1 ram, and we'll have a background to be our second primary color. Font size is going to be 1.2 ram. Color is going to be first primary color. Padding is going to be our 0.2 ram and 0.5 ram. Border radius 0.5 ram. Cursor pointer will come down. We'll target the pool add box price right amount. We'll do the same thing for the button, and we'll say margin top is going to be 1 ram. Display is going to be grid. We'll come down. We'll target the box price right button, and this will have the background to be our second primary color. It will have the border radius 0, border is 0, and outline is going to be none. It will have a padding 0.5 ram, and border radius is going to be 0.5 ram. It will have a cursor pointer, and it will have a font width is going to be 700. Let's close that. Come down. We have to target the price right amount button, and this time we have to provide background color to be our second primary color. We have to provide the 0, outline none. We have to provide the padding 1 ram, border radius 0.5 ram, cursor pointer, and we'll have the font size going to be 1.2 ram, and font width is going to be 500. So that's the button amount, second button. Let's come here. Let's target the token, the dynamic block which we have added. So we'll tag the token. We'll say position is going to be absolute, so we can place wherever we want. Absolute. We'll say top is going to be 0 ram, and right is going to be 332 ram. So I have to adjust that. Let's close that, save it. So you can see that's the entire CSS, and that's the entire CSS we have written for this component. So everything's looking good. If you have missed anything, you can rewatch, or you can get this code in the complete project. So that looks fine. Save it, and now we can come here, and you can see here, you can see it's looking fine. So that looks perfect. You can see everything's looking good to me. all the component. You can click on this open show, you can select whatever feature you have. That looks fine to me. And you can increase, you can decrease. The functions are also working fine, looking good to me. That's okay. This is the amount. You can click on this and you can select the token whichever you want. Close this one. If you can click on this, here you have the slippage options. That looks fine to me. No more error we have. So this is the price, Uniswap, everything's looking good. So that's okay, that's look fine. So with this we are done with this. Now what we can do, let's have a look. Let's close this one, and come back to the pool. And right now this is how it look. Now what I can do, I can simply open this one. So I have closed that, so that's why we have seen empty. Let's uncomment this and let's start working on this pool connect JSX. So come here, click on this, and now we can start working on the JSX. So let's me quickly write it. So we have to import couple of things from React. So React, we need to import the images, Next.js images, and we have to do the internal import. So we want to import the style CSS file, and I want to import the images as well, and that's coming from the asset folder. So these are the internal import. Now let's define the pool connect functions, and in that we're going to take this, write the entire JSX. So let's take a div. It will have a class style pool connect, and inside that we'll have another div. It will have a class pool connect dash box. Inside that we going to have a div. It will have a class pool connect dash box header. In that we going to take a h2, we'll say pool, and here we're going to take a p tag, we'll say plus new position, and we're going to simply close this div. So this is the header component we have for the pool. And now let's come here. We have to take a div. It will have a class called pool connect dash box middle, and in the middle we want to take a image which will have to provide the source wallet and width 8080, and that's the image we have here. Now let's take the p, your active v3 liquidity. You can display whatever message you want, but this is what I got in the real one. v3 appear here. So that's the p tag we have. Now simply take a button, we'll take the connect wallet, and we're going to simply close this div. So this is the middle section. Now we have to work on the final section. So let's come here, take a div. It will have a class called style pool connect dash box info. In that we're going to take a div. It will have a class pool connect box info dash left. In the left hand side we're going to have a h5, learn about providing liquidity, and down below we're going to have our p tag. So here we're going to display check out your v3 lp walkthrough and migrate guide. And now we have to simply close this div. Now we have to take the right hand side div. So we'll take another div. It will have a class called pool connect dash box dash info right. Inside that we're going to take again h5, and in that we're going to display top pools. We have a p tag, and in that we're going to display the explore Uniswap analytics, and we're going to simply close that, and we have to simply close that and close this, and that's the entire JSX we have written. Simply close this one as well, and that's it. And now we have to make it default export, and that's the only thing we have to do. It's looking pretty fine, pretty small JSX. So that looks fine, everything's looking good so far. Save it, and if you come back to the application, you can see this is how the content looks. We have the pool, we have the positions, we have our images and the buttons. Everything's looking good. So what we can do now, let's come back here, and now we can start working on the styling. So let's do it very quickly. So we'll target the pool connect box, and we have to assign the background to be our primary color. We'll have a padding 1 RAM and 2 RAM. We have to assign the border radius to be 1.5 RAM, and we'll come down, we'll target the pool connect box header, and it will have the display is going to be flex. It will have the justify content is going to be a space between, and we'll have the align item to be center. Well, close that. We'll come down, we'll target the pool connect box header h2, and we have to set the font size, so it will have a 2 RAM. We'll close that, we'll come down, we'll target the pool connect box header p, and it will have a background color to be this second primary, and we have to assign a padding to be 0.5 RAM and 1 RAM. Let's target the border radius to be 1.5 RAM, and we'll have the color to be our primary color, and font width is going to be 700. We'll have the cursor pointer, and let's target the pool connect dash box middle, and in that what we're going to do is we'll say text align to be center, and let's close that one. Come down, we have to target the connect box middle button, and this will be the, let's say, background color to be this second primary color. We'll have the color to be our primary color, and we'll have a border 0. We'll have a font size is going to be 1.5 RAM. We'll have a font width is going to be 50, and we'll have a padding 0.5 RAM and 3 RAM. We'll have the border radius 4 RAM, and we'll have a cursor is going to be a pointer. We'll say margin top is going to be 0.5 RAM, and we have to simply close it. Let's target the pool connect box info, and this will be display is going to be a grid, and grid template column is going to be, let's something like 0.5 1FR and 1FR. That looks good. Gap is going to be 1 RAM, and we'll have the line height is going to be 0. We'll have the margin top is going to be 2 RAM. That looks good. Come down, we'll take this pool connect box info right, and we have to target the left section as well, and in that we're going to say border 1 pixel solid, and we'll have our second primary color. We'll have a padding 0.5 RAM. We'll have a border radius 0.5 RAM, and that's pretty much. So that looks pretty good to me. You can see the entire CSS we have written for this small component, so that looks pretty fine. And I'm going a little faster for the CSS and for the JS export because that's not related to the smart contract, and I don't want to spend much time on explaining on this because these are the self-explanatory things. So that's why I'm going a little faster. So that looks pretty fine to me, and that looks good. No more problem we have here, and that looks good. Simply come here, and you can see this is how it will look. Beautiful. We have the pool. This is the header section we have, and this is the middle section we have with the connect wallet function. You can simply come here. You can see this one is also looking good. This one is also looking good. So close this one, and simply open this. If you open that, you can see these are both the components are displaying together, but we're going to make it dynamic on the base of the account. So let's click on this. Everything is working fine. No more problem we have. You can close, you can increase, you can decrease, and this is the connect wallet and pool functions. So that looks good, and close this one, and come here, close this one, close this, and close this. So with that, we are done with this entire UI part where we have designed both the component, and in the next video we're going to connect the smart contract. We already have the smart contract, pool smart contract, and that's contract we're going to attach to each of this UI, and we can make some transaction. So with that said, let's move to the next video. Hi everyone, hope all of you are doing great. So we are starting with our decentralized exchange. So we have built the smart contract, we have tested those smart contract, and we have also connected the smart contract with the front end, and we have done certain testing in the front end. So if you haven't watched that part, make sure to watch. I'll link in the I button in the description so you can follow that. And now we're going to actually learn about the Uniswap. So it's very important that we have to know every single functions, every single keyword, every single parameters which Uniswap defined in the smart contract and in the SDK, V3 SDK. So that's what we're going to start right from this video. So in the next 5 to 6 tutorial, we're going to talk about only Uniswap contracts and SDK. And once we're done with this entire Uniswap, then we're going to take this knowledge and we're going to connect in our decentralized exchange and make that swap happen. If you look at the real Uniswap exchange, what happened there? When you want to swap the token, you are getting an estimated output. So you have to learn about that. You have to learn about the square root. On the base of that, you set the pricing of the slippage and the curve. So that's what we're going to understand, and that's what we're going to learn, because once you have that kind of knowledge, you can build any application, you can build any logic, you can build any protocol and use it in your application. So that's going to be my motive, and that's what we're going to start. So instead of going with the smart contract of Uniswap, as I told you in the last video that we will start with the smart contract, but we're going to start with the Uniswap V3 SDK. That's we're going to start with because that one is really big. So we'll start with that, then we'll move to the smart contract. There are minimum things out there because most of the things we have already covered in the smart contract section when we are testing that. So we're going to talk about SDK, V3 SDK. So what we're going to do now, we're not going to write code in the project. We're going to create a separate project. In that, we're going to test all the V3 SDK. And once we done with that, then we're going to pick these broken pieces and we're going to attach into our application. So that's going to be the motive. So what I have done here, I have created a project and I called it Uniswap Test. In that I have created a Next.js application. So you can see my package.json file. In this I have I have installed these two packages, Uniswap SDK core, this is the version, and Uniswap V3 SDK. So make sure to install these two packages, and you need to install the Ethers.js package. Close this one, and now let's test this out. First thing we have to do is we have to understand what is SDK. So Uniswap provide two different methods which you can use to fetch the data from the Uniswap protocol. One, you have the smart contract which you can utilize to fetch the data and make different type of calls, whether you want to create liquidity, whether you want to create an instant of the pools, whether you want to do the transaction of the swap, or whether you want to list your own token. So that's all you can do with the help of the contract. And on the other hand, we have the V3 SDK, and this is so powerful. This will allow you to perform certain functionality at the real time, because SDK will provide you a lot of power features which you can utilize is to calculate the price at the real time. So when someone will enter the amount of the token they want to shop, you can easily able to find out that how much output they're going to get. You can set the alpha router as an optional property, so they can add it or they can skip that. So all that estimation you can able to do with this V3 router, because if you want to do the same thing with the smart contract, it's not possible, because to utilize that we have to make a constant call. It is possible. All you have to do is you have to make a server where you have to run the code over and over again. You have to call the function over and over again, and that will look for the change in the data, which is really hectic task, which we're not going to do. We're going to use this V3 SDK. Okay, so here I have my empty project, and now first thing we have to do is to import the necessary states. So we want the use state and we want use effects. So these are the two hooks we are using. Now we use this Ethers.js package which I have already installed. For the provider I'm using Acmeli, so make sure to go to acmeli.com and create your account and get your own provider. Don't use my. So I have connected with the mainnet, so this is my provider. Now I have to console log this out. So simply console, and if I do that, you can see in the browser here my browser is repeating, and here you can see here I got my provider, and here I will get bunch of data. So if I come into the network section, you can see this is the hosted, this is the EN address, this is the chain ID. One stand for mainnet. So different chain ID we have different numbers. So mainnet is 1. If you go with Gorilla, it has 3, maybe it's 3. So this is the provider which I have got. Let's come back here and now write the other code. So once we have that, now let me comment this one, and now we have to get the pool address. So this is the pool address. So this pool contract is deployed already on the mainnet. So you can simply copy this, and if you want to know that what is this pool address, come here in the browser and go to this ether scan. I have already saved here, and if I paste here, if I click on the search, I can able to find this entire contract. So you can see all the transaction is happening in this particular contract. So click on this contract, and here you can able to find all the function which exist into this contract. So we have this libraries, we have this Uniswap V3 pool which allow us to create pools, liquidity, hell lot of things. So you need these all things. They have bunch of functions. So we have this slot one, we are using this one as well, and there's a lot of things. You can see all these functions, all the data we have into the smart contract, and this entire data, this entire function is also provided to you in the V3 SDK. Use this contract in our V3 SDK. We need the address of this contract, because ultimately we're going to interact with this contract. So let's come here. So we have this pool address. That's what I have called. You can call whatever you want. So this is the address I got. Now let me take a variable. So here I have taken a variable. In that I'm going to define the ABI, the function which I want to call into this pool address. Okay. So these are the function which I want to call. I have pre-written here. So I want to call the function factory. It will give me the address. I want to call the token 1, so the first token, and this is the second token. I want to get the fee. I want to get the tick spacing. That's concept we're going to talk about, and this is the max liquidity per tick. So these are the function for the time being we are calling. You can add multiple things. You can add multiple function, whatever you find in this contract. So sorry, this pool address contract. So these are the these are the ABI we have taken, and now we're going to make the call of the contract. So we have the address, we have the ABI, and we have our provider, and now we can interact with the contract. So we have all the important data we need to make the connection with the contract. So we have our provider, we have our pool address, and we have the API of the contract. So let's take a variable, another variable. So here I have taken another variable, I called it pool contract, and here I'm using ether package contract, and in that I have to pass all these three data: address, mutable API, and we have to pass our provider. So we have this provider. Let's console log this out and save it, and let's come back to the browser, and boom, here you can see here we got the contract which we are using to interact. So this is the entire data you will find about the contract. So we have the address of the contract, we have this couple of methods, we have the factory, we have the fee, we have the filter, we have the function, we have interface. Inside the interface we have a lot of functions. You can see we have a couple of functions here: deploy, error, event, fragment, function, struct. So we have all these things in this interface. We have this max liquidity price, that's the function we have called here. You can see this is the function we have passed here, and that's what we are getting. So we have all these things, token 1, token 0, so we can easily able to interact with the contract. So we got our contract. Now simply comment this and simply take a variable. So here what I have done here, I have taken a let, and this is an object because I'm going to fetch the data from the contract and I'm going to assign to these objects. So factory, token 1, token 0, token 1, fee, tick spacing, and we have max liquidity per tick. So this is the entire object we have taken, and we have defined as a let because we're going to update this data. So let's console log this out. If I console log out, you can see I have an empty object. So you can see I have nothing in this entire data is empty, so it's working. Now let's come back to the code, and here what I want to do is let's comment this. Simply take a function. Right now we are creating async functions and we are calling it get pool immutable. This is the function we have here, and we want to return this from here, but this data will come from where? So we have to get this data. So to get this data, what we're going to do is we're going to take a variable, this pool immutable, and we're going to assign this variable right here, and we have to update this variable. I know many of you are getting confused because we are going backward, okay, but don't be confused. So what I'm going to do, I'll come here, I'll take this variables, and here I'm going to make the calls. So right now I have the contract, this pool contract, which contained all the functions, and here we have the function. So we have the factory function, token 1 function, token 0, token 1, fee, tick spacing, and max liquidity per tick. So we have all this function we are getting from the contract, and we are calling it. It's an async function because we have to wait from the promises, and then we are assigning to each of this. So it looks fine. So we are updating this entire data with this functions, and finally we are returning from here. So that looks fine. Now come here, come down, and we create another function. So this is the function we have created, get pool immutable, then result, and then we are simply consoling logging the entire result. Hope this makes sense to all of you guys. What we have done, we have taken out provider, pool address, mutable API. You can define as many data as you want. You can go to the Etherscan, look at the contract, that what are the functions it has, and you can get the data. It's totally up, because these are the 6 common functions I have taken to show you, to get you familiarized with the SDK, that how you can utilize, because these are the things we're going to use a lot. And we have our contract. This is the variables, the data we want to take from the contract, and these are the function calls we are doing, and then we are simply returning. So if I save it, if I come to the browser, you can see this is the data I will get back. So just wait, because we are making a request to the mainnet, that's why it's taking a little bit of time. So come back, and finally you can see the data we have here. So we have the factory, this is the factory. So here we have this 2 token. So this one is the USDC and this one is the ETH. So to check that, come here and simply paste, remove the 2, this, and make a call. If you look at this, it's a USD token, stable price. You can see the transaction, everything and all. So they have taken USD and ETH. You can see the tick spacing is 16. We're going to talk about that, what is tick spacing. These are the 2 tokens, because right now we are taking these 2 data, and that's how you interact with the Uniswap. So hope this entire things makes sense. You guys have got understood that how you can use this Ethers.js package to make a call to this Uniswap pool address. We're going to spend a lot of time around this pool address. We're going to fetch different pricings for the token into the pools. We're going to create the instance. So a lot of things is coming. Just take one step at a time and try to make your hand dirty before we move to the actual stuff. So this is the general thing we have done. What we have learned from here, that how we can use the Ethers.js package to interact with the pool address and fetch the data of the token which we want into our applications. So I believe that you guys have understood that what we have done. We have connected with the pool contract address and we are interacting and we are getting the data from there, including the tick spacing, liquidity. We're going to talk hell lot of things. Okay, so make sure to rewatch, try to understand, and in the next video we can start with the little advanced things. In that we're going to talk about different variables which goes into this SDK V3. So let's move to that. Hey all of you, hope you guys are great. So we are starting with our DeFi exchange project, and this is where we left. And as I told you that we're going to discuss more about the Solidity smart contract and the V3 SDK, but I'll keep that for a side. Let's complete the project and later we're going to discuss about those SDK and the smart contract. So right now you can see that I have initialized my project on my local host and I'm using Forknet to do the transaction of the swap the token and fetching the data, all of those things. Okay, so I believe that you know that what is Forknet, and I have already made a video that how you can connect. So if you still have any confusion and what it does, make sure to follow that video. Okay, so this is how it will work. So right now if I click here you will find all the token which exist on the mainnet. So we have this Bob, which is my GMT, EURT, DAI, FTX, Leo, Mate and ETH. So now what I want to swap the token between ETH to DAI. So that's how I can do. If I click on this ETH, here I will have that ETH and I have 0 ETH in this. Don't need to worry about this 0 balance because I'm testing this ETH locally. That's why it's saying 0. But I have balance in the same address. You can see the MetaMask provide these much balances. Okay, because we are using this as a locally, that's why you can't able to see the balance of this particular token, but you will find the other token balance right up here. But we're going to utilize this balance. So this is the address, the first token. If we click on the second and I want to shop with the, let's say, DAI. If I click on DAI, right now I have this much DAI in my wallet. Just imagine that I want to shop 2 ETH. You can see this is our loader is working. It's fetching the data from the mainnet because we are using the Forknet, and it will tell us that what is the estimated output we are getting when we want to swap the token. So just wait, let this process happen. And here you can see this is the expected output we can get if we swap 1 ETH to Ethna DAI. 2025 80.513704. So this much DAI will get, and this is the pool we are using. So you can add multiple pool here, but here I have taken the pool for these 2 tokens specifically. So you can see this is the pool we are using and this much balance that particular pool has. So we're going to talk about each of these. Okay, don't need to be confused. So if you visit Uniswap, you will find that you will get the similar architecture here. The amount you have provided, the output you will get in terms of DAI. So it's working fine. Now if you click on this swap, and this swap will happen. So let me see, where is my MetaMask? Here is my MetaMask, and right now I'm sending this 2 Ether. This is the price in the terms of dollar, and if I click on confirm, and here the transaction is happening. If I click one more time, I think, and here I'm providing the confirmation to my smart contract to take my token and do the swap. So click on confirm and just wait, and one more I have to confirm here, and I know why it's happening because I clicked twice. So instead of happening 2 Ether, it will have 4 Ether maybe. Let's see. So I think I have to click one more time, and here the transaction is happening. Yeah, as I told you that it will send 4 Ether. So click on confirm and the transaction went successful. So right now the transaction is happening at the background, or you can display a loader. So let me do the inspect element and see that what I get. And right now you can see I got an object back, and these are the data we are taking from the user. And right now you can see this is the error message I got. And if I reload the browser, and let's see what balance I should get. So if I click on this DAI, token, and you can see the transaction went successful. If you come here and if you want to take the example of ETH, you can see right now I have this too. Okay, so that's how it will work, and you can easily able to swap from multiple tokens. So right now I want to swap with the DAI to ETH. Okay, sorry, with to Mati coin. So if I click on this Mati, and here all I have to do right now, I have 0 Mati. So if I pass, see, this is the output I will get in the Mati coin, and here I have hard coded this value, but you can take it dynamic, and obviously I'm going to do that and display a dynamic pool. Okay, so you can see this price is optimized, and if you click here, from here you can easily able to set the snippet tolerance in terms of percentage, but we have hard coded that value and we're going to make that dynamic as well. Okay, so everything, you can see everything is working fine, and we have to work on the very first thing is that if we click here you can see we get all these token. So right now I have this wrap2 stable coin, and if I want to make the transactions, all I have to do is to click on this swap token. Here you can see the MetaMask got open, and now I can easily able to get the Mati coin. So right now I'm sending 1 ETH and in exchange of Mati. So click on this confirm, and here is the another one. Here we have to confirm the smart contract so it can swap the token. So click on confirm, and we have to confirm one more time and just wait. And here you can see this is the swap input. Click on confirm and the transaction is happening in the background. So just wait for a second, and we're going to add a loader here, so it will say that okay, so the transaction is happening. Once the transaction get completed, we'll display the data. So I guess the transaction went through. Now what I want to check the balance of the Mati coin. So if I click on this Mati, and you can see right now I have this much Mati. So we have successfully swapped the token from WETH to DAI, and you can do for any token. So if you want to get any token, you can get it. So right now here we have the list of all the tokens. So Mati coin I have, DAI coin I have, RIVE Ether. So you can just simply swap token in any one of these. So it's also working fine. So that looks pretty good. Hope you guys have got the idea that what are the things we're going to do. Now the very first thing we have to do is we have to work on this. Right now you can see we have all of these tokens, and these tokens are on the mainnet. So we're going to get all the popular tokens which are there on the mainnet, which people do frequently transaction. We're going to take their addresses and we're going to attach in our decentralized exchange. So that's going to be the first work we're going to do. So come here, we're going to come and we're going to go to the ether scans, and I have already taken a couple of addresses, and the same addresses I will get here. You can come, go to this token ERC20 token section, and from here you can pick whatever ERC20 token which you want to provide as a swap. But in my case I have already done this, so I'm going to take the same addresses here. So that's for the intro part. Now what I can do, now let's get into the project. So this is the completed project I have, and we have done a lot of things into this. So simply close this one, and this is the unfinished project. So I'm going to simply minimize this one, and I'm going to open this one. So this is our unfinished project. So let me give you a walkthrough because of what we have done so far. So right now you can see we have the artifact assets. In this we have all the images, we have this component inside this. We haven't, this is where we left in the last time, and in the context it looks pretty fine. We have all the ABIs. If we click on this swap, and that looks pretty fine. So these are the things we have done in the context. If we come back to the contract, we have written so many contracts. We're going to write more contract. And here if we come into this like swap token, here we have to do a little bit modification. So instead of getting this hard coded value, we can get it from the user in which he want to do the transfer. So we're going to modify this contract, and there is a lot of things. And here we're going to build like 3 more script for fetching the price, getting the pool data. So a lot of things we're going to add into this. So let's take one step at a time. So what I'm going to do is I'm going to first work on the context. So let's start with the smart contract first. So what I'm going to do, come here and we can start working on the smart contract, and let's optimize it for the universal, so anybody can swap any token. So this is the basic things. So hope you guys have the same code. Make sure to pause the video and try to and just check your code, that you guys should have to have the same code instead of everything's working. Okay, so these are the code is there. Now let's start modifying this. So very first thing we have to do is we have to simply comment this out, and we don't need this hard-coded value. And here we can come into this functions, and here we're going to define the tokens. So we'll say address, we'll say token 1 2. So these are the 2 tokens we have, and now we're going to simply replace this. So come here, select this width, click on F, and here you will find this. Simply click on this replace with the first token. And now we have the second token. So let's come here, click, simply copy this second token and click on this, find F, and simply delete this, simply replace this. So these are the two changes we have done for this token. And one more thing we have to do is simply come here, we have to grab this one, and we're going to do the same thing in the exact output. So right now you can see it's not defined, so we're going to simply place this, and that's pretty much. And that's all you need to do for making this to swap multiple different token, not the only two tokens. And this looks pretty fine to me, no more problems we have in the code. And here you can see the fee is we have taken hard coded. You can make it like 5, you can make it 1, but I will go with this because most of the pools which I have found, this is the optimal fee they charge. So this one is the fixed one, and if you want you can go with the dynamic one, but for the time being let's do with the fixed one. And that's the only changes we have to do here. Now let's come here and let's go to this. So this is the smart contract we have done. Now we can go to the context. Inside the context we have all these codes. So here we have to do the modification in the contract, and we have to paste the addresses of the token. So what I can do is, so that looks pretty fine. Open up your terminal, and now what we can do is simply clear the artifacts. This will clean the artifact, and we're going to work only in one contract at a time. So let's come here. Here we have that, this, where it is. This is the single swap token. We have simply remove this one because we going to redeploy this, and that looks fine to me, no more problems we have here. And let's come back to the package.json file. Before we do that, let's come to the script. And here we're not going to deploy all the scripts, we're going to work on the only one script at a time. So we're going to comment this one, and we're going to deploy this one. We don't need to deploy the token for the time being, just comment this one, and this looks fine. So these are the changes you have to do. We're going to work on this script, close this one, and before we do that we have to do couple of important installations. So right now you can see these are the packages we are using. This is the OpenZoe plane, Uniswap V3, Ethers, Next, React, React Down, and Web3 model. So all of these packages we are using, and we are using this one as well. But now we have to install a couple of more things. Bring the terminal up, and the first package we want to install is the Axios. Okay, so we are done with the installation. Simply close it, and we have to install this router so we can get our updated price. So that looks pretty fine so far, things are looking good. These are the two packages we have taken, and for the time being that looks good to me. So make sure to install this router and the Axios so we can make our API calls. So simply close this one and come back to the context, not contract, context, and here we have to do a couple of imports. So these are the things we got it from core SDK, and now we have to come here and we have to create the two more files. So simply close this one and come back to the utils. In that utils we're going to create two files. So the first one we're going to call it, let's say, so this is the first script we're going to write in this. We'll create one more swap update price.js. This is another script we're going to write. Okay, so this looks fine to me. And let's come here we have to import the file. So let's do the import, and later we're going to do it. So we can say, so these are the two files we have imported. Make sure to do that, and that looks fine to me. Here we got that, and now what we're going to do is, here we're going to import the actual addresses. Okay, so I'll provide you these addresses. I have already done the copy paste. You can take of your choice. You can go to the Etherscan, find the token which you want to allow user to swap on your decentralized exchange, but I have already taken a couple of addresses, and that's what I'm going to paste here. And simply come here and simply paste. So these are the addresses I have taken, close to 8. These are the addresses I have. Now let's open this one, and we can come here. This looks pretty fine to me, no more problems we have here. Simply scroll all the way down, and now we can start working. So right now you can see we are not calling this function, but we're going to call it. So So let's make this uncomment, call this function, and here we have to do the modification. So in this we're going to receive data. So the data we're going to receive is going to be token 1, token 2, and we want to take the swap amount. So these are the data we're going to take, and the data would come something like this. So let me console log out that, and the data will come in the form of object. So I have to extract the data. So we'll take this token 1. Inside that we will have the token addresses, and we'll have this token address. So this is how the data will construct, and that goes for the second token as well. So we'll say simply replicate this and simply paste here, and we're going to make it 2. So this is the token 1, token 2, and we have the our amount. So we'll the swap amount. So this is how we're going to construct the data. We'll take an object, and in that we're going to take this addresses, and we don't need to do any changes here in the contract, because both the contract is ERC20 token and we'll have the same function, so we can use this contract. So that looks fine to me. Don't need to change anything here. And here we have to construct the amount we want to show. So instead of this 1 ether, what I'm going to do is here we have to define things. So we'll take a const, and we have to define the decimal point, because every token is different from one another. If you talk about the stable coins, they have 18, some have 16, some have 8. So they have different decimal points. So we're going to take that decimal point. You can call it whatever, decimal 0, and it's going to be 18. Amount, going to take a swap the amount, and here we're going to take that const amount in, and in this we're going to take this ether package, Ethers.js package, and then we have to convert the price. Utils will say parse, and then we have to simply pass the amount. So first thing, we'll take the input amount and we have to convert it into a string. Once we convert that, after that we have to define the decimal point, and that's the price. That looks fine to me. And right now we don't have anything, so simply console log out, console.log, so we can get the output when we actually do the transaction. So we'll say amount in. That looks fine. That's the changes we have to do. And here we are simply passing the depositing the amount to our swap router. That looks fine here. And here we had making the transactions, and here we have to do the changes. So here we are calling swap exact input single, and here we have to pass the 2 token addresses. So first thing I will do is I'm going to simply store it as a variable, so we can vet transactions, and we are storing the variables, and now we have to pass the 2 token addresses. So here we have taken that. So simply grab this one, grab this entire one, copy this, and simply paste it here. And here we have to simply remove this pricing, because this is not the pricing we are sending, and this looks fine. So these are the 2 tokens we have, token 1, token 2, and this is the amount we want to swap. Once we done that, we have to wait for the transaction to be completed, and we'll say transaction dot, we'll call this wait method, and once we get done with that, we're going to simply console.log the. So right now here we're displaying the balance of the ether. You can display the token balance, but for the time being, let's keep it like this. We're not doing anything here, we are just facing the balance of the DAI token. Okay, so that looks pretty fine of our swap token, and we don't need to do any changes here in the functions. And I want to do a couple of changes here in this, because right now we have this data, we have these tokens. So let's come here, and here we have to do and here we need the token addresses as well. So we'll say token address, and the address we have inside this. Okay, so make sure to do all the changes, whatever we have done here, whatever changes we have done here to make things working. So we have created these 2 components, but we haven't written any code into this, and now we're going to start creating the functions. So this looks good. Let's have a final look. No more problems we have optimized this entire functions, and this looks good to me. So simply close this one, and now what we can do is come back to the fetching price, and now let's create one more file. Let's create one more file, this called JS, so price helper, and let's create a function into this. And here first thing we're going to do is import the XCS, and here we're going to use the Etherscan API. tell you how you can get it. And here we're going to simply build the function. So we'll say exports dot get ABI, and it's going to be async functions. Will have the address, it will take the address. In that we have to construct the URL, and we'll say URL, and in that we're going to define the entire URL. And this is the URL we have, and with the help of this ether scan we are getting the actual price of the token, so we can check the price and display in the front end that how much output they will get when they want to shop the token. Okay, so make sure you have to get your own Etherscan API, which I will tell you. Let me write the functions. So this is the URL we have. Now here we have to get the response. So once we get the response, what I have to do is we have to say await. We're going to use this XES, and we're going to call this get method, and in that we're going to pass this URL. So it will give us the response. Once we get the response, we have to get the ABI, and we're going to use the JSON dot parse, and then we have to pass the response dot dat data dot result. So this is the result we'll get, response, and we have to simply return this to this function, the ABI, which we need in other functions. That looks pretty fine. That's what we are doing here. That's the very first function for getting the ABI of the contract. All we have to do is to pass the address, and it will return the API of that contract. Now let's come here. Here we're going to create one more function, exports dot, and this time we'll call it get pool, and in that we're going to pass the contract of the pool, whatever pool data we want, and we extract the data. So the data we need, there is a bunch of data, but the data we want is the token, first token, and we want the token number 2, and we want the pool fee. These are the data we need, and this data will come from here, wait promise dot, that's what we have. And here we're going to call the pool contract, and in that we're going to simply call token 1 function pool contract dot token 2, and pool contract we have the fee, call this one. That looks fine. So these are the 3 data we'll get here, and now we have to simply take a variable, and that's what we're going to return. So we'll say const immutables, and then we're going to pass the data. So we'll say token 1 is going to be token 0, we'll say token 1 is going to be this, and now we have the fee. We'll have the fee. Once we have the data, we're going to return this data from here, so we can receive immutable, and that's all the thing you have to do. We have our XES, we have this ABI function which give us the ABI of the address, and this is the pool for getting the data. Okay, and now let me show you how you can get this Etherscan APIs. So here I'm back into my Etherscan account, and here you will find all the details about the account. So all you have to do is come here, click on this, and here you will find this API key. Click on this here, and this is the API key which you need to download. Simply copy, and that's the API key you're going to simply paste here. Simply come and paste here. Okay, so that's how you can get your API key, and that's the only thing we need to write here in this function. So we're done with this. Simply close this one, and now we can simply go back to this fetching price function, because there we're going to need these functions, and it's going to be a little huge. Okay, so what we have to do is we're going to first import the packages ethers, and that's coming from, we have a required, in that we have the ethers, and now we have to use the V3 SDK to get the ABIs of the contract which we want to use to fetch the data. And these are the ABI. So first thing is ABI Uniswap V3 pool ABI, and we have installed the packages, so it's coming from the artifact, contract, interface, Uniswap, and in that we have this ABI of the contract. So if you navigate, and you can easily able to find in the node modules. Okay, so we are getting the ABI of the Uniswap V3 pool, and this is the quoter, and this quoter contract will give us the price, the output we'll get before we swap the token. Okay, so make sure to type the exact thing, pause the video and type it, and that's the ABI we have here. And now we have to get the functions which we have created, so we can do it const, and then we're going to import the function get ABI, and we have to get the pool addresses, and this is the two function we have created in price fetch, and that's what we have here. And now we have to get the RPC URL so we can connect with the Ethereum mainnet, and we have already done that. So I already have in this, so what I can do is let me bring this one, and if I go to this Hardhat, inside this I have my link. So I'm going to simply copy this URL because this is what I'm using to connect with the mainnet, and that's what I'm going to utilize it here as a RPC URL. So let's say cons, I'll say mainnet URL, and that's the URL we have. We got the URL, and now we can utilize it. So we'll say cons, we have to create the provider, and to get the provider we're going to use this new ethers.providers.jcp RC provider, and then we have to simply pass the mainnet, the URL we have here. So this is the provider we have got. Now we have to get the contract of the quoter address, and here we have to get the address of the quoter contract. So if you go to the Uniswap documentation, you will find in the addresses section all the addresses of the contract. Okay, and I have already imported that, so I will simply get that address. This is the address we have for the quoter contract of Uniswap. Whether you are on mainnet, testnet, all the network has the same address of the quoter contract. Okay, so make sure to get it. I'll provide you this address, or you can pause it and you can get it, or you can go to the Uniswap. In the documentation, you will have all the addresses of the contract, and from there you can also get it. So that's the addresses we have, and now we can start working on the function. So we'll create a function. Okay, let's say get price. It's going to be async function, and then we're going to receive the amount we want the user to be swap. Input amount. We have the input amount, and we have to pass the contract address because we have different pools, and all pools have a different price ratio. So if someone wants to do the swap on the base of the particular pool, we have to pass the pool of that. We have to pass the address of that pool. So we'll say pool address. We got that, and now we're going to take a variable. We'll say call pool contract. We have to get the contract and new ethers dot contract, and then we have to pass the data. So to get the contract, all we have to do is to pass the pool address. We have to pass the Uniswap ABI, so which we already have it, V3 ABI, and we have to pass the provider. We have to pass the provider. So this is the ABI we are using right up here. Okay, so this is the contract it will give us back, and now, so let me console log it. So we'll say pool contract. Right now it will not work because we are not logging the data. So but we're going to test it. We're just building the functionality. So we got the pool contract. Now we have to get the data. So we'll say the two token. This is the first token we have. Now we have to say await pool contract. We have the pool contract, and then we can call the token 0. This is the first contract we have replicated, and this is going to be the second token, and this will become the second token we have. Let's do the console.log so we can test this out later. So in this we're going to simply pass the, let's say token and token 1. That looks pretty fine to me. Now once we have that, we'll say const. We're going to take more data. We'll say token. Now we have to take the token ABI. So we'll say token ABI 0, first token ABI, and then we'll get it very easily. So we'll say await. We'll have get ABI. This is the function we have created, and then we have to pass the token address, and this will give us the ABI of that particular token. Same thing we have to do for the other token. So in this we have to pass 2, and this will become 1. So these are the ABI we get of both. So we have the ABI of both the token. That looks pretty fine. Once we have the ABI of both the token, now we can make a call, and we can get the contract of those tokens. So we'll say const is a TOK token contract 1. We'll say new ether dot contract, and then we have to pass the data. So we have to pass the first is the token 1 address. We have to pass the token 1 ABI, and we have to pass the provider. So this is the first token. So we replicate this one, and here we have to make a change. So we'll say 0, and this will become 0, 0. So we got the contract of both the token, and now here we can make the call. So and now we can call the data. So we'll say const. We have the token, so we'll take the token symbol. Now we have to get the data. We'll say token symbol 0 first, and we want to get the tokens. We'll say await token contract 0, and then we're going to call the symbol function. Symbol function. This will give us the symbol of the token. So replicate it, and here we have to make it 1 to change. We have the token symbols. We need one more data. We'll say const token decimal. Token dot decimals. So we replicate it, and here we have to do the changes. Token decimal 1. Hope this makes sense to all of you guys. And I made a mistake. Instead of this token address, I have to pass this. Okay, not a big deal. So we can simply copy this and replace this one, and simply from here we have to replace this one. So we got the data of both the token, and now we're going to pass these data to our quoters. And now we have to get our quoter contract to get the data. Okay, so we'll say const contract new ethers dot contract, and then we have to pass the quoter address. We have to pass the ABI quoter ABI, and we have to pass the provider. This will give us the data of the quoter. Once we have the data, once we have the quoter contract, we can simply pass it. So we'll say const immutables. In that we're going to simply say await get immutable pools, and then we have to pass the contract, pool contract, and in return we'll get the data. So we'll say const amount in. We have to convert it into utils. Dot parse unity in that. So we have to simply pass this. So we have to pass the input amount. We have to convert it to a string, and we have to pass the token decimal points. So what decimal points we want to use? So let's go with 0. So that's the things looks pretty fine to me. We have our input balance which is coming from these functions, and we're getting this pool addresses, and that's what we are passing here. It will give us the data back. So once we've done that, it will return us the data. So we have to say const out in that await. We have the code contract, and then we have to call this plastic static, and then we have to simply pass the code exact in all the code functions. So this is the exact input, and then we have to take the data immutables dot token first, immutables dot token 2, immutables dot fee, and the last one is going to be the amount in, and let's go with the 0 one. So this is the coded data. Once we have that, now we can simply take another variable because we have to convert the amount. Let's call it out, and then we're going to use this ether dot utils dot from units, and then we have to simply pass the quoter amount out, and we have to pass the token decimal 1, because that's what we're going to get as an output. Token first is the input, and token 0 is the input, and token 1 is the output. So this makes sense. Once we have that data, and we're going to return this data from here. So we'll say return, and it's going to be in a form of array. So we'll say amount out, we return the token symbol, so the first token, and that's why we have taken this, and now we can take this token second. So the second symbol. So these two data we are needed. So let's go through this one more time. We are taking the package, when we are getting the API of the pool, V3 pool. Then we are getting the API of the quoter API. Then we have these two functions which we have created in the helper page. Then we are creating the mainnet, we are creating the provider, getting the address of the quoter, now calling the get price, and then we are receiving this input and pool addresses. So with this, we are getting the first pool contract. Here we have the pool contract. With the help of this pool contract, we can getting the two token addresses, because this pool contract will have the addresses of the two token. Because every pool have two addresses. Because every pool contains two tokens. Okay. So from there we are getting the address of the tokens, and then we are simply getting the API, because we have the address, and this is the function we have created in our helper. Passing, we are getting the API in this, and here we are simply getting the contract of the two tokens. Once we get that, we are getting the data, symbols, and the decimal points, and here we are getting the quoter contract. Here we are getting the quoter contract, and then we are passing the pool contract, and this will return us the data immutable, which we are returning there, like token address and the fee. And here we have the amount, we are simply converting into a readable format, and here we have the quoted amount output. So token 1, token 2, fee, amount, and 0 index. And here we are simply converting the output amount into a readable format, and from here we are returning. So I hope this entire things makes sense. Because there's a lot of things going on. We have used different contract to get the data. Okay. So if we come here, so we are done with this helper functions, we are done with this fetch price. Now simply close this down, and now we have to work on this one function with swap update price. And in this, we're going to import a couple of packages. So let me do it very quickly. So here we have the alpha router, the router which we have created. This is the package we have installed. So if I come back to the package.json file, in that you can see this is the package we have installed, and from here we are getting the alpha router. So this is the alpha router, this is the Ethers.js package. In that we are taking this big number and ether, and here we are using the SDK code. From that we need this token, currency output, trade type, and percentage for setting up the slippage. So make sure to do this import, and here I have the V3 swap router, and we are using the contract address for V3 swap router. So this is the address. Make sure to pause the video and get it. And here I've taken the chain ID to 1 because we are connecting the mainnet. If you connect with Gorilla or any other network, they have different chain ID, so you can provide that. So but we are using this chain ID 1 as a mainnet. And here I have my provider. So this is the Ethereum RPC URL which I've got from Equity, and that's what I've pasted. So these are the basic setup we have done, and now we can start creating the data. So let's come here. Here we're going to declare a couple of variables. So we'll say cons first, we're going to take the name of the first token, and then we're going to define, let's go with the hardcode value, okay, for the time being. But later we're going to make it dynamic. So we'll say wrapped ether, we'll take a symbol of the first token, and this is going to be with. We'll take another one. This will become the decimal points. Decimal, so this will become 18. And we'll take another one. This will become the address of the token. So make sure to add this. So make sure to add this 0 because we are dealing with two tokens, so that's how you can keep differentiates. And here are the addresses I have, I guess. Let's come here. The address of the token I have into this. Go to the context, inside the context, and here I have the address of the width. I grab that one. I'm going to simply paste here. So this is the first token we have. Now we are dealing with another token which is a die. And here we have to do the changes. So this will become the, select this and turn it to 1. So we have that one. Now let's convert it to die. The symbol is going to be die, and it will have the 18 decimal points. And let's come back to the utils functions API feature, in that I have the address of the die token. So we'll grab this one, and that's what we're going to simply pass it here. So these are two tokens. Right now we have taken as a hardcode value, but later we're going to do it dynamically. So that looks pretty fine here. Now here we have to get the token data. So we'll say token, and now we have to get the token data. Cons, we'll say width, and here we're going to use this new token. And then we have to pass, the first data we're going to pass is the chain ID. The second data we have to pass is the address of the first token. The second is going to be the decimal point. We have taken that variable, and now we have to take the symbol, and at the end meaning the name. So these are the data we are taking. Simply replicate the same thing for this other token, and here we're going to say die, and this will be 1. So there we have the token, and this is the function we are using, and it's coming from the SDK token. Looks fine. Come down. Now we have to create a function export const, and then we're going to call our swap date price. So this is the function name we have given. If we come and have a look into our context, that's the exact name we have given. Let's see when we're importing that. Yeah, swap exact import. This is the name we have given. We have that now. Async function, and then we're going to receive a couple of data. So first is going to be the input amount. We need the slippage. Amount, we have the line, we have the wallet addresses. These are the data we're taking: input, slippage, deadline, and wallet address. Okay. Once we have that, now we can simply call this, and then we have to do a couple of things. So first thing, we have to take the percentage slippage. New percentage, and then we're going to simply pass the slippage amount, and this function will convert it into a percentage. So if you pass 1, it will convert that into 1%. If you pass 25, it will convert that into 25. And that's the percentage we have now. We have to take this weight, and then we're going to take the amount, we'll call it utils, and we have to simply convert that. So we'll say percentage, and then we have to simply pass the input amount to string, and we have to pass the decimal. When we have now, we have to take the currency, we'll say amount, we'll say currency dot, and then we have this method called for raw amount, and that raw amount we have to pass the width, the amount we have taken, and we have to take this big number and we have to convert it into a table format. So we'll say big number in that form and pass the way amount. That looks pretty fine. So once we have that, now we have to build up the router. So we'll say const route await, and we haven't built the router, so let's come up here, and we haven't built the router yet, so we have to build the router. So let's come here in the provider section, and here we have to build the router. So we'll say const router, and that we're going to use this new alpha router we have imported on the top, and then we're going to pass an object. So first thing we have to pass is the chain ID, and the chain we are connected with, so we are connected with the chain ID, and let's make it to this chain ID to chain ID, and we have to pass the provider. So we have the provider, we're going to pass the provider. Okay, so that looks pretty fine. This is the router we have now. So we grab this and come here, and here we have to construct that router dot route, and then we have to pass the currency amount, we have to pass the DAI, we have to pass the trade type, and then we have this function called exact input. So whatever the user is providing, I want to get that exact input, and then I have to convert it and get the price. Okay, and here I have to define the variable. So we have to define the recipient. So who is the recipient going to be? So the recipient is going to be the wallet address, and the slippage tolerance we have to define is the, let's say, percentage. The slippage tolerance we have to define is going to be percentage slippage, and deadline, that what is the deadline is going to be. The deadline is going to be deadline. So these are the three variables we have taken. Deadline and going to be deadline. So hope this makes sense to all of you guys. We are passing this data to our swap router to get the output as a alpha. So we are passing all this data so we can get the output of the token we want to show. And now once we have that, now we have to do the transaction. So we'll take a call and we'll say transaction. We have the transaction, and then we have to pass the object of data. So first thing we have to pass the date, and then we have to pass the router, and this router would be, and this would be method parameters. This one is the first, and then we're going to pass the call data. That's the one data we are passing. Now we have to pass the 2, and we have our V3 router. We have to pass the value. In that value we have to pass the big number because we want to convert it. We leave this form, and then we have to simply pass the route dot, and the method we have is this method dot params, and then we have the value. So make sure to type the exact value if you really want to have an output. We'll take the form, and the form is going to be our wallet address. We have to define the gas price. Big dot from. Inside that we have to pass the route dot gas price in way. Then we have to define the gas limit, and then we have ether dot utils dot hexify, and then we have to simply pass the amount. So we'll go with close to 60, so we can assure that we can have the transaction. So 60. So that looks pretty fine. No more problems we have till now. So things are looking good. So these are the data we're passing: data to value, and we have from, gas, and gas limit. So 3 types of data we're passing. So that's the transaction we have here. Now come down. In here, we're going to take this const. We'll take a quote. We'll take a quote amount out, and then we're going to pass this route dot quote to fix, and we have to pass the 6 decimal. Const ratio. We have to take a ratio, and this ratio will have the input amount, will have the divided by the output code output amount, and we have to simply call this to fix method, so, and define the value to 3.
And I believe that most of you are really confused that what are these functions and why we are doing this way, because these are all a part of this SDK packages, and I'm just utilizing that packages. Don't need to worry, we're going to have a detailed discussion once we build this entire project. Okay, so make sure to follow the way I'm doing it. So once we have that, now let me do this. So we have a lot of data. So first thing we're going to simply console log all the data. So we'll pass the quote, we'll pass the quote amount output, and we'll pass the ratio. So these are the data, and the data we want to return from this function. So let's return the data because we need the data. So we return, and we need the entire transaction, we need the quote amount output, and we need the ratio as well. And that's pretty much you have to do. So we are importing the three packages: alpha router, Ethers.js, and SDK code, and then we have this all functions. Then we have our V3 swap router address, we have the chain ID, we have the provider, we have the alpha router set. These are the two tokens we are just going with hard code, but we're going to change this dynamically. Okay, all you have to do is to pass the addresses. And we have the contract, and we are passing the data to the token, and it will give us the data of the tokens. And we have the entire function, and here we are passing the slippage, tolerance, router, and making the transaction, and then we are getting the output. So that looks pretty fine to me. Everything's looking good here. So we close this out, and you can see these are the two functions we have written. So we have done with this page, helper, and swap update. Things looking good to me. Close this one, and now come back to the context. And here we are in the context. You can see these are the packages we have done, and these are the functions we have imported. Now simply come here, copy this one, and simply pass this function. So we can call this function in our component. So let's come here. Let's pass this price one, and we have to simply pass this function as well. What is the other function we have? Update price. These are the two functions ready. And with this, I think we are done with this session. Hope this entire thing makes sense to all of you guys. If you still have any confusion, any doubt, don't need to be worried. Everything will make sense when we start connecting. Okay, so with that, let's move to the next video. Everyone, hope all of you are doing great. So this is where we left in the last video. We had built all the utility functions. If you haven't watched, make sure to watch that. I will link an I button in the description. And this video, we're going to simply test that. Okay, so this is where we left. We have done all the settings, all the modification in the contract, and the contract function itself. So let me open the terminal. So let me open up the terminal, and let's split it out, and let's try and deploy the contract. So we'll run our local blockchains, npx Hardhat node, and here we go to run the deploy script. And currently we are deploying only one contract, which is this single swap. That's the thing you have to keep in mind. Here we have initialized that. We have clear our artifacts, no more artifacts we have. Now we have to simply run the deploy script. So this is the script we are running. Click on enter, and the contract is getting deployed. Just wait. So compile successfully, and here we have the address of the contract, which we got it. Simply grab that one, go to the context, and then we have this single swap token and replace this one with this. And now we have to drag and drop the ABI of the contract. So this is the single swap. Simply grab that one and paste it here, move it. So that looks fine to me. And now we can start our application. So we'll type, let's say something like npm run dev, hit enter, and click on this 3000. Here we are, and here you can see the application is working fine. We got our MetaMask open, and here we can easily able to connect. So we go to connect with account 2, click on next, connect, and here we are back. Reload the browser to see things are looking fine. Yes, it is. Let's do the console log, and let's see that do we have any error. No more error we have into this. And here we can see that the balance of the WETH token and the DAI token is getting updated. If we click on this, here you can see we have all the token we have defined, and their balances are also displaying. But I want that this is the name, so I want to display the symbols, I want to display the name here. So let's fix this one, and that's we can do it very easily. Let's come here. This is the one we have here, and where we have the token list, get into the components, we have the token list. Inside that, here we add. So instead of name, what we're going to do is we'll type symbol, and here we'll type the name. Actually, I have name, and save it. If you click, now you can see we have the token symbols and we have the name, so it looks fine to me. Now that looks pretty good. And now if we click here, you can see that we have hard coded this token data, but we want to display these tokens, not these demo data. So let's fix this one. Let's come here, go back to the code, and let's close this one. And now we have to go back into the search one. Close this one. This is the search token. Get into the hero section. Into that, we have to receive the data. So right now we are receiving these data from our context, single swap token, correct wallet, account, ether, and DAI. But we need more. So close this one and come back to the context. And we need the data itself, the token data. That's what we're going to pass it here. We need the token data. We need the two functions we have created, get price and set price. And here we're going to pass the two functions. We need the swap price as well. And that's what we're going to pass it here. So that looks pretty fine. We have the data, and where else I've used this one. So here I'm also getting in the form of props, but what I will do, I'll simply remove this one. I don't want to get it as a prop. Okay. So we have the data, and that's data we are receiving here. And for the time, that data we are receiving here, and that's the data we're going to pass. And that data we are receiving here, and this data we are passing into our, let's say, search component. Here we are passing. If we save it, this might fix this issue. So come back to the browser, and if I click here, you can see right now we have all the token we have defined. No, we don't have that. So I know why it's not working. So here we have the data. We have sent the, and here we have the data. We have sent this data to our search component. Now we can get into the search component. Click on this, and here we are receiving this data, token data. That's what I have called. Yeah, token data. And instead of this coin, we're going to run this data. Simply close this one. And here we have the actual data. We're going to simply replace this and save it. If we do that, if you click, you can see here we have the data. It's working fine. And we have to do the changes here as well. So let's come here, and where we are displaying the name. So this is the name we have. So here we can display the symbols. Symbol, save it, come back to the browser, and you can see reload the browser. Reload the browser, click on this, and it's repeating twice. Okay, it's repeating twice. We can fix that easily. So let's come here, and to fix this, all you have to do is come back to the token list. We have already created the function. Come back to the token list, and you can see this is the small script we have written. Simply grab that one, and that's what we're going to call it here. So here we are receiving the data. We're going to pass that to this, and simply grab this one, copy, paste here, and this is the one we'll take it, and that's what we're going to render here. So make sure to do the changes. So once you save it, you can see the problem is gone. Now you can click, and you can see the token names are displaying. It's pretty huge. If you click on this, you can see the token names are displaying, and here we have to do the changes. So we can easily get that. So with this we are done. Actually we need a data. So we have this data. Now what I can do is, here you can see here we are sending only two data. We are sending the name and the image, but we need more data, like a symbol, we need a balance, we need the addresses. So we have all this data. We'll say define say less symbol, and the symbol we have into this symbol. We have the symbols. Now we have the other one we want to take is token balance, and then we have this token balance. Now we need the address, and that we have inside this element. So these are the data we are receiving into this token. This looks fine, and that's the only changes we have to do for the time being. That looks fine. Let me have a look. Do we need to do any changes? No, I think so. So things look good. So if we come back to the hero section, what you will find in that, and here we have to do a little bit changes in the data modeling. So we are receiving a lot of data. So we'll come here, and instead of name and image, we need more data here, because you can see here we are passing multiple data. Where it is, and we are passing symbol, token balance, and token address. So we need that. So let's grab one by one. So we'll take the symbols, come back here, and we'll say initially it's going to be empty. What else we need? We need the token balance. We need the addresses. So we got this data. Now simply grab this one and do the same thing for the other token as well. So here we have the data. Now we'll simply scroll down, and we'll find a place where we're displaying the data. So this is the first input we have, and this is the place where we're going to call the two functions we have created. So if you come here we have to display the pricing and the updated pricing, the swap they will get. So that's the function we're going to create right up here. So let's come here. Let's create the function right up here. So we'll say call output. It's going to be async function. It will take the UE value. We got the value. Here we have to define a couple of variables like a deadline, slippage, and the account address. And as we are connected with the forknet, so need to find a real address which actually has any one of these tokens. So this is the address which I have found. Later we're going to make it dynamic for the individual person who is connected with this application, but for the development purpose, I have found an account who has each of this token. Okay, so let me take a variable. So we'll say your account, and here I'm going to define the wallet address. And the address we have, if you go into the test, if you go to the test script, so when we were testing the contract, we got, if you go into the test in the liquidity sections, you can see this is the address we have taken. This is the real address on the mainnet, and this address has all of these tokens. So I'll simply grab this one, and that's the address I'm going to utilize it here. So I pasted the address, and now I have to define the deadline. So I'll take a deadline, and I'm going to go with the hardcode value right now. I'll take, say, 10 is the deadline, and I want to define the slippage. The slippage would be something like slippage. You can define whatever number you want. So I'll go with something like, let's say, 25% slippage. These are the three data we are passing, and now we're going to simply call the function. So we'll say con, and I will say data. We have the function called await. We have swap price, and in that we have to simply pass the data. So we are getting this value. So we have the value, we have the slippage, we have the deadline, we have the your account, and that's the data we are passing. Once we get the data, we have to simply set the data. So here we have to take a couple of variables. So we'll come here, go up here, and we have to set that as a variable. So here we have taken already these three data. So let's come here. We'll say use state snippet, and the first one would say something like token swap output. This will be 0, and we'll take another one. This will become the pool message. It will be a string, and we have to define a variable called search, and this will be false. So these are the three states we have taken. Now we can come here and we'll take another one. So we have to take from, and we have to take one more variable. So we'll take another one. This will become something like swap amount, and this will be initially 0. because it's going to be from the user. So user will provide it that how many ether, how many and swap amount. So they're going to provide you the amount which they want to show. These are the variables we have taken: swap output, pool message, search, and swap amount. So the user will provide you the amount that how many token they want to shop, and that's what we're going to store into this state. So that looks pretty fine. And now we can simply come here with the function we have created. So here we are, and once we get that, we're going to simply call this set token output, and that we're going to simply pass the data. So we want to take the data like the token we have. So we have the data, and then we want to take the first data. So this data will come in the form of array, and we are taking the first element into that array. So let's console log of the array. We're going to check this. So we are setting up the value. Let's find to me, and here we're going to simply call this set. We have to display our loader, okay? So we'll say set search, and then we have to turn this to false. That looks fine. That's the one function. Now here we're going to call the second function. So we'll say this contract, and it will say pool address address. Remember, this is the function we have created. So if we come back here in the utilities, you will find that this is the function we have created, fetching price. Okay, in this we have to pass the amount, and we have to pass that's what we are passing, and at the end we are returning these three data: amount, output, symbols, and the token. So hope these things make sense. Now let's come here into the functions, and here we have to provide the pool address. So if you visit Uniswap, there are multiple pools in different tokens, but the pool I'm taking is the ETH, the ETH, and the DAI. Right now we are going with the face value, but we'll make it dynamic. So here we have to provide the address of the pool. So I have already done that pool address. I will simply paste here. Just follow along with me. Everything will make sense. And we'll take another one variable. We'll say pool DAT data. In that we're going to call this await get price function. In that we have to pass the value we are getting from the user, and we have to pass the pool address. So once we have that, now we're going to simply construct the message. So here we can say message, and the message will be something like take a template literal, and then we'll take this $sign. We'll take the value the user is providing value, and here we have to display the pool. So we have to take the pool data which has all the data. So let's make it capital. This looks better. And this also become a capital. Pool data, we have the pool data, and we want to take a element number 2 because it will come in the form of array. Remember, we are passing 2, and we have to take the element number 2. So the price, and here we want to display the other one is going to be something like let's come here, and here we have to take another data. So we'll have this pool DAT data. In that we have to take the second, so we have to take the first element and the one, and that's going to be our message, the message we want to display. So once we have that, now all we have to do is simply set the message, set the pool message, and then we're going to simply pass the message. So that's the entire function. Hope this entire things make sense to all of you. If it's still confusing, everything will make sense. Just wait and follow along with me. And now we have to simply call out this function. So the function we're going to call right up here. Where is the first input we have? Here we're going to call the functions. So here we're going to use this on change, in that we're going to define the E, and here we're going to call all the functions. Because take this bracket because we want to call multiple functions. So first thing we're going to call this call, and then we have to pass the value. So we'll pass this e.target.value. So this is the first function we have. Now we have to take the second one. We have to set the amount, swap amount. So the variables we have taken here. So if you come here, this is the amount we have taken. So this is swap amount. So we copy that, and that's what we have to set here. So where it is? Okay, here we are. So we come here and simply pass that. So e.target.value. We got that. 2 functions. And now we have to simply open the search. Because we have to show our loader. So we'll set search to true. And that looks pretty good. That's the one change you have to do. And here we are displaying the balance. So that looks fine. And here we have to do the change. So here instead of displaying the name, we have to display the symbols. So we have the symbols, and do the same thing for the other one as well. So simply grab that one, and here we have to display the symbols. And here we're going to display the price, and here we have to display the actual balance. So we'll call this token balance 1. Copy that and do the same thing from here as well. So where is the second token balance we have? Here we are displaying the DAI. Paste here, and this will become 2. Remove this comma. Because refactoring is the most difficult thing. When you do refactoring, that takes a lot of work, because you have to know every single variables, and you have to find every single place where we want to do the changes. So that's the changes we have done, and now we have to display the data. So this is the first input field we have, where we are getting the data, and here we have the second input field, and here we want to make it a little bit dynamic. So what I'm going to do into the second input field, so we're going to simply comment this, and in here I'm going to display the output, the token output the user will get. So in that I will take a p tag, and inside the p tag I'm going to take a dynamic tag, and it will say search if. Then we want to display this. So in that we're going to display the image. So simply come here. We have to grab the image, the loading image we want to take. Simply copy, and that's what I'm going to simply paste here. And the ratio I want to make it something like 100:40, so a little small, and this will call loading. Else we want to display the message, else we have to display the output price. So we'll say token swap output, which we are getting. So if you come here, we're getting from here, we are assigning to this, where it is, we're assigning to this, and then we are displaying to our component. So that looks pretty fine. So that's our dynamic block, and let's save it out. And I believe that I don't have the images, so what I can do, I can simply come here, replace this one, and here I have to get the images. So let me get that quickly. So I'll come here, close this component, go into my assets folder. So here I have this loading image. That's what I'm going to do. So let's come here, let me quickly import it. So I'll say import loading, and that's coming from loading. That's a zip, and that's what I have to simply export it. This looks fine to me. Now I can come here, and here I can use this loading. This looks pretty good. So this is the changes we have done here, and we need to display this function price, or the pool price. So where it is, there are so many codes we have written. So we are done with this swap output, and we are getting these functions, and we are getting the data and displaying. Now we have to, the data we are getting from here, like the message we have built, this one we have to display, and that's we can display right up here. So simply scroll all the way down to account section here, and here we're going to take a dynamic block. We'll say search if, and then we're going to display our loader. So the loader we have already built. So simply grab this one. Simply grab this entire component. Copy this entire component, and that's what we're going to simply replace here. So that's the component we have, search component. But instead of displaying this data, we want to display the pool message. Pool message. And this looks fine. This looks fine. Okay, so I believe you have done all these changes. So we have this import, we have our token, this is the context, we have these are the three variables we have taken, and this is the pool message. We have simply grab that one, and that's what I'm displaying here. Not pool data, we have to display pool message. So this looks fine. This is the swap amount we have to pass, and this amount we're going to pass. Can you guess where we have to pass this amount? So where we are calling the swap function. So the function we are calling right up here. In this we have to pass the amount, and in this we have to pass the address of the token, and we have to pass the amount. So if you come to the constructor, as I told you that this is how we're going to construct the data of the address, and let's pass it here. So if we come here, and here we have to pass, so all the data we have inside this, all the data we have in this tokens, token 1, token 2, and token 1. So this entire data we're going to send, and we're going to access this data. So let's come here, and where it is, so okay, here it is. And this we're going to take an object, and we'll say token 1, and this will become token 1. We'll take a token 2, and this will become token 2, and here we have to set the swap amount, and that's it. That looks pretty fine to me. Let's come back to the applications and reload the browser. Let's see, have a look. Do we have any error? Okay, so objects are not a valid React child. So I was stuck for half an hour and tried to find out the problem we are having in the code, and this is the very simple mistake I had done. So let me show you what I have done. So make sure to change this to number. Okay, this input was text, I changed this to number, and here you are calling, so and here we are calling this value. So earlier what I did, I wrapped this entire data into this bracket, and when I saved it, I was getting that error. This is the error. So make sure to do these changes here, remove this bracket, put the value directly, and do the same thing for here, the pool message, and that's the only change you have to do. Simply save it, come back to the browser, and we have no more error. So let's refresh the browser, and let's try to have a look. So things looking good. Let's do the clear your MetaMask, otherwise it will throw an error message. So I'll click here, I'll go to the settings, and from here I can go to the advanced, click on, and simply reload the browser. So this looks pretty fine. If you click here, you can easily able to find the balances we have. We have the DAI token, and the other tokens are into 0. So it's also looking fine. And if I try, let's do the console log, and let's try to see what data we get in return. And just wait, the data is coming. It's loading. Okay, so we have problem in our swap update price, and maybe we have installed the wrong package. And I was stuck for a while to find out the problem, and this is what I have found, that we need other package, different package version. So let's quickly uninstall this and reinstall the version we need. Uninstall this one. Simply clear terminal, and this is the version we have to install. So 2.5.30, and install this one. Hit enter. And one thing you have to keep in mind, that version is very important. You have to install the exact version if you really want to things work. So make sure to use the exact version which we are using in this project if you really want your code to be working. No matter what time you are building this project, whether you are building after 2 years of publish, make sure to use the exact version. Here the package got installed. Let me clear the terminal, and now we can have a look. So things are looking pretty good to me. No more problem we have into this, and now we can test this out. So let's come back to the applications, and here we are. Now we can see this is how it will look. Simply reload the browser, I don't know why my stylings got disturbed. Let's make it full screen. And here everything's working fine. So something what happened that when you uninstall any packages, some major changes take place into your code. So in that scenario, it's always better that you should restart the application and everything will be working fine. So here you can see our code is working fine. We have no more error in the browser. And now we can test this out. So if we come here, you can see no more error we have. And we're using this version of packages. Now simply close this one. And this function is really good to me. And this is the swap token. Simply close all of this. Because now it's time to test whatever we have written so long. So let's come here in the browser and let's try to type. So if we type 2, it's loading and we'll get an output. So let me do the inspect element. So see if we get an error. And just a moment. Still it's loading because we are fetching. And here you can see we got an array. This is the data we got. This is the two data we have console logout. And this is an object we have got. The price of the pool. You can see this is the price of the pool we have got. That's what we have defined. Everything's working fine. Everything's working fine. You can see everything's working fine. So everything was working fine. So if you come back to the code, go to the utility sections, into this fetch pricing, and that's what we are passing this 3 data. And that's what we are getting here. That's what we are getting here. The 3 data in the form of array. And here we are getting the data from our 2 utility functions. So the first function we have is swap output price. So if you provide 2 ether, you will get this much output of DAI. And here we are getting this liquidity pool. So if you provide 2 with, you will get this much of DAI token. So everything's working fine. You can see we are displaying all the data right up here. That looks fine. What I can do, if I reload, you can type any number. So we all know that 1 ether is equal to 1300 something DAI token. So if I type like something 1, if I type 1, you will see this data is dynamic based on the value which you provide. So this is the DAI token we'll get in return. And just wait, the pool data is also coming fine. So this is our pool data. We got it. So I want to swap token from with to DAI. Let's click on DAI. And don't need to worry about this pricing. Actually, we are using this one because the address of the coin which we have into our MetaMask, which we get from the Hardhat, and this is both same. But we are taking the instead of this and then we are doing the swap of this DAI. And now I want to swap like 2. It's loading. Actually, I want to adjust this loader right in the center. I'll do it very quickly. Just wait. Let's see the output, what we get. And here we get the expected output we get in 2 ether. This much DAI we'll receive. Let's have a look of the other DAI pools data. And just wait, it's taking a little bit of time. Now here we have it. So if we click on the swap, here we have the MetaMask popped up and we can simply do the swap of the token. So right now we are sending this 2 ether. We can click on this confirm. And here you can see the modification we have done, it's also working fine to a smart contract. So this is the confirmation. We are allowing our smart contract to spend the ether on behalf of us. And here we have the last confirmation we have to do. And just wait, let's click on confirm. And the transaction went through. Just wait, let me open the console and you will see the updated price. So here you can see it came in the big form of big number and transaction.wait is not a function. Okay, somehow the transaction failed. The error we got. Now let's reload the browser and let's see. Do we have the transaction failed? Click on this with, we have the, let's see, on the DAI token, and the transaction actually went successful. Transaction went successful. If we come back to the code, the transaction went successful. So all the things are working fine. Let's come back here, go to this swap context, and here we got an error message. So it says the transaction, okay, this is the entire log we are displaying, but the transaction went successful. Why it was showing that? Let's do the one more time. What I wanted, let's click on the with, click on the other token, it's DAI, and let's do the swap. If we want to have an output of 2 DAI, let's see how much we get. An output. And you can see this is the output we get in terms of DAI. All the data is updating. Just wait and let's have the other data. So here we got the data, 2 DAI, 2 WETH equal to ether DAI. And now we can click on swap token. You can see this is the amount we have passed. Now just wait, to ether, click on confirm. Here we have the another one. Now we have to simply confirm this, allow our Uniswap contract to take our token. Now we have to click on this. The last one is this one. Now click on this confirm. And here you can see the transaction, it's happening. Here it says the transaction.wait is not a function. Okay, I made a spelling mistake here. It's WITH, wait, it's not A. And that's why we are getting an error. So if I come here, it's wait. WAIT, wait. Okay, I believe that you guys have noticed that. Now let's have a look one more time. Okay, no. So click on this and let's do the transaction one more time. You can see the transaction went through. And this is how the development works, buddy. If you feel that we are making a lot of mistakes, but that's not a big deal. This is how you develop. So you can see we got this much DAI. Now if we want, I can simply type 1 and I'll get the output. Just wait. It's loading. And here we get the output we get. This is the addresses we got it from fetch pricing of the 2 contract. and this is the output we get. Now we can click on the swap, and here we have the MetaMask. Let's do the transaction. Let's confirm it. Let's click on confirm. Here we have the MetaMask. Simply click on confirm, and the transaction went successful. You can see here we got the transaction log, the balance of the DAI token, and this is the transaction, the successful transaction. You can easily able to test on a, if you're doing on a test network, you can easily able to find this on a Etherscan. So this looks pretty fine. If you reload the browser, you can able to find the DAI token here. Let's make on full screen. You can see this data is also getting updated. Okay, this will take a little bit of time. You can see this is the data we updated, and now we want to do the swap between the, let's say, Matty to WETH. Okay, so what I can do, I can simply select this, not Matty, I will select this WETH, and let's check and do this time Matty. Click on this too. This will update the pricing, and it will give us that how much Matty coin will get back in return. This much Matty coin will get back. Now, if we want to swap, all we have to do is to click on this swap. Here we have the MetaMask popped up. Click on this. Here we are confirming the deposit. Click on this confirm. Here we have to click on this approve. So sometimes MetaMask will pop up, sometimes it will not. So make sure to always click. You can see right now I have to confirm it manually. So click on confirm, and the transaction is happening behind the scene. So just wait. Here the swaps got completed. No more error, we got it. So let's have a look in the console. Everything's looking fine. This is the entire object we get for the transaction. That looks pretty awesome to me. And if we come here, if we try to reload the browser, we're going to change this behavior from reloading every time. We're going to fix that. If you click on this, and here you can see I got this Matty coin. But you have noticed one thing. Here you have 2872 Matty coin, but the output we got was close to 25 something. Because, and that happened because we have fixed the addresses of the two tokens. So if I come here, if you come here into the contract, if you go into the swap utilities, here you will find that here we are hard coding the address of the two token. This is the WETH and this is the DAI token. So the pricing, the output pricing we're getting, it's getting you. So the output pricing you are getting between these two tokens. So it's very easy. I believe that you guys can do this very easily. All you have to do to pass the token. So right now we have swapped between WETH to Ether. All you have to do is to take that address and pass into these functions. So right now here we are receiving this through data. All you have to do is to receive these token addresses, and it will work in the same way. Okay. So for the time being, I just leave it like this. But later we're going to change this at the end. So this one is also working fine. Now let's do the final test. Let's do the final test because I really like it. You can see we have this DAI coin. Now if I come here, reload the browser, everything's working fine. This time I want to have some, if I come here, if I want to take this WETH, and if I want to transfer, so right now I have this, and if I want to get them other coins, so if I want to get this FTX, right now I have 0 into this. If I pass 2, it will give me the FTX. So here you can see it's getting the price, and just wait, it's taking a little bit of time. And here we are. If we click on this swap, you can see we got the MetaMask. Now we can click on confirm. We can click on this. We can have to approve it, and here we have to approve it one more time. Here the transaction is pending. It's happening, and just wait. It's depositing, and the transaction went successful. If you reload the browser and if you have a look, the FTX coin. So if you click on this FTX, you can see how much FTX you have. You have this much FTX. If you click on this data is also get updated. This much FTX. So everything's working fine. Everything's working fine. So you can get any token with the help of ETH, and that's what we have defined in the contract. So that's looking fine to me. Close this one. And if we come to the context, here we have done all the important modification into the contract. That looks absolutely wonderful for me. Okay. So hope this makes sense to all of you guys. And we have to do a little bit more modification into these functions to make it 100% industry ready, okay? But for the time being, that's the only thing I want to cover in this video. Hope you guys have understood everything. And now from the next video, we can start working on the liquidity section. So we're going to use V3 SDK. We're going to upload all the smart contract of Uniswap. We're not going to use the existing Uniswap smart contract, which is already uploaded into mainnet. What we're going to do is, so what I'm going to do, I'm going to import all the contract of the Uniswap V3, and that's what we're going to deploy locally. So we'll have enough Ether for the testing. So we're going to deploy the entire Uniswap contract locally, and then we're going to build the entire function around that. So once we'll have the entire function ready, then we can move to the mainnet, testnet, wherever you want. Okay. So we're going to do it locally, and at the end we're going to move with this. I'm ending this video. Hope you guys have found this video valuable. If you still have any confusion, any doubt, do leave in the comment section. Rewatch the video. The code is provided to you. If you get any error, make sure to follow the exact NPM packages. Visit the GitHub repo, get the code, and try to compare your code. You can see everything is working fine here in this contract. With that, let's move to the next video. Hi everyone, hope all of you are doing great. So this is where we left in the last video, and this video is going to be very crucial because in this video we're going to do a little bit modification in our NPM packages. What I have found when I was testing the code which I have written, I encounter a lot of error, and the packages we are using right here, we need to reinstall couple of things and we're going to uninstall couple of things from this packages. So make sure you have to do this, all the changes which I'm going to do in this video, if you really want that your smart contract, your liquidity, if you really want to work. Okay, so here we're going to uninstall couple of things and we're going to reinstall couple of things. So let's have a look one more time what we have done here so far. So these are the components which we have already built, and if we come back to the contracts, we have this contract, we have this interface, and in this I'm going to include 3 more tokens just for testing purpose. So I'm going to add 3 more tokens into this, and if we come to the utils, in that we have built this all 4 functions in the previous video. So I believe that you have followed that, and we have connected with our front end and fetching all the data. So make sure we have done a lot of things into this project. Make sure to follow that, and then you should continue and do the major changes which we are about to do in this video. So the first thing we have to do is, right now I'm going to uninstall this, because the SDK I'm using, it's in the previous version, and this Hardhat Nomic Foundations toolbox is in the updated version, and when I was using that SDK it was giving me an error. So I thought to go in the old version of that. So I'm going to simply select this, I'm going to copy that, and I'm going to open my terminal. I'm going to uninstall this clearly. So I have to uninstall this, and I have to uninstall this Hardhat version as well. So I will simply clear my terminal. I'm going to install old Hardhat version. So let's uninstall this one. So right now we have this. Let me make my side by sides. So this is the packages, this is the complete project, and in this we're going to install all of these packages, the updated one. So let's compare it out. So what version we have? So we have this opens up smart contract, and this is the version we are using here. It looks fine. Now we have to install this. So make sure you have to install the exact version, otherwise you will get an error. And I was stuck for a long to find out that what's the problem I'm having in the code. So make sure to install the exact version. No matter when you are building this project, you have to use the exact version. And this is the one more package we have to install. Simply copy that, and this one we're going to install it. So here we have installed the packages. Simply comment, remove that, and now we're going to uninstall this. Paste 2.0.3 Hardhat waffle. So this is also installs, and now we are using this smart router or smart order router. So it has this version, the same version we have Uniswap V3. This is 1.4.3, and this is one is the old one. So I have to uninstall this package, and I have to get the old one, because the ABI we will upload, and that will get an error if we use this package. So don't need to worry, just uninstall and reinstall the packages which I'm doing. So here we have installed. Simply clear your terminal, and now we have to install the version. So what we have installed right now, this version. So simply select this one, and we have to uninstall this. And we have to install this version. Simply grab this one, copy, it's gone. Now we have to reinstall this version. Now we have to install the SDK, exact version we have to install. We have this access already. We have to get this big number JS. Clear your terminal. paste that, and now we have to, so we have this one, and now we have to install Ethereum waffle, and our Ethereum waffle, we have to install the Hardhat, this version 2.11.2. This looks fine to me. And here we have installed the Hardhat. Let me bring the terminal down and let's compare it. So we have this one Hardhat waffle, we have the contract exact version, we have smart order router, we have this version, periphery exact version, we have V3 SDK, okay, and we have XCS, we have big number.js, this version, we have the Ethereum waffle, this Ethers, Hardhat exact version, we have Next, React DOM and Web3 model. So make sure you have to install the exact version. Whatever version we have installed, you have to use the exact packages. And these are the major changes you have to do in your NPM packages. Okay, that looks pretty good. Now simply close this one, come here, and now we have to do the changes in our Hardhat config file. So right now you can see these are the configuration we have done. So this is the Solidity compiler version, this is the network. And what I will do, I will simply select all this and I'm going to comment this out. And this is the configuration you have to create here. So this is the exact configuration you have to paste here. So these are the exact configuration you have to do. So you have to use this Nomic lab Hardhat waffle. This is the Solidity compiler version and this is the network. So we are using forking network and this is the account private key you have to add. So I'll tell you that from where you will get it. And this is coming from Hardhat, okay? So these are the configuration you have to do in the Hardhat config file. Let's come here. And let's see the Next.js. Here we don't need to do any configuration. That looks perfect. Close this one. And what I will do now, let's come back to the contract. And here we have written already couple of contracts. So if you come to the liquidity section, here you will find that some of these packages are coming from the latest version. So whatever installation we have done right now in our NPM packages, if we try to execute this smart contract, it's going to throw a lot of error. And ultimately we're not going to use this smart contract because we're going to use V3 SDK for providing liquidity into our applications. We're not going to use the smart contract. So it's better that you should select all this and simply comment this one, because if you leave it like it, it will throw you a compiler error. Because I was encountered this error and I wasted a lot of time to find out that what is the problem exactly I'm having into the code, and I came across that these are the packages which is coming from the Uniswap V3 periphery. It's the latest one, but in the old version they don't have this one and you will get a lot of error. So make sure you have to comment this one because we're going to use V3 SDK for providing liquidity. And if you come to the other smart contract, you don't need to do any changes here because they all are look good to me. And this is the MultiHop. So right now we have work on the single hop smart contract. So you can swap any token from Ether to DAI or Ether to MATI or Ether to FTX. So this is the single hop. So this is the multiple hop. So this is the one contract we're going to include. We allow user to hop multiple token, not from only ETH to other token. We'll allow multiple token hop. So this is the contract we're going to attach at the end because it's also working fine and we have already tested this. So that looks fine to me. Come here, and here we have to create 3 more tokens. So we already have this 2 token, ERC20 Boo, ERC20 Live. So let's create 2 more token. So I'll come here and I'm going to create a pop-up.sol. This is the name I'm going to give to my first contract, first token. Let's create another one, RAYYAN.sol. This is the second token we have. Let's create the last one, SHOAIB, So let me quickly create the token. So come to the pop, and here I'm going to simply paste this because we have already created this token. So you can see this is the configuration so this is the configuration we are doing, license identifier and Solidity version, and we are using this packages, OpenJeplin packages, and here we are initializing our contract for creating the token. So this is nothing new to you, all of you guys. I have given the name and I have given this pop, and I'm simply calling this main functions. So let me select this one and let's come back to the Rayan token, and that's what I'm going to paste here. And here I have to do the changes. Simply select this, double tap and change Rayan, and this will say RAY, the symbol. So this is our second Rayan token. Now simply close this one and simply select this one all again, and we have to come here in the Schwab, simply paste here, simply change the contract name Schwab, and this will say SHO Schwab. So you can call whatever you want. So make sure you have to create these 3 token, because we're going to create multiple liquidity, multiple token to swap. Okay, so these are the contracts we have, and now we are done with the contract sections. Simply close this one and come back to the script, and here we're going to create 5 script. One for deploying the Uniswap smart contract, the second one is for creating the token, the third one is for creating pool, and the fourth one is for adding liquidity, and the last one is going to be checking our liquidity. So these are the 5 script we're going to create, and this is going to be the huge one. Okay, so let's create the very first script, which is our, I'll call it, come here, click on this, and we have to call Uniswap contract.js. In this we're going to write, in this we're going to build a script to redeploy the entire Uniswap contract, because we're going to test the entire system, the liquidity, the swap token. We are building the system to test locally. So once we test locally, we can deploy the same contract, the same script into any test network, and it will work in the same way. Okay, so this is the first script we have, Uniswap contract.js. Now we have to create the second one, deploy token.js. This will deploy the token. Close this one. Have is deploy pool.js. Now we have to create the fourth one. The fourth one we have is the add liquidity. This is the fourth script. And the last one we have is check liquidity. Check liquidity.js. So these are the 5 scripts which we have to write. So first we'll start with the Uniswap contract, because each one of these script is dependent on the addresses. So first we have to deploy this, then we have to deploy the token, and in the pool section we need the address of the token and the smart contract of Uniswap to create a pool. After we're done with that, we'll move to the liquidity, and that we're going to create liquidity, and at the final we're going to check liquidity. So that's the script we have created. Hope these things make sense to all of you guys, and I'll simply close that, and now we can start working on the very first script, which is a Uniswap contract. So we have created all the file, and we need one more things. So what I will do, I have already taken this ABI. So this is the ABI which I have into this, and we need this ABI as well. So with 9, simply drag and drop into your context. So this is the ABI which I have found on internet. It's a simple ERC20 ABI, and that's what we're going to utilize it for making the function call. So I'll provide you in the starter file or in the final code, so you can visit to the GitHub repo, or you can visit to the article, and that you will find all these codes, and we're going to utilize this. So simply close this one, and that's the only thing we have to do right now. We are done with this context setup. We are done with our script. Okay, so that looks pretty fine, and now we can start writing the script for our Uniswap contract. And now we have to import couple of packages from Ethers.js. So we'll take a const, and we're going to import contract factory, utils, and big number, and that's coming from Ethers. Now we have to import the API, with 9 API, which we have taken into our context. So let's import that, with 9 required, that's coming from context, with 9 API. So these are the 2 imports we have. Now let's come here, and now we're going to import the API of the Uniswap contract, which is deployed on the mainnet. So we have already installed those packages. In those packages we have the APIs and the artifacts, and that's what we're going to import. So let me write it first, and then I will show you that from where we are getting this file. So we'll take a variable called artifact. In that we're going to take this Uniswap V3 factory. All the network, whether it's mainnet or testnet, they have the same addresses and the same APIs of the contract. So let's import that. We'll say required, and it's coming from Uniswap V3 core. Inside that we have the artifact folder. Inside the artifact folder we have this contract Uniswap V3 factory dot sold. So this is the smart contract, and this is the Uniswap V3 factory JSON. So this is the first import of our Uniswap V3 factory. Let's come here. Let's take the another one, swap router, and it's coming from Uniswap V3 periphery artifacts contract. We have the swap router.sol and we have the JSON, the ABI. Then we have to take the NFT description. We also have the ABI of this NFT descriptor in the NPM package. So let's import that descriptor. Require Uniswap V3 periphery artifact contract library NFT descriptions, and in that we have that one, NFT description.js. So these are the ABIs we have imported. Now let's come down. We have to import one more, non-fungible token position descriptor. And this one is a very important smart contract which allows us to create the liquidity and hold the position. So let's import that. Required Uniswap V3 periphery artifact. Inside the contract we have this non-fungible token position descriptor, and we have the contract and we have the JSON API. So we have our non-fungible token position descriptor, and now we have to import the non-fungible position manager. We have this coming from periphery artifact contract non-fungible position manager and the JSON file we have. That looks pretty fine to me. And now we have to take the ABI which we have imported with9. So this is our artifact. And now let me show you from where we are getting this. So we have these packages. Now if you come to the node modules, inside the node modules we have to get into the V3 core for this Uniswap V3 factory. So if we go to the Uniswap, let's find out the Uniswap. Here we have the Uniswap. Inside the Uniswap we have this V3 core. V3 core. Click on this. Inside that you will have this artifact. And this is the artifact. Inside the artifact we have the contract. So you can see this is the contract we have. Inside the contract we are getting this v3.sol. So if you click on this, inside that we have this JSON file, and this is what we are importing because this is the deployed ABI of the contract, and that's how we are getting. So you will find all the packages which we have installed right in the NPM package of Uniswap. Okay, so if you get any error in the typing, make sure to check the spelling and check the right folder and file structure which we have followed here. So I believe that you guys have understood from where we are getting all of this. So let's start writing the code. Now we're going to take a variable we'll call link library. Inside that we're going to receive the bytecode, and we'll receive the link reference, and we'll receive the library. And this functions I found in the Uniswap documentations, but this function was in the TypeScript, so I converted into a JavaScript. So let's work on this. So we'll take an object.key. Inside that we'll take this link reference and we'll call this for each. In that we're going to pass the file name, and we're going to simply call object.key. In that we're going to call the link reference, file name, for each, contract name, and inside that we're going to take this if statement. We'll say if library has own property, then we're going to pass this contract name. After that we're going to take this throw error message. If we don't have that, we'll say missing link library name, and we'll pass this contract name. Okay, if you still have any confusion, don't need to worry. It's just a simple library which allows us to give the bytecode of the contract, and the bytecode we're going to utilize it to deploy the contract locally. So just write. If it's not make sense, just write along with me. We'll come here, we're going to take this, and now we're going to create a variable called address. We'll take this utils. Inside that we're going to call this get address, and we have to pass the library and contract name. Inside that we're going to take this, call this to lowercase, then we'll call this slice to, we'll call the library reference. In that we're going to pass the file name and the contract name, and we're going to run a for each, and we'll give the start and the length data. So we'll take a variable, we'll say start2, and we'll say 2 plus 2 start multiply by 2. Again, I'm telling you that I'm not coming up with this. This is all there in the documentation, but it was in the TypeScript, so I converted into a JavaScript variable. Now we take another variable. We'll say const length 2, and we have to take this length multiply by 2. This will give us the length. Now let's come here. We're going to take a bytecode, and that's bytecode. We have that bytecode. We'll say slice, and we have to get the starting, and we have to provide the length concat, and we're going to pass the address. And we'll come here, we're going to take concat, and we're going to pass the bytecode, and we're going to slice it down from to start and length, and then we provide the length of the bytecode. Hope this makes sense to all of you. Close all this Now let's come here. We're going to simply return the bytecode from this entire functions. I hope this entire function makes sense. What we are doing, we're going to pass the bytecode, link reference, and the library. It's going to return the bytecode, and the bytecode we're going to use to deploy the contract locally. Okay, it's just a simple library. So hope this makes sense. Writing the codes for, we'll take a async function. This will say main, and this is the function we're going to initialize to get the data. So we'll say const, in that we're going to take this honor, and this honor is coming from ether.get signer. So the first contract, so the first address of the Hardhat, it becomes the honor. We're going to take this with, and we're going to call the contract factory, and in that we have to pass the artifact. Inside the artifact we have this veth9 ABI. We're going to pass it, and we have to pass the artifact of veth9 bytecode. Inside that we have the bytecode, and we have to pass the honor, and this will give us the contract. Hope this makes sense. Now take another one. We'll say with.deployed, and in that we're going to take this factory. We'll call this new factory, and here we have to get the factory contract. So we have already imported the ABI, so V3 factory ABI, and here we have to provide the artifacts, which is a bytecode. We'll pass the bytecode, and now we have to pass the honor. Okay, so this is the factory contract, we got it. Now come down, and we have to create the factory, and then we have to simply deploy this contract, because we have the ABI, we have the honor, we have the bytecode, and we are deploying this factory contract one more time locally. So we have to call this deploy function. So the factory is got deployed. Now we have to click this swap router. So we already have the swap router contract, and that's what we're going to deploy it now. First we'll get the contract, and then we'll deploy it. So it's pretty simple. Follow the same thing. Contract factory, and we have to pass the artifacts ABI, swap router ABI, and we have to pass the bytecode, and we have to pass the honor. This looks pretty fine to me. Close this one, come down. We're going to take this swap router, and we're going to simply deploy this one, swap.deployed. And that we're going to simply pass the factory.address with address, because this swap router needs two things. It needs the factory, and it needs the ether address with address. So that's the two data we have to pass into this to make our swap router work. So it's got deployed. Now let's come here. We'll take this NFT descriptor, and we're going to call the contract. So we'll say contract factory, and we have to pass the ABI, which is inside this NFT descriptor.abi, and we have to pass the simple bytecode, and we have to pass the honor. So this is the NFT descriptor, and we have to simply deploy it. We'll say NFT descriptor, we'll await NFT descriptor.deployed. We have deployed our NFT descriptor. We'll come down, and here we're going to take a variable, say link library. So the library we have created on the top, we're going to call this library, and in that we're going to pass the data, and it will return us the bytecode. So we'll say link by code. Here we're going to call link library. Inside the function we have to take an object, and it's good. We'll say bytecode, and the bytecode we have inside the artifact. We'll say non-fungible position descriptor, and we have the bytecode. So this is the first. Let's come here, take another one, link reference, and it's going to be an object. So inside that we'll take this name, NFT descriptor, because you can see in the library we are looking for the file name. So that's why we have to give the name of the file. And here we're going to provide the data. So we'll provide the NFT descriptor. It's going to be an array, and in that we're going to pass the starting array of object, and in that we have to pass the, let's say, length 20, and we have to pass the start is going to be 1261. And in the old version we have used, in that this is the recommended method which you have to follow to get the bytecode, but in the new package this is not recommended. Okay, but we are using the old package, that's why we are defining the length and the start time. So that looks fine to me. Simply close this one, come here, and we have to take a, and in this we have to pass the simply the library. So we'll say NFT descriptor, in that we pass the NFT descriptor, and we have to pass the address, and close it. So I believe that it makes sense to all of you. We are getting the honor, we are getting the contract factory of veth9, when we are deploying that, then we are getting the factory contract, deploying that, then we are getting the swap router, and we are deploying that, and it's need the factory address and the veth, And here we have the NFT descriptor, and this is the link library, and that's what we are passing here. So you can see this is the bytecode we have taken, and it's coming from non-fungible position manager byte. So you can find here inside this we have taken in position descriptor or position manager. In that we have the JSON, and inside this we have the API, and that's what we are utilizing it. So hope these things make sense to all of you. Still, if you have any confusion, just follow along with me. Everything will make sense. Come here, take another one. We'll say non-fungible token position descriptor, and that we're going to call this new, and we have to get the contract. So we have to pass the ABI, which is we have inside the artifact position descriptor ABI, and we have to pass the link bytecode, because this is the only contract which needs the bytecode, and we have already have the bytecode which we have generated into with the help of the library, and that's what we have to pass inside this. So link bytecode, and we have to pass the order. So that looks pretty fine, and now we have to simply deploy the contract. We'll say non-fungible position descriptor, and we're going to call this await non-fungible position descriptor and dot deployed, and inside that we have to pass the WETH address, and we have to just simply close that. And to see everything is working fine, let's simply console log this. We'll log this one non-fungible position descriptor. That looks fine. Let's come down. We're going to take this non-fungible position manager, and we have to get the contract this also. So many contract we are using for Uniswap, redeploying into our localhost, and we can test it. So we have to pass the data, we have to pass the artifact. Inside that we have this manager.bytecode, and we have to pass the order. So that looks pretty fine. Let's come here, we'll take this deployed, and we have to deploy this position manager contract. We'll call deployed. Inside that we have to pass the factory address, and we have to pass the WETH address, and we have to pass the non-fungible token position descriptor and their address, and close this out. You can see that whatever contract we are utilizing, all the Uniswap contract, they are dependent on one another. Okay, so order is very important. The order we have followed, make sure to follow the same order if you really want that your code should work. So order is very important. So that looks fine. And now what I'm going to do, I'm going to simply console log out all the addresses we will get of this contract when we deploy that, because those addresses we need in the other scripts. So let's simply create the script for that. So we'll say console.log, we'll say WETH address, and here we're going to pass the WETH address. Now we have to do the console log, and here we're going to take this factory address, which is coming from factory address, and then take this console.log, we have this swap router address, and it's coming from the swap router address, and it's coming from another one. We'll have this non descriptor address, and it's coming for NFT descriptor dot address. Then we'll take another one, we'll have the our position descriptor address, and this is coming from non-fungible token position descriptor address. Close this one. Now let's take the another one. We'll have this we have the position manager descript address, and it's coming from non-fungible position manager, and we have the address. So all the contract which we are deploying, we have the data of the deployed contract in each of these variables which we have defined above, like swap router, NFT descriptor. In that we have the data, and from that we are accessing the address. I believe that this is nothing new to all of you, okay? Because so far you guys have deployed so many contract, in this project. So we have all the addresses. Come here, we're going to create the script. So this is the script which you have to run for deploying this contract. So let me type this npm hardhat run, and we're going to deploy this to the local network. So we'll type local network localhost, and here we have to go into the script folder. Inside the script we have this Uniswap contract.js, and this is the script we have to run in the terminal to deploy this script into our localhost. Okay, and I'm giving this comment so you guys can take the reference. And here we're going to build the main function, because we have created the function and now we have to call the functions. So we'll say main. Inside that we're going to take this then and process.exist, because once the script is get deployed, I want to stop the execution. I don't want to continue. So let's exit that, and we'll say catch error. If anything goes wrong, we have to catch that. And here we're going to pass the error message and process.exist1. So that looks pretty fine. Hope this entire thing makes sense to all of you guys. So this looks pretty good to me, and that looks pretty fine here. No more problems we have in the code. So we have written so many codes. So these are the imports we have done. We have the artifacts, we have the link libraries, we have this function we have created. Now we have the main function. Inside that we have this contracts, all the contracts we have created. This is the library bytecode, this is the non-fungible position descriptor, and here we are consolely logging the address of the deployed contract, and this is the script we have written. So it looks absolutely fine. Now we can deploy this contract, the script we have written. Open up your terminal and make sure to split your terminal. And here what I'm going to do before I'm going to deploy, I have this. So let's initialize our local blockchain. So we'll type npx hardhat and we'll say simply node. This will initialize the local blockchain into our terminal so we can test our contract look. And you can see that the sound is in the background because I am having constructor right in my apartment, so there is a lot of noise. So that looks pretty fine. Our local blockchain is running, and let me clear the terminal. And first thing we have to do is that we have to clear the artifacts. So if I come here, we have opened our node modules. They have so many folders into that. Okay, there is so many things here. We have the artifacts, so we have to first clear this. So to clear the artifacts, we have to write this command npx hardhat. We have to type clean and hit enter. So this will clean the artifact. You can simply delete it from here, but we have a command which we can use it. So now simply deploy it. So this is the script which we have to run. So let me bring this down and let me grab this one, the script we have taken, and that's what we're going to simply paste here. Hit enter and just wait. Here you can see we got the so many notification, but don't need to worry, it's compiled successfully. And boom, here you can see the transaction went successful. Here we got all the functions which we have created. That looks pretty fine. And here we got the addresses of all the tokens, all the contracts which we have deployed. So with factory address, swap router address, NFT descriptor address, position descriptor address, and position manager address. So we're going to simply grab these, copy that one, and we're going to simply copy, and that's what we're going to keep it into this txt file because we need this in other pages. Okay, so I'll simply come here, I'll simply paste here so we can don't forget it, so we can get it later. Okay, and if I come here, if I come to the contract, you can find everything is working fine. We have no issues into this. Okay, that looks pretty fine. Or if you want to play around with these functions which we have created, so what you can do, you can simply console log out and see what data you're getting, like in this or in the NFT description or in the library bytecode. So you can console log out the data and you can check from your end, but I'm not going to do it because these are the pretty simple things. So we are done with this. Now what we can do is we have the addresses, we are keeping it here. Simply close this one and we are done with this Uniswap contract. And now we can start writing the code in our deployed token. Everyone, hope all of you are doing great. So in the last video we have deployed all the Uniswap contract locally, and we have written the huge script which allow us to deploy the contract. So if you haven't watched, I'll link in the I button on the description so you guys can follow that. In this video we're going to write the script for deploying tokens. So recently we have created 3 tokens in our contract. So if you come here into the contracts, in the contract file, here you will find these 3 tokens: pop, up, Ryan, and Shoaib. So we're going to build a script to deploy these 3 tokens. We're not going to keep it this one for a time being, we'll keep it for later, but we're going to work on these 3 tokens. So let's write the script very quickly. So let's create a async function, and we'll say main. Inside the function we're going to take a variable owner and signer, and this person is coming from our await ether.getSigner. So this will give us the address of 2 person, like the owner and the signer. And we're going to assign the token to the assigner 2, the second address. So let's come here. We're going to take a Shoaib. The variable will say await ether.getContract, and we have to give the name of the contract. So we have a token by the name Shoaib contract, and we're going to pass it. And the owner is going to be the account owner. And here we have to simply call the deployed await Shoaib deployed. So we are deploying that. Let's take the another token which is a Ryan. We'll say await ether.getContract factory Ryan and honor, and here we have to simply deploy that token. So this is the second token. Now we have the third token. We'll say pop-up, await, ether, get contract factory. We have to give the name of the contract, honor, and simply we have to deploy the contract, token contract. So we'll say pop-up deployed. So these are the three contract which is ready, which we can deploy now. Come here, we'll take await, Schwab, and in that we're going to call this function. So we're going to connect honor, and we're going to connect with Ming function because we have to initialize, because right now we haven't initialized that how many token we want to create. So we're going to call the mint function which we have into the smart contract, and we're going to assign all the token to our signer 2, and honor is going to be the one who going to do that. And that's why we have used this connect function, which allow us to connect and assign the honor to it, assign the token to the signer 2. So we'll say address, and we'll pass this ether utils and how many tokens we want to create. Let's say million, 1 and after 50, 1 and 50. So this much token we want to create. Now simply come here, we'll do the same thing for the other tokens, Ryan, and we'll say connect honor, and we're going to assign the token to the signer 2. We'll pass the address and we'll pass the UNT, the amount we want to create. So the same amount we want to create. Let's do the same thing for the third token, pop-up, and we'll call it connect honor. We'll call the mint function, and we're going to assign the token to the second honor. Same thing. Looks pretty good to me. Same amount we want to assign. So all the three contract we are initializing and creating the token and assigning that token to our signer 2. That looks fine to me. Let's come here. And by the way, if you guys are getting any noise in the background, so please ignore that, okay? Because we are having construction and you can see the sound is coming. So I don't want to stop the recording because I'm getting a very good flow right now. So if I stop, I maybe get stuck, but everything's working right now. So we'll come here, we'll take a variable, and in that I'm going to take the Schwab address, because once the contract get deployed, we need to take the address. And that address is very important. The address is very important because we're going to utilize those addresses to create the pool, to create the liquidity. So we have to get the address of the token, Schwab that address we have in this. Let's do the same thing for the other token as well. Rayan address. Now we have the third console, which is a pop-up address and pop-up address. So these are the addresses of the three token we are getting. And now we have to simply call this script. So this is the script we're going to run. Hardhat run local network, localhost. Then we have the script and deploy token. And we have to create the main functions. Process.exist, then we have to catch the error if anything goes wrong, and we have to politely shut down, close that. So console log of the error, and then we have to politely stop the application from running. And that looks pretty fine. So hope this entire thing makes sense to all of you guys. Whatever we have done, these are the pretty basic things. So that looks pretty fine. You can see we have the two honors, honor and signer 2. We have the contracts, and here we are deploying that and minting the token, and here we are getting the addresses. So let's quickly deploy this one. So simply grab this one and open up your terminal, and that looks pretty fine. Let's clear the terminal. Make sure that you should run your local blockchain. Okay, don't stop this. And here we're going to paste this and hit enter. So just wait. If everything goes right, it will make sense. So let's see what is the name we have given, DEPLOI deploy token, and here we have called something deploy tokens. Okay, my bad. So simply remove the S because there is no S I have provided. Simply okay. Clear the terminal and paste here and hit enter. So it will deploy the tokens we have created, and here you can see the transaction is happening, and boom, here we got the three token addresses. All we have to do is simply grab this one, copy, and that's what we're going to simply paste here in our here. So simply paste here, and that looks pretty fine. Hope this makes sense to all of you guys. So we have the address of the Uniswap contract, we have the address of the token, but you have to keep one thing in mind, that your blockchain, local blockchain, should be running. You don't need to stop this, because the moment you will stop, it will not work, because the contract address will get changed when you will redeploy the contract. So just imagine that I have deployed this contract and I have stopped my local blockchains, and then I deploy this contract, the token contract. So it will not work. When you deploy the contract, make sure that all the local blockchain is running, and then you are deploying all the script. Then it will work, because all the contract, all the addresses are related with one another. The moment you will stop this, it will not work. So that looks pretty fine to me. There is no more problem into this we have. Now what we can do is, we are done with this script now. Now let me bring this down, close this one, and now we have to create the third script, which is a deployed pool. And that's the only thing I want to cover in this video. Hope everything makes sense to all of you guys. If you guys have still any confusion, any error, make sure to rewatch the video and try to understand every single logic we have built. With that, I'm ending this video. Let's move to the next video. In that, we're going to work on our deploy pool. Hey all of you, hope you guys are great. So in this video, we're going to build a script for our deploy pool. In the last video, we have built the script of deploy token, and before that video, we have worked on our Uniswap contract. So I believe that your local blockchain is running. You haven't stopped your local blockchains, and we have deployed the contracts, both the contract of Uniswap and the deploy token, and we got the addresses here. We have simply copy and paste the addresses here. So what I'm going to do is, I'm going to simply grab this entire Uniswap contract addresses, and I'm going to utilize it in the deploy pool. So come here and we're going to paste here, because we need the addresses to create a pool. Same thing we have to do for the token. So let's come here and we have to get the token addresses, the 3 token addresses we have deployed in the last video, and that's what we're going to paste here. So hope this is what you have to do. Don't stop this local blockchain, otherwise the addresses will get changed and you have to redeploy that, and you have to do this configurations. Okay, so let's bring the terminal down. This looks good, and now we can start writing the code. Okay, so let me close this one, and now we can start writing the code here. Let's come here. We'll take a variable called artifact, and now we have to get the artifact which allow us to create the pool. So these are the artifacts we're going to use. So we're going to take the artifact of Uniswap V3 factory, because that's very important contract you need to do anything on the Uniswap blockchain, Uniswap smart contract. We'll take this required, and this is coming from Uniswap V3 core artifact contract, Uniswap V3 factory sold, and we have the JSON API. This is the one more, and we need the non-fungible position manager, and that's coming from the same place, Uniswap V3 periphery artifact contract position manager dot sol, and we have the JSON file, the API. So these are the 2 API we need. Okay, so make sure to get the exact API which we are using here, and if you haven't found, make sure to get it from the starter file, or I will provide you in the article which I have in my website. So go to there you will find all the descriptions, all the instruction, the way you have to utilize it. Okay, so we have the artifact. Now let's come down. We're going to take a variable, we'll call it contract, and we have to import couple of packages. Contract, we have to import big number, and that's coming from Ether. Here we're going to import the Bane. We'll take this required, and it's coming from big number JS. So this is the package which allow us to convert. Okay, so make sure to utilize it. We'll take another variable, and now we have to configure this big number JS. So we'll say bin.configure, and that we have to pass the exponential art, and this is the value which we have to pass. And again, this data I'm getting from the package itself. Let's take a variable, we'll take mainnet, and we're going to connect, because as we are testing on a forknet, so you have to get the RPC URL, and we have already used that in our fetching price function. So the same URL we're going to provide it here. So let me paste the URL. So let me type it, mainnet acmeli v3, and this is my API key. Don't use my, try to use your own, otherwise if you will have too many requests on the same API, your code might not work. So use your own API, and this is the API which I have got from Acmeli, and it's free to get. So when you will create your account, you will get a free RPC URL, and that's why I'm showing you all. Okay, and now here I'm going to build the provider, because we need the provider to connect. So we'll say new ether.provider, and that we have to simply pass the mainnet RPC provider. Come here we're going to build the provider. So there is a one more method, we have this one for creating a provider, and this will create a non-address provider. It will work in both way, but try to avoid it if you might encounter some sort of error. So that's why I have taken that mainnet approach. So let's come here, let's build the function. We'll say encoded price. It will take the reserve 1 and reserve 2. So as you all know that when it's come to providing liquidity and when it's come to providing price to the token, it's happened on the terms of a square. So there is a square method on the Uniswap, which is very complicated. Still, I'm very confused, but it's working. So this is the exact code which I have found in the Uniswap TypeScript, and the same one is I'm using here, because I still a little bit confused on this, the way it's worked, but it's worked. So it will take the price to price, the token we want to, the price of the tokens. And here we go to build the logic. We'll say return big number from, and inside that we have to simply take this, the package we have taken, reserve 1 dot, and we have to call this string. We have to call this div reserve dot string. We'll take this one square, and we're going to simply call this multiply by the bin2 dot prop. Then we have to take this internal value 3, and we have to take this to string, and that's it. So this is the function which convert the price which you want to assign to your token into a square form. Come here, we're going to create a variable const non-fungible position, and we have to simply deploy the contract, get the contract, okay? And then we have to pass the position, the ABI address, position manager address, and we have to pass the ABI, which we have inside this, and we have to pass the provider. So this is the contract of non-fungible position manager. Let's take another variable. We'll say factory, and now we have to get the factory contract. So we have to pass the address of the factory, we have to pass the factory ABI, and we have to pass the provider. That looks fine to me. Let's come down. We have to take this async function. Inside that we're going to call this deploy pool, and it will receive couple of parameters. So this function will deploy our pool. So it will need the addresses of the token, so token 0, token 1, and we have to provide the fee and the price, that what is the price we want to take when someone will swap the token, whether you want to take 0.3% or 5% or 1%, and we have to define the price which we want to assign to the token. So let's come here. Here we're going to simply take a variable. We'll take this honor, and we call this ether.getSigner. So this will give us the honor address. We'll take this await non-fungible position manager, and here we're going to call this connect. We have to connect the honor, and then we have to call this create and initialize pool if necessary, token 1, token 2, and fee and the price. And here we have to assign the object. The gas limit is going to be 5, and that's pretty much. Let's come here. We'll take another variable, pool address, and here we have to take the address which we'll have inside this factory.connect, and it will pass the honor. It will say get pool, and this will give us the data of the pool. So in that we have to pass the token 1, token 2, and we have to simply return the pool address from this function. Hope this makes sense to all of you guys. So that looks pretty fine to me. Let's take another function, async function. It will say main, and here we're going to initialize that. So we'll take a variable const, we'll say show up Roy, because this is the name I want to give to the pool. And let's deploy that. So we have to call this deploy function, deploy pool, and in that we have to pass the data. So we have to pass the address of the Schwab, the token. We have to pass the other token address, and we have to pass the fee. We have to pass the encoded price square, and right now I'm going with 1:1. And the reason why I have taken this ratio of the pricing 1:1, because I want to be into the range. I don't want that my pricing of the token go out of the range. There's a lot of concept in that, but for the time being, just focus on this. Just provide the range of your token pricing is to 1:1, so it always be in the range, and there is no high fluctuation in the price of the token. And that's the pricing. Let's come here, and here we have to simply close that. Here we're going to console log out the address of the deployed pool. So once we deploy that, we'll get an address, and that address is the unique identifier of this particular pool on the Uniswap exchange. So let me simply print that address, and here we're going to write the script. So this is the one script we have to run in the terminal. So we'll say network localhost script dash deploy pools.js, and here we have to build the main functions. We have to say then prop.exit, we have to catch an error if everything goes wrong, and here we have to log the error and we have to shut the application politely, and that looks pretty fine. So try to understand what exactly happening here. So these are the 3 addresses we got when we deploy the tokens, and these are the addresses of the Uniswap contract we have required in this pool deploy. So these are the 2 data must to create a pool, and here we have the artifact, here we have the packages we are importing, this is the mainnet, and here we have this encoded price square which will give us the price, create the pricing of our token. This is the non-fungible position manager contract, this is the factory contract, and here we have the deploy functions, and here we are passing this, getting the honor, getting this data, initializing that, and here we are initializing the token 1, token 2, and the fee. So make sure this is what you have to provide in this, in the factory connect, and from here we are getting the address of the pool address, and that's looking absolutely fine. And here we are consoling log this pool address. So hope this makes sense. Now let's deploy and let's see everything's working fine or not. And here I have to do the changes. I have to remove the S, simply grab this one, open up your terminal, and make sure that your local blockchain is running. You haven't stopped this. If you stop this and then you try to redeploy, it will throw you an error. So I haven't stopped this, my local node, since I'm deploying the contract. So first we deploy the Uniswap contract, then we deploy the token contract, and now we are deploying the pool contract. So let me simply clear that, and here we go to paste the script and hit enter. So just wait, it's deploying, and if everything's went successful, everything is not good. Here we got an error, and this error is coming from HTTP provider error. Okay, so we have to see what's the problem we have in the code. Deploy our deploy pool script, we were getting an error, and what I did, I simply restarted the applications, closed my Visual Code Studio, closed my internal blockchains, deleted the artifact, and I found that everything's working fine, and I have no idea that why I was getting that error. Still I'm getting this error, sometime I'm getting, sometime I'm not getting. So I don't know why I'm getting this weird behavior in our RPC URL, but right now the method we have written, it's working absolutely fine. So if you get an error, try to delete the artifact, restart your internal blockchains, redeploy all the contracts, and then it will be working fine. So let me show you what I'm going to do now. So I'm going to simply clear my terminal, and I'm going to initialize the Hardhat node. This will initialize my local blockchains, and now I'm going to redeploy all the contract. So first I will start with this Uniswap contract. So let's come here, let's redeploy that. So where it is, this is the one we want to deploy, and just wait. And you can see this is the contract got deployed successfully. All we have to do is to grab this entire address, copy, and that's what we're going to paste right up here in deploy script. So I'll simply come here, I'll take this one, I'm going to simply replicate it, not replicate, I'm going to simply replace this. So here I've replaced the contract addresses. Now I'm going to simply clear this, and I'm going to deploy the tokens, the token script we have here. So just wait, it's working, and here it's working fine. We got our token addresses, simply grab that one, and that's what we're going to simply replace here, paste, and that looks fine. Now we're going to run the script we were getting an error. So this is the script we're going to initialize. I have not done any changes in the script. You can see we have written the same piece of code here, and everything's working fine. So sometime I'm getting this error, sometime I'm not getting this error. I don't know why I'm getting this weird behavior. So let's try to deploy this one. So this is the script, deploy pool. This is the script we want to deploy, and hit enter. Inshallah this will work fine. So just wait, and you can see this time it worked. So it's went through. Here we got the address of the pools which we have deployed locally. Okay, so this time it's worked fine. So, okay, so I believe that you guys have fixed this issue. Still, if you have any issue, try to deploy the contracts again and again. I don't know why I'm getting this weird problem in my computer, and I believe that you guys will not have any issues, but I'm getting, at the time of recording, I'm getting this weird error message. Okay, so now it's worked, but in 5 attempts I found that the 3 times it's working and 2 times it's not working. So right now it's working, so I will go in this approach. So if you get an error, do let me know in the comment section, so I'll come with a better script, modify one, and in that we can try to tackle this issue. But right now it's working, so let it go like this. Okay, so it's working fine. So simply we have to do is simply grab the address of this, and we're going to paste the address in the, because we need this address. So all the address we have taken here, these are the old addresses, don't need to worry about this. The only thing we have to worry about this address, because whatever address we have included this here and here is the optimized addresses. Just now we have deployed and pasted. Now what I'm going to do is, let's continue working on our the other script in the liquidity script. Now we can start working on our liquidity script. So for this, what we have to do is, we need to have all the addresses. So let's come here, we're going to need all these addresses. I'm going to grab this address, and that's what we're going to simply paste here. So let's bring it down and paste here. So this is the token addresses, this is the contract addresses, and now we need the address. So this is the address, the pool address. Grab that one, and that's what we're going to replace, paste right up here. Okay, so this is the pool address. So hope this entire thing makes sense. And now we're going to write the code for our liquidity. So let's do it quickly. Now let's take a variable, we'll take artifact, and now we have to import all the ABIs which we're going to use to provide the liquidity. So we're going to follow the same pattern. We need this non-fungible position manager, and that's coming from the same module files. Okay, V3 factory artifact contract, non-fungible smart contract, and then we have the ABI there. So this is the first import of the package. Now let's take the tokens, the ABI of the token. So we need the ABI of the token, so which is inside this artifact, contract, Schwab, Sol, and this one. Now we need the other tokens ABI, which is inside the contract, Rayan, Sol, Schwab, Rayan.json. Okay, so these are the artifacts we have. Now we have to import the Swap V3 pool, which will allow us to create the pool, and that's coming from the same place we have already imported multiple times, JSON. And that's the artifacts we have imported here. Now let's come here, we're going to take this variable, and we're going to import a couple of things from the Ethers.js, like contract, that's coming from Ether. And we have to take another one, we have to import the token, and that's coming from our Uniswap SDK core. Now we have to import the pool and positions and nearest usable tick, because when we define our price, so we can't define any price just like this. This is not how the Uniswap work exactly. So this is the function they have assigned. So they're going to find you the right suitable, the tick position of the pricing which you want to assign to the token. Okay, so just use this function, and that's coming from, we have the Uniswap V3 SDK. So these are the packages we are required into this. Now let's come here, we're going to take a function, get pool data, and in that we have to pass the pool contract address. So remember the address we have taken, so remember the address we have got when we deploy the pool. So that contract we're going to pass here. So let's come here, first thing we have to take a couple of things. So we need the tick spacing, we need the feed, we need the liquidity, and we need the slot. So this slot will have a lot of function in it, and it will give us a lot of data which we actually need to display in our frontend. So we'll say await, and we're going to use this promise.all, and in this we're going to make a multiple call. It's just like an API, it's just like you make an API call. And here we're going to call this, we'll call the pool contract, this pool contract, and in that we're going to call this tick spacing function. It will give us the data of that. Let's do it quickly for other. So this will give us the fee. Now we have to get the liquidity and liquidity function, and now we have to get the slot, and this will give us the slot functions, and that's it. So these are the function we are getting here. Now let's come down, we're gonna create a, and now we're going to simply return the data which we have taken, so like tick spacing, fee, liquidity, and slot. So let's quickly return this one. So tick spacing, it's called tick spacing. Now we need a fee, now we need a liquidity, and we need a slot 0. Price, square price 96, and we have this slot function, and that the 0 index is the pricing. Okay, as I told you that this slot 0 contain a lot of data, and it will come in the form of array. Okay, the data you will get in the slot, it will come in the form of array, and how you can extract this data like this. Okay, so now we have to get the other data, which is a tick, which is inside the slot 1. Now we have to come down here, and that's the 2 data we need for the time being. If we find that we need more data, we definitely take that. So that's the function we have. Now we have to get the main function, and in that we go to build the logic, and we'll pass the contract pool. So it's gonna be, we'll have this const, and we need the owner and the signer. Owner and the signer to await, and it's coming from ether.getSigner, and this will give us the two wallet addresses. We'll take this const provider, and we already have the provider, and again we're going to use this waffle.provider, which is available to us. Or you can use the ether, or you can use Acme, the RPC URL for creating the provider, but this is the package we have installed, ether waffle, and that's the package we're going to install, and it will create a provider with non-address. Let's come here, we will take a variable, we'll say swap contract, and now we have to get the contract of the token. So right now we have this two token, we have to get the tokens contract. So we'll call it new contract, and in that we have to pass the address, we have to pass the ABI, so which we have inside this swap.abi, and here we have to pass the provider. So this will give us the contract. Now we have to take the other contract, which is a Ryan contract, and in that we have to pass the data. So we need to pass the address of the token, we have to pass the ABI, which we have inside the artifact, and we have to pass the provider. So this will give us the two token contract. Let's come here, we'll take a await swap contract, and we're going to call this connect method because we want to provide the liquidity to the signer too. And we are using this connect method because owner is the owner of the contract. Remember, when you deploy the token, so when you deploy the ERC20 token, at that time the signer, the first account is the owner. So we are using this connect method to connect the owner, connect signer, and we're going to simply call approve. And we'll set the position manager, and in this we're going to pass the ether.utils parse int, and we have to simply pass the amount of liquidity we want to provide. Position manager, this is the amount we want to provide. Let's come here, and we have to do the same thing for the other token as well. So we'll connect signer to approve, and we have to approve our position manager so it can take the token, and in that we have to simply pass the liquidity we want to create in both the tokens. So 1000. Hope this makes sense to all of you guys. We are not doing anything fancy here, we are just following the normal stuff which we have done so many times in this project. That looks good. Come here, we're going to take this const pool contract, and here we're going to take this new contract, and in that we have to get the contract. So we have to get this show ROI, and remember this is the pool address, and this is the address we got when we deploy our last script, like create pool, deploy pool. Okay, and that's the address we have taken on the top, and that's what we are assigning in this pool contract. We have to assign the ABI, which we have inside the Uniswap V3.abi, and we have to assign the provider. This will give us the contract of the pool which we have created. So we have the contract. Now we'll come here, we'll call this const pool data await get pool data, and in that we have to pass the pool contract. Remember, this is the function we have created at the top, pool get pool data, and we are passing the contract. This will give us the data back in our pool data. So nothing complicated, very simple. Let's come here, we're going to say const swap token new token, and here we have to assign the data which we want to take from the token. So first we are targeting the swap. The chain ID we have provided as we are testing locally, so this is the chain ID for the local, and here we're going to provide the address, we'll provide the decimal point, the name, and the symbol. So that looks pretty fine. Let's do the same thing for the other token, Ryan token, new token, chain ID, address, decimals, name, and the symbol. So that looks pretty fine to me. So we have the tokens. Now we come down, we can take a variable called pool, and we will new pool, and here we're going to extract most of the data. We need a lot of data, so we'll use this new pool, and here we're going to define that swap token. We'll define the Ryan token, and we'll define the pool data fee, the fee we want to charge. We have to pass the pool data dot square price, which we have inside this, and we need to pass the pool data liquidity. We have to convert it into a string. We have to pass the pool data tick, and these are the data is coming from that function. Okay, so that looks pretty fine. Now let's come down, we'll take a variable called position. Inside that we're going to call this new position, and this is the method which we have in the SDK to get the data. Okay, so let's call position, and inside that we have to send an object, and that we're going to say pools, we will say liquidity the data we need, that's all we're going to provide here. So we have to convert it to 1. We'll say tick, lower tick, and here we're going to assign it, and the lower tick is actually a price which we want to set to our liquidity. Okay, so we'll use this function which we have imported. In that we're going to pass this tick, pool data spacing, and we're going to call subtract this with this pool data tick spacing multiply by 2. So I'm not coming up with this method because these are there in the documentation. If you really want to assign price to your liquidity in the range, then you have to follow this formula which they have mentioned in their documentation. Okay, so these are not magical script, these are the formula you have to add to make the pricing in the range. Now let's take the upper, and we have to do the same thing here. We'll call this function, we have to assign the tick, we'll take this pool data tick spacing, and we're going to add that, and we're going to simply take the same model and we're going to multiply with that. So it will go to +2 and -2. So you can imagine in this way, and then we have to simply close it. That looks pretty fine. Let's come here, we'll take another variables, we'll take this amount, desirable amount, and these are the second amount, desirable, and these data we are getting from here. So positions.mint amount, when you call that, it will give you the data of these two parameter. Okay, so in the smart contract you must have seen in our liquidity smart contract, when we have written, we have these methods when we building the params like amount desire 1, and that data we are getting in amount 1 and amount 0 and amount 1, which is coming from mint amount. And here we have to build the entire params, the data we need to pass into the liquidity function. So here we are to build the params. So let's define the data. It's going to be an object. Inside that we need the token, first token, so it's the token address. We need the second token, token 1, which is a RAN address. Now we need the fee, that fee we want to charge, and we need the ticks lower, and here we're going to call this method. So we have this tick, pool data tick spacing minus, we have to take this pool data tick spacing multiply by 2. So the same formula for we have to follow for the upper tick as well. So we're going to take this for methods, and we're going to call this tick spacing, we're going to subtract that with pool tick spacing, and we're going to multiply with 2. Simple, not complicated. And we have to pass the desired amount to desire, and we have to convert into a string. Same thing goes for the other one, desirable 1 to a string, and we have to take the amount minimum 0, and this is going to be maximum 0. Let's come here, we're going to take the recipient is going to be the message sent, recipient is going to be sender.to, and recipient is going to be signer.to address, and we'll take the deadline math floor, and we want to have a timing like close to this minute, and that's the entire params we have written. Hope nothing is complicated to all of you guys. It's pretty simple JavaScript we have written, and these are the params which is already defined in the contract in the V3 SDK, and the same methods we are calling here. We are not doing anything extra, we are simply following the documentation. So looks good here. Now let's come here, take a variable, we'll say non-fungible position manager, and in that we're going to take this new contract, and we have to get this contract. So we'll pass the position manager address, we have to pass the ABI which we have inside the artifact, and we have to pass the provider. So in this way we can easily able to get the contract of this non-fungible position manager. Let's take another variable, DEX, and this will give us the data of the transaction. Okay, so we'll call it non-fungible position manager. We'll connect the signer to, we'll simply call this mint function. In that we're going to pass the entire params we have created along with the gas fee, so gas limit. So this is the gas limit I want to assign, and I have found that these gas limit is most of the time it's work fine and the code executes. Let's create another variable, we'll say receipt wait tax of wait. So we have to wait till the transaction get completed. Once the transaction get completed, I want to simply console log out the entire receipt. Let's come down, this is the script we have to write in the terminal to make the code execute. So this is the entire script, and let's call this function main function. In that we have to simply call this process.exist, and we have to politely shut down the application once we execute the code. So this is the error, and now we're going to shut it down. So process.exit1, and that looks pretty fine. We have 100% working code, no more error we have here, and this looks pretty good to me. So we have written the entire code for this add liquidity. So we have the token address, we have the pool we have created in the last script, we have the contract address, we have the artifacts, we have the tokens, the imports. This is the first function we have, get pool data, and that we are passing the pool contract, we are getting all of these data and we are returning from here. This is the main function, we are getting these two accounts, we have the provider, we are getting the contract of the tokens, we are getting the simply assigning this, so we can take the provide the approval to our position manager so it can spend the token on behalf of us. This is the contract, and these are the general function. We are using this token to get the data, and here we are using this new pool to get the data, and this is the positions, and we have the entire big params so we can add the liquidity. Okay, these are the pretty generic things. So let's test this out. Open up your terminal, and these are the commands we have to run. And one thing we have to keep in mind, that this internal blockchain should be running. So when you deploy the first contract, it should be running, then deploy second, then third, and this is the fourth one. Because the moment you will stop, the entire address would be changed. So simply paste that one, and let's deploy this contract. And if I hit enter, inshallah this will happen. So just wait. And the transaction went successful. Here you can see we got all the receipts, the block hash, the entire transaction is successful. So I believe that you guys have got the same output. You can see I got the entire data back here. So all these events are get called, and here you can see we got all the data back in our terminal. The liquidity we have created successfully, and I believe that you guys have got the same data. You can see this is the two token, so you can see this is the addresses, this is the entire gas amount, all the things you can able to find. If you have any kind of error, make sure to restart the application, redeploy all the contract, and follow the normal steps, and it will work fine. Okay, so but in my case it's working fine, so it's looking fine to me. Now what we can do is, so it looks pretty fine. Now we have to create one more script to check the liquidity. So the liquidity we have created, we have to have a function. So that function will allow us to check the liquidity and will fetch the information of that liquidity so we can display into our front-end applications. And that's the last script we're going to write. Okay, with that, let's move to the next video. Everyone, hope all of you are doing great. So this is where we left in the last video. We have successfully created our liquidity script, and we have created the first liquidity. In this video, we're going to write the check liquidity function, check liquidity script. So let me close this one, and let me close this one. So let's come here. I will go into the last script, close this utils. We have the last one is check liquidity, and here we need one data. Can you guess what data we need to check the liquidity? We need the liquidity address. So if I come here, this is the liquidity pool address, and that's what we need here. Copy that, come here, and that's what we're going to paste here. And let's start working and writing the script. Let's come here. We're going to take this const variables, and we have to get the Uniswap V3 package. We need the ABI, so which we have inside the V3 pool, and we have the ABI Uniswap V3, and now we have to take a couple of import from Ether. So we need the contract, we need to import the pool, and that's coming from the Uniswap V3 SDK. Now we have to import the token, and that's coming from Uniswap SDK core. Let's come here. We have to create a function called get pool data. Inside that we have to pass the pool contract, and here we can pass the data. So the data we need is the ticks, spacing, we need the fee, we need the liquidity, and this script is going to be similar like the add liquidity function we have created, because to create a liquidity you need all these data, and the same data we need as an output. Okay, so I'll go a little faster here. We need the slot, and we need the factory, we need the token 0, we need the token 1, and we need the max liquidity price tick. We need this, and this all data is coming from here. Okay, we are taking so many data from the pool which we have created, and we'll say promise.all, and in that we have to simply call the function pool tick spacing. We have to call this fee, we have to get the, let's say, liquidity, the liquidity we have provided. Then we have to get the pool contract slot. Come here, we'll take the factory. Now we have to take the tokens 0 and we have to get the token 1. We'll come here, we'll take this pool contract, max liquidity per tick, and that's all data we are taking here. Close that, come here, we're going to take a variable, we'll say token A, and in that we're going to pass a couple of data which will give us the data of the token. So we'll say new token, we'll pass the chain ID to 3, token 0, 18, and Schwab symbol and the name. Let's do the same thing for the token, other token as well. So token B, new token, chain ID, token 1, and then we have to pass this information. So that looks pretty good. Let's come here, we're going to take a variable call, we'll call it pool example, and in this we're going to call this method new pool, and in that we have to simply get the data. So we need to get the data to token A, token B, we need to get the data of fee, we need a slot 0, and we have to convert that into a string. Then we need the data of liquidity, we have to convert into a string. Then we need a data to slot 01, we need a, these are the data we have to pass. So these are the data we have passed into our pool example. And let's come here, and here we're going to simply return the lot of data. So we'll take the factory. Now we'll take this token 0, we'll take this token 1, we'll take this max liquidity per tick, which is a max liquidity per tick. We have the tick spacing, we have the fee, we have the liquidity to string, and we have the square price slot 0, we have the ticks slot 1, we have the observation index slot 2, and this one we have. So there is so many data available to us, but it's totally up to you that what are the data you want to display into your frontend applications. But here I try to find out, here I try to extract all the data. So later we can decide what we want to display. Let's take this observation credential next, which we have in this slot 4, then fee protocols in the 5 slot, then we have unlock, which is 6th, and we have the pool example, and that's it. We get so many data. Okay, let's come here, create a function called main, and in that we're going to pass this provider, which is coming from full provider. We'll come here, we'll take this contract, we're going to call this new contract, and we're going to pass the address of the pool and the ABI of the Uniswap V3 and the provider. So this will give us the contract, pool contract, and from here we can easily able to call the data. So await get pool data, we pass this pool contract, and this will give us the data back. So we'll console log out this simple pool data, and we'll say pool data, and this is the script we have to run. So simply run the script. So local script check liquidity, that looks pretty fine to me, and we're going to call this function we have created. Then process.exit, we have to shut the application slightly gently. Okay, console log out the error, and we're going to set it peacefully. Process.exit, and that's pretty much. So these are the huge script we have written to get the data for the liquidity. Okay, so hope this and that thing makes sense to all of you guys. So this is the huge script we have written. We have the address, we have the ABIs, we have the imports, we have the big function which we give us all the data, we have the token, now we have this, we are returning so many data, and here we are calling this. Now simply run the script. So if I simply save it, open up my terminal, you can see this was the previous liquidity generation. Now simply going to clear this, and now I'm going to run the script, and this will give us the data for the liquidity. So just wait, and here you can see we got the data, we got the fee, square price, liquidity, we got the data of the token 1, we got the data of the token 2, and there is so much data. So right now you can see the liquidity we have provided is this is the liquidity, and I want to increase this liquidity, I want to provide more liquidity. So it's very easy. All you have to do is to open up your terminal. It's already open. I'm going to clear the terminal, and I'm going to run the script number 4. You can create as many liquidity as you want. All you have to do is to change the address of the liquid create liquidity. So this is the address you will change and you will have a different, but I want to create a liquidity in the same tokens, in the same pool. So again, I'm going to simply run the command is this add liquidity, and this will work fine for me. This will work fine for me, and just boom, and here you can see the liquidity is got created, and now we can check one more time. Sorry for the mispronounce, and this time I'm going to call this check liquidity, and you will see that liquidity got increased by almost double. So here we got the data, and right now you can see the liquidity we have is this 2. Earlier it was 1, but now we have 2. So this is how it's working. It's working absolutely fine. You can see we have written so many scripts, and all the scripts are working fine for us. Simply close this one, and now what I'm going to do is, now we have the script, we have all the data. All we have to do is to connect this with the front end, and that's what we're going to start from the next video. Okay, so with that, let's move to the next video. Hey all of you, hope you guys are great. So in the last video we have completed our check liquidity script. So this is the script we have built in the last video, which allow us to check the liquidity. So altogether we have written 6 scripts which allow us to deploy the contract. So if you haven't followed any one of these tutorials, so make sure to watch that, because these are the very vital script which you have to build before we start connecting that. Okay, so we have all the functionality. We are deploying the Uniswap contract, then we are creating the token, then we are deploying the pool, then we are adding the liquidity, then we are checking the liquidity. So we have all these data here, and now what we're going to do is we're going to create 3 more files. So right now you can see that here we have defined hard-coded data, but we need this deploy, pool, check liquidity, and add liquidity as a front end. So user can interact with the front end, they can add their information, and they can create liquidity. So we can come here, and here we're going to create the same file, and we're going to do a modification, because ultimately we have to connect with the front end, and we're going to extract the data from the front end, and then we want to make it transaction. So we don't want to go with this hardcode value. So if we come in the pool section, here you can see we have this hardcode value, but we don't want to do that. So we want to make it dynamic. So what I will do, I will simply copy this, and that's what I'm going to paste here. So this is what I'm going to paste. I'm going to copy this check liquidity, copy that, and that's what I'm going to paste here. Check liquidity, and copy this add liquidity, copy, and that's we're going to paste here. So we have all these 3 scripts. Now what we're going to do is we have to open it, because we have to do a lot of modifications. So instead of modifying every single thing, we're going to rewrite this, because modifying will take a lot of time, and it's better to write once again everything, because we have to do a lot of changes. So I'm going to select this one, and I'm going to remove this and save it. Do the same thing for the check liquidity. I'm going to select this, I'm going to remove it and save it, and let's do the same thing for the deploy script. Select one and delete it. So we have these 3 files in our utils. So make sure this is the architecture you have to follow. All the utility function, all the major function we're going to keep inside the utils, and we're going to fetch it from here and make it work. So right now we don't need to focus here. So we have these 3 files. We're going to write the script shortly. Now what we have to do is come back to the contract, and here we have to do the major changes. So right now you can see, if we come to the pop-up token contract, here you can see that here we had defined this function, but I don't want to define this function. I want to initialize my token at the time of token deployment. So if you come here, if you come to this boo token, here you can see this is the method we have used. So this time what I will do, I'm going to simply copy this, and this method I'm going to call here. I don't want to initialize with the help of this. So I'll come here, I'll simply paste test, and right now you can see these are the function we have assigned. So simply remove this one, and here we're going to do the major modification. So instead of this, I'm going to pass this the name of the token and pass it, and we have to pass the symbol. So these are the changes we have to do, and from here I'm going to remove this constructor. So now it will work fine, and these are the changes we have to do. Okay, so we have this pop token, we want to create this much token. So this time I will go with 8. Okay, 8. So that's it. Now do one thing, save this one, come back to the Ryan token, and here we have to do the modification. So we don't need this one, replace it, and here we have to change it. So I'm going to call this one is going to be Ryan, and this one be the symbol. So paste here, and we're going to remove that. So this is our Ryan token. Now simply grab this one more time, and this time 8 is fine. Okay, let's go to the Schwab, and we're going to remove this one, and here we're going to simply pass this Schwab, and here we're going to type our symbol, and this time I will go with 6. So all token will have a different quantities. So these are the changes we have to do in all these pop, ran and swap token. So let me remove this one. That's the one change you have to do in the contract. And now we're going to create one more contract, and in that we're going to keep the data of the user. So just imagine a user will create a liquidity. So once he create the liquidity, so we have to store the information about the liquidity address. We need the two token addresses in which he or she has created the liquidity, so we can later fetch those liquidity in our front end. Okay, so for that, what we're going to do is I'm going to use a smart contract as a data storage, or in most of the application what will happen that this information you're going to store in an API, or you can store in the smart contract, but I will go with the smart contract approach. So I'll come here, click here, and inside this I'm going to create a new file, and on this file I'm going to call it user storage. So this is the smart contract we have built. Now we have to simply write the contract which can store the information. So let's come back to the swap token, and here we need this. So these are the configuration we need, and we also need this ABI, like ABI decoder, because we're going to use the constructor. And let's build the smart contract very quickly. So we'll come here, we're going to create a contract, and I'm going to call it, let's say, user storage data. And then we're going to define our struct, and inside the struct we're going to call it, let's say transaction struct, and here we have to define the data we want to store. So first data is going to be the address, and this will call caller, so the person who will call the functions, and the second one is going to be the address, and in this time we're going to store the information of pool address. Now we have to store the information of the token, so we'll say token address 0, and now the last one data we want to store is the token address 1. So this is our struct for storing the data. Now let's come here, and now we're going to create an array. So we'll say transaction struct, it's going to be an array, and we'll call transactions. So our transaction is array. Now we have to create a function to put the data into this struct, into this contract. So we'll create a function, and we'll call it add to chain. You can call whatever you want. I'll go with add to the blockchain because this is the information I want to store. And first thing I need the address, and the address of the pool will be the address. So this time will be token address 0, and now we have to take another address, and this will become token 1. So these are the data is coming, and we'll make it public so we can call it. So we got the functions. Now we have to put the data into a struct. So we'll take our array, transaction array, and in that we're going to call this push method, which is available to us, and now we're going to call the struct. So here we're going to call the transaction. So we'll say transaction struct, and inside that I'm going to pass the data. So first data we want to pass is the message.sender, so the one who's calling this. So dot sender, that he becomes the callee. Now let's pass the pool address, and then we have to pass the token 0, and we have to pass the token 1. So this is the function which allows us to give us the data back once we load the data into a struct, and you can see things are looking good to me. Now what we can do is, so this function is ready, and I'm getting some sort of error. Let's have a look why this. So it says we have the struct. Okay, let's come down, and here we're going to simply now we have to write a function which allows us to get the entire information, the entire array. So it's very easy. We'll get all transactions is going to be public, and we will say view, and we want to return the information, and then we have to simply return the entire array. So we have the transaction, so we have the transaction struct, and that's what I want to return from here. Will be a memory, and then we have to simply say return, and we want to return the transaction array, and that's it. So this is a smart contract, a very simple smart contract. All it does that it's take this information, so we can store this information into this. Okay, so that's pretty simple. Save it, and now we can simply close this one, and close this one. So make sure you have to do this major changes in the tokens, and you have to create this smart contract. So we are done with this. Now what we can do is, let's come here, we can get into the script, and we can come here in the deploy, and here we're going to simply build a script to deploy the user contract we have created. So what I will do, I will simply come here, I'm going to simply comment this, simply copy this entire contract, make it hide, and here we can come, and we're going to simply deploy this. So this will become the user data contract, and here we have to do the modification. So let's come here, we have to get the name of the contract. So this is the name of the contract we have taken, and now we're going to simply pass the name here. So let's select here, tab, and so tab, and paste here we have to paste, and here we're going to simply select this and paste, but we have to make it small, and make sure to do these changes, and here we get the address of this contract. So that looks pretty fine to me in the deploy script. We can simply close this one and Now what we can do is, so let's first deploy this contract. Let's deploy this contract. So let's come here, let's open up your terminal. And so before we deploy, what we can do is, let's build the script. Okay, let's build the script first. So let me close this and let me clear all the things. Okay, so things are looking good. So we're not going to deploy right now. First, what we will do is, so we are done with this major changes. So make sure you have to do is, let's come here in the contract. So we have done in these 3 token, we have done created this contract. So our script is ready, and we have done the modification in the deploy script. So we can deploy this one, and it's also look fine. And now what we can do is, things are looking pretty good. Now we can come to the utils and we can start writing the script of this one. So first we're going to write the script for this deploy pool. So come here, we're going to import couple of things. First one is ether, big number, and it's coming from ethers package. Now we have to import the XCS for making an API call, and that's coming from XCS. Now we have to import the Web3 model, and that's coming from Web3 model. Come down, we're gonna create a variable called bn, and in that we're going to use this big.js. And this is the same structure we are following, the structure we have followed in a deploy script. And here we're going to modify the data, but the structure is going to be the same. So I will go a little faster. I'm not going to, I'll go a little faster because we're going to write the same code here. So let's quickly do that. You have to provide the configuration in the big.js package. This is the decimal point I want. Let's come down, we're going to take a variable called Uniswap V3, and we need the contract of the address. So right now I'm going with this previous data, but we're going to change this data when we actually connect the application with the front end. Okay, that's the thing you have to keep in mind. So just go with this data, because you have seen that our local blockchain is not running at all. So I'm just taking this hardcore data for the time being. Let's take this one. Now we have to take the fungible manager, and this is the address for my test one. So let me type this very quickly. Let's take a variable. We're going to take the artifacts of these 2 contracts. So we have this Uniswap V3 factory, and that's coming from our Uniswap V3 core artifact contract Uniswap V3 factory.api. So this is the Uniswap V3 factory. Now we have to take a non-fungible position manager. We have to get the ABI of this, and which is inside the periphery artifact contract non-fungible, and we have the API right up here. So these are the 2 artifacts we are taking. Now let's create the function export const fetch, and this function will allow us to get fetch the contract of this V3 and non-fungible position manager. So let's quickly create the function. In this we're going to provide this signer provider, and we're going to use this new ether contract, and we have to pass the address of the contract. Then we have to pass the ABI, which we have inside the artifact ABI, and then we have to pass the signer. So this is the fetch one, and now we have to build another function which allows us to fetch the other contract, which is a fetching position contract signer or provider. We're going to use this ether.contract, and in that we have to pass the simple non-fungible manager address and the ABI, which we have here inside this position manager, and we have to pass the signer or provider. So these are the 2 fetching contract function we have created. Now let's come down. We're going to create a variable called encoded price, and this is the same structure we have followed in the deploy pool script, the same script I'm going to write here. So in this we're going to take this 2 data, reverse 1, reverse 2, and we have to perform this. So we're going to return this big number, and in that we're going to use this big Ethers.js package. In that we're going to convert it into a string. Then we have to take this div reverse 0, we have to convert it to a string, and we're going to use this method called square, and on that we're going to call this multiply by, and then we're going to pass this bn to convert it to a string. That looks fine. So this is the encoded price. Let's come down, we're going to export a function. So we'll say const connecting with pool contract, and this is the function which allow us to connect. So we'll call this function in the front end, and in this we're going to pass couple of data. So it's going to be an async function. So in that we're going to pass this first data. First we'll pass the address of the first token, then we have to pass the address of the second token, then we have to pass the fee we want to charge, and we will have to take the token fee, the price we want to assign to the token. So this is the first price for the token. Now we have to take the second token, and that's it. So these are the data we're going to take into this connecting with pool contracts. Okay, so let's come here, we're going to call this, and in that we're going to simply take a variable because we need a provider. So we'll say web3 model, and we have to take our provider, which we have here. Now we have to build the connections, and we can easily able to do that, web3.connect, and now we have to build the provider. So we'll say new ether.provider.web3 model, in that we have to pass the connection. So same old school we are following here. Let's come down, we're going to take another variable, we'll say signer, because we need a signer to perform the transaction when we transfer the token. So we'll say get signer, so we'll have the signer. Let's come down, we're going to take a console log. So let's see what we'll get. Let's come down here, we're going to take a variable called create pool contract, and we have to create the contract. So we'll say await fetch position contract. So this is the function we have created, in that we have to pass the signer. So this will give us the contract of this create pool contract. And come down, we'll take another one, price, and we're going to store the price here in this variable, price variable, and we're going to call the function. In that we're going to pass this token 1 fee and token 2 fee, because this is the price user will going to assign. We'll console log out the price. So let's come down, we're going to take a variable called transaction await create. So here we have our create pool contract, and in that we have to simply call this connect method. So we have the transaction, so we have the signer. So that's what we have to use to connect, because if I'm doing the transaction, so I will be the signer, and here I'm going to call the function. So we'll have this function create and initialize pool necessary, and in that we're going to pass the address of the 2 token and the fee and the price. So these are the 3 data we are passing, and we have to assign the gas fee. This gas fee is the recommended one, because if you go beyond this, it will say you that you have assigned too much gas fee. So this is the recommended one in the middle. So this is the initialize function. Let's come down here, we're going to await. We have to wait for the transaction to be completed. Now let's come down, we're going to take another variable, we'll say factory, and we have to do the same thing for the factory, because this factory will give us the data of the pool we have created. So let's fetch the contract, we'll pass the signer, and once we have the signer, we have to get this pool address, which we have in this. So we'll say factory.get pool address of the 2 token, and we have to pass the price. When we pass these 3 data like token 1 and token 2 and the fee in our get pool function, which we have inside the factory, it will give us the address. So make sure these are the exact data you have to provide, because if you provide different pool fee, instead of 3, if you provide 5, you will get an error. You will not get the address of that particular pool, because same token can have a different pool fee. So that's the key point you have to keep in mind. Let's come here, we can return the pool address from these functions, and that's it. So you have seen we have written all these functions. So we have this import, we have this big number JS, we have the contract addresses. So right now we have hard coded this, but we're going to make it dynamic. This is the artifact we have, this is the pool fetch pool contract, this is the position contract, and this is the price, this is the connecting pool contract functions, and we are doing this, and at the end we'll get the address. And this address is very important, because we need this address to create liquidity. First we'll initialize the pool. Once the pool is ready, then we're going to create liquidity, and that's how the Uniswap smart contract exactly work. So right now we're not going to deploy, we already know that it's working fine, because we have to connect this and it's working fine. So let's close this one, and now we can start working on our add liquidity, and now we can start working on our add liquidity script, and after that we're going to work on the check liquidity. So we have to modify this entire add liquidity script we have written into a connectable format, so the user can provide and create liquidity. So let's create this. So first thing we're going to do a couple of imports. We need web3 model, and that's coming from web3. Then we need the, let's say, contract ethers, and that coming from the ether package. Now we have to import the token, and that's coming from Uniswap SDK core. We have to import the pool, positions, and nearest usable tick, and that's coming from our Uniswap V3 SDK. Let's come down here, we're going to write the Uniswap contract addresses. Here I'm going with the demo addresses, but later we're going to change these addresses with the real one. So let's build the functionality, and later we're going to simply change the address. So we have all this address, and let's come down here. We're going to take our artifact, which we have inside this first artifact. We need this non-fungible position manager, and it's coming from the same place. So let me quickly write this. So here we have the artifact, we have the non-fungible position manager, and we have the Uniswap V3 Pro. So let's start working. Let's come on, we have to create a function, async function, and we'll say get pool data. So this function will allow us to get the data of the particular pool. So, and that pool address we're going to pass here. So we'll say pool contract. Inside that we're going to take a variable called tick spacing, fee, liquidity, slot 0, and it's coming from promise.all. And in that we're going to make the function call. So we have the contract, and on that contract we're going to make this function call. So first is going to be the tick spacing, second one is going to be the pool contract.fee, and third one is going to be the pool contract.liquidity, and the last one is going to be the slot 0. So these are the data we are getting from here, and let's come down here. We're going to return that. So the data I want to return is this tick spacing. It will say tick spacing, and now we have to take the fee, we have to ready, now we have to take the square price which we have inside the slot 0, then we have to take the tick which we have in 1, and that these are the data we are returning. And these are the data we are returning from this function. So let's come down here. We're going to take a function called export const add liquidity external, and this function we're going to attach in our front end to take the data and create a liquidity. So it's going to be an async function, and in that we're going to take this data. So first data we need the token address 1, second data we need the token address 2, third one is the pool addresses, because first the pool will get generated, after that we're going to use that pool to create a liquidity. So we have the pool address. Now we're going to take this pool fee, we're going to take this pool amount 1, that how much amount we want to provide as a liquidity. So that's amount for 1 token, and we have to take the other token first, second, and these are the data we are getting into this function. Now let's come here. Here we're going to build this const, we need a provider, so let's build our provider web3 model. Then we have to build the connection, await web3 model connect. Once we have the connection, we have to create the provider, and we'll call it provider web3 model. In that we have to pass the connection. So that looks pretty fine. Let's come here, take a signer, and we have get signer. So we have all these crucial important data which allow us to interact with the wallet. So we'll take a variable, we'll say account address, and we have to get the address of that account because we need to transfer the funds. So when we do the transfer of the funds, we need to assign the address where we want to receive the fund. Okay, so we have the address. Now let's come here. Here we're going to take this const token contracts, and now we have to get the token contract to get the information of the token which we can utilize to provide a chain IG symbol name. So we need information. So let's get the token contract, and we have addresses of the token. We already have the address, and in that we have to pass the ABI which we have inside this IEWTH9. So this is the package which we have installed, and that's what we have here, IEWTH9, and we're going to pass this provider. So that looks pretty fine to me. We have the first contract. Now let's come here. We'll take the second contract, and we're going to pass the token address 1. We have to pass the artifact which we have inside this IEWTH9.abi, and we have to simply pass the provider. So that looks pretty fine to me. Let's come here. Here we're going to take this await token 1 contract, and now it's time to get the data. So first we're going to simply connect the signer, and now we're going to make a call. So first thing we have to do is to approve position manager. So it's going to spend the token on behalf of us. So we have to provide the amount. So here we're going to provide the amount the user is providing, and we have to convert it into a string. I believe these things are making sense. This is a very generic function we are writing and function calls we are making. So this is the contract 1. Now we have to do the same thing for the contract 2. So we'll say contract 2, we're gonna pass this, connect the first signer, and then you have to approve the position manager address, and then we have to assign the amount. So which we have ether.utils.parse ether. In that we have to send the second amount and convert it into string. So these are the approval we are giving to the position manager. Let's come down here. We're going to create a const. we'll say pool contract. So we have the address of the pool. We're going to utilize that pool address to get the contract. So let's come here we're going to say contract, and then we have to pass the pool address. Inside the pool address we have to pass the artifact. So we have into this Uniswap V3 pool, and this Uniswap V3 pool contain all the information about the pools, and here we're going to pass the provider. So in this way we can easily able to get the pool contract. Let's come down here, we're going to take another variable, and that we're going to get the chain ID. So which network we are connected. So if you talk about mainnet, it's one. If you talk about Gorilla, Test, so they have different chain ID. If you talk about the local host, it's had different. So, and this data is coming from here. So we have a provider, and that we're going to call this get network, and this will give us the chain ID. So get network will return an array, and from there we are extracting the chain ID. So that's the chain ID we have. Let's take a variable token1, and we have to extract couple of information from the token, because we need the information of the token. To token we want to provide liquidity. So this is the first, we need the token name, and we have a function called, this is the contract we have, token1 contract, and in that we're going to call this name functions. This will give it the name. Do the same thing for the symbol. We have to give the contract, and we have to call the symbol functions. Do the same thing for the decimal point, because not all the token going to have the same decimal point. Some will have 18, some will have 9, some will have 16. Okay, so they have different decimal points. So that's why we cannot go with a hard code value. We're going to fetch the information on the base of the user selections and get the decimal data, so we can make the liquidity happen. Here we're going to call this token dot decimals, and now we have to get the address of this token, which we have inside this. So we'll say await contract dot address. You can simply get it from the contract, or you can get it from the functions where the user is providing these information, the token addresses. So that looks fine to me. Let's come here, do the same thing for the other token. Token 2, we have to get the name, and this data we have inside name, then symbol. We have to take this token 2 contract, and we have to call the symbols. Do the same for the decimal points. Await token 2 contract dots decimal point, and we have the address. So to address is token 2 contract dot address. So we got the address of both the tokens. So that looks pretty fine. Make sure to do all of these. Now let's come take a variable. We'll say token a, and here we're going to call the token function, which available in the SDK to get the information. And it's nothing new to all of you guys. We have already done this when we were building the script in the liquidity section, adding liquidity section. We are just modifying the data. So we'll call this new token, and in that we have to pass the information. So we have the information. First thing, we have to pass the chain ID, then we have to pass the token addresses, then third we have to pass the token decimal, then we have to pass the token name, then we have to pass the token symbol. So these are the data, it's must. And the reason why we are using this function, because we want to display the information in the front end. So this is the first token we have. Do the same thing for the other token. So this will become token B, new, and we have to pass the relevant information, chain ID, second token address, decimal point of the second token, name of the second token, and symbol of the second token. So that looks pretty good. So we have this information. Now we can come here, and here we're going to take a variable, say pool data, and here we're going to call the function. So get pool data. So this is the function we have created at the top, and in that we're going to pass the pool contract, and now we can easily able to get the data. So we'll say console pool data, so we can check. And now let's come here we're going to take this variable, we'll say pool, and we'll call new pool. In that we're going to simply call this token A, token B, and we have to take this pool data fee, because this pool data will contain all the information. Here we're going to say pool data square, and we have to convert it into a string. We have to say pool data liquidity, convert it to a string. We have this pool data tick. We have come down here, we're going to take a variable called position, and we'll say new position. It's going to be an object. Inside that we have to take this pool, we have to take this liquidity, provide this value. So right now I'm going with this hardcode value of the pricing. So I'm going with the hardcode value. If you want, you can make it this one is also optimized or a user input, but just go like this for a time being, and later we can definitely come and change it. So let's come here. we're gonna take this tick, lower tick, and we have to assign the lower tick nearest usable tick pool data. We pool tick spacing minus pool data dot tick spacing multiplied by 2. So, and do the same thing for the lower tick as well, so upper tick as well. So first we have done with the minus, now we have to do with the plus. So in that we're going to add it the same exact amount. So pool data dot tick spacing multiplied by 2. So it will be always in the range. So these are the information we are assigning to the positions. Now let's come down. Here we're going to create another variable. In that we need the amount, and this amount is coming from there. So we have this desirable, one amount, and we have this position dot mint amount. So this will give us the amount of the desirable. So we have this one. Now we can come down, we're going to take another variable, we'll say params, and we have to build the entire params which we want to pass to provide a liquidity. So let's come here. Here we're going to take a token 1, this will become the token 2, then we have to take this fee, and that's we have inside the pool data fee. Then we have to take the tick, lower tick, and the same nearest usable tick we have to assign. So ticks pool data spacing, we have to say minus, and we have to say pool data dot tick spacing multiply by 2. To do the same thing for the upper tick, tick spacing, and we have to simply go with the upper value, tick spacing multiply by 2. So this is the lower and upper tick we have. We have to assign the amount, desired amount is going to be the amount, convert it to a string. Do the same thing for the other desirable, number 1, sorry, and convert it to a string. Let's come here. Here we have to define the min is going to be a 0, and max min is going to be 0 for both the token. Then recipient is going to be the account address. So this is the account address we have taken at the top, and that's going to be the recipient. Let's come here, and we're going to say deadline. So this data is going to be, so right now I'm going with the hardcode value, but you can make it, this one is dynamic, but in the industry this is the recommended standard deadline time is assigned, so that's why I'm going with 10 minutes, not more than that. But later if you want, you can make it dynamic as well, but let's go with the 10 minutes. And that's the entire params we have. Now let's come here. Here we're going to take another variable, we'll say non-fungible position manager. So we have to get this contract, and we have this contract. Inside that we have to pass the address of the contract. So we already have it at the top, position managers. So right now we have hard coded this data, but we're going to add the real addresses. When we deploy the contract and get the real address, that's what we're going to assign. So we have this address, position manager address. Now we have to assign the artifact, non-fungible position manager, and we have the ABI in that. Let's assign the provider. So we already have the provider. So this will give us the contract of non-fungible position manager. Let's come down, and here we're going to take another variable, and now we have to make the transaction. So we'll say non-fungible position manager. We're going to say connect. We have to connect with the signer, and we have to call this mint function. In that we're going to pass this params, and we have to pass the gas limit. And this time I will go with this number, and that looks fine. Let's take another variable. In that we're going to take this recipient, and we have to say await dot, so we have to wait till the transaction get completed. Once we have this recipient, all the information about the transaction, in that we're going to simply return that from this function, and that's it. So we are done with this entire add liquidity functionality. So these are the hard-coded demo data we have taken for this contract, but we're going to replace with this actual one. This is the artifact we have, this is the pool data, this is the liquidity functions, and we have written so many codes. So hope this entire things makes sense to all of you. If you still have any confusion, any doubt, do let me know in the comment section. Now let's write the last and final script, which is this one, check liquidity. So first thing, we have to import couple of things, Web3 model, and that's coming from Web3, and then we have to import the Uniswap V3 pool, and that's coming from the packages we have installed, V3 core artifact contract Uniswap V3 Sol, and we have the ABI, which is a JSON. Now we have to import the contract Ethers, and that's coming from the Ether package. We have to import the pool, and it's coming from the Uniswap V3 SDK. Now we have to import the token, and it's coming from the SDK core. Now we have to import the ERC20 interface, and that's we have inside the context ERC20 JSON. So I hope you guys can make the sense that from where I'm getting all these values. So that's fine. Let's come here. Here we're going to create a function, async function, and that we're going to say get pool data, and that we're going to pass the pool contract, token address, and token address 2. So these are the two addresses of the token we're going to assign, and it will give us the pool data. So here we're going to take a variable, and in that we have to pass this tick spacing. We need the fee, we need the liquidity, we need the slot 0, and we need the factory, we need the token 0, we need the token 1, and we need the max liquidity per tick, and these are the data we need. So we're going to call this wait promise.all, and we're going to simply call this. So we have the contract, in that we're going to call all of these functions. So tick spacing, fee, we'll call the liquidity, we'll call the slot, pool contract.slot, we have to get the factory, we have to get the token 1, we have to get the token 2, sorry, token 0 and token 1. Now we have to get the pool contract max liquidity per tick, and these are the data we are returning. Let's come down here. We're going to take a variable called web3 model, because we need to get a provider, then we have to build the connections. So await web3 model dot connect, we have to get the provider, and here we're going to call this new ether dot provider dot web3 provider, and then we have to pass the connections. Let's come down. We're going to take this const token contract 1. Now we have to get the first token contract. So token 0 contract, we're going to call this, pass the address of the token, pass the ERC20, which is the ABA, and the provider. This will give us the token contract. Do the same thing for the other token. So this will say address to ERC20 and provider. So those two token contracts we have here. We'll come down here. We're going to call this chain ID, because we need to get the information, and for that we need to have a chain ID. So this chain ID is coming from provider dot get new network, get network, and here we're going to use this token, and here we're going to assign the token information to our token functions which we have imported from the SDK. So let's do that quickly. So we'll say const token 0, it's gonna be await token contract dot name. Let me write it very quickly. Let's come here. Here we're going to take a variable called token A, and in that we're going to pass this. We have to pass the chain ID, we have to pass the address, we have to pass the decimal point, we have to pass the token symbol, and we have to pass the name. Do the same thing for the token B. So these are the token A, token B we have done. Let's come down. Now we have to take this const pool example, and we're going to call this new pool, and in that we're going to pass this token A, token B, we have to take the fee, we have to call the slot string, liquidity string, slot 1. So these are the data we are passing into our new pool. Let's come down. Here we're going to take a return the data. So the data we want to return is the factory, and we want to return the token 1 0 and token 1. We want to return the max liquidity per tick. Now we want to return the tick spacing, and we want to return the fee, we want to return the liquidity, we have to convert it to a string. Now we have to import the square price slot 0, import the tick which we have in slot 1, import the observant index which we have in slot 2, and we have this observant credentiality slot 3, we have this observant next slot 4, and we have this fee protocol to 5, and unlock we have this 6, and at the end we're going to receive this entire pool example data. So that looks pretty fine, and now close this one. So these are the data we are receiving from here. Now we can come down. We're going to create another function called export, and this function we're going to call on the front end. So get liquidity data. In that we have to pass a couple of data. So we have to pass the pool address to get the liquidity data and the two token addresses, token 1, token 2, and we will get the data. So let's come here, we'll create a variable. We need a provider, so let's build the provider. So we got our provider. Now we're going to take this pool contract, and in that we're going to pass the data. So we'll pass the pool address, we'll pass the Uniswap V3 API, and we have to pass the provider. So we'll give it the pool contract, and in the pool contract we're going to call this pool data, and here we're going to call the pool data. Inside that we're going to pass this pool contract, so it will give us all the data. Okay, same logic we are following here. Pool contract, and we have to pass the pool address 1, and we have to pass the pool address 2. That's it. And let's come down here. We're going to simply return the pool data, and that's it. So here we have modified the entire check liquidity function. So now we can call this function in our front end. So hope this entire thing makes sense, because the same thing we have, so same logic we have follow here. We have done a major modification to make it usable at the front end, and token information can be fetched through this function. So hope this entire thing makes sense to all of you guys, and these are the major things we have done, and now we can start working on our context. We're done with that. So before we write any code in our context and do the modification, we have to do a little bit setup in our context. So here you can see, here we are getting all the contract addresses and the API. So this is the previous two token. Here we have the single swap, MultiHop, and this is the with address. Here we're going to import the contract. So remember we have created this contract. So what is this contract? So this is the contract we have created, user data.sol, and that's what we're going to build this and that's what we're going to export here. Okay, so we haven't deployed this contract, but let's build the system. Once we have that ready, all we have to do is to provide the address and it will work fine. So we can come here, we can say user storage data, and if I make any spelling mistake, please forgive me for that. Let me zoom a bit, and here we're going to call this export const, and I'm going to say that user storage data address, and here we're going to pass the address of the contract, and here we're going to export the API. Export const, and here we're going to say user storage data API. So right now we don't have that, but we have this function. So ready? That's fine to me. Now what we can do is simply come here, and that's what we're going to utilize it in here. So we can come here, we can close this contract, and here we can go to this API feature, because here we are building the connection with the contract. So if you come here, if you scroll all the way down, so these are the contract we have built that connections now. Here we're going to call that, we'll say user contra contract connection. Okay, and here what I'm going to do is I'm going to simply copy this one. So copy this part, and that's what I'm going to paste here. That's fine to me. Now if we come here, and here first we have to import the addresses, the two addresses we have here. So we're going to import this, copy that, and that's what we're going to import it here. And that's also this one, we're going to API user one, and that's what I'm going to import here. This looks fine to me. Now let's come here, and here we have to do the modification. So this is where it is. We have written so many scripts, you can see that. So this is the user section. Let me give this, and here I have to pass the address. So this one is going to be the API. Yes, it is an API, and now I have to get the address. We're just building the setup, and here we have the address. So that looks fine to me. Now I want to change the name of this contract, so let's do it. And here we're going to change the name. So this will become the, let's say, user storage, and let's make it, this one is contract. Make sure to do these major changes, and all you have to do is simply grab this one, and that's what you have to pass here. So here we have that. So in the API feature, you can see we have written so many scripts to connect with the contract, because we have built so many contracts. So that looks fine to me. Now all we have to do is to simply grab this one, and we can done with the setups. We're done with this part. Here we're going to pass the real API and the address, but right now we don't have that. So let's go like this. Come here, and here what I'm going to do is let's close this one and go to the context and go to the swap context. And now we're going to start working on the functionality. So first thing we have to do is here we're going to import the user. So this is the first import, the contract which we want to interact with, and now we have to import. So what I'm going to do, I'm going to simply reorder this. So let's bring this up. All the files import one side, and these are the APIs. So here we're going to import. So let's come here, and we close this one. Come back to the utils. Inside the utils, you will find we have all this functionality. So we have already imported this get price and user update price. Now we have to get the liquidity one. Okay. So first thing we have to do, come here, and we have to say import, and let's click on this liquidity. Okay, come here. What is the function name we have called? Okay, liquidity example. That's what I'm going to copy, and that's what I'm going to call here. And this coming from utils. We have utils. Inside the utils we have this add liquidity. So this is the one import we have. Now I have to import the other one, which is a, let's say, the second import I have is connecting with pool contract. Now we have the second one we have is the get liquidity data. So which one is that? This is the one. If I scroll down, where is the function? So this is the function. Where is the function? Okay, this is the function we have. Get liquidity data. Come here, and that's what we go to import. And this coming from that dash utils slash we have this check liquidity. Check liquidity. Now we can come here. We have to import our pool. So where is the pool? This is the pool. And what is the function name we have given?
connecting with pool contracts. Simply copy that one, and that's what we're going to import it here, and that's coming from /utils-pool deploy. We are working with so many scripts. Okay, so when you build an application like this, which is so huge, going with a different functionality, then this is how you should be architecturing. Okay, so these are the pretty good things we have done here. So let's come here. So we're done with this import. We're done with this utility imports. Here we have the API, and this is the context. And here we can come down. And here we will take another use state, and this use state will contain all the liquidity which a user will create on our API, on our application. So we'll say use state snippet, and here I'm going to take it. I'll call it get all liquidity. DIT all liquidity. I believe I'm writing the right spelling. If I make any spelling mistake, please forgive me for that. So here we have the data. In this, we're going to store all the liquidity which a user will create. And now, what I will do for the time being, here actually we're on the focus, and that's looks good to me. No problem we have here. Now we have to come back into the, and now we can start working on this get all liquidity data. Let's build the functionality. I know that there's no data into this, but let's build the functionality. So let's come here, and that's function we're going to create right up here. So right up here, right here, we'll say get liquidity, and this we're going to build the functionality. So first thing we have to do is we have to come down. We'll take a course. We'll say user storage data, and we already have a contract. We have to get the contract. We'll say connecting with a pool contract, connecting with a user, and what is the name we have given in our function? So let's come here. Here we have that connecting with user storage contract, and that's the function we're going to call it here. Once we have the function, let's come down here, and now we're going to take this data. Once we get that, we'll say user liquidity liquidity. We'll say await, and we'll say user storage data. So we have the user storage data contract. That's what we're going to pass it here, and we're going to call the function. So it's a const. const. So make sure you don't make this spelling mistake. And what is the function we have called into this? So this is user storage data, and what is the function we have into the contract? So let's come here into the contract, and this is the contract we are accessing. And to get the data, all we have to do is to call this get all transaction. So let's call this function, and that's the function we're going to call it. This will give us the data. This function we will call. This will return us the data, and now once we get the data, let's console log out. Console.log, and we want to log the user liquidity data. Okay, so this is the one thing we have to do. And what I want, let's do one thing. We don't need this. We don't need this anymore. Remove this one. Remove this one. It looks clean. So once we have the data, now what we're going to do is, and this data will come in the form of array. So let's do one thing. We have the data, user liquidity, and then we're going to run this map function, and it's going to be async function. So we'll say async functions element I, and from here we have to get the three important data. We need a pool address, we need the token address, and we need the token one address, and we have the data into this. So we'll say, let's say pool address. Now we have to take the element dot token address 0, and we have to take the another one which is a 1. So these are the data we are getting. Once we have the data, now what do we have to do? Can you guess? And this array will have the data. So what we can do? So const, and in that we're going to call this liquidity data, and here we're going to call the functions. So the function we have is get all liquidity. Get liquidity data. So this is the function we have, and we're going to simply call that. So remember, this is the function we have created. If we come up here, and you can see this is the function is coming from the check liquidity, and this will give us the liquidity data, all the liquidity data. So we have that, and then we have to pass the data. So the data we want to pass is element pool address. We have to pass the token address 1, and we have to pass the another one which is a 2. So these are the two data we're passing into this get liquidity address, and once we have the data will come right up here. Once we have the data here, what we're going to do is we're going to call this get all liquidity. So once we have the data in here, this is what we have taken here. Here we have taken a variable. So the variable we have taken this get all liquidity. So here we have get all liquidity. Come here, we're going to simply push this into an array, and we're going to push this liquidity data. So this is the data we're pushing. Now come here, and we're going to simply console.log the get liquidity. Hope this entire thing makes sense. So we are using our get liquidity data, and that we are passing, because get liquidity data function need these three address: pool address, token 0, and token 1. So hope this makes sense to all of you guys. If you still have any confusion, make sure to rewatch and try to understand what we are doing here. Okay, and these are the only thing you have to do into this fetch data function. Okay, so we are done with this function. It looks pretty fine to me, and now we can actually start working on liquidity. And now we can start working on create and add liquidity function. So we'll say, that looks fine to me. Let's bring the swap down here, and I'm going to write it down. So right now, I'm going to create a function. Let's say create liquidity and pool, because this function will do both things. It's going to be async function, and in this function we're going to pass a couple of data. So the data we want to take into this function is the token 1, the first token address. Now we need the token 2 address, and we need the fee we want to charge, and we need the token price 1, and we need the token price 2. We need a slippage, we need a deadline, we need the token amount 0, and we need the token amount 1. We're taking so many data into this function because our creating liquidity needs that. So hope this makes sense to all of you. Now let's come here, and here we're going to build the logic. So first thing we have to do is we have to take a try and catch. Otherwise, if anything goes wrong, we have to catch that error, and we want to simply console.log the error, log the entire error. So we'll say error object, and that's explained to me. Now let's come here. Here we're going to simply first we'll create the pool, because we'll create a pool, because if we want to add liquidity, we need the address of the pool. So we're going to create pool address first, then we're going to add liquidity. So let's come here. So let's say create pool. So we'll take a variable and say create pool, and we have await, and we have the function. So if you come up here we have the function. So where it is, this is the function we have created, connecting with pool contract. Simply grab that one, and that's what we're going to call it here. So we have the contract in that, and then we have to pass the data. So to create a pool, we need to pass data. And if you come here into the utils, if you into the utils in the deploy pool section, you can see these are the data we need. These are the data, 5 data we need, and these are the data we need to pass here. So let's come here, and with the first data we want to pass the token address. First token address, we'll pass the second one, and we have to pass the fee we want to charge, and we have to pass the token price. So we have taken the token price, and then we have to pass the token price to 5 data. Once we get done with that, now we have to set the gas limit which we want to spend for creating the pool. So here we're going to save it gas limit with close to, let's say, 5, and that looks good to me. So these are the data we are passing into this, and this will have the data once the function executes successfully. We can come here and we can take a variable, say const pool address, and here we're going to assign that create pool. Okay, hope makes sense. Now here we'll build the functionality for adding liquidity. So we have the address of the pool and we have the address of the tokens. Now we can create liquidity. So we'll say create like UIDITY liquidity. So here we're going to take this const, we'll say info will say await, and here we're going to call this add liquidity external function. So we have this function we have imported, and where it is. So add liquidity data, we have this function. So this function will create a liquidity, add liquidity. So let's come here, and here we're going to call and in this we have to pass the data. So the data we want to assign to create a liquidity, like the token addresses, token address 1, token address number 2, and we have to assign the pool address. Here we have taken. So this is the pool address we have taken. We have that information. Now we have to assign the fee. We have to assign the token amount 1, and token amount this. So this looks pretty good to me. And if we come here, let's make it this. Let's call it, because this ONT1 and this will come to TW2. So we can make the difference. Okay, this address, because everything started with T, so it's become quite confusing. So here we're going to pass this, and this will become 2. So these are the data we are passing into our add liquidity external. And once we have that looks pretty good to me. Now let's come here. Once the transaction went successful, we want to simply console log the info to see info. And now, once the transaction will be successful, we have to store the information of the pool address and the 2 tokens. So we can fetch that liquidity information. And we have already built the functionality. Okay. So what I can do here, I can simply come here. Let's come bring it down, and it will say add data. UID liquidity. Okay. Add data. That looks fine to me. Now come here, we'll take a few commands. We'll say user storage data, and we have to store the data. So we'll say await, and for storing that we have the function we have built. So let's come here, and here we have the function. So here it is, user storage data. This is the contract we have created. So now we have to get the contract. So this is the function we have. So if we come here, if we go to the feature section, here you can see this is the function we have built just now, user storage contract. So we already got this, and here we are importing that, and that's the function we're going to call right up here to store the user information. So let's call the function. In this way we can get the entire contract. Once we have the contract, we'll say user QU liquidity, and we'll say user, we have the contract, await, we have the contract, and here we're going to call the function. So the function we have inside the contract for adding the user information, let's check what is the name we have given to user storage data. Okay, this is the function that allows us to add the data. Come here, and that's what we're going to call. So this will return us the entire data, and in this we have to add the data. So simply come here, we're going to add the data like pool address, we have to add the token 1 address, and we have to add the token 2 address. That's fine to me. So we are adding the data. So what we have done in this create liquidity and pools, first we are taking this input from the user, then we are creating the pool address here, then we are assigning the liquidity because we need the pool address to create a liquidity. Once we done both the things, okay, we create the pool, we create the liquidity. After that we are storing this in the store user data, so we can fetch the liquidity which created by user. Hope this makes sense to all of you guys. These are very crucial things which you have to understand. Okay, and that's pretty much we have to do in here. Okay, so that's the only thing we have to do. So we have the data in. So now what we can do is we need this data, because this data, in this we have all the data about the liquidity, and that's what we're going to display in front end. So let's simply export that, simply export it here, and we have to get the functions we have created. So the first function we have created, let me close this one. Okay, now so this is the create liquidity with create liquidity and pool. Simply grab this one, and that's the function we're going to simply call here. Okay, that's it. Hope this entire thing makes sense to all of you guys. If you still have any confusion, do leave in the comment section, okay, because these are the very important things which you have to make it right. And that's the only thing we have to do. Simply close this one, and now we can start working and getting some real data from the front end.
Hey all of you, hope you guys are great. So in the last video we have built all the functionality to create liquidity, fetch data, all those things we have done in our context file. Okay, so we are almost done with this entire context file, and we have also done with the entire utility folder. We are done with the smart contract, and now what I'm going to do is I'm going to initialize the application, and we're going to do a little bit adjustment in our UI part. So let me show you what I mean by that. So first thing we have to do is I have to initialize the local node, otherwise it will throw an error and I would not able to connect my MetaMask. So just me wait. So here it's started, and I'm not going to deploy any contract right now. We're just going to first work on the UI part, and we'll make it a little bit responsive, and we're going to adjust the entire data. So we can come here and let me close this one. It will open the application, and here you can see the MetaMask, and here we are getting this error. Can you guess why we are getting this error? Because we are calling an address which don't exist. So to fix this, all we have to do is come here, go to this context, and here we have to comment these functions. So first we have to design the UI, after that we're going to connect that. So first simply close this one, and here we have the data. So what I'm going to do is, these are the data we have, the addresses we have taken. So right now none of these addresses exist. So here we are fetching all the information. So what I can do, I can simply grab this entire function, and whatever we have written, this is the liquidity, and simply comment this, and let's see why I'm getting this error. So this looks fine to me. Here we have that, and we have to comment this part as well, comment this one as well. If you come back to the application, and here you can see we got an error. If we reload the page, right now we don't have an error, the error is gone. Okay, so hope this entire things make sense to all of you guys. And let's click on this token, and if I click here, you can see we have the hard-coded data here, but we're going to use an API to fetch the pricing. But let's start working on the pool sections. So if we come in the pool section, here you can see right now the tokens are not displaying, but we have to make it responsive. So if I do in the responsive mode, you can see this is how it look. It's not responsive. So first we're going to make it responsive, and then we're going to attach all the functionality. So to do that, what I can do, I come back here, and I'm going to close this context, and first thing we have to do is to go into the component section, and not the component, page section. Inside the page we have this pool, and in the pool page we have to import couple of data. So let's start with here first. So here we are importing the account address, and we need more information. So let's come back to the context, and here we are exporting all that. So we're going to import the data. So the first thing we need is this create liquidity, and that's what I want. So I'll go back to the pool page, and here I'm going to pass that. I need this function, and I also need the token data itself. So I can come back to the here, and I can just give me this comment. So okay, so I can have that. I need the data, this token data, copy that one, and that's the data I need here. My niche is crying. So that's the data, and we have to get all liquidity data. So let's come here, we have the function called get all liquidity. So we have to get that data as well. Simply come here, and that's what we're going to pass it here. So these are the data we are getting from here, and now what we're going to do is we're going to create a new state. So let's come down, we'll take close pool. Initially it would be false. So the reason why I have taken this, that I have to show you the liquidity data. So once the user is connected, then only I have to show you this liquidity data. Otherwise I don't want to show that. So for that I have taken this one. And now I have to send the props into our add pool. So first thing we need is the address, the account address. So that's what we're going to send it here as a props. So this is the first piece of data we have. Now we have to send the set close. So grab this one, and the second one is going to be this set close. We're going to send that, and the third data we need the token data itself. So we already have the token data, so grab that one, and that's what we're going to send here, paste here. So that we have the token data, and we have to send the function as well. So this is the function we have for the liquidity. We're going to send that as well, add liquidity. Okay, so these are the data we are passing in here, and let me close that. So these are the data we are sending as a prop, and we can also send this one. So simply grab this one, set close pool, and that's what we're going to say send as a prop here. And we have to send the liquidity data as well. So let's come here, get liquidity, and that's what we can simply send here. And that's the props we are sending, and that's the only thing we have to do in here. Hope this entire thing makes sense. So here we are getting the data from our context, we are taking this state so we can say the display the dynamic blocks, and here we can, here instead of account we can change this to close pool, because this time we're not going to look for address, we're going to look for the close pool. Okay, that looks pretty good to me. Now let's have a look on the CSS. Let's see what modification we can do into this. So this is the pool page. Let's come here and let's go to this pool, and here the only thing we have to do is to add the media query. So we'll say media query, and this will become only screen. In that we're going to set the pool width is going to be something like, let's say, I don't know why my emit is not working, so we'll say width is going to be, let's say, 95% for a mobile device. And that's the thing, that's the only thing we have to do here. So we are done with the CSS. Now we can come back to the pool page. We'll start with this pool connect. So click on this, and in this we're going to receive the props. So if I come here in the pool and let's receive the props, copy that one, and that's what we're going to receive as a prop. Come back here and we need to receive this liquidity data as well. So right now we don't have, but let's set that. So that looks fine to me. We have this data. So we are getting this data. Come here, let me simply console log out. Right now we don't have that, but let me do this so we can see the data is flowing or not. So we'll say get liquidity, we have all the data, and this data is getting repeated when I was testing. So for that, to fix that, all we can do is we have already built the function to stop that repeating data. So we have these functions. All we have to do is to simply grab that one, and we can come back to this connect, and that's what we're going to utilize it here. So once we have that, simply copy this, and that's what we're going to replace and simply pass here. Hope this things makes sense to all of you guys. Still, if you have any confusion, try to understand what we are doing here. So that looks pretty fine to me. And here we're going to attach the function. So this is the function we have created, set close pool, and that's function we're going to call it here. So let's come here, we'll say on click, and on the click event I want to make this to true. So I want to open a liquidity component. So that looks fine to me. Now what we can do is, so let's come here, let's come to this, and here we are sending pool connect. We need the account as well. So simply take that one, and we can come here, we can pass the account as a props. So we have the account. Now that's what we can receive it here. Close this one token, and that's receive the account. And here we're going to display the dynamic block. So let's come here. Here we're going to take that, and we'll take this account. So we'll say if account is there, then we want to display this component. Else we want to display this component. So the component we want to display is this one. Simply cut this one and simply paste right up here. Hit enter and paste in here. So this is the component we want to display when the user is connected. But if the user is not connected, then we want to display this. But if user is connected, then we want to display this. So we can come here, and in that we're going to first take a div. We'll take a div. It will have a class, and the class name we want to assign is, let's say, style.box dash liquidity. So we have this. Inside that we're going to have another div. It will have a class, and in here we're going to take this style.poolConnect liquidity dash header. Inside that we're going to take a p, and we'll say your positions, and here we will display the data. And remember the data we have in this token list. This is an array. So here we want to display the length. We'll call say length. So it will display the length of how many liquidity this user have created. So that's the first thing we have to do. Now we'll come here, and we have the data. So we have this token data. This is the entire array we have, and that's what we're going to call it. We'll say map. It will be element/I, and we have to simply return straight away. And in that we're going to build the JSX which we want to display. So we'll take a div, and we have to close it. I don't know why my emit is not working. So this will have a class, and we have to take the class to be style, style, and let's call this class to be something like liquidity dash box. So this is what we can call to our div, and inside the div we'll have another div. It will have a class called style dot liquidity dash box liquidity dash list list. Inside the list we'll have a paragraph. Inside the paragraph we're going to take that, display the data. So before that data I'm going to take a small tag, and this small tag And this small style will have a class because we want to mark the, like we have to give a special style to our icons. So I'll say something like mark, and in this mark, I'm going to display the token. So we have this element dot, and we have the pool example. So this is the data will come in the form of. So we'll say pool examp of the example token 0 dot name. And if you don't know from where we are getting this, make sure to watch these scripts which we have written. So if you come into the utilities, we have written this script. This script we have written. So make sure to check this. It will make sense that from where we are getting this data. Okay. So let's close this check liquidity script and let's work on the JSX. So we have the data. We have the data now. I want to assign a space. So let's give the space now. Let's come down here. We're going to take another small tag, and this will have the same. And I'm going to replicate it because I want to have the second icon, and here I'm going to display the token 1, second token. This looks fine to me. Now let's come here. We have this space. Now here we're going to take a span, and this span will have a class. So generally we'll have a 2 class. So let's take it. We'll say style dot, and we'll say paragraph, and we have another class because I want to hide this in mobile device. So let's say style dot hid hide, and inside that we will display the data. So the data we have into this element dot, we have the pool example. So we have display the, and we have display the name. So let me grab that because this is what I have in the design which I have built, and in that I'm going to display this and this. Grab this and paste it. So hope this makes sense to all of you guys. If you still make any confusion, make sure to code along with me. Everything will make sense. Let's come here. We have to assign a space. Grab this one, replicate it, copy and paste, and this time we need to have only one class. And in this we're going to display the fee. So instead of putting all this, we can pass the fee. And the fee we have inside this. So we'll replace this, we'll say element.fw fee. So that looks pretty fine. So we are getting all the data which we want to display, and that looks pretty good to me. Now we can continue ahead. So here we are. Let's take another paragraph, and here we're going to display the range. So this range will have a class, and in this range we say style, and the class we want to assign is something like, let's say highlight, and this will have the text called in range. So this is the range. This is the range come out of the div, and we have to take another div, and this div will have a class, and here we're going to take our style. We'll call it something like pool liquidity dash list dash info. Inside that, we're going to take this paragraph, and this paragraph will have a small. Inside the small, we have to display the minimum price. So let's go with the hardcode value, and we'll say something like 0.999, something like that. We'll come out of that. Here we're going to provide a space. Come down, we'll take a span, and in this span, we're going to display the actual information, name of the token. So the name of the tokens we have here. So we have already taken that. So we grab this one, and that's. So if you visit Uniswap, this is how they have construct. So I'll say per, and we can provide a space, and here we can display the second token. So paste it, and here we have to change this to this one is 1, and this one is become 0, the first token. So that looks pretty good to me. And here we have to take a span, and in this span we're going to simply take the space, and here we're going to assign it. Take a small tag, and in this we have to display the max price, which is something like, let's say 1.000. Provide that. Once we're done with that, come down, we'll take a final span, and in that span we're going to have a class. This class will have the style dot hide, and it's hide not heat. Inside that we're going to display the same data. So simply grab this one, copy that, and that's what we're going to paste here. The 2 tokens. Hope this entire thing makes sense to all of you. SHIDE hide. And that looks pretty fine to me. No more problems we have here. If you come down, these are the buttons we are displaying, so no changes need to be done here. So that's the entire things. Come here, simply grab this liquidity, and that's what we're going to style right now. So go to this, go to the CSS file, and from here we can start writing some CSS. Let's call it new CSS. Inside that we're going to take this border 1 pixels solid, and we'll have our green color. Then we'll have the border radius GST height is going to be 0. So make sure to do this. This is the first one, and now we can come down, and here we're going to target the list. So this is the one we have here. No need to do anything in here. Target the list. Come back here. In here we're going to target first. We'll say display is going to be flex. We'll target justify. Content is going to be space between, and we'll take a line item is going to be center, and we'll make this line height to be 0. So that looks pretty fine to me. Copy, and that's what we're going to paste here. So things like good number we have in here. So that looks fine to me. Now let's come here. We have the one more plus mark, and this one will have the background color to be our primary color. Now we'll have the second color is going to be our second primary color. Now we have the padding 0.5 gram. We'll have the border radius will 0.5 gram. That looks fine to me. No more problems we have in here. So that looks good. Now we have to target the para. So we have the para in here. So we have assigned the para class. Para class, come here. Let's come down. We'll target the para class. In this way, going to say font size is going to be something like 1.2 gram. We'll make a highlight. So we have taken this highlight class. So is it highlight? Yeah, we have this highlight class. Copy that one and come here. Come down. We'll make it something like background is going to be our primary. Then we'll have the border radius will have 0.5 gram. We'll have the padding is going to be 1 gram from top and bottom and 5 gram from left and right. Then we'll have the color to be our second color. This looks good. Now let's add a media query so we can make it responsive. And we'll say media only and max. Width is going to be, let's say 35 em. In that we're going to take this height property. So the height class we have taken, and we'll say display is going to be none. Display none. That's the one. And now we're going to target the box info. Now we're going to target this. Now we're going to target this. And now we're going to target this. So we grab that one. We'll target box info. Come down here, and here we have to something Target that, and we have to, line height is going to be, let's say 1, we have to make it width is going to be 100% on a mobile device, and this will become the font size. Font size is going to be 0.8 RAM. That looks fine, pretty much. So we have written all the CSS, we have written. This looks pretty good to us. And so we close this one, close this. Current volume is looking fine to me. Now this is also looking good, and now we can start working on this add tool. So click on this add tool, and here we have to receive the props which we have sent, and here we have to receive the props. So let's come here. These are the props we are sending. So we need to have this set tool, get that one. That's what we're going to receive here. We need to receive all the data. So what's data we are transporting? So we need the token data. We need the liquidity function. So this is the function we have, create liquidity. That's what we're going to receive here. So these are the states we are receiving. Now what we can do, so these are the min and max price we have taken, and this is the new states. So in here we're going to take a couple of state variable, which the first one is going to be, let's say, use state snippet. We need to take the fee user want to provide. So initially it's going to be a 0, or fee, like, yeah, let's make it fee is 0, and we'll take another one use state, and this will become something like slippage. And the initial slippage I want to assign is close to 25%, because this is most of the transaction follow. We'll take another one, and this will become the deadline, and initial deadline time is going to be 10 minutes, but you can modify it. We'll have an option for that as well. We'll take a use state snippet, and in that we're going to take the amount the user want to provide liquidity. So we'll say token amount 1, and initially it will be 0, so we replicate that, and this will become 2. So I'm going to simply change this to 2. So these are the states we have taken. I hope these things make sense to all of you guys. And now what we're going to do is, now we need to take the token data, and as I can see, if we come here, if we go to this, close this one, and go to this home section, and here we have built the functionality already. So we're getting all of these data. So what I can do, I can simply copy this, and that's the same state I'm going to utilize it here. So I can come here, and I will simply, I can simply paste here. So here we have the token data we're going to take from the user. Okay, so we'll have the name, image, symbol, token balance, and the address to make the transaction happen. That looks pretty good. And that looks pretty good to me. And if you come here, these are the fee sections which we have defined. In that, I want to do a little bit modification. So the modification I can do is, I can say, come here, I'll say fee system. The reason why I'm taking this fee system and this fee, because this data is only for displaying, but this data will actually do the transaction. So 0.05% is equal to 500. Hope this makes sense. And do the same thing for the other. This one is 3, so it will become 3000 with 10, and it's actually a 1. 1%, so it will become the 40. So these are the only changes we have to do. Save it, and we don't need to need this function. Remove that one. Now open this function. Inside that you can see we have this, and here we have this arrow left. So here we go to call the function. So here we have imported this function set. So where it is, here we have got this close set pool, and that's what we're going to attach it. So when somebody click, we want to close the pool component, and that's what we're going to attach it here and say on click, and on the click event I want to close it down. So I'll turn it to false. So hope this makes sense to all of you. Just do the modification we are doing here, and this is the pool data, this is the clean, and instead of clean, what we can do is we can display the actual data of the token which users are selecting. Okay, users are selecting. So that's what we have here. Now what I'm going to do is, this is the image which we have. So instead of this, I can simply remove this text, and in that I'm going to display the token data. So I'll say token 1. I'm going to display the name. If we have the name of the token. If we have the name of the token, then display the name of the token. Otherwise, we don't want to display anything. That's the logic we are building here. And here we have to display the price, the token, and here we have to display the token balance. So we'll have the token 1.token balance, and we have to slice it down. Slice, and I want to display only 9 characters. So we'll start from 0 and we'll go to 9. If it doesn't have any token, then we want to display nothing. Hope this makes sense. We're not doing anything else. We're just following the simple thing. And here we want to assign the space. Let's provide one more space, and that looks fine. So we have this 2 space. Once we're done with that, we have to do the same thing for the other token. Grab this one, and that's what we're going to place here. And this time it will become 2. So this will become 2. I know modification is very hard. It always is hard. So we have this, the data for displaying. Now simply close here. Here we have the function. No changes we have to do in here. So come here, select price range, and this is the one. So we open this one, and in this we don't have to do any changes. So this is the pair we have, and we have a div, and on this div we have to attach function. So we'll say on the click event, we want to simply call this set open model, and I think we don't have that function. Okay, so we have the slippage. This one is let's call it 1, and this will become 1. So we bring it down, and this will become 2, and this one will become 2. Initially the value will be false. Simply grab that one, and that's what we're going to call it here. So where it is, okay, this one, and then we have to send it. We have to call it true because we have to open the model, and that's fine. And here we have to display the actual data. So the data we have into the token. So we have the data into the token 1 dot, and we want to display the name of the token. If we have the token, then display that token. Otherwise, display the default value, which is ETH. That looks good. Now we have to simply grab that one, come here, and here we go to do the same thing for the width, and paste here. This will become the 2, and this will become select. So that's the changes we have to do, and we don't need to do any changes in here, but we have to do changes in the fee list. So let's come here in the fee list. So here we are setting the active state. What I'm going to do is we're going to wrap it, and here we're going to take the fee the user wants to charge. So wrap it into the bracket with this comma. We'll call it set fee, and in the fee we're going to pass the data. So we have the data element, and in the data we have this system fee, because this is the fee we need to make the transaction happen. So we have the fee, and that's the changes we have to do. That's fine. This is the information we're displaying, and let's come here in the deposit amount. So in the deposit amount, here we have the input. In that we have to take it number, and the placeholder will define the price, the amount the user has. So what I would say in this, I'll say this token 1 dot token balance. Token balance, we'll use the slice, and we have to slice the entire number. So this is the placeholder, and inside this I have to add an on-click function. Sorry, on-change function. So add an on-change function because we want to get the data. So we'll say, and we'll call the function set token amount 1, and we have to simply pass that. So e.target.value. So we have the amount which user want to do the transfer. So simply copy this entire info and do the same thing for the other input. So this is the second input we have. Second input we have simply replace this one, and here we have to do the changes. So instead of token 1, we have to call it this 2, and this will become 2. So this will update the data. Now we have to remove this one. So that looks fine. And here we have to change that. So this is the first one. In this we're going to display the token 1 dot name. If you have the name, otherwise we're going to default is ETH. And here is going to be the full name. So in that we're going to assign the space. We're going to assign the space, and here we're going to display that data. So we have this token 1 dot symbol. If we have, otherwise we want to display Ether. Hope this thing makes sense to all of you. And we don't need to show the balance because we're already showing the balance in the input field. So simply remove this one, and that looks fine to me. Simply grab this one and do the same thing for the other token. So we don't need this. Replace this one, and here we have to change this to token 2. Select this one, make it 2. And instead of this, I can display the, let's say, here we can say city select. Okay, that looks fine to me. No more problems we have in here. So this is the input component. Come to the right section, open this one, and here we can see we are displaying the current price. So right now we don't have the current price. So what we can do, let's add the token first. So we'll say token 1 dot name, and we'll say default is going to be ETH. And here we're going to say grab this one, copy and paste. And this will say ECT select. And this one is the second token. So we'll say 2. So that looks fine. Right now we don't have this hardcode value here. So this is the right sense, looks good to me. Now let's come to the price range. So this is the price range. What I can do is I can simply get rid of this prices because we don't need it. Instead of this, we're going to take this like input field. Take an input field, and the type is going to be number because we are taking a number. Now we have to set the, let's say, placeholder. So the placeholder will something look like this because this is what the value I want to display. This is the placeholder. Then we want to set the minimum value. So min value is going to be something like this. So it will start from 0.00 because you should provide options like this. And the step I want to have is, so I don't want to increase 1, 1, 1, 1. So I don't want that. I don't want that behavior. So for that, I want is to go like this. Both options the user will have. So it go into the decimal or it go in all form as well. And it will also have a class. So let's assign a class. So we can say style dot pool add box dash price left dash range. Okay, so that's the class we have assigned to this. Now this class will also have an on-chain function, so we can check the value. So we'll say it will say this e. Now we have to take the value to this, so we'll say e, and then we're going to call the function. So we'll call set min. First we are taking the min price, and in this min price we're going to set the value. So we'll say e dot target dot value. So we got the first input. Now simply grab this input, copy this input, and that's the same thing we have to do in the second input. So here we're going to simply remove that, and here we have to set the, let's say, set max. So it will set the max value. Hope this thing makes sense to all of you guys. If it's still you have any confusion, make sure to rewatch. And here I'm going to change the name. So this will become the token 1. So we'll say token 1 dot. We have to display the name. If we don't have the name, then we want to display this. Default value say ETH, and this will become something like, we'll say token 2 dot name, and we can go select. That looks pretty fine to me. Now so we grab this one, copy, and the same thing we have to do in the other part. So we scroll down, and here we have to replace that. So that looks good. It's looking perfect. I think we are now going. I think we are growing. So that looks perfect. So that looks perfect. We are doing all the modifications now. We can start working on the button. And this button is going to be really huge. So you can see this is the called full range. So we have the button. We have the button. I don't want to have 2 buttons. I want to have 1 button. So let's remove the 1 button. And here we have the 1 button, right amount. And instead of enter amount, I can say add liquidity, because that's what we're going to do. Liquidity. Okay. And on this liquidity, in this button, we're going to attach the function. So we'll have the function on click, and it will have the function. It will have the create liquidity function we have created. So what is the name we have given? So if we come up here and you can see this is the function we have imported, create liquidity and add pool. So we grab that one, pass it here, and that's what we're going to simply initialize that. So that looks good to me. Where it is, where we have the button. So here, okay, let me scroll down, and this is the button we have now. So we can pass it here, and here we're going to save this. So we have to send the data in the form of object. So let's come here, let's send the data. So first data we want to send is the token 1. So we'll say token, we'll say 0, and in this we want to send the token. So we have the token, we have the token 1 we have, inside the token we have the token address, and then we have the token. And then we have the token address. This is how we have constructed the data. Okay, so that's fine. We have our first token. Now we can simply replicate the second token. This is the token 2. We'll say 2, and this will become 1. So this is the 2 token. Now we have to send the fee. So we have the fee inside the fee. Now we have to send the token price. Token price price 1, and this token price 1 we have inside this min price. And we have this another one is the 2, which is a max price, and this will become the 2. So the 2 token prices we have now, we have to get the slippage. It will take the slippage, and we have to pass the slippage. We have to pass the deadline, and we have the deadline. So the deadline is there. Now we have to set the amount of tokens. So we have the amount, token amount 1, and in that we have to set this token amount 1. This will become the token amount 2, and this will become token amount 2. So these are the information we are taking for creating the liquidity. So hope this makes sense to all of you guys. And let's scroll down, and here we are. In this we want to send data. So this is the first token we have. First thing we have to set is we have already sent this prop. Now the second thing we have to send is the set slippage. So we want to take the slippage data. We have to take the slippage data from the user input. So that's the function we want to send here. So we'll say set slippage. That's the one we are set. Now we need other thing, and we have to take this slippage as well, because we want to display in that puts this slippage the user is providing. So this is the slippage. We have to take this deadline. Now we have to take the set deadline,
we have to check send deadline. So these are the props we are sending into our token to get the information, and now we have to send a couple of information in the search token as well. So first data we are to send that we are sending this token data, and we have to simply remove this. If we come here, we have taken this tokens. So if we come here, here we have taken that. So this is the function we have to call it. Grab that one, scroll all the way down, and this is the props we're going to send into the search token, so we can get the information about the token. So you can come here, and here we're going to say TOKENSQ tokens. Don't forget to add the S, and that function we're going to send into this for the token 1. Now we have to get the token data. We have the token data, and then we're going to send the prop. So in this, we're going to send the token data. So token data. So the token data we already have it here. If I come up here, we have written so many codes. So this is the token data we have, and that's what we are sending here. So let me come down all the way down here. So that looks pretty good to me. These are the two props we are sending. First we are sending this, then we are sending this, and we need one more component. So here we have to do the changes. So you can see this is the open model, which is absolutely good, no problem in that. But if I come here we have taken this open model 1, open model 2, because we want to take two such component. So here we're going to say open model 1, and that's what we are passing here. So in this we're going to say set open model 1. So let's come here, what I have called. So we have this search open model, that's what we're going to call it, all the way down, and search open model. So this is for opening the model 1, and simply grab this one, and we're going to replicate one more time. So this will become the model 2, because we are displaying two token component, and this will become the, so we'll take this and we'll say 2, and here we have to say 2 as well, 2. So that looks fine to me. Make sure to do these major changes, otherwise it won't work. Now we can come back. So that looks pretty fine to me. But before we go into the search component and token component, let's do the modification in the styling, because we have created a couple of things. So this is the add pool add. Let's come here. We can go into this pool add CSS, and here we go write the CSS to do the little modifications. Okay. So let's come here. Let's call it new CSS and comment this. This looks good. And in this we have to do the changes. So let's start this one and bring it up here. And here we have to do the couple of changes. So first changes we have to do is position is going to be absolute, and we have to assign a background. So the background is going to be something this, our second primary color. Then we have to assign an insert, and this will become, let's say 0, 0, 0, 0. So everything 100%. Then we have to say display is going to be flex. We'll have the justify. Content is going to be center, and we'll have the align item is going to be our center. And the last one is going to be the border. Border 1 pixel solid, and we'll have our primary color. So that's the changes we have to do in the token class. So this is the class we have taken. So if you come here, we are adjusting this token class, this token class, and this token class. That's what we are styling. Come here. Now we're going to target this. So now we're going to target this. The input field we have changed. So this one, and that's what we're going to copy. Come here, and that's what we're going to target. So we'll say. So this will be, we'll have a background color. Our primary color will have the border is going to be 0, outline is going to be 0, and we'll have the width is going to be 80%. We'll have height is going to be 2 RAM. We'll have padding is going to be 0.2 RAM and 1 RAM. Then we'll have a border radius is going to be 0.5 RAM. That looks very fine. These are the changes we have to do. Now it looks good. Now let's come here. We have to write the media query. So we'll say media only, and we have to assign the classes, and we'll say max width. We're going to 35 here. So that looks good to me. Now first we're going to target this pool price dash price. Okay, let's see, we have assigned the right one. So we have this is the one we are targeting. Copy that one and scroll all the way down here. So that looks pretty good. Okay, right in the right class. First we say display is going to be grid. We have the display grid, and now we have set the grid column is going to be 1 FR. That looks good. Come here, we have to close this one, otherwise it will throw an error. So that looks good. Now we have to get the token box dot price dash left token info. Inside that, we'll say display is going to be flex, align item is going to be center, we'll say gap is going to be our 1 RAM, and background color is going to be our second primary. Border radius is going to be 0.5 RAM. We'll have the color is going to be our second primary color, and we'll have the padding is going to be 0 and 0.5 RAM, and font width is going to be 700. So that looks pretty good to me. Come here, and now we have to grab the token. So simply do one thing. This is the token we have taken. Grab this one, copy, and come down here. And that's what we're going to trigger now. So we have this positions, we'll have the background color, and the rest of the property will be the same. So we're going to remove this align item, this one, and here we have to do the adjustment. So I want 50% here. I want to decrease the height. So I want it to 2%. I don't want to create any conflict. And that looks pretty good. And these are the major changes you have to do to make it responsive. And that looks pretty fine to me. That's the CSS. We're done with that. So we close this one. And this is the one. This is the component. And now we can start working on this token model, because these are the components. These are the data we have to receive here. So simply click on this. And here we are receiving the props. So let's receive the props very quickly. So this is what we have to receive: slippage. We have to receive the slippage, set slippage and slippage. Both the one we have to receive, and we have to receive the deadline, and we have to receive the set deadline. Okay. So these are the changes we have to do. So we grab this one. Grab the slippage, come here, and here the user is going to be setting the slippage. So this is the input field. So here what I'm going to do is, in the placeholder, I'm going to define the slippage. So I'll say slippage. No, not a replicate one. So I'll simply copy the slippage, and here I'm going to define the slippage in that. So where it is? Here, in the placeholder. And it will have a on change function, and in this I'm going to take the slippage data. I'm going to set the slippage data which user want to provide. So slippage. And then I'm going to simply say e.target.value. So I'll get the slippage which users are providing, and here is the slippage. So this will be the, let's say, DEAD, deadline, time. and I have a input. So this is the input I have. So in this placeholder, I'm going to display the deadline, and here I'm going to call the deadline function. So we'll say on change e, we'll say set deadline, and then we're going to simply set the deadline target dot value. That's fine. Okay, hope this makes sense to all of you guys. So we are getting the slippage, we are setting up the slippage, and we are doing our stuff. And here we are already opening and closing this. So this is good. We have set the value. Now we can close this one, and now we can start work on this search component. So here you can see we are receiving this couple of data. So do one thing, click on this search component, come here, and here we have to receive the data. So we are reading open token. So let's see what's the data we have passed in open token. It's K. Then we have this tokens, and that's what we have passed tokens. And let's come here, and here we have the token data. So we copy that one, and that's what we have passed here, token data. So that looks good. That looks good. That looks good. Hope this makes sense to all of you guys. Now simply close this one because we don't need this pool data, and here we have to do the modification. And here you can see here we're getting the token data, then we're replacing it, and then we're simply displaying here. And here we are sending all the data from the token. So make sure to do this major changes, and that's it. Things are looking fine. So we have done the changes, all the changes right up here. So if we come back to the browser, I know we got an error, so that's not a big deal. So this error is happening because we don't have the data, and the data we try to log. Okay, so we don't have the data. So let's simply comment this out. So this looks fine to me. Close this one, and that error is happening into this. So if we come here, this is the correct one we have. And what I can do is, and here we have the add pool. So let's click on this pool connect, and the error is coming from here. So this is the place where we are getting the error because we don't have this data. So what we can do is, for the time being, let's clear this one and close this, and simply comment this one for the time being. Comment this, and you can see this is the border. So we are getting this error into a CSS file, which is module pool connect. So this is the error we are getting. So let's come here, and we have to get into this pool, and this is happening in line number 61. So where it is, here we are having the problem. So you can see this is the error we are getting. So we come here, and we can say border 1 pixel solid. We will have our this color. If we come here, into the browser, and you can see we will have no error. You can see everything is looking good. We have no error because we have simply comment out this portion because here we are displaying the data, but actually we don't have it. So if we come here, if you click on this, you can see here we got it, and actually we don't have the data of these token 1 symbol, and we are trying to display that. So token symbol is not a function. Token 1 is not a function. Okay, let's see where we are getting an error. So let's come back to the close this one because we have no more issues in this. We have no more issues in this. So we have the problem in here. Click on this, and we are getting an error from here. So line number 196. Where it is, here we are, 196. So this is the error we are getting. Is okay, my bad, it's not a function, so we remove this, it's a data. So save it and come here to the browser, and you might have everything's working fine. You can see if you click on this, here we are, and still we are getting an error, and this error is coming from placeholder. So line number 224, line number 204. So this is coming from here, 204, place, token, and placeholder. Okay, here it is spelling this in, is token, T-O-K-E-N. And this looks good. Number error we have now, come here into the browser and see the change. That looks good. Click on this. Here we have the problem, it's a symbol. Okay, my bad, I have called this symbol. And let's see what else changes I need to do to make things working. Okay, I think that was the only problem we had. Let's give it a try, and you can see right now it's working fine. Okay, if you click on this, we can go back. If you click on this, we can come. If you click on this, we have this, and here we will display all the tokens. If you click on this, we can close. If you click on this, it says that set open token model true. So set open token model is not defined. Okay, so we have a problem in here, so we can fix this. Not a big deal, we can easily do that. So it's coming from 120, it's coming from add pool 120. Add pool 120. So add pool 120, come here up. 120 add pool. Okay, this one is not defined. So here we have that, and here we have to choose the changes. We become 2. And that looks good. If you come here, let's have a look one more time. You can click on this, you can open that, you can select the token, yeah, close it, you can select this, and you can close it. If you click on this from here, you can easily get the data, the last one fine, and right now we don't have that pricing, so it's displaying nothing. Okay, this looks fine to me. You can increase, you can decrease, and you can see the pricing is in, you can pass 1, or you can give the value in decimal also. So that looks fine. Everything's working fine. So let's come here, come to the code. So things are looking good to me. Now, what we can do is, now we can deploy it. So let's close all of these, and let's see the responsiveness of this token. So if we can make it responsive, and let's see how it's look. You can see it's 100% responsive. Right now we don't have any data, so you can see the error is at 0. It's nothing there. If you click on this, it's 100% responsive for mobile device. You can click, you can search it, you can search the token, you can open the slippage, you can switch it on, select the price range, and things like that to me. But things will look even better when we have the actual data. So everything's looking good. Now we can simply come here and close this one, and now we can start deploying the contracts we have created. Okay. So if we come down here in the script section, so we'll start with this contract, and then we'll create the token. So open up your terminal and stop the application from running. Hit enter, clear your terminal, come here, close it, and clear your terminal. So first thing, we have to delete this artifact. So we'll type npx hardhat clean. Okay, it's clean. Now we have to run the internal blockchain. So it's running. It's running, no more problems we have so far. Now click on this, here we have initialized that, click on this, and here we have to run the scripts. First we have to deploy the contract, this Uniswap contract, we'll paste here and hit enter. And just wait, it's look good, it's compiled successfully. Here we got the token, just wait, and here, boom, here you can see we have all these addresses, Uniswap contract addresses. So what I'm going to do is, let's come back to the deploy token script, and let's keep it from here. Okay,
Okay, so that looks good. That's look good. Now what we can do is close this one and come back to the utility, because in utility we have this deploy pool, and here we need the address, this two addresses. You can see this is the two address, v3 factory and non-fungible manager. So first we have to get the v3 factory address, and that's what we're going to replace. But this time I got the same addresses. This is the non-fungible manager, where we have it manager. Simply grab that one, and that's it. So we got the addresses, so this one is ready. Save it. Now simply clear it, and now we have to create the token. So to create a token, we have this is the script we have to initialize. Save it, and let's simply paste that. But before we deploy the token, I have noticed that I forgot to do the changes. So if we come to the deploy, because you have noticed that we have done the modification in our token contract. So if we come here, the newly token contract, here we have done the modifications. So we have to do a little bit modification in the deploy token as well. So here you can see, here we have to do the modifications, then we can deploy that. And here we have to do the modification. So what we have to do is we have to simply remove this, because right now we don't need to pass anything, because that's what we have initialized in our contract. So if I come here, if I show you the contract, you can see this token has the number of token we want to generate. Okay, so simply copy this, and that's what we can into here. And first thing we have to pass this pop. Okay, things are look good to me. We don't need to pass the owner, because I'm going to be the owner because I'm deploying it. Same thing I have to do from here as well for the RAN token and for the Schwab token, and that looks pretty fine. And these are the only changes you have to do. Right now we don't need the signer, and we don't need even the owner, but let it be there. Okay, let it be there in case in future if we want to do any third-party transfer, so we can utilize it. Okay, so that's the changes you have to do before you deploy the token. Now simply copy that one, open up your terminal, and here we have to simply deploy the token. Close this one, and here we got the token. The token address is simply copy that and come to this script first and deploy, and here we have the addresses. First we're going to keep it here, and close this. Now we don't need this scripts. Now we can to work on this. So we have these addresses work fine. So we can come into the first thing. So this is the deploy pool. In this we only need this one. So we'll come back to the context, and in the context what I'm going to do here, we can see that here we have the addresses. So instead of these addresses, I'm going to simply remove it. I'm going to simply copy it, and I'm going to replace that. This is the one token, this is the second token, and this is the third token. We have the tokens. Now simply grab this one and remove it. So we got the 3 token which is there. Now look fine to me. So this looks good. Bring the terminal down a bit. Here comes down, and here we have to simply uncomment these portions, because right now things are looking good, so we can fetch the data. So uncomment this part, and we have to uncomment this section as well. So this looks good. The function will work absolutely fine, no more error we'll have. But I have to deploy one more contract. So if we come back to this, close this one, come back to the script and come back to the deploy, here we have this user contract. Okay, so we have to initialize this contract as well, because we are storing the information of the liquidity into this. So let's deploy this one as well, and then we can check. So this is the script we have. Let's open it up, and we'll get address. So we'll have to run the script. We'll say deploy deploy.js, deploy the JS, hit enter. So this will deploy our user contract. Hope everything's good. Yeah, everything's good. Simply copy the address and come back to the context, because here we have already not contract, component, context and constants, and here we have to provide the address. Hope you guys haven't forgot that. Now come back to the artifact. Inside the artifact we have the ABI of the user contract. Simply drag and drop here, so we can utilize it, move it. So we have in this, and now we can simply import that. So we'll say import user store data, and that's coming from, so we have this user store data. So we have the ABI, simply grab that one, and that's the ABI we're going to pass it here, dot ABI. Make sure to do these changes, these values. Now simply close this one, close this one, and things will work fine. Close this all files, and now we can initialize our app. So come here, we'll type npm run dev, hit enter, open into a local host, and here you can see everything is working fine. We have no errors in our applications. Let me do the console log and let me show you. So if I come here and if I see in this, you can see everything is working fine. We can reload the browser and things look good to me. Now we can do the transaction. So before we do the transaction, let me clear the history of the MetaMask, otherwise it will throw an error. So you can see I have already done this. Click on this and I will clear the settings, go to the advanced. I have to clear this account reset and I have to reload the browser. Now I will go into the pool section, because here we're going to take the inputs from the user. Click on this new pools and come here and do this console. So this is what we have, and now let me show you that the data is coming. So what I can do, come here, come back to our app, bring the terminal down, and if we come back to the context, so we are already into the context. So what I will do, let's minimize this function. So this is the create liquidity, and this is the function we're going to utilize it now. So now what I will do, I will simply come here, I will say console.log to see the data we are getting or not, and that's all the data we're going to take here. So we're going to simply log the data and then we're going to call it. So let me comment this before we make the actual call. Comment this, let's see if we don't have an error. No, let's come here and you can see we have no more error. So if I come here, if I click on this, and if I come here, you can see this is the 3 token we have created, Ryan, Schwab and Pop. So everything is working fine. If I click on Schwab, and that's Schwab is there. If I click on this Pop, so I can create a liquidity in these 2 tokens, and you can see the token data is also got updated. I have this much Schwab and I have this much Pop. From here I can easily able to select the fee. So I want to go with this 3% because this is the recommended in the industry. You can see the name and the symbols are displaying. So here I'm going to take this, let's say 5 for 50,000, both the token. So this is the token, and from here I have to set the minimum maximum price. So if I pass this 1, I'll go with 1 because this will be always in the range. And if I click on this add liquidity, and here you can see I got the data. So somehow I didn't got the data of the token, so but I got the data of the fee, price and the slippage and the time. But let's see what's the problem I'm having in this, why I'm getting this undefined. If I click one more time, still I'm getting the same data. So that's the problem we have. So the problem, the data is coming from we have the context. So we are providing these data, amount 1, amount 2. So the data is coming from the pool page. Come here, go to the pool page, and here we have that, and here we are calling the function. So where it is, okay, we have written so many things. So we have the token 1, so we are not getting this data somehow. So what I will do, I will simply come here and save it, and let's try to make a call. And you can see the price, the token balance is also displaying on top here of the 2 token. You can do on a mobile device, you can hide it, but you can show it as well. So if I click on this add liquidity, and still I'm getting this undefined. Why it's happening like that? So if I come here and somehow the token data, is not coming here. This token 1, token 2, so let's not coming. So we have to go into the search component. So let's scroll down. This is the search component we have, and here we are sending token 1 Here we are sending token to. So let's go into the search component. We have this tokens, we have this token, we have that, come here, and here we are taking that. So we are taking this address, we are taking this. So it looks fine. I don't know why it's not getting it. So we have this, taking this information, this balance and the addresses. So if I call it one more time, I'm not getting the amount as well, this amounts. Okay, so let's come here. So this is the address one, copy that, and if I come to the add pool, there I'm sending the data, address, amount on, sorry, it's address. This become address 1, address 2. Okay, address 1, address 2. We have the fee, and if you come to the context, we have said amount 1. Maybe this is the issue. So that's what we have here, and I have the slippage deadline. I'm getting this, I'm getting the price, I'm getting the fee. So I'm getting all these 5 data, but I'm not getting the input data. So these 2 data is not coming, and these 2 data is not coming. So if I come here, so if I do this console.log, and in that I pass this token 1. If I open this one, so right now you can see I have this data. So somehow the image is undefined, not a big deal, that's not what I want. So inside that I have this token address. So token 1 can so working fine. So I can come here, we have this token 1, inside that paste, and we'll have the another one. That's how I'm accessing the data. Do the same thing for the token 2. This is the token 2. If I simply grab this one and if I pass it here, and let's see what data I get. I'm getting address. That's weird. So I'm getting the address, but why it's not working here? That's right. Now what happens, let's reload the browser. Let's reload the browser and let's try to set it. Click here. From here we can select the token. I'll go with swap. I got it. I'll go with this pop. I'll got it. Here I will set the 1%. Here is the display balance. I'll go with 200. I'll go with 200. For here the pricing is going to 1 and 1. And from here you can easily able to set the slippage, but I'm going with the default slippage value, 20% and 10%. That looks good, and I will click on this, and this time we have the data. You can see we got this, and this price is undefined. Okay, let's see what's the problem we have. Now let's come here. So it's working. There may be some little issue into that. So let's come here, save it, and this data, all the data is coming, but the only problem we have in this last one. Okay, so this one is 2. Okay, that's got it. Now reload the browser. Let's test one more time before we make a call exactly. So click on this, select the token Ryan, select the token Schwab, select the pricing. This is going to be 200, 1, and click on this, and boom, this time it's work. You can see we got the 2 token address, we got the fee, we got the pricing, we got the slippage, we get the time, and we got the tokens. So things are looking good, everything's working fine. Now the transaction will happen. So close this one, close this one, close this one, And here we are. Now we can simply make this happen. So let's make the transaction. So come here, come to the browser and reload the browser. Reload the browser. Click on this. Here we have to select the 2 token. So before we do that, we have to make our MetaMask history clear. Otherwise, it will throw an error. So let's do it, because I was encountered this error a lot of time, and that's why I know it's going to fail. So if I click on this, I can come here, I can select the 2 tokens, pop the 2 different tokens we have. Let's select the fee. This is the fee, and I want to assign, let's say, 1,000 equal amount of liquidity. Set the price to minimum price 1, and maximum is going to be 1 also, because I want to keep into the range. So fix 1. Click on this, and here you can see the MetaMask got open. Here we got the details, and here you can see we are initializing our create and initialize pool. It is necessary. Click on this confirm, and here it's got failed because we have to do the changes. So it's generally happening, there is no problem in the code, it's happening because of the sometime we have to restart the application. So I knew it was coming. So come here, close this one, close all these open files, and that looks good. Okay man, come on. Now we have to restart the application because sometime it's happened. Clear the artifact, clean, stop the application from running, and here we have to simply start the local blockchain. Now we have to initialize, deploy the contracts. So first thing is going to be our Uniswap contract. Hit enter. I guess the address should be the same. So let's see, the address are same. Yes, we got the same addresses. So let's deploy the token, and the token addresses will be same. Yes, it is same, the address. Now we have to deploy the simply our deploy script, and let's see what was the address, and the address is same, so we don't need to do any changes. Okay, now we can start the application. npm run dev. Click on this local. Here you are. So this is nothing problem with the code. It's happening because of the RPC URL, and sometimes it caused by MetaMask. Okay, so there is no problem we have in the code, and that's you have to keep in mind. So make sure before we do the transaction, we have to clear the account history, and that's why I keep clear my history. You can see the transaction went fail, and here we have to call not the contract. Here we have to call this, and the transaction wait. Come here, and now we can make a transaction. Come here, we can pass the no, not this. So we have to go into the pool section, create a pool, do the side by side so we can see what we are working on. Now we can simply select the token, this one, select the other token, we can select the fee, so we'll go with this 3, select the amount, so we'll go with 200, we'll go with 200, and here we can select the min and max, so 1 1. Click on this, enter. The data is working fine, we have the data, and just wait, it's look fine to me. Click on this confirm, and boom, here you can see right now we don't have error. So sometime it will throw an error. Make sure to restart the application, clear entire artifacts, and everything will be fine. So here we are giving the permission to Uniswap smart contract to take our token, so click on confirm, and here you can see this is the second one we have, cause we have 2 tokens. So this will again we have to give the confirmation of this Ryan token, so click on confirm, and it will have another contract. This will create the you can see we got the data, and here we are calling this mint function, so it will make the liquidity. Click on this confirm, and we'll have one more pop-up, and this pop-up will store the data of the liquidity we have created. You can see we got the transaction log, transaction went successful, and here we are interacting with the contract to store the data into our smart contract about this liquidity. Click on this confirm, and boom, the transaction went successful. If you click on this MetaMask, you can see, just wait, you can see the transaction went successful. We have called this all method: initialize, approve, mint, and creations. Now if you want to see that whether the data is gone, so we can find that very easily. So we come here, and here we're going to display, and here we are displaying all the liquidity. So if we come down, go to this, and remember this is the component we have. So we have this connect component, and in that here we have comment this. So we're going to simply uncomment this because we have the data right now. You want to expand this, and things looks fine. Come here, and you can see here we have an error, and this error is happening into the token.list, and here we have this dynamic block. This is the one we have the div, and then we have taken this, and it's better to do one thing. So we're gonna simply close this one, and we have the data. Simply close this one, and if we try to console log out, console.log, and we see that what data we are getting. So right now we have one liquidity we have created. So come back to the browser, and if we do the console log, you can see the data we are getting. You can see this is the one data we have in. If we click on this, this is the one data we have. This is the entire data we have. So in this we have this example, in that we have all the data. So we have the factory fee, the liquidity we have provided, this much liquidity. We have the max liquidity price. So all the data is working fine. So let's come here, make it side by side so we can see what data we have to assign. So let's come here. Here we can see that. Let's expand this. Make it zoom a bit. So here we can see, so we are TokenList. In that I am accessing this data. So example, so this is the name I have given. Simply copy that, and that's what I have to say here. I'm going to select all. I'm going to replace that with this. Replace this all. So no problem we have into this. Now if I open that, if I open the pool example, inside the pool example I have with this bunch of data. So I try to access this account number 2. So this is the one inside the pool I'm accessing. Grab this one, copy, and that's what I'm accessing. So I'll select this, and I'm going to simply paste this one. So maybe there is no spelling mistake, so that looks fine. Now I will access the token number 1. So simply copy that, and here I have the token number 1. So I'm going to say, and I'm going to paste it and replace it. So no more error. We have inside the token we have the name. So we have the name, and in name we have called that. Name is working fine. Now we have this pool example token name is working fine. This one also good. Now we have the fee. So we have this array, and we have accessing this fee. Looks good. Now we have the highlight. No, this is the range, and here we have the price, min price. We are not displaying that. Here we are getting the token name, first and second, and here we are getting the price. Here we have the token name, this and this. So things look good. I think we have no more issues in here. So let's try to uncomment this, save it, and yes, we have an error. So this is the problem I'm getting from here. So why it's saying wrap it, and come here, and we have to wrap this. Bring it inside. Okay, my bad. So actually I forgot to wrap this one. So make sure you do this. Make sure you wrap this and this, and now it's working fine. So if you make it on full screen, you can see. Simply come here and bring it this side by side and close this one. This looks good. Now what I can do is come here, and here we can do the changes. So right now here we have done something wrong. So if I say that if we have account, then we display this, but if I say that if we don't have account, then we want to display this, otherwise we don't display this. Save it and come here, and reload the browser, and you can see here we got the data. Here we got the data. So if we click here, if we go back here, you can see we have the data. We have the name of the tokens, we have the 2 token owner, and the fee right now is 3000, means 0.3%. And here we have the price range. Right now we are displaying the hardcode prices because I forgot to, because we have to remodel the data. So right now you can see we are getting this data, and in that we have all the data we have, this price, liquidity, and that's what we're going to display. Or you can display any data. So bunch of data is there, you can display whatever you want. So it's working absolutely fine. You can create as many liquidity as you want. So if I click here, if I come to, I will hop, and if I want to create with let's say Schwab, so these are the 2 token I'm taking the fee is going to be this, and I'm going to have this, let's say 500 and 500. Here I have selected the fee. Here I'm going to select the price, so 1, and this will become 1. And if I click on this, add liquidity, here we have the pop-up. Now it will first create our pool address, and I guess the transaction went failed. So I know why it's failed, because of this transaction went failed. I have to simply go to the advanced and do this, and simply reload the browser, and now we'll have no issues. So if we come here, we have created between Schwab and RAN. Now we created a different token, so we'll take this one and we'll say pop, and we'll say Schwab. So these are taken, we have taken. Now we have to take this one, hide 1, and I will go no minus. Okay, this is the one fix we have to do, not into the minus, and we'll say 400. We have to say 400, and this will become 400. We have to set the amount, click on this, add liquidity, looking fine, simply click on confirm, and let's see, the data is getting, and the transaction is getting failed, and the transaction is getting failed because I was stopped the application for a while, and again the RPC URL is creating problem, and MetaMask is creating problem to make the transactions. So application, there is no problem in the application. So problem we have in the RPC URL and MetaMask. So we can select the fee because I was stopped the application for a while, so that's why we're having the problem. We are getting the data now, just wait. We have to make the confirmation, so click on confirm, and here you can see this time it went through. So sometime it will have the problem. Okay, so this is nothing but MetaMask problem. So let's provide this one. So we have the one more one, and here we're going to just wait. We have to do the confirmation, and here we have the final. Actually we'll have one more. Altogether we have 5 pop-ups, and in the final one we're going to store the data in the liquidity, in the user data, and click on confirm, and the transaction went through. So if you reload the browser, the transaction went through. If you cut this, and if you come back to the pool, if you come here, you can see we have the 2 token. So the RAN and Schwab and RAN, we have 1, and we have Schwab and pop-up. This is the fee. It's in range, so it's looking absolutely fine. Now the only thing we have left is we can come back to here. So this is the final thing we left. So right now we can only swap token between ETH to other token. Right now you can swap with this. You can check the balance here. You can see everything is working fine. The updating is happening. So with this function we can only swap from ETH to any other token, but we have to make it multi-hop. So we can swap with any token, whether it's include ETH or RAN or Schwab. So with this I'm ending this video. In the next video we're going to build that functionality, and after that the project is over. If you still have any error, any doubt, the code is provided into the GitHub repo or in the article. Make sure to join and get it from there. So let's move to the next video.
Hey all of you, hope you guys are great. So this video is the last video of our decentralized exchange project, which we have been working for the last 1 month. I know that it took me a lot of time to build this project, but the main idea behind this project I had that I want to teach you that how you can use the power of Uniswap smart contract and SDK to build any kind of application, whether you want to build your
decentralized exchange where the people can come and swap the token. And if you have any project idea and you want to use this smart contract, so you can include this in that. So that's why I gave so much emphasis on the SDK and the smart contract, and we have written so many scripts. In the last video we have created liquidity and we have encountered a couple of errors. So if you haven't watched that, make sure to follow the last video and then you can continue from here. So here you can see that I have opened the project and I will going to provide you the entire source code of this project. So if you guys have encountered any kind of error in the past, so you can continue and you can compare your code. So you can see here we have all this folder and file structure. So first thing I want to do is I'm going to test the single swap. And again, I'm going to connect with the forknet because I don't have any tokens which I want to test. So, okay. So first I will open the terminal, clear the terminal. I'm going to initialize my local blockchain. Now the first thing you have to do before you start running your internal blockchain, you have to clear your old artifact, because if you have your old artifact, you will have a problem, like you will get an error. So we have to clear the artifact. So we'll type npx hardhat and clean. This will remove the old artifact and now we're going to create the new artifact. So here the artifact gone. Now we have to initialize the local blockchain Hardhat, and here we'll get close to 20 account, which is nothing new to all of you guys. So just wait, it will initialize our local blockchain. So here we have the account. Now come here into the script, and we have written so many scripts. We're going to deploy each one of this script. Okay, so first I will come to this deploy script, and in this deploy script, let me bring down, I'm going to deploy the, let's say I'm going to deploy this single swap, multiple swap, and the user data. These are the three contracts I'm going to deploy. I haven't done any changes in the contract, so I'm going to simply clear the terminal. I'm going to deploy the contract. So this is the contract. Let me open my const, go to this constant, and here I'm going to change the address of the contract. So here I got the artifact, and here the contract got deployed in my localhost. So simply grab this address, grab the address, and this is one is a single swap. So let's come here, simply replace that. So we got the same address. Do the same thing for the MultiHop. So this is a MultiHop and I got the same address, and this is the user data and I got the same address for the user data as well. So these are the three contacts we have deployed. And what I have done, if I come to the context file, here you can see that I have already copy couple of addresses from the mainnet. So we are using forknet, and these are the real addresses which I have found on the mainnet, and that's what I'm using, these token address. I hope you guys have these addresses which I have already provided to you. So save it, and now we have to initialize the applications. Let me start this. So here we are, click on this 3000. So right now we are focusing on a single swap. Okay, so we are focusing on the single swap, and after we finish with this, then we're going to move to the liquidity part. So what I will do now, I'm going to simply log into my account. So here I'm logged into my MetaMask. Just wait. So here I'm logged in to reload the browser to see that I'm connected, and yes, I'm connected. So before you do the test, make sure to change the here you can see I was encounter a lot of error. We're going to talk about this error which I have had. So first thing I have to do is I have to simply remove this one, reset the account, because when you are getting any MetaMask related errors, you have to make sure that you have to clear your MetaMask. And I don't know why I was getting this error. We're going to talk about that. So as I have already said the predefined slippage and tolerance, so I'm not going to define any value here. If you want, you can do that, which I have already explained in the liquidity section. So I'll click on this ETH, because I'm saying I'm testing single swap. So I'm testing the token from ETH to other token. So here I've taken ETH, and here I'm going to take this, let's say right now DAI. So I have this much DAI in my wallet. So here I'm going to swap the token like 50. Let me make it side by side if I get any error, so we can easily able to track that. So just wait, it's pulling off the data. So this is, we have used a specific pool, and the pool we have used is between ETH and DAI, and this is the exact output I will get when I will swap the 50 token 50 ETH to DAI. Okay, and this is the exact data we have got it. So if we click on this swap token, here we have the pop-up, and here you can see we are sending the 50 ETH. We'll click on this confirm, and here the transaction is getting confirmed, and here we are interacting with the smart contract. So just a moment, here we are allowing our ETH So click on confirm, and here we have the second pop-up, and here we have to do the confirm. So let's call this function confirm, and the transaction is happening. Just wait, you might get the logs down here, and here the transaction went through, and this is the DAI token we have. So earlier we had this much, but right now we have this. So you can see this is the transaction log. So our single swap is working absolutely fine. We have no issue in that. If you come here, and you can easily able to check the DAI balance. So if you click on this DAI balance, and you can see it's updated. If I want to swap from WETH to Coins, we can do it very easily. If I passed it here, if I pass 5, you can see, just wait, this process let's get completed, and here you will get the amount which is related to the DAI, because we are going with the hard code value of DAI pool, DAI and WETH pool. So that's why you are getting this much DAI output value, but this is not what we'll get a different value. So click on this swap, and here we are interacting with the smart contract of a single swap, and just wait, click on this confirm, and here we have the second MetaMask. Here we are allowing our WETH token to be spent, and we can get that coin. So come here and click on this. Why this time MetaMask not popped up? So sometime it's happened, sometime we get this kind of behavior from the MetaMask. Here you can see we are interacting with the swap contract. Click on confirm, and just a moment, and here the transaction went through, and if you come here, reload the browser, everything is looking fine. So just make sure to come here, and if you click on this, here you can able to find all the tokens. So right now we have this much coin, but you can see that the address is really pretty huge. This is pretty huge. This is the USDC, and this is the coin we have. So you can see everything's working fine. So what I want to do is I want to slice it down. So for that, what I can do, come back to the code, bring the terminal down, and we can go into the component, and we can go into the token list. Come here, and here we are displaying that entire data. So here we are displaying the balance. So we have the symbol, name, and the balance. So what I can do, I will use this slice method. See, slice, and I want to slice it down from 9. If I save it, come back to the browser, and you can see right now it looks good. So it looks perfect. So you can do this changes. So our single swap is absolutely working fine. Close this one and close this one, and now we're going to test this out. Test this out. Close all this. Close this one, and now we have to test this. So let's come into the swap context, and here we have this function, and you have to understand this function, create liquidity and pool. So this function will not work for the old token. This function will work for only new token. Just imagine that I have a token, I am listing my own token. In that scenario, I can use this function to create liquidity, because the method we have called is different for the new token, and the method is available in the smart contract of Uniswap for the existing token. That one is also different. So this function can only be executed when you are adding liquidity to the new token. So let's add a liquidity to the new token. So if we come back here in the script section, so here we have the tokens. So this is the token we have. This is our own token. So if I come back, if I take you to the smart contract, you can see here we have the pop token, we have the Ryan token, and here I have done the changes. So let's change the name. I don't know why I have changed this. So I'll call RAY, and this will become swap, will become, let's say, this, and this will become SHO. So make sure to do these changes, or you don't need to do that changes. Now what I have to do is come here and let me deploy this token. So this is the deploy script we have written. Copy that one, open up your terminal and split your terminal so we can run our command. Paste here, clear the terminal, and simply deploy the token to localhost. So here it got compiled successfully, and here we got the addresses of the token which we need. Simply grab this addresses and come here and go to this pool section. So we can come here, this is the script pool we have. So let's keep the address here for time being, paste the address here, and we need the address in the context as well. So click on this, come here in the context, and here we are fetching the information about the token. So grab the address, and that's what we're going to keep it here. So this is the address for the tokens we have created. Grab the second address, paste here, and this is the last one. So copy, and that's what we're going to simply pass here. So these are the 3 tokens we have, which we have created. Looks fine to me. So we have deployed our token. Now we have to deploy this very important script. So Uniswap smart contract. Uniswap smart contract. So this is the script we have to deploy. So come here, simply grab that script and open up your terminal and simply click on deploy. Just wait, this will take a little bit time, and here the transaction went through and we got our contract of the Uniswap. So these are the contracts we have got. Simply grab all of these contracts, and that's what we need in our deployed pool. So first we need in the deployed pool, because we are not testing this in our terminal, so I just keep it this addresses here in the script as well. And this is the one, copy that one and simply come here and simply paste here. So we got the addresses. Now we have to simply close this one and come back to the utils folder. Inside the utils folder we have to do the changes, because our smart contract, Uniswap smart contract, is already deployed. We have our token deployed, so we have to come back into the deploy pool, because here we have to specify the contract. So if we come up here, here we need the Uniswap V3 factory address and non-fungible position manager. So these are the 2 smart contract will allow you to add liquidity to your new token, and that's the point you have to keep in mind. New token. So we have our 3 new token, and that's what we're going to deploy and provide liquidity in that. So here we have this factory address. That's what I'm going to simply copy, and that's what I'm going to replace it here. And we need have this positions address. Simply grab that one, copy and paste here, and that's the only changes you have to do here. No, nothing else. These scripts already you guys have written. These scripts already you guys have built, so don't need to do the changes. So this entire script will return us the address of the pool. So simply close this down. Now both the contract is got deployed. Now we can start creating the liquidity. So if we come back to the context, so inside the context you will notice one thing, that this is the create liquidity functions. So first we are creating pool, because before you create liquidity you have to initialize the pool, and that's what we are doing here in the utility folder. Deploy pool. This will give us the address of the pool, and we're going to use this pool address to create liquidity. And this is the function we have here, and this function will allow you to add liquidity to the new token, not in the old token. If you want to add liquidity to the old token which is already deployed on the change like DAI and WETH, in that scenario you can call different function. It will return us the address, and once we get the address back, we are providing that address to our add liquidity, and with this value the token addresses, pool fee and the amount, and at the end we are making that call. So these are the things we have already covered in detail, so make sure to watch it again, because these are the very important things which you have to know, otherwise you will encounter a lot of error. So now we can test it out. So what I can do is close this one and close this one all. Come back to the application. Right now we have no more error. If we reload the browser, still we have no more problem. You have seen that we have deployed the first single swap contract, the tokens and multiple contract user data, and now we have deployed the Uniswap contract and the token. So we have all the tokens. So click on this pool, and here we'll land on the pool section. So let me open up the inspect element and come here. So right now we don't have any information about the liquidity, so that's why you can see 00, because we haven't created any liquidity. But before you make the transaction, make sure to reset your MetaMask. And this is the very irritating problem which I'm having. I try to solve this problem for the last 2 days, but still I'm getting this error. I don't know how this error is happening. So I try to connect with different people to fix this issue, but still I'm having these issues. And this issue is related to the MetaMask. There is no problem in the code. So reload the browser again. We have cleared the reset the MetaMask account. click on this add liquidity, and here we have to select the token which we want to use to provide a liquidity. So what I'm going to do is I'm going to select this. So the first liquidity I'm going to create is between with to, and we want to create to, let's say, pop. So this is the two token I'm going to select, and right now I don't have anything into my wet token. So what I can do, I can select this Rayan token because I have token into that, and from here I can select the fee tier which I want to charge. So I will go with, let's say, 3, and here I want to take tokens like 5,000. Same thing I goes with other token, so it will be in the range. From here I can define the price which I want to assign to my token, and from here I have to define the price which I want to charge for my token. So I will go with equal range, so I will say 1 and 1. You can type any value, it's totally up to you. So if I click on this add liquidity, here you can see the MetaMask. We got the logs because these are the data which I'm logging into my console, and here we are interacting with the contracts. So I will click on this confirm, and here you can see now I have to simply approve the transaction. Here I have to give them the permission to the Uniswap smart contract to take my Rayan token, and again I have to approve the other token, pop token, confirm, and here I have to call the send function, click on confirm, and here the transaction went through, and here I have to do the final interaction. This will store the liquidity data, so click on this confirm, and here you can see it's pending, and finally the transaction went through. You can open the logs and you can see the data we have provided, all the data you can able to find about this liquidity. So what I can do, if I simply reload the browser and if I cut this one, if I come here, if I click on this, if I come here, you can see the liquidity we have provided between these two tokens. You can pull this data, you can display this data as well, because we have all this data. And again, I don't want to get into this same repetitive thing. So if I come here in the console, you can see right now we have this one liquidity which we have created, and in that we have all the data about the liquidity. So whatever information you want to display right up here, you can display. So what I have done, I am displaying only the two token and the fee. If you want to display the pricing, so the pricing we have inside this, you can easily able to explain this, you can able to find that, and you can able to find all the information about this. So hope this entire things makes sense to all of you guys. And if I come here, if I try to open this one, and if I try to create one more, let's create one more. So let's create one more, and if I come here, click on this time I want to create between, let's say, if I come here, if I type this 5,000, do the same thing for the here, and provide the pricing to 1, click on this confirm, come here, and let me open the MetaMask. It looks fine to me. Click on this confirm, and here we are, it's got failed. So this is the error which I'm getting over and over again when I was testing the smart contract. It took me almost 2 days to figure it out, and still I haven't found a proper solution, because sometimes the transaction is getting went through and sometimes it's getting failed. So to fix this issue, all you have to do is to make sure to restart the application if you're having the error over and over again. So restart the application, or sometimes you have to simply reset your MetaMask account. So if I come here, here you can see the transaction went failed. Come here, I will click on this, and I have to reset an account. And this is a really very irritating part. To be honest, I haven't found a solution which can fix this issue, but there's nothing problem with the code. This is the problem with the MetaMask. Click on this, let me select the token, so Rayan, and I will go with pop token. So these are the two tokens I'm taking. Let me select the fee. This time I will go with 1. I select the price to 1, looks fine to me. Click on confirm, and here I have the MetaMask. Let's see, it went through and looks fine to me. Click on this confirm, and just wait, and this time the transaction went through. You can see now we got an option to approve. So I don't know why it's happening, but this is the problem. So if you guys are getting this problem, then this problem is related to the MetaMask, nothing with your code. So come here, we have to click on this confirm, and here we have to click on this, the final one is this confirm, and just wait, the transaction is pending and it will be completed very soon. So here it says I have to speed up, and now the transaction went through. If you reload, you can see we have provided the transactions, and that looks fine to me. So we have this 2 transaction with different range. If you open up the logs, Open up the logs, you can able to find the data of the transactions. Now you can see we can easily able to create liquidity and we can easily able to fetch the data. Now let's talk about the important thing. So if I come here in the code, if I go into this utility in the deploy pool sections, and again I'm telling you that this script, the deploy pool script we have written, it's only for the new token, not for the existing token, because for existing token you don't need to do anything. You don't need to build any one of this script. All you have to do is to use the smart contract. The smart contract, liquidity smart contract is here. All you have to do is to use this smart contract, because in this smart contract is designed to pull all the data about the pool. So no matter what token you will assign, it will automatically fetch the pool address and it will create a liquidity. But the script we have built, that is for the new token. So if we come here in the deploy pool section, so here let me take you through this, what is happening here. So here we have this two contract. Here we have the artifact. We are using this non-fungible position manager and Uniswap V3 factory. And this function is really very important. This will allow you to give you the square price of the two token. So you have two token, whether it's your own token or it's existing on the chain, and you want to provide liquidity. So all you do, you set your liquidity price which you want to charge as an initialized price, and it will set into a square form. Here we are interacting with the contract. You can see this is the contract, this is the function, and that we are passing this, and here we are passing this. Here we are calling this create and initialize pool if necessary, and that we are passing this address and fee, the one fee we want to assign to the pool. So this one is really very important. And again I'm telling you, this entire pool function is only work for the new token. If you want to create a liquidity for the existing token, for that you don't need to write any one of this script. All you have to do is to use this liquidity smart contract, and that you have to pass the two token address and the fee, and it will create the liquidity and every single data which you need to know if you really want to use existing token. Okay, so hope things got clear to all of you guys. Now come here, if I go to this, and I noticed one thing, my bad, I noticed one thing, that I haven't changed the address of the liquidity. So I was stuck for a while and I found a problem that here the liquidity says 0, and if I come here, click on this Ryan, here I want to notice that we have still 8,000 token, but we have provided the liquidity. And I found a problem where we have happened. So this is the problem we had. By mistake I put the old address of the Uniswap smart contract, and we are not even using this contract, and because of this we were getting an error. So to fix this, all we have to do is to come here, go to this liquidity, and here we have the addresses. So come here, open up your terminal, and now what I can do is, here you can see, here we have the address of all the token. Here we have the Uniswap contract we have deployed. So make sure to grab this entire address and come here, paste here in the script, and we have to do the changes right up here as well, here as well. So we were using the old addresses, that's why we were not getting that liquidity. So let's come here, let me type this const and simply grab this one and do the same thing for other. This has happened, brother. This has happened. If you are into development, you will do these mistakes. So I do all the time. So we have the contract deployed. Now let's come here, let's test this out. If I reload the browser, you can see I'll get the same liquidity. If I come here, I'll get this liquidity, but there is nothing in here. You can see I have this data, but there is nothing in here, So let's create a new one. So to create a new one, so first thing we have to clear your MetaMask, otherwise I don't want to have that weird error message. So come here, click on this advanced, click on this reset account, and things looks good. So here things are looking fine, and now we're going to create a liquidity. So click on this, come here, click on this pop, and click on this Ryan. So these are the two tokens we have taken. Now we have to set the pricing to this. Why it's not selected? Click on this. So we have this two token, pop and Ryan. Now I have to initialize the price. So this is the price which I want to assign. Now click on this add liquidity, and here I have MetaMask, and that looks fine to me. Just wait, here I got the MetaMask. Click on this confirm. Hope error will not. Okay, you can see I got an error. So it will happen, it will come, it will not come. and I tried more than 10 times and now it's working. So I don't know from where I'm getting this weird error message. So right now it's working. So sometimes it's working, sometimes it's not working. It keep throwing me an error, and that's what is happening. Now I have to call the mint function, and if I click on confirm, and here the transaction got reverted. So let me have a look. What's the problem? So this error message is happening. So if I come here, it's happening in the transactions. So maybe I have done something wrong here in get all transactions. So let's come here, come back to the code, split this, and come to the script. And this is what happened when you get an error. So once you encounter an error, you have to restart everything, and sometimes you forget things. So let me do that and save it, and let me restart the application. Not restart, let me redeploy the deploy contract. So this is the address I have. Simply grab that one and come back to the context, and that we are calling the, and here I have to change this one. So that's the change I have to do. So I've done this change. Make sure to close this up and let's give a try. First time I have encountered so much error in the code, and first time I became frustrated with this MetaMask error. So let's try to create one more time. Hope this time it will go. So let's clear my history, otherwise it will again throw me that same error message, which I really don't like it. Where I have to select the pop, and you have to select the second token, which is the Uniswap token. And here you can see the transaction went through. Last time we had created the liquidity, and the error we got because we haven't deployed the user store smart contract, and because of that we got the error. But we had created the liquidity. You can see the token got deducted here. So this time I will go with something with 400 with token, and from here let's call it 50-50. I don't want to again encounter an error. So let's go to this, and from here I can type the pricing 1 I click on this add deployed. Here we have the MetaMask through, click on this confirm, and I got an error. Nope, not a big deal. Reload the browser, and here you can see I tried more than 20 times, and after that it went. Now I have to initialize, approve the pop token. Now I have to approve the other token, and now I have to click on this mint approve, and the final approve will happen automatically. So just wait, click on this. No, I have to approve it. Click on this, and it's pending, and it will happen soon. And you can see the transaction went through. You can easily able to find the logs right up here, the entire data of the transaction, and finally we have created the liquidity. So if you reload the browser and come here, if you click on this, if you come back here, and here you can see here you have created the liquidity. And I tried more than 20 times, and after that this transaction went through. So there is no problem in the code. It's happening because of the MetaMask. I don't know why it's happening, but there is a problem. So now if you click on this, and if you look at the liquidity section, this is the data we have, and inside that you can able to find that this much liquidity we have provided. So everything's working fine. So you can get all the data which you can convert, and you can display right up here. So right now I'm just displaying this token, RAN, and this, but you can display as many data as you want. This much liquidity we have provided. So if you come back here in the code, if you go to this liquidity section, so where we have the liquidity, in here we have said that this much liquidity we're going to provide. So this is the token we have passed. You can see this is the amount we have defined as a liquidity. So that's what we are defining. So from here you can easily able to manipulate. So if you want to provide higher liquidity, you can provide higher liquidity. And here we are defining the token we have assigned. Hope this entire things makes sense to all of you. And again, I'm telling you that whatever script we have written, this script will work only for the new token. Only for the new token. If you really want to use the existing token, then for that we have a different smart contract. And then for that we have to use this normal smart contract. This normal smart contract. In that all we have to do is to pass the two token and the price and the fee. It will create the entire pool address, and it will automatically do everything. But the script we have built is only for the new contract. Okay, So that's the thing you have to keep in mind, and you can see everything's working fine. So we are done with this. Hope these things make sense to all of you guys. This one is really important. Again, I'm telling you because I encounter a lot of error. So the error we are getting from this MetaMask, the transaction is keep failing. It took me 20 times I tried, then finally the transaction went through. So there is no problem in the code. The only problem we have in the MetaMask, and I try to communicate with the MetaMask developer, and I also requested in the forum to look at this method, and they're looking at it. So as soon as I get a concrete solution for this problem, so then I will definitely update all of you. That's the thing you have to keep in mind. New token, if you really want to create a existing token, then all you have to do is to execute that smart contract, which is a very simple thing. Now we're going to work on this. So right now you can see we are displaying this hardcore data, and I want to display the details of the token, so the popular tokens details. So let's do that. So let's come here. We're done with this. No need to do anything here. Actually, we do have to do here. So let's close this one, close this one, close this one, close this one, and that looks fine to me. And here we're going to call a method. So here we are in the context. Let's scroll down here, and here we have to take a state variable. In that we're going to keep the token details. So I call it top token list, and it's going to be an array type, and in that we're going to store. And now we have to open this fetch data function, because we want to fetch the data when the application is get reloaded. And we can come here, we can scroll all the way down, and here we're going to make that call. Now for getting those data, we have to use an API, and the API is already provided by the Uniswap. So we're going to use the API, and this API is referred to the subgraph. So this is the endpoint of the Uniswap API subgraph. In this we'll have all the data about the token on the Uniswap. So this is the endpoint. Now we have to build a query, because this is a subgraph, and you know that subgraph has a specific format to make a query for the data. So this is the data we're going to retrieve. So we want the data for the token. So there is a lot of data about the pool, contract, factory. There is a lot of method which you can call. Here we are calling for the method is token, because we want to find the top tokens. Here we are saying that order by value in USD. So those token is very high in USD. Those one we want. Here we are setting up the directions, and we need only 20. If you want to go with 100, there is a lot of tokens, so you can get all that, but I will go with 20. You can go with 5, you can go with 1, and these are the data we need about the token. So I need the token ID, name, symbol, decimal, volume USD, total supply, feed USD, total transaction, pool count, all the data we need. So once we have that, now we have to simply make a call on the API. So for making the call, we are using Axios, and I'm calling this post method on this because I'm sending this query. So I'm taking this URL which we have taken here, and in that I'm setting up the query, because these are the data I need. And once I have the data, I'm going to set the data into my set state variable. So in this I will have the data. So what I will do, simply copy that one, and here I'm going to simply console.log, and that I'm going to simply pass this. So let me show you the data. So if I come here, come back to the browser, and if I come down here, error message, it say the Axios is not defined. Okay, my bad. So I have to define the Axios. Okay, my bad. I have to import the Axios package. I have already installed Axios, and that's what I'm going to do. So simply come here and let's see, do we have installed Axios? And Axios, I have already Axios. Now save it and come back to the browser, and here you can see we got the 20 data. You can see we got all the tokens which are top. So first one we have is wrap ether. You can able to find the decimal point, ether, feed value, ID, name, pool count, symbols, total supply, all the data you can able to find, all the data. Once we have all this data, that's what we're going to simply plug into this. So let's come back here. Let's come back to the code. Simply close this one, and here we are. Now simply get this one and copy that, scroll all the way down. Once we have the data, now we have to simply pass the data here. So simply come here, and this data we are displaying in our index page. So come here, go to the close this one, go to the pages. Inside the pages we have to go into the tokens, and here we're going to receive the data. First thing, we have to build the context that's very easy. Come here and let's go into this, and from here we can simply grab this context import, and that's what we're going to take it in here in the pages, because sometimes it becomes very lazy to type the same things over and over again, and all the way this project is getting very huge. And here we have to use a context. Here we have the context. Now go to the index, and Inside the index we have imported already a couple of data. We'll grab this portion, and that's what we're going to simply come here, and that's what we're going to simply pass it here. In that, we're not going to need all of these data. The only data we need is this token. Copy that, come here, and here we have the context. We got the data in our context, and once we have the data, now we're going to use the data right up here. So where we are looping up, so we can come here, and okay, so let's come down here, and where we are looping up, and that's data we're going to pass here, all token. So simply come here, pass it up, and save it, come back here, and you can see I got this error. So it says cannot reverse import. So this data is coming from import context. So I know the problem. Come here, and this time we have to find the right directory. So dash we have to go into the context. Inside the context we have this swap context. Save it. Now the error is gone. We have dealt with the problem, and here we have nothing. You can see we have this broken pieces. Now we have to simply feed the data. So there is a tons of data is available to us. So now what I can do is simply come here, go to this, come scroll all the way down, and we have to go into this all token. Click on this all token, and inside this we have to simply change the data we want to take. And here we have to change this token value in USDC, and here we have to, instead of TVL, we have to say token count, and here instead of the volume we can say total supply, because these are the data we want to display. And here we are displaying the price. So let's come here. Where is the price? Here is the price, and instead of the price we are going to show you the volume in USDC. So it's a in USDC price, and here I have to do the change. So this will become, instead of change, I can type lock USDC amount, and here I want to display the transaction count, and here I want to display the volume, the total supply. And let's come up here. Here we are looping. If you save it, come back to the browser. If you save it, come back to the browser, you can see the data looks perfect. We have no more problems. So all the pricings looks fine. All these relevant data we have. Some of the tokens names are really big, and this is image is broken. So what I can do here, so if I come up here, I have the images. I'll grab the images, and instead of displaying it, because I don't have all the token images, so I can display the Uniswap image. Save it, come back to the browser. You can see this is the images we have, and I want to fix this. So here we have the number. So instead of this, what I can say simply I+1. Save it, and here we have that. So it looks fine. You can see all the data we have here, and it's already responsive. So hope this entire things makes sense to all of you guys. You can create pool, you can display the tokens, and you can easily able to do the single swap. Hope you can see, if you come here, if you select this, because the token balance is already down, so not this one, you can see, because we have provided the liquidity to close to 30, and the balance is getting down. Everything's working fine. Hope this entire things makes sense to all of you guys. So what we have covered so far, we have created the liquidity, and we are fetching the entire data, and we can easily able to do the single swap. We cannot able to do the multiple swap because very easy. I don't want to do the same thing over and again. So if you really want to do the multiple swaps, you can do that very easily. So I want you to guys to do and add this functionality, because we have done so many things. If you still can't do it, then I have no words to tell you. If you come back to the contract, here we have this MultiHop contract. In that we have this contract. So here I have already done the changes. You can see these are the old contract which do the multi-hop in a fixed token, but here I have made the dynamic one, and that all you have to do is to take the 2 token and the fee. That's all you pass, and you can easily able to do the swap. So I want you to try. That's why I'm not going to include this functionality. I will leave it up to you. So hope this entire project makes sense to all of you guys. Hope you guys have learned something new. The entire focus was to teach you everything about the Uniswap SDK and the smart contract. So we have built all these scripts I want you to go each one of to this script, look at the functions, try to analyze it, what is happening. We have tested all the scripts, so hope this entire thing makes sense to all of you guys. And again, I will provide you this running code to all of you, so you can be on the same path where I'm left here, where I'm leaving you all here, and that looks pretty fine to me. So make sure you guys can follow this entire project, and I hope you guys have learned something new. The extra functionality which you can include into this application is this. So if I come here, so right now you can see if I type any amount and the data I'm getting here, these are coming from the fixed pool. Because if you come here in the contract, here we are fetching the information. So fetch price needs the quoter address, and here we have to pass the data of the pool we want to fetch the price. So let's come to the helper function. So Ethers scan API we are using, where we have the swap, and here we have taken this V3 swap router. Come on, yeah, where it is. But if you look at this fetch pricing, it's need a pool address, and the pool address we are passing here. Come to the component hero sections, and in here we are passing the fixed address. This is the fixed address we are passing. This is really very easy, and that's why I want to leave this on you, because so far you have coded, and if you have built the same functionality which we have covered, then you are pretty ready for building a logic to do and solve this particular issue. So instead of going with this hardcode pool address, you have to find a way in which you can create multi addresses of the pool for different tokens in an array, and all you have to do is to build a logic to check for the name of the token, and on base of that you can define a pool and simply pass here, and that will give you the data. So this is the one I want to leave on you. So you have to come with a logic. If you can't do that, make sure to rewatch, because this one is a very simple program you have to build, simple logic you have to build. It's just a JavaScript, nothing related to the smart contract, nothing related to the blockchains. It's just a simple JavaScript which you have to use to get all the data. So this is the feature I want to leave on you guys. This pricing feature, this feature is totally up to you, and I want you to add a multi-hop. Right now we can do only from WETH to ETH to other token, but you have to add a multi-hop. So this is the pool we have created. All you have to do is to add the multi-hop functionality, and you can easily able to swap the token. So that function I'm going to leave on you guys. I want you to complete and add these two functionality, because if you have coded along this far, then it's really a piece of cake. So if you encounter that error which we are having over and over again, don't get frustrated. Make sure to restart the application, delete the old artifact, redeploy the contract, redone all the settings, and let's try one more time, because there is no problem in the code. The only problem you're having in the MetaMask, and that's why you're getting this error. The only task I want to give you all that, just build the logic, build the necessary functionality which I told you to build, multi-hop and fetching all the spool data and doing the swap. So send me the code and I'm going to make a video on that. With that, we are complete this project. So hope you guys have learned a lot of things into this. And again, I'm going to provide you this entire code in the GitHub repo or in the article. So from there you can get it. So with that, I'm ending this video.